It's 66,000 miles an hour. Fuck off. All right. And anybody who wants to buy into that bullshit, good luck with that, because that's ridiculous. And I know you guys know it deep down, man. I know you guys, you believers. Yeah, we're shooting around at 66,600 miles an hour. Yeah. And we're shooting through space at a billion, trillion. Fuck off. You aren't spinning through shooting through fuck all. And if you don't realize that, man, I can't help you, man. You have to realize you're not shooting through fuck all at, millions of miles an hour. So get that through your heads. Get back to me, man. Get back to me. 'Cause I'm here, man. I'm here. You can DM me, whatever, man. If you got, but the fact is, man, you don't feel any of this shit. You don't see any of this shit. And you don't experience any of this shit that they are selling. And that's a sucky kind of shit situation we're in, man. There are people that will accept the reality that they are given, which is flat and stationary, and all those stars and suns and moons are like cruising above our heads with no parallax, zero parallax. They say those stars, this one, that one, next to, they're like trillions of miles apart. If that was true, man, they wouldn't be in the same position. They would not be there, man. But they're there every year, the same position. Oh,
you can't see shit that far away. That is too fucking far to see anything.
Listen, God. You can see trillions of billions and trillions of billions of miles of light years.
Have you lost your fucking mind? Have you lost your mind?
100 million light years away. I was like, what? 100 million light years away? Fuck off.
You can't see a million miles away, let alone a trillion.
Yeah, that's where I get, that's what drives me, man. Like, you're going to see 100
no
million
fucking way.
Fuck off.
Those things were that far away. They would be so tiny, so small, you couldn't, they would have
Hey, the closest light, God, listen, man, the closest light is only 26 light years away, man. Come on.
26 light years? 1 light year is almost 6 trillion miles.
Oh my God. Oh my God. 1 light year is 6 trillion fucking miles.
Yeah.
I want everybody to get that through their head, man. 1 light year is 6 trillion miles. And those lights in the sky above your head every night are trillions of miles away. Trillions.
And what people see, here's another way to look at that. A light year is a year at the speed of light. That's what that means. Going the speed of light for a full year. And light travels, so they say, at 186,000 miles per second.
186,500 miles per second, to be exact.
Yeah, well, okay.
I'm just fucking with you, rocking.
I know. We need to get real with this situation. These claims are just so ridiculous that they're laughable.
They're laughable. That's why I come on here, is to make laughables of your ridiculousness, Globers. It's ridiculous, man.
186,500 miles an hour per second.
I took them all on, man.
For a whole fucking year.
For 5 years, man. I've been taking these motherfuckers on. And these motherfuckers ain't got ball shit, nothing, man. Except, like, you're just a retard flat earther. Okay, thanks, fuckhead. Yeah, that I'm a retard flat earther. Fuck off. We've
I mean, that's
actually
fuck.
fucking gone out and done some homework, boys and girls. We've done some homework. And we
That
kicked.
makes about as much sense as driving a caterpillar through the eye of a needle. It's fucking impossible.
Well,
I mean,
we've kicked your fucking ball shit from here to the fucking moon, man. We've kicked it. And we've kicked it, and we've kicked it, and we fucking keep on kicking it until you can show me gas pressure without a container, man. Fuck the fuck off, okay?
ain't
I don't want to
nothing
hear
floating
anything
around
else.
in no goddamn vacuum. Nothing.
Show me the motherfucking gas pressure without a container, please. If you got one of those laying around, man, I'd be happy to invest in your company because that is some magical, astronomical invention, and I would be willing to invest. Please show me gas pressure without a container, and I will be your top investor. I'll be your first, at least your first investor. Please, I'll invest in your company.
I'll be standing right next to you to kick him straight in the balls when he can't produce it.
I appreciate the backup, bro.
Yeah, no problem.
I'll put the money down. Hey, man. Here's the money. Show me that gas pressure without a container. And that's the death nail, man. That and curvature are death nails to these cucks. And I just want them to wake up and say, hey, man, what's the reality of where I live, man? What is it? I want the reality to be outer space, and I want to go to the moon, and I want to go to Mars, and I'm going to go to the outer atmosphere. It's 26 years to even get there, bitch. 20 fucking 6 years before you get to the closest star, man. The closest one. It's going to take you 26 years one way. One fucking way, man.
Yeah, that's if you can travel at the speed of light.
If you're traveling at the speed of light.
Who in the fuck can travel that fast? Fastest they've ever gone is what, about fucking, what they claim, like, what, 40,000 miles an hour when they supposedly slingshotted around the moon on their way back, like 40,000 miles an hour or something. That's far cry short of 186,000 miles per second. We're talking 40,000 miles per hour.
Hey, 128,500 miles a second. Okay, bitch. Whatever. 160. Doesn't matter.
I know, it's all.
You're not traveling, man, to the fucking stars and back. If it takes you 26 years to get to the first fucking star,
at
not
the speed of light.
You know,
that's traveling at the speed of light. Traveling at our modern technology, it would take thousands of years.
Yeah, it would take thousands of years. And you ain't going. And anything you thought about space is only on your fucking screen on your TV, okay? And if anything else, it's not reality, man. Reality is standing out and seeing the oceans flat, dumbass. Get your ass out to the fucking ocean. Get yourself to a big fucking lake. You can see there's no bendy fucking water. You can see there's no bendy nothing. So get your ass off your ass and get out there and look at this horizon. Because the horizon doesn't lie, man. Level is level. Flat is flat. If you guys can't dig that, man, that's not my problem, man. Get over it. Hey, you guys, flat earthers, you guys are the best, man. Keep it up. Everybody, stay strong, man. Stay strong, because reality is reality, and you can't deny reality, man. It sticks you in your face. So welcome to reality, and welcome to Flat Earth, Mongos. Get on it. All right. I got to go to bed. Cheers.
All right, bro.
Carry
good
on,
night.
man. Keep the energy going.
We
It's
got
all,
this.
yeah.
Yeah, brother. All good.
Away go. Muchacho.
Peace out, brother. Peace out.
The sun is not so far away. The moon isn't what they say. Everything that glitters is not gold. They sell a dream and steal your soul. They see the victim as she cries, and all the poets wonder why. The sun is not so far away, and the moon is not what they say. The sun is not so far away, and the moon isn't what they say. 600 miles using stars, compass was our arm. The lies and love too much to bear. Tell the story, make it fair. The sun is not so far away. The moon is not what they say. The sun is not so far away. The moon is not what they say. The thinker thinks is on his own. The song adjusting to the tune. And dreams of revolution's dome. The clouds they hide the mystic's home. The sun is not so far away. Everything isn't what they say. The sun is not so far away. The moon is not what they say. Everything that glitters is not gold. They sell a dream and steal your soul. They see the victim as she cries, and all the poets wonder why. The sun is not so far away. Is not what they say. The sun is not so far away, and the moon isn't what they say.
Man, everybody's quiet now. I missed the party.
Are you there, Bong?
And a headphone.
Okay, I think I'm in. Hello.
There you go.
How's it going, man?
Welcome. Sorry about that. I'm a complete noob when it comes to Discord.
No problem at all. Good to have you here, Robert.
Thank you. So, wondering if you had anything you want to pick the brains of a physicist.
Yeah, real quick, before you start, can you tell us what you're a physicist of and maybe a little bit background so we can kind of know a little bit about you, if you don't mind?
I am a cosmologist at a university in Britain. I'll prefer to just leave that unnamed, if that's okay with you.
Yep.
But I'm a cosmologist, essentially. I work with the early universe.
Oh,
Cool, man.
So you study celestial objects? Is that?
Oh, that's way too new for me. I study background radiation and what happened, during the original Big Bang stuff, inflation, all that kind of stuff. When stars and stuff have formed, it's already way too recent for me. I mean, I know the stuff, but my research is before stars form.
Okay, like the microwave background radiation and stuff like that.
Much before galaxies form.
Okay.
Before.
yeah, thanks,
I mean, we kind of look at the superstructure of galaxies because it tells us something about how the universe began. But I don't actually look too much at the individual stars.
Are you in touch with the people in Antarctica doing their research down there about the microwave background radiation and that sort of thing? Or is that something different to what you're talking about?
I don't have anything to do with that research. I'm working with ESA vaguely with there's a probe that's going to be launched in 2024, which is going to be measuring some background radiation. I'm doing a little bit of work with that, but that's about it.
So Robert, do you know? Have you ever looked into flat Earth?
Oh yeah. I've been talking to flat earthers for 2 or 3 years or so. It's I enjoy it.
That's cool, man.
So, Robert, you understand the background of the initial flat Earth claim: we see too far. The spherical geometry does not adhere with the reality of which we measure and observe. You understand that, yeah?
I've heard all those claims before, yes.
What gives you the stance that you do right now at this point, studying the cosmology, that some people come in here and say that there's terrestrial planets out there? What give you the idea that there is that information that you can go ahead or evidence that you could cite maybe?
Sure. I mean, again, that's not the stuff that I do, but I mean, I know the science that's going on. It's kind of cool. Because it's pretty new. It took us, it's only 30 years ago we detected a planet around another star. Before that, we had no clue that there were any planets outside our own solar system. Yeah. But we found them. We have really cool ways of finding them. I don't know how much detail you want me to go into with that. I can explain how we see them, how we know they're there, and how we know what they're made of, all that kind of stuff. It depends how curious you are, really.
Could we get what they're made of from you? I mean, can you explain that?
The way we do that is because we have a really fortunate thing called spectral analysis. It turns out, if you go into a lab, forget all about planets and everything outside in space for now. You just go into a lab and you take all the elements that we know. We've detected elements for hundreds of years. We have a whole periodic table. We have them all in the lab, right? And what we do is we put this, we send electricity, we really force a few electrons through this gas, because what happens is that the gas sends out light. It starts emitting light when we shove electricity through this gas. This is well known. This is how light bulbs, modern light bulbs work. That's not a big deal. The great thing is, though, that the lights that it put out is dependent completely on the element that we're looking at. There are some, and that's called the spectrum of the element. So every single element in the periodic table has a completely different signature of light to it.
Like a fingerprint.
Yeah, completely different. There are no two elements that have the same spectrum. So that means it gives us an incredibly cool way of knowing what element we're looking at simply by looking at the light from this element, because the light from the element is the indicative of what the element is. That's
ask a question
really
on that,
practical
Carry
when
on.
we're looking at stars, because one thing that stars do, obviously, is
Just
send out
ask a
light.
quick question.
So if we analyze the wavelengths of this
Just a quick
light,
question,
it tells us
please.
exactly what the stars are made of.
Can I ask a quick
To
question?
astronomers and physicists in general.
Can I ask a question?
So that's how it is used, and we can look
Can't
at
hear me.
the starlight,
Let
which
him
is
finish
reflected.
explaining.
Are being muted or something?
Ask a quick question, please.
No, Robert. Chad is asking if he can ask you a question.
Go ahead.
When you say you can tell what things are made of by the light they emit, is it the thing that you're telling what it's made of, or is it the atmosphere of the
can you hear
thing
me?
around it? The atmosphere. Can you hear me?
I can hear you, Chad.
You can't hear me. Robert
Can
can't
you
hear
hear
me.
us, Robert?
Me?
Robert.
Hello. Can you hear me?
Robert.
Yeah, we can hear you, Robert. Can you hear us?
Okay. Yes, I can hear you perfectly.
Okay, so Chad's asking you a question right now, so go ahead, Chad.
Can you hear Chad? Sometimes
No.
there's a thing where you won't be able to hear certain users. I don't know what
can't
that
hear
is.
I didn't hear a question from anyone.
Oh.
Question. Can you hear me now?
Can you repeat the question, maybe? The people who I can hear?
I'm
That would be
repeating
fine.
now. Is it the object that you're seeing the light from, or is it the atmosphere around the object which you're seeing the light from?
I'm hearing nothing. I'm sorry.
Oh, hey, Robert, will you just try leaving the voice chat and coming back, and sometimes it resets the sound?
Press back, I guess. Just hold on.
Just like disconnect and then reconnect.
I'll try.
Yeah.
That's a problem. It's a problem with
Yeah.
Discord.
It's the phone with
Refresh on the page. That's what I do. Hear me now?
Okay, yes, I can hear now. Are you Chad?
I'm Chad, yeah. I was asking, is it
perfectly.
the object which is that is emitting the light that we can see, or is it the atmosphere around the object which is making the color of the light different?
If we're talking about a planet, an exoplanet, is that what we're talking about?
Anything we see in the sky, is it? Are we seeing what the actual planet's made of, or are we seeing what the atmosphere is?
We would be seeing the atmosphere of exoplanets. That is what we're able to see.
Right, so we don't actually know what the planet looks like itself then.
We have a very, very bad low resolution image of something called the Beta Pictoris system, where we can see a few pixels of the planets, but that's all we have. We don't have
Actually
any
seeing
clear
the planets, we're seeing the air around the planets then, yeah?
Well, I mean, of course you're going to see the surface of the planet. I mean, you can't look through a planet that's opaque. So yeah. We are definitely not in the position to see actual, good images of planets at this point at all. They're way too far away.
You talk about the planets in our solar system, Robert, or what planets?
Sorry, no. We're talking about exoplanets. We're talking about planets around other stars. We have very good images of our own planets. But
Okay, I just didn't know. I wanted to be clear about what you were saying.
Yeah, sure. We have excellent imagery of our own solar system, but we don't have pictures of other planets around other stars, aside from a few pixels, which were basically just there to show that we could do it. It's really, really hard to see them because the star, of course, is very bright and it's blinding out the planets. But we did manage to do it once.
Hey, Robert. Can you hear me?
Yes.
Am I in the channel? Yeah.
I can hear you. Yeah, sure. Hello.
Wait, you can hear me?
He can hear you.
He can.
Yes,
I can hear you.
Have you heard about
Maybe you
solar
can't hear me.
luminescence?
Sonoluminescence is this weird phenomenon which causes light from sound waves and bubbles.
Yeah, in light. In water. So what? Scripture has the word of God, It has the dividing of the waters, and it has the light. I mean, that's all of the constituents of that scenario right there. So, you know, there's
I
light
mean,
in
if
that
you
parallel.
want to interpret that Genesis line as solar
No, we're
luminescence,
not
then I
talking
can't.
about religion here. We're talking about the flat Earth.
No, but I mean, it's fine. If you want to interpret it like that, I'm not going to.
No, it's fine.
In that case, I won't answer it. Anyway, Chad, did I answer your question as you wanted? Because I feel like we didn't get into the atmosphere versus surface.
I mean, like the sun.
Discussion.
You know, are we seeing what the sun's made of, or are we seeing the sun's atmosphere?
We are mainly seeing the atmosphere of the sun. I will
We
agree.
don't know
to
what
you
the
on
sun's
that.
made of. Then we're just seeing the atmosphere.
Well, we can see what the atmosphere is made of, but the thing with the sun.
Do you know
is
what
that
the
it's a
sun's
totally-
made of, or not?
Oh, the atmosphere of the sun is
What
made
the
of.
atmosphere is
and
made of.
Yes, and we have very good seismic data for deeper into the sun, and of course we have clear understanding of what's going on in the core of the sun.
Sorry, did you say seismic
You're saying
data?
you can only see the atmosphere of the sun. That's all you can see, isn't it?
Well, yes, but
You said spectroscopy. I can't even speak. Spectroscopy. I just had a coffee. I can't speak. Sorry.
Spectroscopy.
But I think
Deals with light.
what you need to remember is that the
Deals
light
with
that
light.
comes
We're
from
talking about what we can see.
Can I
See,
respond?
when we look at the star, what we see is its atmosphere, isn't it? Not what the actual star is made of. Wrong or right?
You're completely right. What we see directly is the atmosphere of the sun.
So we don't know what the sun's made of, do we?
Well, we do, because the sun is not. The sun is not.
Spectroscopy.
Or
Let him speak.
The thing about the sun is it's not a solid object. The photons that come off the atmosphere come from inside the core originally. That is how the sun works. It is a ball of plasma.
Okay, I have a question, Robert. How do you know that?
Well, because we can see the motion. It's not really.
I'm saying, how do you know it's coming from the core of the sun?
Yeah, that's a good question. We know that because we can see the convection patterns. Do you know what convection is?
Yeah, we know what convection is.
Convection, you can see the way the flow of the plasma is working. That we can see, and we can see the magnetic fields of the sun. At least we can measure it. And the magnetic fields also tell us how the plasma is moving.
Okay, but you were saying that you can only see from the atmosphere of the sun. But you said
we can only see the surface.
How do we actually measure the magnetic field of the sun? I'm not
it's
sure.
kind of difficult from the Earth. That is a good question. It's really hard to do from the Earth. We have a solar probe which did it. You have to actually send the probe.
That's what. I know we can measure magnetic flux with a Gauss meter or a flux meter. So I was wondering who probed the sun or got close enough to get a Gauss reading or magnetic flux density reading of the sun.
Exactly. We had a probe of that. I can't remember what the probe's name was. It's about 10 years ago. We did a really nice mapping of the solar power, and it has some really weird properties, which we have no idea why they do. I mean, it has a northern magnetic pole, but not a solid southern one, which is super strange. But whatever.
How close did that probe get? Do you have any idea?
I don't know. Closer than Mercury, definitely. It was incredibly.
It did not melt. Yeah, I was about to say, what kind of material? Because I like material science myself.
That's cool.
What kind of materials?
Is it the Parker one? The Parker solar probe?
Parker's
probably. Honestly, I only know about this probably from.
Just summarise what I think of what you've said, Robert. Before I'm going to stop talking after this. Basically, you said we can know what the sun's made of because of this spectroscopy. We can only see the atmosphere. We don't know what it is. So you just lied, and I'm finished with you. Thank you very much.
That's cool. Anyway, anybody else?
It's also a fallacious reason.
Hey, Robert, if you look in voice text for everyone, I have a little shot where it's a picture from ESA where they show an event on the surface of the sun where it causes ripples in the sun's surface. Cool. So I want to know how that could happen if the sun is not, or is a gas, or is just plasma.
I mean, there's no big. You think that these ripples would require a liquid? Is that what you're implying?
Well, Does that happen in plasma? Because I've never seen it happen in plasma.
Happens in gravitationally bound plasma, of course. All you have there is an emission of energy. I mean, I've never seen this photo before, so all I'm just doing is looking at it. But these ring waves, that's a disturbance in gravitationally bound plasma. It doesn't surprise me that it looks like that. It looks cool, though. What's the scale?
How
of this
do you
thing?
know that it's gravitationally bound plasma?
We know it's plasma because we can measure the temperature of it and we can measure the composition of it. And that's just, we know the pressure, we know the temperature, it's not a big deal.
You're measuring the composition, okay, from the light based on, you're inferring it or correlating it to the composition of metals or the light that's emitted by the plasma of the metals here on Earth, correct?
Not metals, because
well, like sodium metal, or you can go noble gases. I mean, metals do. Like I play around with this stuff too. Believe it or not, I like vacuum stuff, especially lighting stuff. So yeah, I mean, mercury is a metal, and we have mercury plasma or mercury vapor lamps. Sodium is a metal, and we got low pressure sodium and high pressure sodium lamps. And yes, we do know that, like the spectral, whatever. What do you want to call it? The spectroscopy of it, or whatever, that complicated word. So you're just correlating that data with whatever you're getting from the sun, right? And then you're hypothesizing that, hey, you know what? Since this is like that, thus the sun is X metal, or a blend or amalgam of these metals, right?
Well, apart from the fact that it's not metals, it's hydrogen and helium. But yeah. We have no other way. Yeah, but that's beside the point. We have no other way of getting those spectral lines unless hydrogen and helium are present, basically. Those spectral lines will only occur if hydrogen and helium are there. So we know what the sun is made of from the Fraunhofer spectrum. Does it emit sodium spectral lines or not? Yeah, it has some sodium in there, but it's not very clear. But it does have some.
It does, right? Doesn't it?
You say that it was the atmosphere which makes the light. And you've just gone back again. We've already told you it's the atmosphere. You just said it was, and you've gone straight back to saying it's the sun.
The atmosphere is part of the sun.
We're analyzing the light from the sun, correct, Robert?
The light that is emitted from the surface of the sun. That's all we can do.
Oh, correct. Right. From the sun. I just call it the sun. I do not know what it is. I'm just analyzing this light that I'm receiving here on Earth, right?
Yep.
It's not science then, is it?
It's definitely not science, is it, Robert?
Yeah. It's good correlation, but it's not definitive,
Yeah, it's not. We're not doing science here, are we? We're not proving cause and effect relationships, are we? It's just correlations and inference.
You wish to call it that, but I would just like to say, what on earth? What else would make those spectral lines if it's not those?
So you do agree that it is an assumption then? But like, as you might put it, an educated
guys. You got to stop being hypocrites and stop yelling at him. You're telling.
No one's yelled. Angry. No one has yelled.
You're putting him down like what he's saying is just ridiculous. It's like you sound like a bunch of children, not even considering.
Yeah, mute that guy.
Sorry, I can't deal with that. No one's shouted at you, mate. So let's carry on.
No, I'm fine. I'm completely fine. Yeah, I mean, I get what you're saying. You're saying that it is not definitive proof.
Right. So we would say it's an assumption, though, right? Wouldn't you agree? An educated guess?
I would say that it's much closer to being a fact than being a guess.
Okay, but you're still dancing. I'm a flat earther, okay? And you came in here and called yourself a physicist. So be honest to me. You don't know what the Polaris star is made up of, do you? You don't know, do you?
I don't know, because that's not how science works. Science works by getting the best possible guess.
No. You're a physicist. You're a scientist. You do know the scientific method, don't you? So science proves cause and effect relationships, doesn't it? And start telling me this isn't what science does. Science proves cause and effect relationships, yes?
Science proves nothing. Science establishes theorems. Proofs is for mathematics.
Pardon?
Oh.
No, hold on. Let me get this right. Scientific method, we are doing cause and effect relationships. Science studies the physical and natural world. The question we ask is, what causes that effect After we have proven cause and effect relationships, after experiment and validation, we can then move on to scientific theory, taking the things of which we have proven and building our theory upon the things that we have proven.
And nope.
I can't believe I'm actually explaining this to a physicist.
We need to
No,
agree on what
it's not true.
means. Always continue this. Because I would disagree on that definition, essentially. What a proof is. Because you can't prove anything in natural sciences at all. All you can do is get very close by consistently attempting to falsify your theory. And if it fails, then you get closer to the truth.
You're talking about logical deduction, Robert, right? Logical deduction.
I'm talking about proof, as in what happens in mathematics and logic. Yes, and that doesn't happen in science.
Hold on. Do you think maths proves things?
Of course, maths proves things, but it doesn't prove anything about the natural world.
Okay, so maths not proving things, yet we're studying the physical and natural world, and in science we prove cause and effect relationships. After we've proven those causes, we can then go on to build scientific theories.
Is your definition?
So no, your maths isn't proving anything, and you're not doing any actual science, are you? You're basing it upon an assumption.
Try again.
And it's not his definition. I have 5 university papers that actually comply with what he's saying, if you'd like to see them.
What I'm saying is, mathematically, you can prove things within the realm of mathematics. There you have proof. It's easy. You can prove lots of things.
Can you put yourself on mute? I can hear you.
Hear me?
Your hot mic and Vito.
What's good, gamers?
Am I visible?
What's good, gamers?
Can you hear me? I think maybe
we can hear you. Yes,
yeah.
We can hear you.
Oh,
How
okay.
are you doing? What brings you to this Discord?
Hold on, G1. We're having a conversation, bud.
Heck yeah, hold on.
Proof.
No, we're talking to Robert. Hold on, man. Go continue.
So it's about what proof is. I mean, is it the big question is, can you prove any statement about the natural world?
If you can physically manipulate your presumed cause of the effect, then you've proven the cause of the effect. It's not like you are going to the sun or the stars and physically manipulating that actual thing. You're basing it on the inferences of things that you can do here, and the formal logical fallacy because of what you say light in the sky does based on your inferences. This is not science. You're not proving cause. You can't physically manipulate the sun, can you? You can't get there.
What you're saying is indirect measurement doesn't count for you. Is that correct?
Indirect measurement. Well, it's a nice inference, as I said, but you're not doing science. That's the only thing that I'm saying.
So look, you have 2 methods. You can do non-experimental, where you lack independent variables. And the best you can do with non-experimental is correlate. And we know in science, correlation is not causation. Now, if you want to establish a cause for something and prove that's what it is, you then do you have to manipulate that independent variable so you can establish that cause and effect. So a non-experimental, you lack the independent variables. Experimental, you have a manipulation of it.
If you want to establish a correlation, you cannot prove a correlation. Not in science. It's just not possible. But you can get really, really close to accepting it as true. That's easy. But I think we need to talk about what an indirect measurement, why would that be a less plausible measurement than a direct measurement? Would be the problem.
Can I say something about the sun and the spectral lines real quick, Robert?
Sure.
Let's say if I have a source, because that stuff, it's very intriguing. Let's say if I have a source of some ultraviolet electromagnetic radiation, correct? And it's contained within a boundary. On this boundary, I have phosphorus, which we know it does react with ultraviolet electromagnetic radiation and emits light. Now, we can change the composition of the phosphorus to get whatever, light temperature we want. Now, if you, with your measuring device, with your whatever, however you're going to do your spectroscopy, or whatever that word is, what kind of spectral lines are you going to get? And are you going to be able to tell that this is coming from a UV source inside of this boundary? Or are you just going to pick up the light from the phosphorus?
It will just pick up the light from the phosphorus.
Correct. So you'd have no clue what's going on inside of the phosphorus bulb, right? These are whatchamacallit, what do you call it? These are the UV bulbs. I forgot.
I see what you're saying. But
what I'm saying? Back to the sun, because you were saying we're just picking up these spectral lines from the sun. So you said it's fact, like we know what this is, right? But we've got no idea what the primary like mechanism could be. We've got no clue. Like you just be picking up the stuff from the phosphorus, and you've got no idea what's going on inside, or if there is an inside.
I will disagree that I have no idea. Of
Well,
the composition
okay.
of what's inside the lamp, but I do know how much energy is coming out of it.
I think he's saying to be certain, not have an idea, because that would just leave you open to saying that, yeah, I could have an assumption, but not to be certain about it. And I think that's what he's getting at.
I think I mean, correct me if I'm wrong, but I think the question was, if you can only see the surface light of this phosphorus, then you can't know anything about what photons stimulates in the phosphorus, right? That's what he said, and I agree with him. You can't necessarily say anything about that, right? So it's not just an assumption, it's just about that. But we do have information about what's going on inside. Not necessarily.
Well, because I brought you an example of the fluorescent bulb, and we know how that works. And we know that phosphorus reacts with UV. So again, back to the surface of the sun and what is the primary, the prime mover for this light? We have got no clue. We're just analyzing the light, and then you're deducing, or you're correlating. Oh, okay. Let's say the sun is emitting a very high spectral line of sodium, thus it's sodium. It has a sodium core. You can't do that, really. You can assume, sure, it's just an assumption, though, and that's it. It's not fact. And you can't write it in a textbook as like, oh, yeah, we know exactly what's going on.
I see what you're saying.
Again, with the fluorescent bulb, you're just picking up whatever light the phosphorus blend I put on the outer shell of the bulb is. And, of course, if I make the bulb out of quartz glass, it's going to let this UV come through, and you will be picking up UV, too.
So, okay, let's say that we're an alien, and we found this fluorescent bulb, right? And we have no idea how it works. We have no clue how it works. We do spectral analysis on it, and we see, okay, we're getting some lines from it, and by analyzing those lines, there's phosphorus. Do you agree that's definitely that's the conclusion we can make, right? And that's not an incorrect conclusion.
No, it's not incorrect. No, it's not bad.
So what we can say is, then they can say, okay, well, what's going on inside this? We can also measure how much energy we are getting out of the light bulb, right?
Sure.
So we can say something about, well, how much energy in total are we getting out of the light bulb? Meaning we can calculate energies are going into the phosphorus to excite it, to make it transmit this.
Within a margin of error, of course, because there are losses, as you know, for sure, of course. But yes, I'm with you.
That means that we have information, indirect information, about which energies have excited the phosphorus.
But then you have to know how phosphorus works, though. And you said we've got no clue. We just picked up phosphorus spectral lines.
I didn't say that. I said we're aliens who found the phosphorus bulb. We're assuming that these are aliens who have actually done experiments.
Yeah, but that's a hypothetical, Robert. We're getting into the realm of like hypotheticals, and we're trying to get to the basis of understanding things with certainty, and we're going into like aliens, and that we're getting off the topic, even talking about what we're subject here. So yeah, I just want to bring it back to that. But we're going to ask a few more questions, but then we're going to try to get to the shape of the earth and so on. So, but please go ahead and finish what you're.
Okay, cool. I mean, the only reason I mentioned aliens was just to sort of get this concept, because what you said was that we already know how a phosphorus bulb works, so that's why we know where there's UV. So I just added the aliens to give an sort of a framework where we could talk about it. I'm not actually saying that there are actually aliens looking at the light bulb. Yeah.
Right, I get
Is though that if we understand how emission works and how emission and absorption lines work, we can calculate by the energy output what the energies that were used to excite the phosphorus were, and then we can correlate that with other spectral lines because those energies would be UV energies, and we'll be able to say, okay, well, it's definitely not argon inside because argon cannot emit this energy, etc. So we can infer it like that. It's not these poor aliens or whatever who are looking at this light bulb.
But
are
mercury, you brought up argon, noble gas. Mercury does emit UV, though. So would you know that it's mercury, or would you know that it's just UV?
No, you'll know which wavelength. That's the whole point.
Well, you can't. It's blocked by the glass. You're only picking up the phosphorus. You're not picking up any UV.
No, because you know that
the boundary conditions do not allow this higher excitement of electromagnetic radiation to pop through. So you're only getting the secondary excitement.
Matter if we can see that the phosphorus has been excited to, let's say, the third energy level or whatever. If we say that's happened, then we know what the exact energy required to excite it to the third energy level is, because we know phosphorus energy. We know what the exact energy of that photon was, and then we know which elements have emitted that photon inside the bulb. It's not just UV or not UV. It is a direct measurement. There's a clear number that we get, not just...
We have a direct measurement of the emitted light, correct. But we kind of, if we don't break the bulb open, we have to assume from here on out, correct?
No. Nope. That's the whole point. If you
you can never, ever know that there's mercury inside of the bulb, because you're not going to pick up any spectral lines related to mercury if I design the glass composition correctly. And I do play around with this stuff. That's why I'm just bringing it up, because of the sun and all of that. So I do have some plasma chambers and stuff. I do play with this stuff. So I'm sorry if I just caught you off guard, but it's all good. It's very interesting to me, like, how you guys figure this stuff out without actually probing the sun. It's extremely interesting.
You can totally tell that you understand this stuff. But what I'm saying is, since you understand this stuff, right? So you know that if you get the full spectrum of visible light from mercury, you get the full spectrum of all radiation from phosphorus on the sort of the outer bound of this light, right? If you know that, then you also know the energies that are being emitted from inside.
Well, I don't know how much losses are going through, but sure, we can, I can say, in order for me to get this much light, I would need this much excitement. Okay, fine.
Because to excite phosphorus, you need the exact right wavelength. Otherwise, it doesn't get excited. Then it just passes through.
Okay, cool.
So if it's been excited,
I do know the properties of phosphorus, correct? So this element that's going to react with my primary waves, that's going to give me secondary waves, you want to call it that. I know some properties about the phosphorus, but if you correlate that with the sun, okay, the sun is emitting this stuff, and I've got no clue what the surface of the sun is. Now you can say we got these hydrogen fusion reactions in the flares of the surface, right? But that's also an assumption. We don't actually know. Like phosphorus, you can probe it because we know about it. We have it here on Earth. We don't have a sample of the sun. We never sampled the sun.
We understand what you're saying. You tell me that
we've got no idea what the primary mover or the secondary mover is, or the secondary stuff that's emitting the visible light. And we've got no clue if there's a primary electromagnetic radiation that's causing the secondary electromagnetic radiation, which is visible in spectrum.
Okay. So what you're saying is, let me just understand what you're saying. You're saying that it's possible for us to detect the phosphorus in the light bulb by looking at the lines coming out of the light bulb. Time that it's not possible to say what the surface of the sun is made of, but that's the same method. So why does one
can infer that? Yeah, if let's say you pick up phosphorus spectral lines, you can make an assumption, a good scientific assumption that okay, so the surface must contain phosphorus, right? That's fine. I'm okay with that.
So what's the problem with applying the exact same method to the surface of the sun?
Well, the phosphorus, I brought up the phosphorus to be specific because phosphorus works on, it's a secondary thing. There's a primary, which is the UV. Primary emittance, then it's exciting the phosphorus, then it's giving you the secondary light. So with the sun, you're just analyzing the visible, and we're drawing conclusions with the visible stuff, but we really have no clue what's going on. Anyways, I'm sorry if it's taking too long.
Jump in a sec.
You guys can
if you want to
switch subjects or whatever.
It's fine, but it's a cool thing to discuss. So
no, it's very cool. I kind of like this stuff.
We are able to know what the surface of the sun is made of by the exact same method that you use to detect the phosphorus.
Right, yeah. You assume that it's phosphorus, right? Unless you actually break the bulb open and you sample what's inside, right?
Well, no. I think there's no other reason for those phosphorus lines to be there.
Because we have phosphorus to begin with, and we have measured what phosphorus emits, and we recorded that. Thus, we know Okay, phosphorus, because we actually played with phosphorus to begin with, correct? That's how we know these. Agree? Okay, then, all right. So because we have had this stuff in our hands, and we played with it, measured it, recorded it, okay, phosphorus emits X, quantity X. Thus, if I measure some light and it gives me quantity X, then most likely it shall be phosphorus. Cool. But now, give me a piece of the surface of the sun so I could play with at home and measure that, and then I could tell you, same way we did with phosphorus, because you played with phosphorus to begin with. But if I give you this new, if I come out with a new substance that it's not phosphorus, this crazy amalgam, maybe it's just a mixture of all this stuff, who knows? Just this new element, let's say, right, hypothetically, right? Let's say new element you never played with, and it emits crazy spectral lines, all of it. Would you know what this element is?
Do you know what? This is actually kind of cool. Can I tell a story about this? Because you are actually putting a finger on something which has happened in reality with the sun.
Go for it.
When we started doing this spectral line stuff, that happened in the early 1900s. That's when we figured out how all the spectral lines worked. And everybody, of course, we took whatever element we had on Earth and we measured the spectral lines. That's what you're saying. Like, we got them, we have them in our hands. We have hydrogen in our hands. We have lithium. We have everything. We can test all this stuff and get all the spectral lines. And that's what we did, of course, because we're physicists and we're massive geeks. So we do this immediately, and we have all the spectral lines, and we're really happy. And then we look up into the sun, and we see these absorption lines, and we say, hey, check that out. That's how cool is this? The lines for hydrogen is in the absorption lines of the sun. That must mean there's hydrogen in the sun. That is the conclusion, right? And we do this, and we find lots of lines. And you know what? When we figured out all the lines that we knew, there were some spectral lines that we didn't recognize. We were exactly where you told me, where you said, what happened? There's an element we had never seen.
Right on. Right on. That's the point I was getting at,
We noticed this in the sun. We're just like, what the hell is this element? We have never seen this in the lab before. All we can say is, okay, the lines are here, but we've never noticed it before. So we named the element after the sun. We called it helium because we'd never seen this element before. Helios, of course, heliocentric. Right. This is the word that every flat earther knows. We called it helium because we noticed it in the sun's lines first. What this is.
Right on.
And then later, like 20 years later, we finally isolated helium in the lab, and we're like, oh, we found it. That's what it was. Sun first. That's why it's called helium.
No, I get you. I like helium. Gives you a nice reddish glow. Pretty cool.
Cool substance. It's an absolutely insane substance. It escapes into space and stuff. Cool. Anyway, I feel like we talked a lot about this, and there were questions about the shape of the Earth, I guess you want to get to.
Yeah, we got light nerdy on these guys. I'm sorry, guys.
Yeah, we got people probably waiting in the wings. Does anybody want to ask?
No, it was fun. I enjoyed listening to that. I think we understand what is and what is not going on here.
We gotta be careful when we're like pretending to be logical, because, well, like, I know that's a bit of a vague statement, but Platonic logic is kind of hard to stick by because it's the razor's edge, So.
Right. Is there any questions that anybody has? Since Robert's a physicist and people want to ask questions and
So
find
Robert,
out.
Could I give you, say, a metaphysical question? You just like what you think about it.
If you want to give it to me, I mean, I'll just answer on that level that I can.
Okay.
Sure.
So, do you think condition is unconditional?
Can you define your term, please?
Condition being being, or definition.
Are you asking me if you think that existence is necessary, like logically necessary?
No, not necessary. No, not like that. Like, it's kind of like this. When something is conditional, it's a factor. It's part of a multiplicity of actions, right?
You sure?
Right. So
yeah, go ahead.
Multiplicity is kind of the derivative here, because everything derives from it. From self. What would be the word? Oh, I don't know.
Kind of struggling understanding what you're saying, but is this kind of the question of why is there something rather than nothing? Is that kind of what you're asking me?
Yeah. I guess if you can treat it like an open-ended question, then go for it.
Okay, well, that's a great question. I don't know. There is something, and I really can't tell you what nothing would be like. There's one of those questions
like
that physicists
how I see it.
have any interest in answering.
How
But
I'm
it's a
kind
fun
of seeing it is that if you divide opposing forces into time, then in a sense that is a nothing, right? Waiting to cancel out. So perhaps that's the answer to the paradox. But we either came from nothing or we never came at all. Like, at least in my eyes. But
I can't answer that at all. I mean, I am not.
Doesn't that make sense though? Like,
yeah, I'm not really.
If we
to be quite
said,
honest, but
if we said, where did this come from, and then it's like, oh well, where did this come from? Like,
that's called the infinite regress issue. If the question is either something has arisen from nothing, or there's always been something.
Well, what are we talking about?
Lots.
We're talking about some kind of weird physical problem. It's not really physics, but it's
Upon that subject, I want to ask you a quick question, man. Since you study the Big Bang and the beginnings, what is your biggest proof that the Big Bang actually happened?
We have two. We have the expansion of the universe, and we have the cosmic microwave background radiation. Those are the two. Do you want to explain why they are proofs?
Please.
Yes, please. Go, please. I love this stuff. Go ahead.
Which ones should we talk about? The expansion or the microwave background?
The never proved expansion and the microwave background, please.
Okay, which one first?
Are you gonna go with the WMAP stuff from the microwave background, or what? The WMAP satellite?
The Planck is later, but sure. We can talk about the measurement of the CMBR.
Yeah, go ahead, please. Yes.
Well, I mean,
let's do that one first.
So the Planck probe is the most recent and most highly resolutive image, but we don't need to look at the WMAP or even the original one. The CMBR in itself, black body radiation. Do you know what that is?
Yes, I've studied black body radiations and heat transfer stuff, but go ahead. That was a long time ago. That was like 7 years ago. If you want to refresh my memory, that'll be
okay. I'll just go through it. If you have something which has a temperature, it's going to emit radiation. If it has a temperature, it's going to emit radiation. Not only that, but it's going to emit radiation which wavelengths are dependent on the temperature it has. Essentially, the warmer something is, the shorter the wavelength it's going to spit out. Right now, you're presumably emitting infrared radiation unless you're really, really hot or cold. I'm guessing since you're a mammal, you're going to probably be emitting infrared radiation, just like me. Twinsies. So that is the temperature of an object is dependent on this radiation. But we have different ways of having a temperature, right? Because if you ask somebody, what's the temperature of a car? In question, right? Because inside the cabin is a different temperature than, inside the wheels, and that's the different sense of the engine. There's lots of different. You hearing me, right? Yeah, that makes sense.
Yep, I'm with you. That's
going to be different. Is going to emit different radiation wavelengths because it has different temperatures. So if you sort of looked at the car from a radiation standpoint, it's going to be quite complicated. There's going to be lots of different radiation coming out of it. The reason for that is because the car is too big to sort of transfer all the energy around itself. If you have rock and you can't heat that on one side without the heat spreading through the entire rock really quickly, because that's just how thermal conduction works. So if you take a little tiny rock and you heat it on the one end of it and leave it for a while, then it's going to have the same temperature everywhere.
Well, except the losses, or you're assuming a perfect environment where it's not going to have any, heat transmission or any heat transfer whatsoever.
Yeah, this is just a thought experiment.
Oh, okay, all right, yeah. Heat one side of the rock, okay. Yeah, eventually, it will transfer to the other side, yes, and it will cool off, or you don't want it to cool off.
It can cool off if you want, but it's going to have the same temperature all over the place. There's not going to be areas where it's hotter than that's pure statistics, really. You can't really
eventually.
You can allow it to cool off. Yeah, exactly, right. When you have something like that, when you have something which has the same temperature everywhere, of its heat radiation is going to be really characteristic. It's going to make something called a Planck curve. It's a neat little sort of bell-shaped thing. And it's always going to have this exact curve, and that's what's called black body radiation. Black body radiation only occurs when the object has a consistent temperature over everything. So a car won't have black body radiation, but this tiny little pebble will.
All right. Okay.
The only way that you can have, because if we look at the universe now, I hope we agree that it doesn't have the same temperature everywhere. I'm pretty sure we agree that the Sahara Desert is hotter than where you are. You know, the universe has different temperatures, right?
Yeah.
So
you mean the universe as Earth, man? You kind of got me confused. I was looking up in the Alpha Centauri or whatever. It's like, oh, okay, what's he talking about?
The universe is everything. But I mean, I'm just saying, as a flat earther, not necessarily you don't have a universe necessarily. You just have the Earth. But no matter which model we have to agree that if we looked at the heat radiation of everything in the existence, there's going to be all kinds of different temperatures. Yeah.
Sure.
So that makes us really curious. Has there ever been a sort of a flash of heat radiation that emitted from the entire universe at once? And if so, can we see it? That's the big question. The great answer to the can we see it thing is yes, we can, for the beautiful reason that radiation cannot escape the universe. Once it's here, it's going to stay here because there's no way out. So when we have a flash of light from the early universe, it's got nowhere to go. It's still here.
Well, you're really assuming that there's no way out, though, right? Because I thought in infinity, I mean, it just keeps on going and going and going. Maybe the radiation has traveled further away, right?
Now you're assuming the universe is infinite, which you don't have any basis for. But
that's what they say in the science books, man.
An ever-expanding universe into infinity.
Exactly. Right.
Okay.
That is what we're discussing here, the cosmic, background radiation.
Philosophically, we can just philosophically define it if that helps.
God bless you.
We can define it by simply saying the universe, by definition, is everything that exists. If we do so, then there is no way out, right? Because then we've defined ourselves out of that problem. If you really want to do it like that. So, in that sense, there is no escape. Actually, there's no escape. Heat radiation, no escape from the universe. I know, so dramatic, right? No, I can't get out. I don't really want to leave the universe. So I'm pretty cool about it, to be honest. So we have this. We can expect to see this light, but we didn't see it until the 50s, where it's a quite cute story. We had two radio astronomers who were trying to measure, and they had this noise, this background noise, which was really annoying them because no matter what they did, they kept picking up this noise, and they thought it was like pigeon crap on the antenna, and it turned out to be, the echo of the universe from old times, which was quite funny.
Or actually, microwaves being emitted from the water on Earth.
And they thought all kinds of weird stuff. They thought that they tried all kinds of things.
I've looked at the data from the WMAP and stuff like that. It's a joke. Like they keep on fudging it, or that's what they did. They kept on fudging it, until they got what they wanted, because the microwave noise that was being emitted from the water, because we know, right, what's a good absorber is a good emitter. Water absorbs microwaves quite well, and it also emits it quite well. So what they really got in the beginning is just this, they got bombarded with signals. Like, it's all noise. That's all they got. So they kept on just tweaking it, and putting correction factors and correction factors and correction factors until they got what they wanted. Here it is. Right or wrong? Am I lying here?
Well, I'm misinformed.
Ooh, dude, you gotta look at the history of that stuff. The correction factors. When did those guys with the WMAP put that stuff in? Because all they were getting is just straight up noise. Nothing but noise. So they kept on fudging it. Like what physicists are good for. They fudge. It's called a constant. They fudge stuff. Oh, yeah, well, you know what? This is the result. Yeah, you're right. However, you got to multiply it by this. It's like, why? Oh, so you get the result you want.
That's what I mean. That's not how it went at all. But that's okay. Can I continue my explanation?
Yeah, go ahead. I looked into history of that. That's why I asked you about it.
I
But
think you should look into it a little deeper, probably, and maybe find some sort of, a little more sort of fair. But okay, we can talk about it later if you want.
Okay.
But anyway, the point is, when we look at this radiation from the universe, which comes from every direction, and when we control for absorption in the oceans and all that kind of stuff, once we control for that, which is not a fudge, it's just basically making sure that we know that we're not measuring something which isn't the radiation from the universe. Once we get that fixed, and we know that we're not measuring something incorrect, then we look at it, and lo and behold, what we get is this perfect Planck curve, this completely beautiful, perfect Planck curve. I mean, the error bars on this thing are so small you can't even see them. It's just magically, perfectly a Planck.
After you got rid of the noise, correct?
Used a method which was consistent in getting rid of noise that we understood was there. Yes, that is not fudging.
Which wasn't actually noise, it was actually a signal. You understand that, right? That's my whole point. It was not noise. You know.
So what you're implying is that the WMAP data is faked. Is that what you're implying?
Yes, sir. Yes, sir. It's not by me, but other astrophysicists, and they come out and said that straight up. You know, they did. It was fudge.
Straight up.
To fit their model.
I think you misunderstood them at that point. Fudge, to make
the
conclusion.
Yeah, fudge. That's what in science we call it fudging. We don't call it faking, right? We call it fudging. Right.
But you're implying that we're trying to get a certain conclusion, and then we just
we're trying to get that perfect curve. So we fudged it until we got it.
You're claiming that that's incorrect.
Man, okay. I'm on my phone and I'm about to go to work. I swear I will look up for you when they exactly did this and how they did this.
Please do. We can talk about it later. But the point is that it shows that the temperature of the entire universe was uniform. That means that everything in the universe is everything else, and that is only possible if the universe was extremely hot and extremely dense. Looking down to the Big Bang, there's no way out of that. You cannot avoid this.
Okay, I think that from that point we can probably move on. Dem, did you have something you wanted to add or move on to?
I can move on to anything.
All right, maybe let's talk about the shape of the Earth. What gives you the best evidence, Robert, that you could give us that the Earth is a spherical shape? What's your best
geometry of the horizon?
The geometry of the horizon, you say?
The words based on horizontal.
Robert, did you say the geometry of the horizon?
The geometry of the horizon.
What about the geometry of the horizon?
The horizon is acting exactly.
What about my geometry on my horizon?
Hang on, sorry. Hang on. What was that, Robert?
Just saying that the horizon that we observe completely comports with the horizon in the sphere.
Really?
Yes. How would you go about doing that? Can you please walk us through the evidence of that?
Of course. Well, let's define what a horizon even is. We can actually give a horizon to any object we want. Okay, it doesn't have to be the Earth.
Let's talk about our horizon. We're the ones that are looking. Let's talk about the one that we perceive.
No, we're just talking about what a horizon even is. Okay, because if you have a hill,
yeah.
Everybody understands the horizon is the limit of your view.
Yeah, let him explain it. Cyclone, please let them have this discussion.
Yeah, sure.
So, if you're looking at a hill, now we're going to get back to the Earth. I promise you. Just let's put the Earth in the box for now, and we're going to come back to it. Let's just understand what we're talking about here. So, we're looking at a hill, and we can have it on a flat Earth if you want. I don't care. We're looking at a hill, and the edge of that hill is the horizon of that hill in some sense. Because what a horizon is the line of sight, the tangent line to the object. It is basically the lowest line you can make from your eye to the edge of that thing, and you can't look behind it. That's what the horizon is. That is what a horizon is.
Okay.
Now, the thing about...
Hold on. One quick question. So is this horizon going to cause obstruction? Like physical obstruction? Like if I were to try to shine a laser through this horizon, would it go through? Or is it the leading edge of the sphere Earth to you? Or is it an apparent horizon where it's a visual optical horizon?
You cannot see beyond the horizon.
That wasn't my question. My question was, would I be able to shoot a laser through this horizon? Or is it an apparent horizon? or is it the leading edge of a sphere where it's a physical horizon?
Asking me if it's possible to get a laser beam on the other side of the horizon from where you're standing. Is that what you're asking me?
Yes.
No, you shouldn't be able to do that.
Said no.
Choose carefully your response.
It's a very simple question. It's a can you yes or can you not? I mean, is it the leading edge of a sphere? Like it's actually like a physical place you can land on? It's the horizon, or is it an optical illusion created by the eyes?
It's not an illusion. It is the points on the Earth that are the furthest away from your eyes that you can see until the rest gets obscured by the shape of the Earth.
Okay, so we shouldn't see things past the curvature, right?
Guys, I want to build on it. I was building to something. Hold on. All right, wonderful. So now you agree that like I wouldn't be able to shoot a laser to that because it's the curvature of the Earth, in other words, right? Right?
Yes.
Okay. So here's the thing. Here's the problem with the globe Earth model. When a globe Earth see the horizon, they do call that the leading edge of the sphere. Or when they see any type of obstruction by that horizon, they call that the leading edge of a sphere. Now the problem is that when we actually go out and do measurements with lasers, high-powered lasers, a 0.8 millirad laser, about 2 meters above sea level, doing a horizontal pan from 6 kilometers, 12 kilometers, 41 kilometers. All target heights are 1.5 meters of height. Use the WGS84 model, which is the oblique spheroid model. We get that the shortest target at the furthest distance of the 41 kilometer mark should only be 90 meters. And if we added a 7.6R standard refraction, it'd be 85 meters. But these people are hitting 1.5 meter targets. So the problem is that we see what you think is curvature. Everyone could see that horizon. But when we actually go out to directly measure over water, we don't get that horizon whatsoever. We don't get that obstruction. We can literally draw a tangent line between 2 points and hit it. So there is no measurable curvature on Earth. It's only optically induced by people when they see obstruction or a horizon. But when you go out to measure it directly, there is no curvature whatsoever.
Do you have a concrete measurement? Do you have an actual data point here?
Absolutely. I'll send you the PDF. Yeah, I'll send you the PDF right now. 1 sec.
Let's just take one measurement at a time. So let's just have a look at one.
It was actually 3 measurements. It was a horizontal pan. Picture like the laser being leveled, and then they hit their first target, which is 6 kilometers, and then they horizontally pan it to the next target, which is 12 kilometers. They pretty much surveyed those 3 points with the laser by doing a horizontal pan, and all target heights were the same height. You know.
Okay, so wait, we have a 6 kilometer distance, and we have 1.5 meter height.
Yeah, the target was 1.5 meters of height. Correct.
What is the elevation of the laser itself?
2 meters. And the divergence of the beam at the furthest distance is about a 2 meter spread beam because it's a 0.08 millirad.
Have a look at that. 0.8 millirad. That's going to spread quite a lot over 6 kilometers. Let's just, I'll check that. But okay, yeah. Is it 2 meters over sea level?
2 meters above. Correct.
Sea level, not over ground, but over sea level.
Oh, yeah, from sea level.
So we are actually at the ocean doing this.
You mean over sea curve, bro?
It's a lake. They're right over a lake. I'm posting it. I'm posting the whole document, the whole document for you right now in voice text for everyone. It's called FE Core.
I've seen this before. So this is Lake Balaton, right?
No. This is all of them. Lake Balaton, Lake Hungary, Sweden, Lake Issel.
Which one do you want to take? We need to take a particular.
I was talking particularly about Lake Gisel, which is the 41 kilometer distant one.
We just find that one. That's the Balaton one. Just hold on. Okay, so
yeah,
Issel one.
It's Issel, ISSEL, Lake Gisel.
This is Dutch. Dutch people have weird ways of saying things, so ISIL is the pronunciation.
Yeah.
Who cares about that? So we have Lake ISIL is presumably pretty low. But let me have a look at what the elevation of Lake ISIL is. Just hold on. We need to have the actual answer. Okay, it's the surface elevation of ISIL is about. That's fine.
Hey, Robert, I was just. Forgive me. I was just curious. Is this the first time you've seen this?
No.
What Jose sent you?
I have seen.
Is this the first time you've seen
measurements before, but I haven't looked into them yet. So this is kind of fun to have a reason to.
Okay.
So anyway, we have the Lake ISIL things here. We have a target position here. Let me see what it says. It says that we have a blue laser placed 2.85 meters above the lake surface. And it was seen on the opposite shore at 21.26 kilometers to target 1 at 1.2 meters. That is on page something. I'm sorry, I can't see the page numbers on this viewer. This is measurement 3, Lake ISIL target 1. Is that okay with you? Did we look on that one?
Yeah, I'm looking at it too.
Okay, so we agree that that's the one on the 8th of April at 1 a.m. That's the one we're looking at, yeah?
Yep.
Okay. So let's have a look. We need to figure out what you're claiming is that this is impossible on the globe Earth, essentially, right?
Yep. Absolutely. 100% impossible on the ball.
That's your claim. So we have a 0.8 millirad spread. Do you understand what that means? What 0.8 millirad means?
Spreading.
You actually calculate that.
I have some
it's about 1 meter.
19-year-old kids here I want to sacrifice, you know. In which channel do you turn?
Sorry, what?
Oh, God.
I'm joking.
What?
Though.
No, I just didn't hear what you said.
Yeah, it's about 1 meter.
He was trying to make a joke. It wasn't funny.
I didn't catch it, I have to say. So the first thing we need to figure out is how much the spread actually is on 0.8 millirad, yeah?
Sure,
so,
it's 1 meter.
No, let's calculate this. I have 0.8 millirad. Do you agree that is the same as 0.045366 degrees? You are welcome.
No, he said 0.08 millirad, I believe, not 0.8 millirad.
So 0.08, okay.
Well, I would want Jose to double confirm that.
Yeah, it was a 0.08 millirad. I don't ever say the first zero. I always go with point. I start with the point, so it's 0.08.
They didn't
So that
say the
gives
size of the aperture coming out, though.
We'll get to that. So we have, that gives us a spread of 0.00458 degrees. Do you agree?
Yeah.
So we just need to figure out what that means. Do you know trig enough to do this?
Yeah. Oh, yeah.
We're just going to make a little triangle here. I can't do a diagram, but I'm sure you can figure it out. The one point is at the laser, and the other 2 points at the triangle is at the edges of the spread beam. Yeah?
Yeah.
Yeah, you're going to use tangent. Yep. Inverse tangent. Got it.
That seems meaningful. We have a distance of 21.26 kilometers. We don't know the spread, so it's going to be something like the tangent 2x over 21.26 is half that angle. Yeah?
Yeah.
Spitballing that. So let's just solve that.
Yeah, that's right. We don't know what the aperture is. So we know what spread is, but we don't know what the initial aperture is.
But I mean, we guess it does say what kind of laser it is, though, so we can check that afterwards. But let's just figure out the spread, assuming, for friendliness sake, that it starts at the point. Of course it doesn't, but we'll try. So we know that. And we know that this angle is 0.002 something. Okay. I'll just do some math here live on air. Isn't that exciting? So we have the half degree, 0.0229. I know, it's incredibly exciting stuff. So we need to do inverse tangent of that. Hold on, arctan.
0.9 meters.
Let me have a look. This is how we do things. So that means we have 0.02. Okay. Hold on. That by 21.
It would have been easier if you just used a calculator online.
That's what I'm doing. I'm calculating this from.
I won't bother you no more. Sorry.
I'm going to get a reasonable calculator here. 0.002. The tangent is equals to, well, hold on. Tangent to the angle. I'm being really slow at the moment. Just hold on a second. Okay, we're back. A little bit annoying. I apologize. So, Google, you suck. Okay, so that gives us, gives us a half spread of 0.09 kilometers, apparently. 0.09744 kilometers, which is 9.7 meters.
That's a
run through
huge spread, isn't it?
It really is. Do you want to do the? Do you want to run through the math with me, so we'll make sure that we're agreed on it?
I'm gonna fucking smash that.
No, I'll actually be more than happy to give you the 90-meter spread because that's still not enough. So go ahead, take it.
We'll take 10-meter spread just around. Is that okay with you? Just to
That's
make
fine.
it easier. We can. Okay. So now that means we also have an aperture, as it's been pointing out. We need to know the initial size of the beam, because that's of course going to be spread out. We are assuming a point-sized beam. So this is the blue laser pointer. It just says. So we need to know something more about what this laser pointer is. So let's go looking in the documents. WGS84 laser? No, that's not right. Right, that's not the one they use. That's a target correction thing. Anybody got a clue of what it is?
Yeah, they didn't actually list it, the brand or anything.
I'm guessing we need to assume a basic. I mean, it's going to have a pretty good range, right? Do they mention the power output of this thing?
They do. I have to go through the document. It's been a while since no one's really for that.
You can just assume, man. You can, give it a couple of millimeters or a few millimeters, 5 millimeters, whatever. You can start with the point, and then you can do another calculation with the, whatever beam look you want, as long as it's within reason, right? A few millimeters or so. Or I don't think it's going to have a 1-inch beam to begin with.
Oh, it's going to be.
It could though. It could. I don't know.
I mean, the thing is, if it needs to reach 21 kilometers, it needs to be a pretty solid laser. I mean, it's going to be a 200 milliwatts or 400 milliwatts or something like that. I mean, otherwise you're just not going to see it.
I think it's pretty expensive. Yeah, it might be a really nice laser.
I can imagine it is. If you want to, are you kidding me? This is a great toy.
That's a good laser.
Especially blue lasers, because they're quite expensive. Actually, the green ones are way cheaper. You can buy them.
But the blue ones are the most effective, I think, for long range.
Yeah, because blue gets scattered less, or gets scattered more actually.
So it's the green ones then, either green or blue, one of those.
I think blue gets scattered more. I think I think so, Robert. I'm not totally sure.
More on the blue, yeah.
Right.
All that.
I'm back, guys.
Refraction. I mean, you have to have a really solid case before you try anything,
Right, let's have a look at the expected curve, shall we? Just have something to do while we're looking for that thing. So, what did you say the distance was? 21.26 kilometers, yeah?
No, it was 41 kilometers. The furthest distance.
We are looking at we agreed to look at the measurement of.
The furthest distance was 41 kilometers.
Yeah, but
which is about 25 miles.
You know what?
Yes, but we agreed to look at the one with 21.26 because that's the one I did the.
I agreed to look at the 41 kilometer one, which is the furthest distance.
Yeah, but then we need
the longest one. Let's do the longest one.
Sure.
Yeah, because
hold on. That means we need to do a new calculation of the divergence because I did it based on 41.26.
All you got to do is look at that document and tell me what are your targets, because there's no pictures of the targets.
No.
Hey, Busted, we talked to you about this last time. Let Robert handle it this time, all right?
Sure.
You're kind of just interfering now.
Let's just have a look. It's just having fun. Red's rhetoric? I feel honored. Okay, let's have a look. So we need the one. Which measurement is that then? This is the one that's called the
latest kilometers furthest distant.
Measurement what? Measurement 5? No, that's not long enough.
Yeah, let's go grab it for you 1 sec.
I have here
6 to 7.
Yeah, there we go. 40.14 kilometers. Yes, that is the 22nd of April at 2:19 a.m. Do you agree with this? Is that the one?
Yeah, 1 sec. Let me just double check it.
It is. That's measurement 6.
We good?
That's correct. Measurement 6. What you said.
Yep. So that means we need what was the measurement again? It was 40.14 kilometers. Yes. Okay. So from a point laser, was a divergence of 18.39 meters.
How are you calculating the spread?
Starting from a point source, that is being very generous because, of course, it's not a point source. Then I'm looking at it as a triangle where the one point is at the laser, the two other points are at the upper and the lower edge of the spread beam.
The spread. That's a good question, though. Yeah, like a V-ray, like a shooting engine, you know, with all the lights and stuff.
Imagine a V-ray that just stops at 40.14 kilometers, and that gives us a triangle, right?
Okay.
And we know
Fair
that the small angle of this triangle is 0.08 millirads, because that's what's been told us in the document, and that gives us all we need to know, because we know the distance, we know the height of this triangle, because that's 40.14 kilometers, and we know that angle. So by doing that basic trigonometry, we get that the spread is 18.39 meters. I can run through the calculation if you want. We have an 18-meter gap, which we need to realize at least, based on a point source. So it's going to be bigger in real life.
Can you type out like the math you're doing? Because I want to double check, because I don't know how the hell you're getting 18 meters of spread.
10 of 0.04 millirad.
No, type it out in the voice text for everyone. Type out your whole math equation so I can see it, because I don't know how you're getting that spread.
That is what I'm doing. Do you want just the calculation, or do you want the I'm calculating from? And then we need 2x as the spread. Do you see that?
Let me see. One sec. So why are you putting a 0.04 millirad?
Because if you imagine that V-ray, you have to divide it into
we don't have to imagine. We know the millirad. The millirad is 0.08. You're cutting it in half.
Yes. Now listen.
Why are you doing?
We want a right angle triangle because that's easiest to calculate this, and we just simply split that V-ray into half. That means that the angle gets halved in the middle. Yeah. The opposite end. Yeah, when we're talking about we have this ray coming out of the laser and it's spreading as it goes. Up it at 40.14 kilometers, then we get a triangle. Drawing in here somehow? I don't think I can, but
I mean, like in V-ray, you have to bounce from something, you know, to another. You know, the ray has to bounce, you know. So I mean, if you end up with a triangular shape, it's your problem, you know. It's not mine.
We're trying to. Okay, you have a beam, right, and it has a certain size. Do we agree on that? Do we also agree that the further away we get from the laser, the diameter of this beam is going to grow? Yeah. Make sense? The diameter of the dot that we are seeing is going to grow.
Yeah.
Okay. So the diameter of the beam is what we're going to call, that's what I call 2x. It means that the radius of the beam is just x. Of the beam out to the edge. That distance is going to be half the angle of the spread, 0.04 millirads, to get the radius, as opposed to the diameter. And once I calculate that, I can multiply by 2 to get the actual spread.
If you're not spreading, is it by default double the angle? You know.
What I'm doing is I'm just making. We can do this. We can calculate it without doing all this halving. This is just basically an easier way to do it. If we have to do it the other way, we're going to have to use the law of sines. You can use that as well if you want. It's just a question of which triangle calculator you're using. If you prefer, we can just go into a triangle calculator and just do it. But then we don't see that the math works. I feel like we should
just
actually do it ourselves, right?
That's Nike said.
You can go into a site called coastsyncalc.com. I'll just give you a link, and you can just type everything in there if you want.
No, seriously though, I'm just messing with you, you know. But is this like a V-ray calculation, you know? Because I find it amusing, you know, interesting.
the calculation of how
listening, I'll read you from the from a book called 13.8: The Quest to Find the True Age of the Universe by John Gribben.
We're talking about something else
with,
now,
I'll start off with
the Big Bang, I guess. Yeah.
It starts off introduction. The most important fact. Now get this. This is the fact, right? And the origin of everything we see about us, stars, planets, galaxies, people, can be traced back to a definite moment in time, 13.8 billion years ago. Now that's a fact.
April the 1st.
Is a heretic. Fact, okay? Theory.
Which book are you reading from here?
Let's not argue then.
13.8: The Quest to Find the True Age of the Universe and the Theory of Everything by John Gribben.
Okay, so what's your point?
It's a fact. It's a fact. The universe is 13.8 years ago old.
Right, billion
years old is a fact.
According to him, sure.
Because John said so. Or,
this is what you guys are selling to the public. This is what you're selling.
What distance are you guys solving for the spread? What's the distance to the object? The 41 or the 21?
This is what's peddled out to the public.
14?
This sort of fact.
You said?
Lies.
Robert?
I don't really care what John Gribben writes. We're going to calculate this stuff now instead.
Yeah, what's the distance to the object that you're using for the spread? Calculate the spread.
40.14 kilometers.
Okay, 40.14. Okay, cool. Gotcha. Thank you.
So, are we good with the spread?
I'm still trying to figure it out, dude. Give me like 5 minutes, all right? Give me 5 minutes. I'll be back.
I'm gonna run the math myself right now.
I'm trying to figure this out, dude, because I don't know how the hell. Like, I think it's kind of strange that you're trying to cut the millirad to 4 and then add it later. I don't know. I think that's kind of just messing it up for me. It's confusing me.
He's just dividing the triangle in half, Jose. So he's solving for the like a 90-degree triangle to make it easy. So he doesn't have to use the law of sines and cosines.
Exactly. I can use the law of sines instead if you want.
Right.
It'll be the same result. I'm being lazy. But anyway, while we're waiting, 5 minutes, I'm happy to talk about something else.
Excellent. Can we talk about space? Is that okay? Can we talk about space?
Sure, as long as we get back to this FE core thing.
Yeah.
I'm fine.
5 minutes, I mean, you have a quick chat about space, yeah?
Sounds good.
Excellent stuff. So you're really into space. Obviously, it's your job. It's what you do. You look at lights in the sky and tell us what they are. That's brilliant. You've obviously been talking, as you said, you've been talking to quite a lot of flat earthers over the last however long. So you've obviously come up with the thermodynamic problem, air pressure and vacuum, yes?
I've heard that before, yes.
Yeah, so we are breathing air pressure said to reside within a vacuum with a vastly lower pressure system. So thermodynamic, when we're talking about energy transfer, especially air pressure, the air pressure would fill the void unless acted upon by a physical container. Where we have air pressure, we need a container. Unless you start asserting unless you start asserting two gravities, both of which you have no scientific evidence for. So what is your retort to this issue?
We are not in a pressurized system because the pressure drops when we go up.
That's a pressure gradient, though, isn't it? Still a pressure gradient, still has press in it, still needs to press.
Pressure gradient goes
it's
to
a pressure
zero.
gradient. Sorry?
Pressure gradient goes to 0 and then you're in a vacuum. There's no problem.
No, nothing's pressure. Yeah, we have an air pressure. It should fill the void. That's what it would do. Exactly what it would do. Just because we have a pressure gradient doesn't negate the air pressure needs to press upon something.
Well,
does it?
That were the case. if that were the case, then there should not be different air pressures at different heights. So you're missing something.
Why not? Why not? We
You
have
just said
different
that
gases. We have different gases. We have energy coming into the system. We have a dynamic pressure environment, a dynamic weather environment, a dynamic environment all told. We have different heat sources around the world, all different types of things. Yes, we have a pressure gradient, but the necessary antecedent for a pressure gradient is something to press upon. So the air is not going to the air is not going to contain itself unless you would like to demonstrate to me gas pressure without a container.
So you claimed that the reason that there is different pressures at different heights is because there are different gases, right?
Different gases, different pressure, yeah, loads of different things. So loads of different things.
The problem is that's not true. It's the same atmospheric composition up a mountain that there is down here.
Yeah, and you go higher up into the atmosphere and you get different gases. And I'm not saying it is not a pressure gradient. Of course there is, but that's got factors to do with moisture in the air and temperature. And obviously it gets colder the further that you go up. That's why we have snow on the top of mountains. My point is this, regardless whether it's a pressure or pressure gradient, that pressure still needs something to press upon. It's not just going to shade out and eventually reach zero and turn into a vacuum. The gas would fill the space.
That's a claim, and you're wrong.
It is. You're just going to say that I'm wrong. You are literally going to fly in the face of the second law of thermodynamics and say that I'm wrong. I'm quite surprised you haven't turned around and said gravity yet.
Of course, it's caused by gravity, but the fact is that this is
which one? Which gravity is it caused by?
Gravity that exists.
Which gravity is it caused by?
There is only one gravity, my friend.
And which gravity is this?
Robert, did you say that there is a place in space with zero pressure?
I said there's a vacuum. I'm not saying there's a perfect vacuum.
You say there's somewhere in space that has zero pressure?
Zero, but incredibly close to zero.
You say there was somewhere in space with zero pressure?
No, there's no space with zero pressure, but you get something which is so close to zero that it doesn't matter. Anyway.
But you said that. You said there was a minute ago. I heard you.
Fine, but that's an approximation.
You said it goes up to zero pressure.
That was an approximation because there's practically zero pressure, but thank you for correcting me. Anyway, yes, it is gravity.
No.
Do you want which gravity?
Yeah, which gravity? Tap, Chad.
I'm
going to do it again in a minute as well.
Hey, Robert.
I'm
sorry. Please, can I finish this conversation, guys? Please.
Oh, for sure. I'm sorry. I didn't mean.
No problem. Because I've just been told there's only one gravity. I want to know which one that is.
Ooh.
We're talking about. I'm assuming you're referring to the Newtonian model of gravity versus the Einsteinian model. Is that what you're doing?
Don't know. There's only one. So which one are you talking about?
I'm talking about the effect that we see. We see that there is a force. We can take it as a force. You can describe it as a space-time curvature if you want. It gives the exact same results. But let's just keep it simple and describe it as a force. And we do see there is a force.
They're mutually exclusive. One's in 3D space, the other one's in 4D space. Mutually exclusive.
It gives completely.
Yeah, because things fall down. So yeah, we have the exact same result. Doesn't matter which idea you come up with. Yeah, things fall down.
And also air falls down. Therefore, there's a pressure gradient.
Yeah, we have a pressure gradient. Yeah, it should disperse into the vacuum. My question is this: what scientific evidence do you have for, this gravity that you're asserting? What's your scientific evidence for it? Because you need it to negate a natural law.
And things fall down with an accelerated speed. That's why.
Yes, hold on. Hold tight. I said scientific evidence, not a mathematical calculation of things going down. No one's disagreeing with you that things fall at a certain rate. I want your scientific experiment proving your gravity. Very simple. Don't want your maths.
That you need a force to create an acceleration. Is that
no. I want your scientific experiment. I mean, when we started talking an hour and a half ago, 2 hours ago, I did have to tell you the scientific method and tell you how you weren't doing it. So now I would like your scientific experiment that proves gravity, not that things fall down at a road.
I have one experiment.
Just want a scientific experiment, hypothesis.
So
first we need to. Okay, please go ahead.
Okay, thank you. So you know Neptune, Neptune, the planet. Yeah.
What?
Neptune, the planet. You know what? You know Neptune.
Oh, Neptune.
Yeah.
Why the fuck are we talking about Neptune now?
Coming in throwing googlies about Neptune. Get out of it.
Go ahead.
So
let's go back to the scientific experiment that proves gravity. I don't want maths.
Okay.
I want your scientific experiment that proves.
Okay. So do you accept?
You know you haven't got one, don't you?
I know I've got one. I just don't know that you're going to listen to it. That's a different question. Do you accept measurement of acceleration as a measurement of force? Yes or no?
Sorry, I've got something in my mouth. Don't mean to be rude. I don't want to talk with my mouth full.
It's fine.
I agree that you can calculate how fast things will fall, depending on their relative, I don't know, density falling through a medium, for example. So if I was to drop a ball through the air couldn't support it, so the ball would drop. But if I was to let go of a helium balloon, helium obviously being lighter than air, it would rise. So yeah, I would agree. You can use a little bit of math to calculate how fast something is going to fall through a relative medium. But I'm not asking for your math. I want your scientific experiment that proves cause of an effect.
Let's try again. I didn't mention calculations at all. I asked you, do you accept a measurement of acceleration as a measurement?
And I expanded on that. So
we did not accept a measurement of acceleration is a cause of force.
Yeah, exactly.
Do you accept the measurement of acceleration? Do you accept that we can measure acceleration?
Measure acceleration. What are you talking about?
Do you accept that acceleration of an object can be measured?
We can measure things.
So you can measure acceleration, right? We're not calculating anything.
Yeah, you can measure acceleration, yeah? What?
Yeah.
Is that an effect and a cause?
Acceleration is caused by a force.
Okay, can you prove that force?
Just asking
what's causing the universe to accelerate outwards? What's the force?
Let's stick to one thing at a time. Do you accept that a force?
No, you said
is
there's
is
the universe, yeah. Well, I'm giving you an example of something that doesn't require a force to accelerate.
Maybe you could give us an example of what is relative to. So dropping something relative to a non-stationary moving plane, right? Or two cars are going at 60 kilometers an hour, and then one car goes 70 kilometers an hour and passes them. Like, we could measure that, but so what would gravity be measured in relation to what? Like, maybe
we're getting to gravity, but we just need to make sure that we actually accept these measurements.
Here's the thing: we accept that things accelerate at 9.8 meters per second squared. What's the cause of the acceleration is what we're debating.
That's a great question. But you accept that there's a force. That you accept there's a force.
Oh, we do not accept there's a force.
My God.
You accept acceleration, though.
Yeah, but we don't know the cause.
Lovely.
Einstein said it wasn't a force. Now shut up.
Yeah.
By the way, your math is pretty shoddy, bro. I ran the math. It's only 3 meters. Total divergence is 3.15 meters at 40.14 kilometers. Your trig is way off. And I snapped a picture of it and posted in voice text for everyone, so you can double check my math yourself. I mean,
I think you used 0.04 degrees and not rads. I think you've made a
no, I converted. No, buddy, I converted the rads to degrees, man. What are you talking about? I used 0.04 millirads to degrees, okay, and then used the tan of that, the tan of x over 40.14. Go ahead, just check my math yourself, please. I drew the triangle. Let me know what I did wrong.
Just check it again. Hold on.
Well, what I think could happen with maths is, considering it's a language and there's different ways for people to learn said language and then being taught said language, it's like saying I write out do not and you write don't with an apostrophe. I mean, that's really what it sounds like is happening.
Nope, that's not what's going on. So what do you get the tan of the angle to? Just alone, just the tan of that half angle.
I got you. Okay, the half angle. How much is the half angle, right? All right, so I'm gonna just go millirad right now. MRad 2 degrees.
I think you're right. Hold on.
Yeah, it's 0.00225, roughly, an estimation. That's the half angle.
I think I have you.
Did you?
It seems that you have to type degrees to make it calculate in degrees. I do apologize.
Did you? Can you see my work? I took a picture of my work and I posted in voice text for everyone. Can you see it?
Yeah, and you're right and I'm wrong. I calculated using Google calculators and I simply used, you have to type something in. I apologize, you're right.
No problem. Thank you, sir. It's not a right or wrong. I'm just saying, clarifying for everybody, at 40 kilometers, the total beam divergence from a point source, yes, I assume the source is a point, is 3.15 meters.
Accept this. Cool.
All right.
Cool.
Carry on.
Are we talking about the divergence thing again? Or are we talking about the force?
Wait, I think Dem had a point.
Yes, you can go and talk about the divergence beam because you are not going to give me a scientific experiment, are you?
Okay. Oh, you're not going to listen to it, so that's probably.
Jose said he needed 5 minutes.
Hold on, don't dismiss me, my friend. I'm going to let you carry on and talk to these other people, but you know, intellectually, honestly, that there are no scientific experiments that prove either of your gravity ideas unless you start asserting math. Now, you know that.
Don't, because we can see, objects directly.
This isn't a scientific experiment, though, is it? I mean, if it was, it would be an adherence to the scientific method, wouldn't it? There would be a naturally observed phenomena, wouldn't there? There would be a hypothesis where you presume your cause, wouldn't there? You could then go and do the experiment, wouldn't you? And then you could validate it, couldn't you? Yes, so you don't have a scientific experiment, do you? No, then exposed, I don't.
Well, you can deny it all you want. It's fine. It's just I do. It's quite simple.
Yeah, no, it's fine. But the thing is that you don't have a scientific experiment that proves gravity. So therefore, you can't overcome the second law of thermodynamics with something you can't prove. You just assert it to be true without actually any evidence behind you. Just a little bit of maths because things fall down. That's my point. You can carry on talking about your laser test now. Now somebody's corrected you on your math.
Okay, so let's go back to the laser test.
All right. Jose, where you at, man? You said you needed 5 minutes. Granted, sir. Math solved. All you, bro.
Okay, so it was.
I'm going to do a 5-minute warning here too. I'm sorry, I really have to go. I'm not trying to run away.
Yeah, that's fine.
I can come back and talk about all the rest of it later, but I do have a life as well. So let's just do the last 5 minutes on this divergence.
Okay.
So
we
found
now
out that we have a 3.25 meter.
Yeah, it was about
the end of
spread.
Okay.
I said 2. I was close.
If we assume a point source.
Right.
Agreed.
So now where are we at? How does that work on the oblate spheroid model? Even if it's the WGS84 model, which predicts that the shortest target you can hit on that oblate spheroid has to be 90 meters. And if we gave you the 7.6 art standard refraction, which is being generous to you, it shaves it down to 85 meters. How are we hitting a 1.5 meter target from that distance with the beam divergence being 3 meters?
Oh, am I back again? I hear nothing.
I could hear you. You're good.
All right. So, as I say, did you hear my 5-minute warning that I have to run? And I'll come back if you need to talk to me. Okay, cool. So we are agreeing that we have a 3.5 meter divergence.
Yep. 3.15. So just call it 3 meters.
Okay, cool. And if we look at the measurement, it says that the blue laser points were placed at a height of 2.92 meters. Yeah.
Yes.
Okay, great. That causes a problem because we can now calculate at what distance the laser beam will strike the surface of the water. The 40.14 kilometers, yeah? Because the divergence is more than 2.92.
Can you go more in depth on that? How would that be a problem exactly?
Because then we have reflection off the water.
Yeah, but where would the reflection be? Think about that. This is 41 kilometers I'm speaking of.
It'll go down on the surface of the water, then it'll bounce off it at the same angle. and that means we can measure it direction as we expected it to be. That's one issue that I'm just pointing out would be a problem here.
Again, that's the full beam width at 40 kilometers. The full beam width would be 3 meters. Okay. All right. Assuming a point source. All right. Cool. And we are roughly 3 meters above the ground. So that's centered. You got to divide that 3 by 2. So you'll be only 1.5 meters from the center of the observer height to the water. Thus, you would still, what's the height of the object? 2 meters above water, or what was that?
2.92.
I don't know. I don't have the paper in front of me. But you assume the full 3 meters. You got to take the half of it, bro.
Of course.
Right? Because you're dealing with it with a conical beam, half triangle again. Yeah. So it'd be only 1.5 meters.
I get that. There would be no issue if there was no atmosphere. But now we have atmosphere, which means diffusion, which means refraction, which means all kinds of things. We're getting pretty damn close.
Yep. Yes, exactly. We're getting close to touching the water, but we did not. We did not.
You would not touch the water if there were no atmosphere. But you have diffraction in the atmosphere.
Here's the thing. We've already assumed 7.6R, which it's not the 7.6R refraction you're going to invoke. Give me what refraction model you want then. Because even if we use your 7.6R, it goes down to 85 meters.
I'm going to invoke scattering.
And now the refraction you're talking about, there's obviously meteorological data. You can take a look at that. It's in the PDF. It's temperature, pressure, tide levels, everything's in there.
But I'm
so yeah, like all that is taken into account. It's not like it's not taken into account. And I'm even giving you the generous Mick West curve calculator, the Metabunk one, the 7.6R. So like, you saying refraction isn't changing the results?
I'm asking you.
Jose, let's give him this. What if the beam actually touched the water, and now where is it shooting? Around the curve or up into space?
It would bounce off at the same angle.
If the beam hit the water, it would be absorbed. Like it wouldn't so much reflect to the target. It'd be impossible, in my opinion, especially on a globe.
Let's assume the water is a mirror. We'll give him another one, Jose. Water is a mirror. It's going to reflect. Where is it going to reflect to, bro? Around the curve or up into space?
Okay, listen, that is the whole problem. The water is definitely not a mirror. It is not a specular highlight you're going to get.
You said it's going to reflect. That's why I gave you the mirror, man. Of course, it's not going to reflect like that off the water.
It's going to reflect off all the angles that it can get. It's going to reflect off all the angles it can get, which means some of the light is going to be thrown downwards. To space, and it's going to be thrown downwards. That's how a diffuse reflection works. So we're going to easily get. But have we taken diffraction? No, sorry. Have we taken scattering into account? That's what I'm asking. You're saying that they've taken refraction into account. That's great. Have they taken scattering into account? Atmospheric scattering, Rayleigh scattering.
I do not have the PDF in front of me. Actually, I never actually took a look at the PDF. I just know my math. Know my trig works. Trig is solid.
I just need to know how to use the calculator I was using. That's quite embarrassing. But
yeah, that's why I go old school, man. Paper and pen.
But I'm glad that you checked me because that's the whole point. But we have a measurement six. We have stuff like the vacuum wavelength. We have the air temperature, humidity, wavelength, refractive index, all that kind of stuff. But we don't seem to have any scattering taken into account. So we need to look at the Rayleigh scattering of this beam.
Okay, but before actually look at the scattering, you have to run the math on this. At 40 kilometers, let's just call it 40 flat, 40 kilometers, what distance below the curve is this object supposed to be?
I checked it while you were gone. I can't remember.
How many meters?
I can't remember. It's definitely below the horizon, clearly.
How many meters below the horizon? Of course it's below the horizon. How many meters?
Let me just check again. I can't remember. It was very clearly below the horizon.
For that, you just use a calculator off a Metabunker.
I'm going to do that. Yeah, I'm not going to do the math there. I'm just going to use the math. Okay, let's say 40 flat, as you said.
Yeah, let's call it 40.
And we have 3 meters in height, I guess. Then we have something with refracted hidden, something like 74 meters.
Awesome. 74 meters.
Yeah.
And the beam width, total beam width is 3 meters at that distance. Okay, total beam width is 3 meters in a conical shape. Okay, above the surface of the water. As we said, we're getting close to touching the water, but we did not touch it actually. All right.
Well,
see what I just posted? Hold on, guys. I just posted this for the document. It's 90 meters. What we're talking about.
Well, according
to that document, at the end of the document, there's technical data you can look at, with details of what
That's
the
without refraction. That's without refraction.
is.
Oh, thank you. I'll check that later. But anyway, you're wrong if you say that it doesn't touch the water. It definitely touches the water. It only does not touch the water if there is no atmosphere.
It's awesome. Does it bend around the curve?
Definitely.
How does it touch the water?
Because you have scattering and you have refraction. It's definitely going to scatter.
Yeah. Are you going to claim that the scattering that's water is the light that's being seen from 41 kilometers? Is that going to be your next claim now?
You need to look at the picture because the smoking gun here is the target for observation location. You need to look at that.
Denying what you're saying, but it sounds like it's not a good excuse to claim that that's the beam that they're seeing. They're seeing a direct line of sight.
So it's scattered downwards around the curve to hit the object 70 meters. I'll give you your 74 meters. Okay. So it's scattered 74 meters downwards.
Of course, it's bouncing off the edge of the water and it's being scattered in all directions. But if you look at
so we're going to lose intensity,
evidence that light. So here's the thing: like are you claiming it's refracting or scattering? What's the difference between scattering? I'm not that familiar with scattering. Like, you mean the light? How it bounces around? Do you mean that type of scattering?
Losses to the atmosphere.
Robert, you don't really
to the molecules or whatnot.
I answer it, or are you just going to yell at me? The scattering happens when you have polarly charged molecules in the atmosphere, and you have Rayleigh scattering, which basically means that it's absorbed and re-emitted, and it gets scattered out in different directions, and it's wavelength dependent, strongly wavelength dependent. And if you look at the picture, which is called target,
isn't that scattering that light source a lot, like big time diffuse it?
Yeah, all light sources get diffused by this.
Exactly. So what we're seeing here is a direct line of sight where the light doesn't seem to be nothing of diffuse. If anything, it might be spread out to 3 to 4 meters.
I don't see any.
For you to claim that the scattering I don't see how the scattering is helping you, to be honest. Like, yeah, scattering is probably taking place, but the light source that is being seen, it's not being diffused.
Okay. Let's just make sure that there is no picture that I have found in this document which shows a direct line of sight. What we see is the target for observation location. Are you seeing that picture? It's on the measurement 6. It's from 2:19 a.m. It's all that stuff. These temperature and humidity things. It's like 2 pages after all the data we've been working on. If you look at that light point, a direct line of sight laser point, it is so unfocused and scattered. It is clearly diverging upwards.
Sorry, Robert, is that the picture under technical data with a 3 by 3 meter surface?
So wait,
at the end of the document under technical data.
Is pretty much in the middle of the.
So this is the part that I'm
go
trying
to
to
the end of
see.
the
How
document.
Scattering or
data. 3 meter thing with a light shining on it. Light that's next to it.
So here's the thing I'm still confused about. Like this, let's just say it's scattering, right?
I misled you. Sorry about that.
So this scattering, the part that I don't understand is like now you're claiming that not only is it scattering, but it's going around the bulge, this 90-meter bulge that should be in between.
What I'm saying is
right. Like you have to think about it. It's like not only is it going to scatter, the light has to go around a bulge now that is 90 meters. That's what you have to believe if that's what you're claiming.
What happens
is the light is not only so the light is not only bending up again, but it has to come back down, right, for it to be observed. What kind of refraction is that?
It's called the magic refraction, Jose, where it just it diverges and yeah, exactly, magic.
That sounded like a lot of mental gymnastics just to make it work, Robert.
Well, can I explain, or are you just going to yell at me?
Oh, go ahead, please, man.
Is this the new standard globe argument where people complain about being yelled at because it's kind of boring?
I'm not complaining. I'm just saying, can I talk? Because I'm being asked.
I'm not yelling. I'm sorry if my voice.
Yelled at you, dude.
I'm completely triggered.
Hold on.
Yeah, I understand that.
Earlier we had a guy complaining about being yelled at.
You guys are dumb ass.
No, all right, Robert, please, man, get to your point.
Can I just say this though? Yeah, we're not really into concern trolling.
Sorry, I don't associate with niggers.
Right. So yeah, just get on with the science. No one cares if you feel like you're being yelled at.
not getting the option to actually answer any of the questions. I'm getting lots of questions thrown at me, and I'm just not getting the airtime to talk. That's all. I'm not pissed off with anime at all.
You understand our point, though.
Yeah, I completely see that you find that strange. So I'm trying to explain what's going on. You have this 90-meter bulge.
Yes, just crack on.
This 90-meter bulge, right? And then you shine a divergent light across it. Some of that light is going to hit the surface of the water, right?
No. We do not know that. If we are sufficient height above the water, we shall not hit it. And if the height of the starting height was roughly 3 meters above the surface of the water, and at 40 kilometers, the beam divergence, which we already know, which is 0.08 milliradians, right? You know, at that distance, 40 kilometers, we should just start to touch the water. Okay?
There was
so,
no atmosphere.
What I don't get, I'll give you it refracted, it bounced, and it got absorbed, all that. How did it recollimate and hit the object?
It does not recollimate. That is the whole point. If you look at the photo, if you look at the target observation, it's not collimated at all. It is a huge smudge.
Smudge?
It is a huge smudge. Have you looked at the picture? It is nothing like a light beam.
Send me the picture. Send me, or just post
2 pages after. Wait, hold on. I'll just click it. Just get it.
Yeah, just give me a snapshot. Just get over with.
So
I really have to run.
Keep going back to between these two aspects here, refraction and scattering. Okay, now refraction. Can you give me evidence that light refracts down at night?
Sure.
Especially if you looked at the weather conditions for this type of measurement right here, they took the meteorological data and they showed that there was negligible refraction. Like the way they could test this out too is by hitting those points. If there was any type of refraction, there'd be a big. I'm not done. There'd be a big deviance from the 1 meter target that was 6 kilometers, 12 kilometers. That's why they did a horizontal pan and managed to see it in all 3 points. If the refraction was there that you're claiming, it would not be visible from all 3 points. It'd be different. So, like, really what you're doing is mental gymnastics right now. And I get it. Like, you don't want the FE core to be you need to find something wrong with it. But the problem is that it's not, it can't be explained with the globe. It really can't. Because now it's not just 1 meter, 41 kilometer meter mark. It's 3 points that are seeing the same observation with the horizontal pan. So now what type of refraction is it going to not happen in the 2 first points, but now you're claiming it's happening on the 41 kilometer mark, which I do agree. There'd probably be a little bit more refraction because it's a longer distance.
I'm saying scattering. Okay. Have you looked at the picture I sent you?
Yes, I have, sir.
Yeah.
Yes, I have.
You see that is not a color.
My question to you, that divergent beam that refracted and it got absorbed and all that, sure. Okay, how did it fly around the 90-meter bulge? Did it follow the curvature of the Earth because of the magnetic field or what? I would like to know your answer.
There's absolutely no magnetic field. There's nothing forcing it around the globe, obviously. But it means that every time it strikes the surface of the water, it's going to have a diffuse reflection. It's not going to be a mirror. It's going to be spread in all directions.
I am 100% with you.
What is it reflecting off of?
The light is going to be bounced off
the surface of the water.
So it's bouncing off the front of the hump or the back of the hump.
Some of it's going to go back.
So the angle of incidence equals the angle of reflection, right? So if it hits the front of the hump, it's going to reflect into space. If it hits the other side of the hump, I don't know how that happens either because it just did a U-turn.
Impossible. It's impossible.
And how you're getting this idea.
You would never be able to hit your target.
Seem to think that when light strikes
Listen,
water,
obviously the beam is blurry because it's 25 miles. It's quite a long ways away. That's far, right? So of course it's going to be blurry and it's not going to be crystal clear. That's not feasible.
Can we give him 60 seconds to just respond? Because he has to leave.
Yes,
so I think we all understand that we want to keep him here, right? But he has a life, so let's just give his 2-minute closing or whatever, and then let's just let him go because we're gonna have to agree to disagree here, guys and gals.
We're never gonna convince each other, and I think actually it's kind of cool. Can I just say?
I want to know your math. I want to know your science behind this. It's not about you're gonna make me agree with you. It just show me how you can do that. Like it's gonna reflect off into space, right? Just show me how. It's going to come back around. Okay, I assume that the water is a mirror. I gave you that. Water is a mirror at point of tangency. No problem, bro. Now what?
All right, stop now. Let me talk. I need to leave. Okay.
All you, sir.
The first thing I like to say is I feel like the FE core measurements are actually really cool. I think it's important that it gets done. I'm not trying to fight you on this one, and we're never going to agree on what they show us, but I think it's important that you're actually doing actual science. So great for that. What I'm trying to say is that
science is an observation. Jesus.
Okay, just let him finish, please.
When light strikes the surface of water, it is not like a mirror. You can't see a reflection of the sun in the ocean like that. You see a long, stretched out thing because that's how the reflection in water works. It throws light in all different kinds of directions. It does not work like a mirror. So when you have light touching the surface of the water, the light beams are going to go in all kinds of different directions because of the diffuse reflection that's going on. Some of that's going to follow the edge of the curve of the Earth. Some of it's going to go into space. We're only going to see the stuff that follows the curve.
How is it going to follow the curve, bro? That's what I'm saying. By me, like, assuming that I give you water as a mirror, which is impossible, I'm helping you out. Like, now you have to explain to me how is it going to follow the curve. I gave you a way out with the magnetic field, but show me your way out. How are you going to do this? How is the light following the curve, like you just said?
Well, can I say one thing? The refraction would have to be 100 times larger than standard refraction. 100 times. Okay, this would only work on an Earth that's a 65,000-mile radius. You understand that?
Not talking about refraction. Okay, so yet again, when light hits water, it gets scattered in all different kinds of directions. Some of it goes up, some of it goes way up, some of it goes horizontally.
Cool.
Great. So that means when you hit the surface of the water, some of that light is going to go horizontally.
Okay.
And the atmosphere, and then hit the water again. And a little tiny bit of it is going to go pretty far around the curve.
How is it going to go around the curve?
Skipping like a rock around the curve of the Earth. Skipping like a rock. The light's just going point, 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 and then going into the, is that what you're saying? I mean, I don't understand.
That a tiny little piece of it, yes.
It is. It is. Really? That's an interesting light, bro. That's very interesting light.
If you think I'm saying that the entire light is doing that, then you're not listening to what I'm saying. I'm saying that.
Well, how much is it?
I heard what you said. You said a tiny bit of the light would skip like a stone across 25 miles. I think you're going to have to demonstrate that.
And would that be enough to illuminate the object with that same luminous intensity? Now we're speaking science, dude. Right? Now we're on the same playing field. With this scattered skipping stone of yours, would it illuminate the object with that same intensity? Now you're gonna have to do some math.
I don't know what the intensity is, so I can do that. But we can predict how much of the intensity that would be.
Let's go. Let's go. Whatever software you want to predict it with, I'll fire it up. How you want to do this?
But I'm gonna have to go, as you know. As I said, I'm not trying to.
I know, man.
We can do it. But I have no idea what the target is. That in the document? How much intensity we get back? We know how much of do we know how much of the laser when we get back?
If we start out, if we know the laser intensity that we're starting out with, we can work some stuff out, man.
No, I mean,
we need to get the sensor size, then the beam diameter, and then you take that cross section of the divergence at that point, and then take the that little area that the sensor would be. Well, actually, the lens. Then you could figure out how many photons would fall onto the sensor. I mean, Jesus, do we really need to be that particular?
I get that part completely, but do we have a measurement? Do they have measured how many photons they actually got? Because that's what we need to test my hypothesis, because that's what that is. What happened? If we don't have that data, we can't test it.
Your skipping stone hypothesis isn't real. Just, you know what I'm saying? It is not real. We gave you that for free, but it is not real. It's not observed.
You can deny it if you want. That's how how non-specular highlights work. That's how diffuse refraction works. That is how light bounces off something which isn't shiny.
Around the curvature, but if you have mass in between, you're gonna reflect behind the mass somehow. This bulge, you got this bulge of water in between you and the target. Now this is gonna scatter around. So how much? And what is the losses of scattering to distance?
I have no idea.
To the inverse square law or what?
inverse square. It's going to be pretty intense. That's why we need to know how much.
Right. You're
how
not
much
going
we
to get
got
any
back.
light, man. It's just like, dude.
You
I
know,
have no
90
idea.
meters is like a 30-story building, right?
It's a big curvature. I agree with
It's
you.
just like a
That's why we got
30-story hill, man, like that you have to get around. You're saying you can be on the other side of the hill, and there's a light source on the other side of this 90-meter hill, and somehow you can see that light. I don't know that that's ever been observed ever in the history of mankind.
Well, have to be in like some kilowatts, man, of power to illuminate
I
something.
mean,
at that
and isn't
distance.
water disruptive of blue light?
Hold on, I'm just checking if this distance is even plausible. Whereas the targets here. Anyway, yeah, as I say, I think it's a fun experiment. I think it's fun to look at. I would like to have known the target intensity. That would have been useful, but we don't have that. But it's cool. So with that, I'm going to have to run. I've been here for way longer than I thought I would be.
Thanks for stopping by, Robert.
Thanks for coming
Appreciate your
here.
time, man.
Thanks for coming here and giving it a shot.
Come back anytime you want to get schooled, bro.
I'll get the WMAP data for your next time you're on here, bro. I got you. Don't worry.
Yeah.
All right, have a good day. All right,
Watch yourself,
You too, bro.
Peace
out, bro.
Peace.
And ye shall know the truth, and the truth shall make you free.
Orion is getting ready to launch. My name is Kelly Smith, and I work on navigation and guidance for Orion. Before we can send astronauts into space on Orion, we have to test all of its systems. And there's only one way to know if we got it right. Fly it in space. For Orion's first flight, no astronauts will be aboard. The spacecraft is loaded with sensors to record and measure all aspects of the flight in every detail. As the spacecraft and the upper stage begin their first lap around Earth, Mission Control in Houston is monitoring the progress of the flight. Orion's over 100 miles up and going about 17,000 miles per hour. Just as it passes over the Indian Ocean, we lose communication. This is expected. The communications link we have through satellites to Orion is momentarily lost, but Orion continues to receive and process data. Its computers can handle 480 million instructions per second. We are headed 3,600 miles above Earth, 15 times higher from the planet than the International Space Station. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. We must solve these challenges before we send people through this region of space. We must solve these challenges before we send people through this region of space.
Here's Apollo 12 astronaut Alan Bean being interviewed about the Van Allen radiation belts.
Any ill effects from the Van Allen radiation belts?
No, now I'm not sure we went far enough out to encounter the Van Allen radiation belt. Maybe we did. I don't know the distance to the Van Allen radiation belt.
The belts are 1,000 miles to 25,000 miles above the Earth.
Then we went right out through them.
No effects on your cells?
We didn't even know it. I don't think anybody, well, maybe somebody said you went through the radiation belt, but we didn't feel it inside, and we didn't get any, added radiation. Not on our mission, by the way. They hadn't been discovered yet.
So you see, he wasn't even sure what the Van Allen belts were, and when he was told, he basically says that the radiation belts didn't apply to his mission because they hadn't been discovered yet.
Okay. Okay. Well, maybe somebody said you went through the radiation belt, but we didn't feel it inside. Not on our mission, by the way. They hadn't been discovered yet.
The guy just said, maybe somebody said we just went through the Van Allen radiation belts, but how is that possible if they hadn't been discovered yet?
Well, maybe somebody said you went through the radiation belt, but we didn't feel it inside. Not on our mission, by the way. They hadn't been discovered yet.
We must solve these challenges before we send people through this region of space.
Not on our mission, by the way. They hadn't been discovered yet.
And ye shall know the truth, and the truth shall make you free.
Hey everybody, today we're debating Flat Earth versus Globe Earth, and we are starting right now with Leo Filius's opening statement. Thanks so much for being with us again, Leo. The floor is all yours.
Yeah, thanks for having me again, James. So, not going to have a very long opener here because, to be quite frank, there really isn't a Flat Earth debate that happens. Nobody's ever had a debate on the Flat Earth because there isn't a debate to be had on this. The Earth is obviously spherical. If we want to understand the world as people and as humans, then we have to, or at least we ought set some rules for the best ways to go about doing that. And a lot of those rules involve things like, going out and actually observing things in the world. Things that include consistency, that our models need to be consistent. Things like parsimony, our models need to account for the things that we expect them to account for and do so in explicative and simplistic ways. And I think that when we examine how humans would have thought the Earth was, like 6,000-7,000 years ago, it made sense to them. They didn't have the technology that we have today. They weren't capable of doing as sensitive measurements on not just the Earth, but various aspects of reality like we are today. And for this reason, I think that anybody would say, if you were alive 6,000 to 8,000 years ago, you'd probably think that the idea that the Earth is sort of this flat plane that perhaps just goes on forever wouldn't have really been that far-fetched. Most humans back then probably never went more than 50 miles outside of where they lived, and there's some humans that are like that today. But as humans developed, as we began to develop technologies, and particularly as we began to travel around the world, humans began to see things change about reality. Going from one place on the Earth to the other, and noticing that the position of the sun in the sky wasn't the same. Noticing that different seasons, the sun would be at a different position in the sky. Noticing that the moon goes through cycles that seem to be related to the amount of the moon that we can see relative to our position to the moon, relative to the sun. That there was a variety of things that we began to see. That when we would see a ship go off into the distance, we would see the bottom of it disappear, and then the mast at the top of the mast disappearing last. All of these things are things that we would see, and I could go on and on and on for hours about the things that we observe about our reality just immediately without really needing much technology, and with our technology. And it seems obvious that the best model to account for why we see the world with the way that we do is that because the planet that we live on is spheroidal, and is traveling at about 67,000 miles in its orbit around a massive star that is about 1.3 million times the size of our planet. We have seen these things elsewhere in reality numerous times. We know these are things that can form. We know the mechanisms, how they can do it. We can describe all this very, very well. So we know that the model is consistent. We know that it's parsimonious. It accounts for everything that we need to account for, and it explains why we see the world the way that we do. In terms of a flat Earth, I've never heard a model. I've never seen a model. All I have ever seen, all I have ever heard are attempts to confute the model that we do have, oftentimes by appealing to things that it can't explain, that it's been capable of explaining for decades, if not centuries. And that is all I have. Thank you.
Thank you very much for that opening statement, Leo Filius. And want to let you know, folks, if it's your first time here at Modern Day Debate, we are a neutral channel hosting debates on science, religion, and politics. And with it gets it, glad to have you with us. The floor is all yours for your opening as well.
How's it going, everybody? Let me share the screen right here. All right. Yeah, so I'll cover a lot of what he said in my little opener here. So we'll go to view the slideshow. All right, you can see it? I think.
Yes, now it's showing.
Cool. All right, so Flat Earth 101. So before we get started, as this guy said, I've never even heard a model. Yeah, we actually don't have to claim a model. Models or scientific models are actually used to explain phenomena, etc. But no one thinks that the Earth is a disk that floats around in space. No one thinks that the Earth is spinning around when they say that the Earth is flat. This is a straw man. So when ridiculed, it's actually ironically ignorant. So just to cover a couple basic parts of debates that should be known. Falsification is independent of replacement, meaning, of course, if something is proven to not be true or falsified, that remains a fact in and of itself. You don't have to replace it before it is not false or before it is actually falsified. The burden of proof is on the one that makes the positive claim. So the shifting the burden of proof is the fallacy of putting the burden of proof on the person who denies or questions the assertion being made. Now, this is very important to understand because as he's already done in his opener, he has shifted the burden of proof, and that is all that you will ever get. So for example, if this guy tells me that unicorns are real, then he shows me some CGI of a unicorn. He says, we have pictures of unicorns. I can't believe you don't think unicorns are real. And then he tells me, I have a book. And if I read my book tells me about this fairy tale world with giant octopuses and unicorns everywhere. And everyone agrees that this book is telling me about these unicorns that are real. If we prove that those unicorns aren't real, you're just reading some fictitious book that has nothing to do with reality. I do not have to give you some replacement unicorn or mythological character, then replace your little books and tell new stories about it before your unicorn isn't real, right? Falsification is independent of replacement. So what were we all taught in school? We were all taught the same thing, that the Earth is a globe. This is what we were all taught. So when people act like there's no debate, this is so ignorant, you guys are so underinformed and uneducated, we were taught the same thing you were. And almost every single time the person that ridicules the flat earther as dumb or ignorant doesn't even know a fraction about the Earth or the supposed globe Earth claims as the flat earther, which should be very telling to anyone honest. So what is the positive claim of the globe, which is what we're testing? Claim number one, the Earth is a sphere with a radius value of 3,959 miles and a supposed circumference of 24,901 miles. This is a positive claim, a shape claim of a sphere with a size claim, a dimension claim of a specific radius value. This is a positive claim. It has the burden of proof. Claim number two, the Earth is supposedly spinning over 1,000 miles per hour at the equator while revolving around the sun 66,600 miles per hour on an axial tilt of 66.6 degrees. This is, of course, a positive claim of axial rotation. It has the burden of proof. Okay, claim number three is that this spinning magic globular Earth with a radius of 3,959 is sitting in a vacuum of space that is encompassed in a near perfect vacuum of 10 to the negative 17 torr. And this is a place that you can actually go to. This is a third positive claim. These are the three fundamental claims of the globe Earth. You have the burden of proof as a globe proponent to prove that this is in fact the case. So the heliocentric model has the burden of proof for all these positive claims. Okay, so that's just objectively the way that it is. We don't have to prove a negative. We don't have to explain any question you can come up with. The burden of proof is on the one making the positive claims, as the heliocentric model is. Wait, isn't it saying the Earth is flat a positive claim? Well, yes. Yes, it is. So you have the burden of proof, right? Flat is the description of a surface. Flat is not a shape. Okay, so we have the burden of proof to show that the surface of the Earth is flat, because that is our positive claim. Well, conveniently enough, this has been done numerous ways, and we can get into plenty of them. But radio waves can be sent over 10,000 miles with no Earth curvature obstruction whatsoever. How is this possible? Of course, it's propagating over a horizontal plane, 10,000 miles, no Earth curvature obstructing it whatsoever. Seconds have been used to successfully navigate for hundreds of years and require the Earth be a horizontal plane as you take an elevation angle to a celestial object, and then it comes down to the plane to have your corner pocket. An elevation angle is to a horizontal. You cannot in any way use a sextant successfully without the Earth being a horizontal plane, and it's worked for hundreds of years for hundreds and hundreds of miles. Next, the horizon has been seen over 10 times the geometric limitations of the globe. This falsifies the globe claim. Again, there is no need for replacement of this model. It has been falsified. The entire globe model depends on the accuracy of this claimed radius value. Everything. So this radius value has been falsified. So welcome to Flat Earth. This is not real, and it's okay. You made the positive claim that this is real. We have falsified that positive claim by falsifying the radius, and you have the burden of proof to substantiate your claims. We must not come up with some fairy tale to replace it. So that is where it all begins, to be intellectually honest about the conversation and where we are. And cool, excited about having the discussion.
You got it. Thank you very much, Austin, for that opening statement. And with that, do want to let you know, folks, just a couple of channel announcements as we are absolutely pumped. In particular, got to let you know, on the bottom right of your screen, as an example, my dear friends, for the first time ever, Modern Day Debate is hosting our first conference, Debate Con, in 1 month, January 15th through 16th in Dallas, Texas. You do not want to miss it, as some of the debates will only be live for those that are actually in person, by the way. And so you have a good reason to grab a ticket. And we have also made it so that the tickets are still at early bird pricing, so that in case you haven't heard about that, that's still available. If you haven't jumped on it, you can jump on it right now. It's only 2 weeks away, you guys. It's coming fast, and we are pumped as there are going to be a lot of juicy debates for that. We'll kick it into the open conversation mode. Do want to let you know your screen share is still on, Austin, and want to let you know, in the meantime, if you haven't yet, hit that subscribe button, as, like I said, we have many juicy debates coming up that you don't want to miss, folks. Thanks so much. The floor is all yours, Leo and Austin.
So do you have any contention with my opening statement? Do you agree that making the positive claim that the Earth is a globe has the burden of proof?
Yeah, that burden of proof has obviously been met.
Okay, so you want to take it step by step. The first claim is that it's a sphere with a radius of 3,000. Yeah, oblate spheroid with a radius of 3,959 miles. Would you like to enlighten us how that was established and proven?
I don't know. I'm not a geologist. I don't know how they measure that.
Okay.
I would assume probably using trigonometric methods by measuring an aspect of the Earth and then utilizing mathematics to extrapolate that to the entire sphere, which could be done. I'm also not a, geometrician, I think they're called, so I couldn't tell you how to do that either.
Okay. Well, you did just say that you know it's been proven. And so what you've immediately admitted is that you actually do not know that it's been proven because you're not even aware of the
I do, though. The fact that I don't know the mathematical methods through which it was proved doesn't mean that those methods haven't been used to prove it.
Well, how can you know something if you don't know it?
I don't know what that means.
Well, how can you claim to know something as a fact if you don't even know what it is you're claiming as fact?
I do know what it is I'm claiming as fact, that the Earth is a sphere.
How was the radius verified?
I don't know. If you wanted to know that, my question would be, why haven't you asked a geologist?
I have debated people that do it for a living.
Did you ask them that question?
Yes.
Did they answer it? I'm sure they answered it. What was the answer that they gave?
They tried to invoke geodetic surveying.
Geodesic surveying?
Geodetic.
I don't think I know what geodetic is. I know what a geodesic is. I don't know what geodetic means, though.
Okay. So we physically measured the surface of the Earth and falsified the claimed radius. So unless you can provide evidence, it doesn't curve at the rate it would have to if it's a sphere.
How do you know that?
for example, I showed you the observation of the black swan, right? So if the Earth has a sphere of a radius of 3,959 miles, then that means that the Earth's geometric horizon or curvature should be no further than 1.225 times the square root of the observer's height in feet. Just basic geometry, right? And you can Google it. This is on Earth Curve Calculator. This is not flat Earth math. This is testing the globe claim, right? And so that means that 1 foot off the Earth, you should see the curvature of the Earth at 1.2 miles. Yeah, we have an observation 1 foot off the surface of the Earth, and the horizon's over 10 miles. That would require the radius be over 250,000 miles, but they claimed it's under 4,000, so we have a problem here.
Yeah, I don't really know anything about that. I just Googled it in like 10 seconds. I found out how we know what the both the circumference and the radius and the diameter of the Earth is. And it's exactly what I said. You use trigonometric methods to measure curvature over a particular area of the Earth. You could say maybe even over 100 miles, and then you can use that to calculate what the whole diameter of that circle would be. If you have part of the circle and you know the angle at which it's curving, then you can essentially piece together what the size of the entire circle would be.
So you're saying if you know the angle at which it's curving, you can determine the radius value, but the way that you know that curvature rate is the radius value. So that would be.
I don't know what that means. We know it by looking at differences in the angle of the sun. I mean, this was calculated thousands of years ago because this kind of math has been around for thousands of years. Humans have been doing this for thousands of years. We are not in rocket appliances right now. This is very, very simple stuff.
But I would pump the brakes on all the arrogance, right? Because you just admitted to the whole audience you didn't know the
What do you mean by arrogance? I'm just stating things that are true. Like, we've known this for thousands of years. These methods humans have been using for thousands of years.
Okay, so you're talking about Aristophanes?
Eratosthenes?
Yeah, that's who you're talking about.
Yes, I believe he was the first one that calculated it, if my memory serves me correctly.
Yeah, there's no primary documentation of that ever happening, even if we pretend that we know it did happen.
So it's just an argument from silence, which is fallacious.
That's why you had to interrupt me, right?
Well, no, but that's what you're presenting. That is just an
No. What I'm saying is you're making a positive claim. This dude measured the circumference of a globe over 2,000 years ago. I'm proving that you can't prove that at all because there's no primary documentation of that ever happening. You don't know that. In addition, we'll pretend
this is an argument from silence. This is
we'll
just a fallacy.
No, you're saying that as if I'm just supposed to.
Do you know what an argument from silence is?
Yeah, you're saying I'm supposed to just believe that it's a real story.
I didn't say that. I didn't say you're supposed to do anything. All I did was say that what you're doing right now is committing an argument from silence.
Okay, can you provide evidence for your positive claim that Aristophanes did this?
The fact that there are thousands-year-old documents of it having been done. Now, if you want to dispute that whether the person who actually ultimately is the actual human that did it, whether his name is Aristophanes, is irrelevant. The math checks out. Do you have an argument against the math?
Yeah, sure. I was trying to get there, right? So my preface was that actually there's no primary documentation, but we'll just assume it is real anyway. But you had to interrupt me. So if we assume it's real, do you know that he had to assume the sun was distant with parallel rays?
Well, of course it's distant with parallel rays. That's how light works.
Light works that the sun is distant. That's the only way light could work?
No, light moves in straight lines.
Okay, so is there anything such thing as divergent rays? Is that a real thing?
Divergent rays? Yeah, there are ways to do that, yeah.
Okay, so that's not how light works.
The electromagnetic radiation, yes, it propagates orthonormally, I believe, if it's not interacting with a form of medium. Yes.
It actually propagates in a transverse movement. Wave-like.
Do you not know what orthonormal means?
Orthonormal, no, you enlighten me.
Orthonormal. One oscillates this way, one oscillates this way. They're orthogonal or at 90 degrees to one another and normalized of unit length. So they're normal. Ortho, normal.
Is it transverse? Yes or no?
Oh, Lord have mercy.
So you don't, okay, so the propagation
the concept of orthonormality would subsume the concept of transverse.
Right, okay. So can you provide evidence that the sun is 93 million miles away, or is it just a claim?
We can measure that.
Okay, so did he measure the sun was 93 million miles away?
Actually, I do not know that. I have no idea whether, he measured the distance to the sun or not.
Right, well, he needed that assumption to deduce the calculations. And did you know he didn't even claim it was anywhere close to 93 million? He claimed something more like 3 million. Did you know that?
I don't know if anything that you're saying is true or false, because I haven't read anything about what Eratosthenes did in terms of calculating distances from the Earth to the Sun.
Well, this is your claim, though. You claimed he proved the Earth was a sphere with a circumference value. It's your claim.
I claimed that he used simple mathematics to determine what the circumference of the Earth is. Yes,
Assuming
and we know that he did that. Yes.
It works the same if the sun's local on a flat surface. He assumed a distant sun with parallel rays and assumed a spherical surface.
Yeah, but those are facts, which is why he assumed them.
Okay.
The sun is distant, and the electromagnetic radiation propagates orthonormally unless it's interacting with a medium.
So your proof of the Earth's measurement is that he assumed the Earth is a sphere, and you can use that assumption to prove that the Earth's a sphere.
If the Earth weren't a sphere, unless you're arguing that there is geometric curvature to it, even though it's not like a sphere, then fine. But that wouldn't be flat. There is geometric curvature on the Earth.
Okay, that's
he figured that out just from walking from two cities. Yeah, that was the claim. Well, actually, that's not the claim. That was the observation. He determined that there is curvature on the surface of the Earth because these things that we see in reality happening.
But did you know that if the surface was flat and the sun was more local, you would get the same results?
How so?
Because the divergent rays would create shadows relative to the angle of the local light.
What do you mean by divergent rays?
They converge to the point of light, the source of light, which is the sun. So
isn't that how all lights work?
Okay, so, well, you just a second ago they're all parallel. So anyway,
yeah, they travel at straight lines outward from the source in all directions. Like that's kind of how field mechanics works.
Well, the globe Earth kind of doesn't claim that any of the sun's rays on Earth is divergent. They claim they're parallel.
I don't know what you mean. They're parallel in terms of them coming from the sun. The light just moves in straight lines through space.
Right.
Yeah.
Right. So if
and it's divergent in the sense that all those straight lines would diverge back onto the sun, the point of origin.
But the globe Earth model has just a small portion of the light of the sun hitting the Earth, and they're all parallel. If the Earth is smaller, or if the sun's more local, then it has divergent rays locally on the Earth. It's a fundamental difference.
I have no idea what you're talking about.
Okay, so you have no. First of all, that wasn't even claimed.
Optics isn't this hard. Actually, optics is a pretty difficult field. It's boring too.
Do you agree or disagree that if the Earth was flat and the sun was local, you'd get the same results?
If you had like a sort of a flat disk Earth and a little ball up here with light, the light would just be covering the whole surface, so you wouldn't have nighttime. So no, I don't think that would work.
Okay, well that's called a straw man fallacy, my man.
No, it's not.
Yes, it is.
What did I straw man?
Yeah, you just straw man a model of the Earth, saying that if the Earth's a disk with a ball above it, then it'd cover up the whole disk. That is just an unfounded claim that no one on this side has ever made. There's something called the attenuation of light. There's something called the attenuation of light.
Sure.
So why would the light go forever if it's a small local light source with attenuation?
What do you mean? Why would the light go forever?
You just claimed to cover the whole Earth. Why would it cover the whole Earth if it's a small local light source with attenuation?
Because attenuation happens when electromagnetic radiation interacts with matter. So
correct.
You wouldn't expect that to happen until it struck the Earth.
Wait, is there not matter in the atmosphere?
Not very much, no.
Oh, so there's not an absorption rate of air when it comes to light? There's not an absorption rate of light?
A very small one. It's more, I think, of a refractive index, but...
Okay, so there's an attenuation rate in the air.
Very, very small one, yes.
Okay, so it's a small local light source. It wouldn't cover the whole Earth. Can we get back to stop trying to pretend you know how to falsify the flat Earth? Can you prove the globe Earth radius value? That's what we're trying to get to here.
I already have. We mathematically calculated it. We measured that there was curvature on the surface and used the amount of curvature measured over the length and extrapolated that to an entire sphere and got an accurate measurement. We've confirmed it today, so...
Really? He was over 15% off. Aristophanes didn't even come up with the radius value, and the person that did it for your model, his name is actually Al-Biruni. So
I don't really care who did it. It doesn't really matter. It doesn't just be in a genetic fallacy. You're trying to appeal to the source as a means of falsifying the information when the source of the information isn't really relevant here. It's
no, I'm not. I'm appealing. I'm appealing to the fallacious methodology they used. You are ignorant of the methods.
What fallacious methodology? Yeah, and the funny thing is you haven't been able to explain them to me, so I don't think you know much about them either.
Yeah.
I never claimed to know everything, and I don't actually know how we've even today measured the circumference and the radius of the Earth. I really don't. I've never asked, but I'm sure if I Googled it, how can we measure the circumference of the Earth, I'd get perfectly fine answers that make sense and have a lot of valid mathematics to back them up. I mean, I'm sure that anybody, if they really wanted to know these things, could just Google them or call a university and ask a professional. My question would be, why haven't you done that?
Well, hey, isn't it pretty ignorant to claim you know the answer to a subject or question if you're completely ignorant of all the details of that subject?
I didn't say I was completely ignorant of all the details. I said there are some things that I do not know. That the Earth is round is one of the things I do know.
You've proven you don't even know how they claim they proved that.
Well, through certain methods. In terms of calculating precisely the circumference and the diameter, I don't know that. That doesn't mean there aren't other ways to know that the Earth is a sphere or spheroidal.
Okay, but maybe we should do this, right? You realize that the entire model depends on that radius value being accurate. If that
what do you mean? We could change that value. The Earth can be larger or smaller. It could be more spheroidal or less spheroidal. The point is that it's a sphere.
No, it can't. It objectively cannot be.
So you're saying that if it couldn't, but it can because there are planets that are.
Okay, so you don't understand it. So say the Earth has a certain size. That's how we've come up with everything else in the model, like relative distances and sizes of the other bodies in the solar system, cosmological distances. If you don't understand this, it doesn't make it not true.
I definitely understand this. I study astronomy.
Okay, so to have orbital trajectories dependent upon the mass, which is dependent upon the size of the dimension, which displaces a certain amount of mass in the curvature of space-time. So the radius of the Earth is directly related to your entire claim, as is day and night cycle. It is objective.
No, actually, no. Our day-night cycle would be related to the rate of rotation of the Earth about its axis.
And the way you come up with the rate of rotation is how much it needs to spin within a certain period of time based on its size.
No, you can make the Earth larger, and it could still spin and have a 24-hour day cycle, day-night cycle.
If the Earth was larger, would it have to spin faster to maintain the day cycle?
I would assume so. Conservation of momentum is kind of a thing that exists in reality.
Yeah. So everything depends on that radius value being correct because the 1,037.
Do you think that the Earth couldn't exist if those numbers weren't exactly what they are?
What a straw man! Do I think the Earth?
No, that was a question, not a straw man. I was asking you a question.
Do I think the Earth couldn't exist?
Yeah, if the Earth was larger, do you think that would just somehow it couldn't exist? The Earth can only ever be one size if it's a sphere. That seems to be what you're saying.
Yeah, because we know distances to different locations on the Earth, right? And so if that radius value changes, those known distances are
of course they would change. The planet would be larger. Why would we not expect that?
But we know the distances, though.
Yes, because the planet is the size that it is.
So if it was falsified, then it could not be a sphere.
Well, no, it would just mean that it's either larger or smaller than what it is.
And that all the distances to known locations are wrong.
Well, sure, because the Earth is either larger or smaller than what we thought it was. It's still a sphere.
Well, that can't work because they're verified distances.
Yes, they are, because the Earth isn't larger or smaller than what we've measured, because we've measured how large the Earth is.
Okay, we'll let the audience decipher that double speak. So another thing that the radius value is connected to is to ever go to space, you have to obtain escape velocity, right? So you have to have a certain orbit. So you have a radius of orbit that's dependent upon the radius of the Earth. Any story about going to space depends on that radius value. So if the radius value is wrong, the entire model is wrong. This is just objective.
I don't know what you mean when you say that. You keep essentially making this argument that, well, if the Earth were any larger or any smaller, all of the values about distances on the Earth and the amount of velocity needed to escape Earth's gravitational field and the radius at which something can be in a free orbit around Earth would all change and your model would fall apart. No, it wouldn't. It just means that the Earth would either be larger or smaller than what it is. It doesn't matter that the Earth is the size that it is. We measure that it's the size that it is because it is that size, but the idea that if it were larger or smaller, if those values were different, all of a sudden we can't explain anything. No, that's not how this works. I'm sorry. It's just not how this works at all.
You don't get it. So how far away do they say the sun is, for example?
The sun is somewhere between, well, it depends, 93 million miles approximately, or 150 million kilometers for the normal people in the chat.
Right. So that's based on the mass of the sun, and then it has a distance to the supposed mass of the Earth, and that's how it's attaining gravitational orbit, right?
Mm-hmm. Yeah.
Okay. So if the mass of the Earth changed, would the rest of the model have to change as well?
What do you mean by the rest of the model? No, general relativity would still work just fine. If you changed nothing, so the velocity of the Earth stayed the same, all you did was increase its mass, well, that would just be a hard thing to do to begin with, because you have conservation of momentum, conservation laws. But likely the Earth would, if it grew larger, more massive, yet somehow retain the same orbital velocity, it would probably start to fall inward toward the sun.
Okay, so if the size of the Earth is wrong, the size of the moon is wrong, the size of the sun is wrong, the size.
What do you
of
mean
all
by
the
wrong? You mean if we calculated it wrong?
They would also have to change, yeah.
Probably not. I mean, if we calculated the Earth of the mass of the Earth wrong, that wouldn't really change much in terms of what we know about the sun, because, I mean, do you realize how small the mass of the Earth is compared to that of the sun?
Well, we're talking about changing that number and relationship, aren't we?
Yeah. Do you know, it would be like changing our understanding of the sun by like 1/100 millionths of a percent. Like it's completely negligible in the math.
Well, that's crazy.
So, I mean, yeah, if we found that the mass of the Earth, it's 15% more than we thought, that's not really going to change much else about our model.
What about 1,000 times?
I would need to see some serious justification for the idea that we would be off by that much in calculating the mass of the Earth.
1,000%.
I seriously doubt our ability to calculate that the mass of the Earth is that skewed.
Yeah, well, we have an observation where the radius value would have to be 264,000 miles. So
I don't know what you mean.
Well, they claim the radius is under 4,000 miles. I've said something that's objective. You've disputed it, but I don't want to keep going in circles. If the radius value is wrong, the entire model is wrong.
I still don't know what that means.
The highest levels of academia on your side would agree with that.
No, they wouldn't.
Okay.
They would say that if somehow the size of the Earth, if you changed the values of the parameters of the Earth, its radius, diameter, circumference, its mass, its density, there are things that would change. You could potentially make it so that life wouldn't have been possible on this planet. But nothing about how we understand, of what we understand, rather, in terms of the way reality works, relativity, thermodynamics, classical mechanics, quantum mechanics, none of that's going to change. And it's through those methods that we know that the Earth is spheroidal. So the methods that we've used to determine the size of the Earth are not going to be changed if the size of the Earth were somehow changed.
Okay, so objectively, man, I'm not going to keep arguing it. If the size of the Earth is wrong, the entire model is intrinsically wrong. It's all dependent upon the mass of the Earth. Day and night cycle, gravity, orbital.
What about yeah? But like I said, those are all parameters that depend on what the size of the Earth is. We could go to anything. The size of the mass of the sun matters too. If we changed the mass of the sun, we'd get the same things. Things would start looking a little different. That does not mean that gravity somehow works differently. That does not mean that our physics does not work and doesn't give us accurate descriptions of reality. What you're talking about isn't that the math doesn't work anymore. You're just talking about changing the parameters within it. Yeah, that's going to change how the system evolves through time. But the fact that the system will evolve through a set of laws that we can determine that are based in symmetries and conservation principles, all that stuff, that's all going to be the same. Changing the parameters doesn't really mean anything for the physics of how we describe how systems evolve.
Okay, so you don't know how they supposedly measured the size of the Earth, and it's Alberuni looking at the horizon. It fluctuated. He reverse engineered a radius value. We have falsified that with physical measurements up the surface. It would require the radius be over 250,000 miles. If the radius
kind of measurements did you do?
Real fast. If the model is, or if the radius value is wrong, the entire model must be trashed because it's dependent upon that R value. This is just objective heliocentric perspective. So if you want to
R value, what?
The radius value, yeah.
An R value doesn't have anything to do with radius. The term R value has to do with insulation and thermodynamics and stuff like that. I think it's a measure of the thermal resistance. I think it's like over the area of a thing, the thermal resistance of the area. It's something like that. Yeah, I don't know. That doesn't have anything to do with radius.
Okay, so if the Earth has that radius, and we're supposed to see the curvature of the Earth at 1.2 miles away from 1 foot off the ground, how do we see the horizon over 10 miles away from 1 foot off the ground?
What? Can you repeat the question, please?
Yeah. So if the Earth's a sphere with a radius of 3959, it curves at a certain rate. That means you can see the curvature of the Earth at a certain distance away from you based on how high above the sphere you are, because it's curving away from you. So if I'm 1 foot off the globe Earth, I should see the curvature of the Earth block my view at 1.225 times the square root of the observer's height in feet. Simply, the square root of 1 is 1. 1 times 1.2 is 1.2. 1 foot off this magic globe Earth I'm so crazy for not believing in, the horizon should be at 1.2 miles. But yet we saw the horizon over 10 miles away. This is impossible geometrically.
Yeah, I would just have to crunch the numbers on that, which I'm not going to do right now because I don't think it really matters. I mean, a lot of the stuff really ultimately that you're bringing up just doesn't matter. There are ways that we know that the Earth is round that don't require us to actually do any measuring of the Earth. There are complete other physical theories we can appeal to that tell us that not just the Earth, but that all sufficiently massive bodies will be spheroidal.
So you agree then that there are no physical measurements of Earth curvature that exist?
No, I don't agree with that.
Do you know of one?
A way to measure the curvature of the Earth? Yeah. Walk from one place to another. Walk from, Tampa, Florida, all the way up to Boston, Massachusetts, and measure the difference in the position of the sun at the same time of day.
Okay. So
and you will notice it will change.
Yeah.
You'll be able to use that to determine the angle of curvature of the distance between Tampa and Boston. And then from that, you could essentially extrapolate all the other pieces and get the full circle and be like, oh, so yeah, the object that I'm standing on is a sphere and its circumference would be this amount. And then from that, I can determine what the radius and what the diameter would be as well.
Right. But so you have to assume the Earth's a sphere. So how?
No, you don't. You would. The thing there is what you're observing when you make that walk is that you're walking on a curve. That's not an assumption you go in starting with. It's something that you get out of doing it. That's a result of what you're doing. It accounts for why you see the world the way that you do. So on your model or lack thereof, you would have to account for why we can experience a curvature to the Earth's surface when there really isn't any.
We literally don't experience a curvature to the Earth's surface at all, ever in the entire.
Why does the position of the sun change when you move? Holy shit, I'm going to get this wrong. I think it's longitude, I think, is this way. Look, guys, I'm not a surveyor. I'm not a geologist. I do physics. Okay, I don't know this. I think this is longitudinal. Correct me if I'm wrong. But when you move longitudinally, if I'm correct on the Earth, the position of the sun changes. The position of the stars change as well.
Okay. Yeah.
And their change is proportionate to a definite curvature that we can measure on the surface that we're walking. Why?
Okay, because that would happen on a flat Earth, and I'm trying to explain it, but you really have impulse control issues. So when they looked at the sky, they reverse engineered the cyclical nature of it to apply it to a spherical assumption.
What does that mean?
So
reverse engineer the cyclical nature of the sky. I don't.
Yeah. So okay, let's take it word by word then. The sky has a cyclical nature.
What does that mean?
It has a cycle.
What? So, what do you mean by cycle? I'm
really
struggling.
Cycle. The stars have a reoccurring cycle.
You mean like they move
in a circle and a cycle?
Yeah, that that's because the Earth is rotating, right? That's why we see the sky spin like this, because we're on the Earth, which is rotating.
That's what you believe, yeah, because you have been indoctrinated. So anyway,
is the whole universe rotating around the Earth? Is that what's going on? Or are you going to go Robertson Genis on me?
The sky moves over top of the Earth. Yeah.
I don't. How? What does that even mean?
Observe. Isn't that what we observe?
No, it's not. We observe the Earth moving.
No, we don't. According to your model, we don't observe the Earth. No, according to your model, we don't observe the Earth moving. It's all relative because the mass of the Earth is so big based on the bending and warping of the curvature of space-time. You actually don't feel it. You're in a gravity well, and everything is relative. The Earth is so big, you don't feel it spinning, and actually the sky is still relative to our position in this coordinate system of space-time. It just looks like it's moving because the Earth is rotating, but we can't feel it. That is your claim.
Yeah, of course. We
Okay,
can't, just like when you're in a car going 100 miles an hour down the highway, you can't really tell that you're in a car going at 100 miles an hour down the highway. I mean, obviously, you know, is the little bumps and stuff in the road, but if that road were like perfectly smooth, there's no bumps or dips or any what's often referred to as a change of vector, you would have no idea that you were moving. This is why in an airplane at almost 700 miles an hour, you are sitting there like, oh yeah, I'm in my couch in my living room, because that's how that works. You don't feel movement, you feel acceleration.
Yeah, and the Earth is rotating, which means it's accelerating.
No, it's not.
Oh, really?
No, the Earth's rotation is slowing at a rate that is so slow that we are never going to be able to tell that change. It would be like slowing down from 100 miles an hour to 0 miles an hour at 1 mile an hour per year. If you were to be, if I understand it's somewhat of a contrived hypothetical, but it makes the point. If you were in that car for 2 years, you're not going to notice the change from 100 miles an hour and 98 miles an hour over that 2 years. I'm sorry, but you're not going to notice that the car has slowed down at all.
Okay, so I know your argument, right? But the reason it's not analogous with the car is
but do you understand it?
Far better, actually. So if you're driving the car and you turn it, are you going to feel it?
Yes, that's a change of vector.
Oh, so if it turns, you feel it. So is the Earth turning?
Is the Earth rotating? Yes.
Okay, so it's intrinsically changing direction then.
Changing what do you mean?
If something's rotating, it's constantly turning.
A rotation, yeah, that angular momentum, yeah, but not linear momentum. This would be angular momentum.
Oh, and so we just wouldn't feel it. So I already said
not on something that's as large as the Earth is. Why?
I said I said that already.
So if you said it, then obviously you understand this. Then I don't know what your contention is. Obviously you understand that the Earth is a very large object, and because it's so large, and our entire existence has been confined to the planet in the atmosphere that is also rotating at the same speed as a result of friction with the Earth's rotation and everything. We're not going to be able to feel that it's rotating. I mean, if you understand that, what is it about that you're contending with? If you seem to understand it so well.
Do you think the fact that you wouldn't theoretically feel it proves that it's spinning?
Well, no, of course not.
Okay, so what's the proof it's spinning then?
The proof that it's spinning would be the fact that we have actually measured the angular momentum of the Earth. We do have instruments sensitive enough to do it. And there's actually an instrument that's not just sensitive enough to measure the angular momentum of the Earth as it rotates, but can measure a change in that momentum, that force going along the surface of the Earth longitudinally. I believe it's Foucault's pendulum is the device that we can use. Also, we see that the sky is spinning in the same direction we would expect the Earth to be spinning if it were. And yeah, these tell us that the Earth is spinning.
So we saw the sky spinning, and so if we theorized that the Earth was a globe spinning and it made the sky look like it spin, it only had one direction it could be spinning, because that's based on what the sky is doing. It's not. It doesn't match the rotation that we expect the Earth to be. That's not what happened. It has to be spinning.
Are you saying that if the Earth if the Earth were rotating, we wouldn't expect to see a rotation in objects in the sky?
I didn't say that. No.
Well, that's the statement that I made. If the Earth were rotating, we would expect to observe a rotation in the sky, given that we're on the Earth.
Okay.
And we do see that.
Yeah. Okay. So
that serves as evidence that accounts. So the idea that the Earth is at least rotating, regardless of what its shape is, accounts for why we see the world this way.
Right. So that's if the stars in the sky are still. Right. So what we actually
they're not still.
Right, you're right, because I time lapse them all the time. They're constantly moving in perfect circles. Yeah.
Well, not in
so
perfect
so
circles,
here's the
but-
question: if the Earth was stationary and the sky was moving, would we observe the same thing?
If assuming it's moving in just the right ways, yes.
Yeah, east to west, like it does.
Well, I mean, just even beyond that.
No, everything else works perfectly.
Well, assuming that it moves, I mean, if everything was, the sky was moving, but it was moving like across us like this, then we wouldn't expect to see a rotation. So we would only expect to see that if the Earth was stationary, the sky would have to be rotating, but the sky isn't like an object that can move like that. So that's another reason why we know that that's not the answer, because like the sky isn't a thing that can rotate.
Okay, the stars in the sky.
How do you know that?
Bud.
Around the Sagittarius A star, yes, not around the, surprisingly enough, what would be the center of the axis of the Earth, because it looks like the sky is rotating around that, which is also something which comports with the idea that the Earth is not just rotating, but is a sphere and is rotating about an axis.
Okay, so yeah, they all revolve around Polaris. We don't actually feel the movement. Your argument is that it's so big you wouldn't feel it. Cool. Still, objectively, we don't feel it, though. That's objective.
Sure.
And then we see the stars move. You claim that it looks like they're moving in a circle, but they're actually sitting still. It's just because
the stars aren't sitting still, no.
Yeah, relative to our reference frame.
Well, yeah, sure, but at that point, I mean, there is no wait, what do you think motion is? You do realize there's no such thing as absolute motion, correct?
Why are you diverting?
No, you're the one that wanted to divert. You said relative to our reference frame. Well, of course.
Yeah, because you just said that they weren't still, and I rebutted.
Yeah, the stars are moving. Yes.
Oh, the stars are moving in.
Yes, they are. The whole. You do realize the Milky Way galaxy is rotating, correct?
Cool. Yeah.
Yeah. So obviously, the stars and our solar system, which is around a star, would be moving with all the other stars. We do not exist for long enough to really see that. I mean, for Christ's sakes, it takes the Milky Way galaxy 225 million years to do one rotation.
That's all pseudoscience, fairy tales.
I don't know what you mean by pseudoscience. These are things we've measured quite well. In fact, we've measured the rotation of not just our own galaxy, but many other galaxies so well that we realize that the amount of baryonic mass that is present in the galaxies isn't enough to account for why they're held together, despite the fact that they're rotating so quickly, which is why we have a thing like dark matter. There has to be some extra mass to create the gravitation to hold the galaxies together, because they're rotating too quickly to do it on their own with just the mass that we can see. So yeah, we do know that galaxies rotate. Well, all of this stuff is obviously tangentially related, and it all comes back to proving my point that the methodologies that I rely on and that everybody else in the sane world here relies on obviously work, and those methods tell us that the Earth is a spheroidal ball that is rotating about an axis and orbits a star.
Okay. No, it doesn't actually. All practical use assumes the Earth's a flat, stationary plane, like flying a plane. Military documents about horizontal propagation, electromagnetic propagation for ground weapon systems. They had to assume the Earth was a dielectric, stationary plane. Helicopters, ballistic missiles.
Relativistically, of course.
Okay, so your claim is that we have to treat the Earth always like it's stationary and flat for anything to work, but it's all relative.
Well, we don't have to do that. We choose to do that for convention because it just makes the math easy.
No, it's because people would die if you didn't do that. If you flew a plane in a spin that was spinning and curving, if you had to account for spin and curvature in a plane, everyone would die.
Well, no, it's just that we don't need to account for the spin and the spin of the rotation of the Earth.
That's convenient.
Well, yeah, because why would we need to? We're spinning with it.
Well, actually, no. Your model claims that the atmosphere doesn't move in synchronicity with the Earth.
Well, not perfectly. No, of course not. What do you think weather is, and like wind and stuff like that, and tornadoes?
Those are just weather patterns within the atmosphere. Your model, what you just said would require it to move in synchronicity, but your model does not.
No, not necessarily. It doesn't have to move in synchronicity. The atmosphere largely is spinning at the points closest to the Earth at roughly the same speed that the Earth is rotating in those areas. with the atmosphere, I mean, there's going to be a gradient to its movement, and there's going to be turbulence in it because you have electromagnetic radiation coming from the sun. You have a bunch of thermal and geochemical processes and geothermal processes and all these other geophysical processes occurring that are adding all this turbulence into the atmosphere. You've got humans that are doing things. You've got the tides, all this stuff having an effect. Yeah, it's not going to be like 100% synchronous moving with the Earth.
Okay,
it's a fluid.
Yeah. So anyway, is there any scientific evidence of axial rotation?
Rotation about the axis? Yeah, the fact that we observe the stars in the sky, they rotate, and they seem to do so about an axis, which is exactly what we would expect to see if we were on a sphere that was rotating about an axis. And it is scientific because, as anybody who knows science understands, the beauty of science is that we can go out and make observations about the world and then find models or form models that help account for the things that we see in the world. And the idea that we are on a planet that is a sphere largely and that is rotating about an axis accounts for looking up and seeing. If you've ever seen the videos, you can see it looks essentially like the sky is rotating. We would expect to see that if we were on, an Earth that was a globe.
And we expect to see that if the Earth is stationary and the sky moves like we see it. So
but see, that's correct. But there are other reasons.
Otherwise,
there are other reasons that we have for thinking that the sky doesn't spin, because the sky isn't an object that can spin. That's just not what the sky is. I mean, you do realize that if you were to just and again, a contrived hypothetical, but it makes the point. If you were to just float up, that you're not gonna hit something. You're gonna continue out into the vast reaches of space. You do realize that, correct?
I know that's a fairy tale. Yeah. So
what do you mean a fairy tale? We literally what days?
Okay, just to be sure there's not too much interrupting. I just want to be sure.
I'm sorry.
Because there is a lot of define this, and that's okay, but it might also be there's a lot of interrupting where I don't want there to be too much. So we might jump into 2-minute kind of modes there for a little while if it doesn't slow down.
Cool. Yeah. So as for there's been no scientific evidence offered for axial rotation. Measurement, which is the first one, the dimension claim, that's actually not a scientific question. That's a measurement question, but there's no physical measurement of Earth curvature. He failed to provide that. He failed to provide any scientific evidence of axial rotation. Observation is not scientific evidence. That's the first step of the scientific method, your dependent variable. Science is literally the study of the cause of an effect, which is your independent variable, which must be varied and manipulated. That's what the scientific method is. If I can just go look at something and make up stories about it and then claim it's science, then science would have no value. So there's no scientific evidence for axial rotation that you can think of, or do we need to move on to the third one?
Yeah, there are. I just wanted to say that. See, you propounded this oft refuted and just not true idea that science is all about causes and effects. That's just not at all the case. There are areas, very well understood and very precisely measured areas of science where causality isn't even a factor. And you can ask most physicists and they'll tell you causality is much like temperature. It's like a phenomenal result of our experience of reality at the scale that we experience it, but it's not this fundamental property that's built into reality. That's not a thing. So much like temperature, causality is just a result of how we experience the reality that we exist in at the scale that we exist in. So that's just not true. You said observations aren't evidence. Literally, they are. The whole point of science is to observe things about the world, find out facts about the world. We look at the world, we see it a certain way, we see it doing things, and then what we need to do is we need to find ways to account for that. Now, I wasn't expecting to have to go into like a lecture on a philosophy of science, but largely when it comes to accounting for things in reality, being a scientific explanation, this is often construed in terms of grounding counterfactuals. Don't know if that's a term you've ever heard. And what this means is that if we want to say that X explains Y or accounts for Y, then we need to be able to establish a counterfactual such that if Y was not observed, then you wouldn't expect to see X. If you can't establish that, then in what sense does X account for Y? If you could get X in the absence of Y, then obviously X doesn't account for Y, or at least not Y exclusively. And then that results in other things, modifying models and things like that and what have you. But this is how it works. So if we see something, we want to account for that. We need to be able to say, okay, what about the world would give us this thing that we're seeing? If we weren't seeing this, what else would we expect to see? What would be other things that we expect to see? And this is why these things are explanations. Being on a sphere that is rotating about an axis explains, it accounts for why we see certain features of reality the way that they are. And sure, there might be other ways that can at least prima facie account for it, and this will be my last point, but there are reasons why those aren't nearly as parsimonious as the idea that we are on a globe.
Okay. Yeah, that's actually just not true. So the default position based on all observable phenomena is that the Earth doesn't move. It's stationary. To do anything in the practical world successfully, you must assume it's stationary, as in fly a plane, shoot a bullet, you name it, or you would not be able to successfully implement practical use. So actually, we just treat the Earth as a stationary. The sky moves over top of us, all circling around Polaris, the North Pole star, over the North Pole, quote unquote, just a geographic location you're not allowed to go to, and it continues to reset. The default position is that. Now, you're making a claim antithetical to observable phenomena, so you have the burden of proof times a million. You're making a claim antithetical to what's actually observed and can be verified. So to flip the script and pretend that if we don't blindly believe your claim antithetical to all observations, we are out of pocket is a bit off-putting, right? It doesn't really make sense. So there's Einstein himself, I'll help you out, I'll throw you a bone, right? Einstein himself said, I've come to the conclusion that there is no optical experiment on the Earth that will ever prove the Earth's movement, although we know it revolves around the sun. So there is no earthly observation that can prove the Earth is spinning according to your own side. It's just philosophical, it's theoretical, and that's just that. And so, yeah, unless you got some scientific evidence, it's just sophistry.
So I just really quickly want to recap. I did outline what is evidence, and then I explained why it's evidence and how we know that it's evidence. I didn't really hear much in the way from you in terms of responding to that. You did cite Einstein, and that quotation is correct. But the thing that is often left out is what Einstein was speaking about there was movement of the Earth through the ether. This is why he referred to an optical experiment. We are never going to be able, if the ether, the luminiferous ether is and there's still people that believe in even that, and it's if that were a real thing, there's no experiment, there's no optical experiment we would ever be capable of doing that's going to be able to determine the Earth's movement or any drag on Earth or on light being emitted from Earth as it moves through that ether. So that's what Einstein was referring to. He wasn't referring to any way of detecting that the Earth moves. But since you brought up Einstein, let me bring up my favorite piece of evidence in favor of the flat Earth, and that's Einstein's field equations. I don't know if you've ever heard of those, but obviously Einstein is a source that we can both agree is reputable. Otherwise, I don't think you would have cited him, even though the quote you cited had nothing to do with the motion of the Earth simpliciter, but the motion of the Earth through the ether, which is also a thing that isn't real. Einstein's field equations describe essentially what gravity is, and they tell us that mass energy has an effect on space-time, and we don't really fully understand yet that because we don't have quantum theory of gravity. But essentially, the point that I'm getting at is that when we look at Einstein's field equations, what we see is that there would be something called hydrostatic equilibrium on massive enough objects. Once an object gets massive enough, there's going to be a tension on its surface. There's going to be a tension on the object as a result of its own gravitational force, the field acting on the object, creating the field. And that material is going to have a resistance to that tension, and it's going to find a shape that can most reduce the tension across the surface of that object. And as anybody versed in material science or physics knows, that's a sphere. And that is why stars and planets are spheroidal, because of the hydrostatic equilibrium between the tension on that object as a result of its own gravitational field and the resistance of the material, which is given like by the Pauli exclusion principle and things like that, but I'm not here to talk about quantum mechanics, that results from the material that is creating the field that is then putting the stress on it. And it's sort of a symbiotic relationship between those two.
Cool. So it's just theoretics. 1905, he attributed constant speed to light, which actually quantum mechanics pretty thoroughly debunked that. They
No, it
cannot
hasn't.
coexist. To even say the word theory of relativity and quantum mechanics in the same sentence is actually laughably ignorant. But anyway,
Wait, do you not know what relativistic quantum mechanics is?
I know that relativity can't coexist with quantum mechanics.
Well, general relativity has not been reconciled with quantum mechanics. Special relativity has been. And just a quick point for the sake of the audience, the U1 gauge transformation symmetry group, which is what we use
Just
in
to be
quantum
sure,
mechanics to define electromagnetism,
well
gives the speed
distributed.
of light.
Okay, maybe you're not hearing me. Just to be sure the time is well distributed. We are going to go into the Q&A shortly. You guys have got a little bit of time yet, but just to let you guys know that.
Okay, so the point is just that actually it doesn't matter. That's a non sequitur anyway. So it was proposed in 1915, superseded Newtonian mechanics. It actually claims to attribute physical properties to conceptual abstractions, one of which is a privation. It
Okay, I
does
do need you to stop talking while Witsit is talking, to be fair, because I don't want Witsit to do the same to you, okay?
So space-time is conceptual, right? So space, the idea of emptiness, nothingness, a privation. Time is a quantification method that we use to quantify passing. We've put it into a coordinate system, right, using breadth, height, width into quote-unquote space to determine this effect of a gravity well, and that gravity effect of the bending and warping of space-time. Anyway, on its face, it's inadmissible. Conceptual abstractions cannot in any way have physical properties. It's also fallen apart as early as the 50s. The galaxy rotational speeds debunked it. Also, as recently as modern times, we now have dark matter, dark energy making up 95%. That is not accounted for in relativistic application, and it's off with 95% of its occupancy claim. So it's not even close to being viable mathematically yet, and none of that even matters. It's all begging the question, because on the local scale on the Earth, you never account for gravity, you never account for spinning, and you never account for Earth curvature. This is just objective, and we need scientific evidence before we believe cartoons from governmental agencies. So we need actual physical scientific evidence, bro.
Am I good, Austin?
You're good, man.
Okay. So a few things here, and I promise this is all going to loop back to how we know that the Earth is not flat, that it's a sphere. So the first thing is, you said that space-time is this conceptual thing. It's not, and ultimately this gets into a lot of philosophy of physics, which I really don't want to get into, and I don't think the audience is really interested in getting to. But if anybody would, I would just recommend looking up things like relationalism versus substantivalism with respect to space-time, and it's the ontology of space-time. In fact, this is a thing I've been reading on a lot in the past couple of days, because I've been doing a lot of reading into things like structural realism and ontic structural realism and relational quantum mechanics and other areas of metaphysics. So this isn't something that's new to me. There's a huge philosophical discussion being had on this, but even substantivalists, relationalists, both would and every physicist I have ever talked to in my life would reject this idea that space-time is purely conceptual. It was proposed not in 1905, but in 1915, at least general relativity was. Special relativity was published in 1905, and Sir Arthur Eddington actually observationally confirmed general relativity in 1917 when he observed two stars that were supposed to be behind the sun, that are behind the sun, but he observed them out here as a result of what's ultimately a shear through the dimension of time, which is how we know that time is actually a real physical fundamental dimension, because it can actively be sheared by the stress of mass energy as described by Einstein's field equations. So he measured that, showing and the amount by which their trajectory was off as a result of the curvature in space-time was precisely what general relativity had predicted. General relativity has never once failed any test that it has been put to. It isn't a complete theory, but that doesn't make it a wrong theory. The reason all of this matters is because, again, I'm making a much broader argument here, not just that the Earth is a sphere, but how we know that. And we know that through a set of sound methodologies that all scientists across the planet utilize, and that all of these methodologies obviously give us accurate descriptions and ways of understanding reality, because if they didn't, none of our technology, the very technology we're using to have this debate, this discussion right now, would work. And so if we can trust them in other areas, why wouldn't we trust them here? All of this science shows that the Earth is a sphere, that it rotates and it orbits the sun.
Yeah. So you cannot provide any substantive specificity of empirical evidence. You just keep making claims appealing to technology. An accelerometer must prove that the Earth's a globe and that gravity bends and warps and physical properties can be attributed to concepts because I have an accelerometer in my cell phone. The electrical grid uses nothing to do with the Earth being a globe. None of our technology does. You can't fly a plane, can't drive a car, assuming that the Earth is a spinning globe. None of that is real. It's just this vague claim, void of specificity, so you can basically appeal to majority or consensus, appeal to authority and credentials. And this is insufficient and in no way admissible in intellectual form. We need empirical evidence. There is no empirical evidence of Earth curvature, no physical measurements of it, only physical measurements falsifying it. You admitted that you didn't know the radius, didn't know the curvature rate, didn't know where it should be seen, and you didn't know how it was supposedly measured. You then said that if the radius was falsified, it wouldn't debunk the globe. Well, every single person with any knowledge or competence on your side at all would tell you that you're patently wrong. Then I asked for scientific evidence for axial rotation, yet to get any whatsoever. There is none. Just pointing at the sky and saying, I think that's what it is, believe my story, and this is how you can apply my story. It's called a begging the question fallacy. It cannot be invoked to prove the very thing you are claiming to prove. That is very fundamental, rudimentary fallacy. So there are the two primary things. Of course, the third one being you can't have a pressurized system adjacent to a near perfect vacuum of 10 to the negative 17 torr. The second law of thermodynamics would not allow that. So there's your three core claims, and they cannot exist. They've been debunked.
I guess I don't understand what this three core claims thing is. The only thing that's being claimed is that the Earth is a sphere, that it rotates about its axis, it also wobbles about its axis or precesses about its axis, and that it orbits a star, all of which can be confirmed just by higher order mathematical theories that have been confirmed at literally every point we've ever tried to test them. Not only that, but we could, I mean, I know flat earthers don't like it when people say this, but that's because it's the easiest way to show that their worldview is wrong and they don't have any objection other than just blatant conspiracies. But we've gone into space. It was 5 days ago that we put the James Webb Space Telescope, and we watch it go up into space. It didn't hit anything. Where did it go? Did God like swallow it up or something? What happened to it? How does a flat earther account for literally watching a thing go up into space?
Yeah, so I actually document the rocket launches personally. I know you probably never have done it. I document them with the highest power commercially available zoom that there has. I actually debate the NASA employees on scene. So I find it quite rich that you think that you can bring up the fact they shoot rockets in Cape Canaveral, which I'm about an hour away from, and constantly document it as if that's some proof of going to a medium that defies the second law of thermodynamics. So to appeal to the authority of the government means nothing to me. NASA was founded admittedly with Nazis, Werner von Braun, Operation Paperclip, declassified. They've lied about all kinds of things, including quote unquote global warming temperature recordings all the way back to the 50s were doctored. It's one of the most corrupt establishments that there is. And so I don't actually have to blindly believe stories about NASA sending stuff into a vacuum that can't exist. But what you will find out, or what's becoming abundantly clear, is you cannot respond with specificity. You cannot have a vacuum next to a pressurized system. This violates the second law of thermodynamics. Claiming they went to Narnia doesn't make Narnia real.
Can you tell me what the second law of thermodynamics states?
Yeah, entropy will increase. In this sense, entropy
what
will
is
increase.
Entropy?
Yeah, entropy will increase as in it will seek equilibrium spontaneously.
What is entropy?
Which part of my definition do you not?
Well, no, you're using the word entropy. You're saying entropy will increase. What is entropy?
Effectively, the pursuit of equilibrium.
I don't know what that means. So the second law of thermodynamics essentially states that if you contain energy, if you localize energy into one system or one state, it's intrinsically going to leak into the others. It's really the simplest way to put it, primarily because thermodynamics isn't really a simple field. Nothing about space-time violates thermodynamics. It operates with thermodynamics perfectly fine. We understand the thermodynamics of vacuums actually quite well.
Do you understand the question, right? So the second law of thermodynamics necessitates that pressure fills the available space. Systems seek spontaneous equilibrium. Entropy will increase. This is a natural law. So if you have a pressurized system adjacent to a near perfect vacuum of 10 to the negative 17 torr, the high pressure system will violently fill the low pressure system seeking equilibrium. So how does that not happen? That's an antithetical. That's a claim antithetical to natural law.
Well, entropy increases globally, but not locally. The Earth is an open system receiving energy from the sun, so it's not currently undergoing those particular thermodynamic processes. And there's a lot of places in the universe that aren't. But I don't know what you mean when you say pressurized. If Earth's atmosphere is quote unquote pressurized, then you would be admitting that there is a force acting on the atmosphere that is containing it to the Earth, despite the fact that it slowly dissipates into a vacuum, which would be correct. That force is gravity.
Slowly dissipates into a vacuum is not in any way what it would happen. There's nothing slow about gas pressure going towards a vacuum. It's instantaneously seeking equilibrium. So there's nothing about dissipating gradually into a vacuum of space. You told me that basically thermodynamics isn't happening on the Earth locally. So I guess the second law of thermodynamics switch got flipped off, and now we can have pressure sitting next to a vacuum. So it doesn't work. And no, I don't have to claim that there's a force pulling anything down. There's a physical container. That's the necessary antecedent to pressure.
So one, I didn't say that thermodynamics doesn't work on the Earth. I said entropy isn't increasing on the Earth because the Earth isn't a closed. Wait, you do realize that only applies to closed and isolated systems, of which the Earth is neither. The Earth is an open system because it is receiving energy from outside of it, namely the sun. Entropy only applies in closed or isolated systems. Now, the whole universe is an isolated system, and entropy on the average globally over the whole universe is increasing, but on Earth, it's not. Also, the container again is gravity. The reason that there's like mass hovering around the Earth, so to speak, is because there's a gravitational field there. I mean, if I put a bowling ball on a trampoline and then I dumped water on the trampoline, and let's just assume like that the water doesn't like leak through the trampoline or anything, don't you think it would all just like roll right down and sit in the well that the ball is creating in the trampoline? It's not just going to go and fly across the sheet, even though there's no water or matter on any other part of the sheet. But it's because it's curved. The water is following the curves. The atmosphere of the Earth is following the geodesic in space-time toward the Earth. That's why it's on the Earth.
Yeah, we're talking about gas, so try to keep up.
Yeah, that gas is matter.
Okay, so
gas has mass.
Yeah, so we're not talking about the water bending around the Earth. We're talking about gas pressure sitting next to a vacuum.
Yeah, wait, do you know what a vacuum is, right?
There's no such thing as a perfect vacuum. It's all near perfect vacuum, at least 2 hydrogen atoms per cubic meter. I know your religion very well. It's why I'm not a part of it.
Telling me that there's no such thing as a perfect vacuum, a thing that I didn't even claim, doesn't answer the question of what is a vacuum.
Yeah, it's nothing more than an area where you manipulate the density of the medium, and there's at least a few hydrogen atoms per cubic
medium
meter.
Of what?
The container.
What do you mean container?
Well, you're saying that you can have a vacuum without a vacuum chamber?
Yes.
Really? How so?
Yeah. The vacuum of space-time.
Oh, so by reifying and begging the thing in question.
Well, no, a vacuum chamber recreates what that is. You realize that, correct?
And the only way to replicate it is to have a container.
Yes, because Earth has an atmosphere. You could also replicate it by just going outside of Earth's atmosphere.
Okay, so can you provide any evidence of gas pressure without a container other than begging the very question?
What do you mean by gas pressure? Do you mean the fact that there is a roughly 14, I think it's like 14 and a half PSI pressure of the Earth's atmosphere at sea level? Is that what you're referring to?
It's not just at sea level, it's everywhere. Pressure is the energy or force.
It increases or decreases as you go up in elevation. That's why I specified.
That's a non sequitur. We're talking about the antecedent relationship, as in the requirement of pressure. It's the energy or force exerted on the walls of a container. The antecedent is the container. If you talk about the gradient, that is qualitative, or that is quantitative, right? So you're conflating qualitative and quantitative, like delta X, right? We're asking you, how do you have X? That's gas pressure. You're invoking delta X, change in X. Change in gas pressure has nothing to do with the antecedent requirement for the gas pressure to be there, which is physical containment. So
I don't know what you mean by physical container. There's a pressure because Earth's atmosphere rotating mass feels the curvature in the geometry of space-time around the Earth, which is going to curve it towards the Earth. That's why I was drawing an analogy. Like if you put a bowling ball on a trampoline and assuming that water doesn't leak through the sheet, and you dumped water on the trampoline, the water will roll down and sit in that pocket that the bowling ball makes where the bowling ball is, because the sheet that you dumped it on is curved. Why do you think things fall toward the Earth? Because space-time is curved in that direction. Well,
What
if
about
it's
helium
curved
balloon?
in that, well, that's because of the density of the Earth.
Okay,
Or
so
the density of Earth's atmosphere
so
compared
when
to
you
helium.
say things fall to the Earth as if it's an all-inclusive statement, it's inaccurate. Not all things fall to the Earth.
Well, I think you understood the context that I meant when I said that. I think most people did. They obviously, I wasn't referring to helium balloons because I don't think anybody's ever seen a helium balloon fall to the Earth.
So then you understand your own question's answer is very simple. You answered it for the helium balloon. It's the same answer for when something else goes down. We can get really specific. Everything's
Wait,
intrinsically.
so why do basketballs fall down? Like basketballs are filled with the air. Like they're pretty much 99% air, other than this 3 millimeter, 5 millimeter layer of material that forms the outside, like the part of the ball that is the basketball. How come those fall? And why did they fall at the exact rate that gravity says they will?
Basketballs are more dense than the air, and 9.8 meters per second squared is just agreed upon average. It doesn't happen every time for anything.
But basketballs are inflated with air. They're like 99% air. Why would they not kind of like hover there or fall a little bit more slowly? I'm confused.
Because the matter of the basketball material is more dense than the air.
But why does it fall at the rate that gravity says it will?
It doesn't always fall at a specific rate. Okay, so 9.8 meters per second squared is an agreed upon average. Yeah, there's an average rate of fall. When something's more dense than the air, it goes down. It has an average rate of fall. That's a non sequitur.
I don't think you understand what gravity is.
I know it.
That density in our atmosphere isn't why things fall. Helium balloons rise because helium as a gas is less dense than nitrogen and oxygen.
Okay, so density.
For helium balloons, yeah. You're talking about gases in gases. I'm talking about like objects, solid objects in gases.
They're more dense than the gas.
Yeah.
Okay, so what happens when I drop a golf ball? If I drop a golf ball in the water, then I drop a ping pong ball in the water, what happens?
If you drop a golf ball or ping pong in the water, it floats, which kind of confutes your argument.
No, the golf ball sinks and the ping pong ball floats. Right, the ping pong ball is less dense than the water. The golf ball is more dense.
It's actually
than the
more
water.
Because the ping pong ball has air in it.
Okay, and it does.
If I had a golf ball and filled it with air, it'd probably float.
You could fill a golf ball with air. Okay,
I said
so
if I were to, yeah, probably. Yeah, no, things fall because of gravity, and gravity is a pseudo force. It's nothing to do with buoyancy in Earth's atmosphere. It does have a thing to do with density.
Meaning it's not actually a force. Pseudo force means
no, of course not. Yeah.
Yeah, so it's just a fairy tale. It's a force that you can think of like a force that acts like a force, but it's not a force. It's the effect of the bending and warping of space and time. It's not the causal agent. It's not the causality anymore. It's no longer considered the intrinsic property of matter. When you say mass attracting mass, which you have not, of course, it's incredibly ignorant and makes no sense because the intellectual framework is patently different. So that's the point. You're making a claim about gravity. Can you please prove it? You're claiming gravity holds gas down next to a vacuum. But what we know about the behavior of gas, which there are numerous laws about this, right? It's just a known natural phenomena, right? Gas disperses in all directions, omnidirectional, instantaneously seeking equilibrium. So if it does that at the surface where gravity is the strongest, then how is it going to stop it from doing that next to a vacuum where gravity is weaker?
You do realize that gases only disperse when there aren't forces keeping them together, correct?
Gas is always dispersed to seek equilibrium.
Not if there's forces keeping them from doing that, correct?
Like what?
Like gravity.
When does gravity stop gases from going omnidirectional dispersal?
In atmospheres on planets, in stars. Stars are plasma, which is a higher state of matter than gases. The reason they're kept together, and also the reason they're spheres, is because of gravity.
Yeah, so why doesn't it stop the gas from going in all directions at the surface where it's the strongest then?
I don't know what you mean.
If I let out gas out of a container on the surface where gravity is the strongest, it will go in all directions.
What do you mean let gas out of a container? You mean like a pressurized container where the gas is coming out because you've pressurized the inside of it?
Well, to have any pressure, yeah, you need a container.
Well, no. Do you know what static pressure is?
Can you give me gas pressure without a container?
Yeah.
Please.
So this lighter is hovering just in the room. There's nothing around it. It's not in a container. There is a pressure on this lighter from Earth's atmosphere.
Okay, so what is that? Okay, if you remove the actual physicality of the lighter, can you keep the butane gas in it?
Well, of course not. There wouldn't be a lighter there.
Thank you. So in order to have pressure, it requires physical containment. Yeah.
No, that's not what pressure is.
It's literally the definition of it. Gas pressure is defined as the energy or force exerted on the walls of a container.
No, it's pressure is the continuous physical force that is exerted on something that is in contact. So when I punch my hand, I'm exerting pressure on it. What does a container have to do with any of this? I don't think you understand what pressure is.
I said gas pressure.
Well, gas pressure is just pressure being applied by a gas.
Okay. So I can cite NASA saying that the definition of gas pressure on NASA's own website is the energy or force exerted on the walls of a container. That's why it's called pressure, because it presses.
It's the force exerted by a gas on some object.
The walls of a container. Yeah.
Well, it doesn't have to be the walls of a container. If I did set this lighter up and I blow, and actually the lighter literally did slide and fall down, I exerted a gas pressure on that because my lungs were exhaling gas, which hit that lighter with a force moving it.
Right, your lungs are containers, my man.
Yeah, but containers have nothing to do with the pressure that I applied using a gas on this lighter to move it.
Yeah, I did. It's the only place you had the pressure built up to excel it.
Yeah, but that doesn't have to do anything with me moving the lighter with it. That has to do with me getting it into my lungs. Those are not the same scenario.
The point is the necessary antecedent to gas pressure is a physical container.
No.
Okay, well, if you can cite a physical demonstration that can be replicated to provide evidence, otherwise,
atmosphere.
That's a star. Begging the question fallacy.
What question am I begging?
That the Earth's a ball with a spherical atmosphere.
No, it's not. The Earth could be flat. It still has an atmosphere, and there's still space. 100%. Austin, the Earth is flat. I'm granting the Earth is flat, but it still has an atmosphere, and that's still held to the Earth because of gravity.
A atmosphere. Yeah, gases have no intrinsic shape. But anyway, so the point is you're supposed to be proving how gas can sit next to a vacuum, and your proof that we've gotten all the way down to is Earth's atmosphere proves it. That's called a begging the question fallacy.
Well, that wasn't.
That's all we've got. We can move on. I mean,
that wasn't my argument. I said gravity is what holds Earth's atmosphere to the surface of the Earth, despite the fact that the rest of space would be a vacuum.
And I asked you, why doesn't gravity prevent gas from going in all directions at the surface where it's the strongest?
I don't know what you mean when you ask that. What do you mean all gas is going in all directions at the surface?
Yeah, if I let go of gas at the surface level, it will go.
What do you mean let go? Are you talking about like if I just open my hand now?
No,
the gas is largely just going to sit there, or it's going to move as a result of the turbulence of me opening my fingers.
It's going to move in what direction?
Whatever direction the turbulence is acting as, which is probably going to be in the directions that my fingers opened.
It's going to be in all directions.
No.
Yes.
My friend, if I were to go downstairs, grab one of our Tupperware containers, put the lid on it, bring it up here, and just open the lid, the gas in the bit of atmosphere gas that I put in there is only going to move because I've opened the lid, and the moving of that lid creates turbulent force, if you know what turbulent force is, that will then pull that gas out of the container. But it isn't if you could theoretically remove the lid without any of that turbulent force, it would just sit in there. And I can set that container on the top of my desk, and there will still be gas in it. So it's not going everywhere.
We can move on. So container of helium, okay? Put it on the ground. Take the lid off of the container of helium. What happens to the helium?
The helium rises.
It actually disperses in all directions.
Upward, yes.
Also upward. Omnidirectional includes upward, yes.
It's meaning it's going like this.
Okay, so is upward the opposite of down?
In a gravitational field, of course.
Well, gravity has a singular vector of down relative to the center. I don't know what that means. A single vector of down relative to the center of mass on a sphere. Well,
Okay.
up is antithetical to down, where gravity is the strongest, gas goes in all directions. Please tell me how you're going to prevent it
What
from
do you?
doing.
I don't know what you mean when you say that. When you say gravity or gas goes in all directions, gravity. Wait, it just makes no sense.
All right, it's getting pretty circular, man. It objectively makes sense. So.
Well, I don't. You're not doing a good job of explaining how.
Oh, well, gas just always seeks equilibrium by dispersing omnidirectional relative to its environment. That's just how it works. It's called the second law of thermodynamics. Heat goes to cold, high pressure goes to low pressure. This is a natural law. It's not debated.
Yeah, but what if the whole system is already largely at equilibrium and I open the container? What happens then?
How is the open system largely at equilibrium if it's sitting next to a 10 to the negative 17 torr vacuum?
What do you mean?
It's sitting next to a 10 to the negative 17 torr vacuum. So
I'm talking about pressure. I'm talking about in terms of gas pressure. So if I were to have a Tupperware container in front of me and I close the lid and I open it, you're telling me that essentially everything in that container is going to go out and I'm just going to have a vacuum left in the Tupperware container?
No, that some air will reside in the container because of the relative densities of the medium around it.
Of course, yeah. So I don't know what your whole point this time has been.
Gas always disperses in all directions. Just because the air will basically fill back in there because it's the same density as the surrounding air doesn't mean that air trapped in isn't still moving around seeking equilibrium. If you don't wait, is your claim that air just sits still? Is that your claim?
No, my claim was that if absent the turbulent forces of the opening of the lid, then yes, it would. So what if I just what if I just take this cup that has nothing in it right now? How come there's not a vacuum in this cup right now? The cup is a container, is it not? It contains a gas right now, does it not? Why is the gas not dispersing out of it equally?
Is the container closed?
No, it's a container though.
So what do you? The gas is leaving the container.
No, it's not. So there's a vacuum inside this cup.
No,
I don't think there is.
It's the same air. Do you actually think this is analogous to an extreme pressure differential?
Well, that's what you're making it out to be. That I don't think you understand the point that I'm getting at here is that you keep saying, oh, well, the gas will disperse in all directions. No, not always. That's only if it's lower pressure than where the gas was released from.
Okay, so then in the conversation we're talking about, objectively, the gas would disperse in all directions next to a vacuum, right?
Assuming that there is no other forces keeping the gas wherever it's located, yes.
But that force where it's the strongest doesn't keep the gas anywhere. So how is it going to do?
I don't know what you mean. It keeps the gas on the surface of the Earth.
Is gravity stronger at the surface or next to outside of our low Earth orbit? Low Earth orbit. Which one's stronger?
At the surface.
Okay, so at the strongest accessible area of gravity, if I let out gas, it goes in all directions. Gravity does not magically prevent it from going somewhere or keep it there. It goes in all directions. That's where gravity's the strongest. So why doesn't it do it next to a vacuum where gravity's weaker? How could it possibly do that?
Why isn't it doing that in my cup right now?
There's
gas in the cup. You keep telling me that if I have a container and I put gas in this container on the surface of the Earth and I open the container, all the gas is going to come flying out and it's going to equally disperse, except that it won't, because Earth's atmosphere is already largely in a state we can, in an ideal scenario, consider a state of equilibrium. There isn't a lower pressure out here than there is in the cup.
Okay, so if you put that cup in a vacuum and took the lid off, what happens?
Well, of course, then it's a lower pressure around the cup. So when I take the lid off, the gas is going to move.
Okay, so is space a lower pressure than the Earth's atmosphere?
Of course.
Okay, so then that means that it would do what? It would do the same thing, right?
What do you mean? Space would suck Earth's atmosphere away? No.
No. Space doesn't suck anything. The gas would violently fill space.
No, because of gravity. Gravity prevents that from happening.
So whenever gravity is on the Earth in your vacuum chamber and you put your cup in there, why doesn't gravity stop the air?
Because that's not nearly enough mass. Do you know how much mass you need to have the attraction of the Earth? You need as much mass as the Earth.
You have the whole Earth here, and then you have the little bitty thing of gas. So how is it that
because the gas is surrounded by a vacuum on the Earth?
Yeah, you're now conflating mass attracting mass and saying that there's more gas, so it pulls down the molecules that are individual as a collective. Is that your argument?
The funny thing is that once you open that container in that vacuum chamber, you would be able to find that at the bottom of the vacuum chamber are going to be resting more gas molecules than at the top as a result of Earth's gravity.
Gas
there
molecules
will be a
don't
gradient
compress.
in that chamber of less dense up here and more dense down here. Now, granted, this is going to be very, very small, and we need seriously sensitive equipment to measure it, but you will be able to measure a differential.
Yeah, did you know that there's an electric charge on the Earth, and that it goes up equipotential 100 volts per meter and has a downward current, and that is on the smallest scale. That electrostatic occurrence is 10 to the 26 power stronger than gravity even claims to be. So what does that have to do?
What's your point? Yes, the electromagnetism is significantly stronger than gravity.
No, electrostatics.
Which is a part of electromagnetism.
Yeah, well, sort of. Yeah, but they're different intrinsically because electromagnetism is coherent, and everything that is matter, all molecular and intermolecular bonds, attractive forces, all of them are electrostatic in nature, and that is 10 to the 26 power stronger than gravity even claims to be.
Sure, yeah.
So
what's your point?
You cannot attribute gravity to any of the phenomena on the local scale because the known to be much stronger force of electrostatics is always present. So when you claim the reason things are going down or you're making claims about densities, none of it objectively can be gravity. Your own paradigm says it doesn't actually overtake electrostatics until you get on the planetary scale and have a big enough mass that the curvature of space and time actually overtake electrostatics. So local phenomena in no way helps gravity.
I don't know what point you're getting at here. I've never denied that electromagnetism is stronger than gravity.
Electrostatics, yeah.
Which is the force is called electromagnetism.
No, it's not. Electrostatics
Yes,
is a force.
Electrostatics is what happens when you have static electric charges. This is defined using the modern physical theory known as classical electromagnetism. You can describe purely electric phenomenon using electromagnetism because that's the name of the modern physical theory that describes all electric and magnetic phenomenon.
Okay, electromagnetism is not synonymous with electrostatics. Electricity
I didn't say that.
Okay, well then stop conflating. I'm saying electrostatics, the weak force electrostatics is known to be 10 to the 26 power stronger than gravity even claims to be on the smallest scale. If you cannot control that variable and isolate gravity, claiming it's real is pseudoscientific nonsense.
No, but it is real. Electromagnetism being stronger than gravity doesn't mean anything for gravity. Also, electrostatics is not the weak force. The weak nuclear force, weak interactions, is an entirely separate force from electromagnetism.
So is electrostatics 10 to the 26 power stronger than gravity? Yes or no?
The electromagnetic interaction is roughly 10 to the 26 times stronger than the gravitational force.
Or the electrostatics. I will quote Purdue University if I need to. Or what about Boston University? Does Harvard work? So it's electrostatics. And all molecular and intermolecular attractive forces are electrostatic. That means every molecule that exists. That means that all the molecules that are together, all matter, everything is electrostatic, way stronger than gravity. Gravity is a fairy tale. Has nothing to do with anything. Okay?
How can we measure it?
How can you measure
and also, it's electromagnetism, and I can cite the Feynman lectures on physics on matter and electromagnetism. I can cite Introduction to Electrodynamics, 4th edition by David J. Griffiths. I can cite Classical Electrodynamics by, I think that's John Jackson. It's one of the most popular books in electrodynamics that you're going to find in any college or university setting. The force is called electromagnetism, and it is stronger than gravity. Yes, that has no bearing on the Earth being spherical or not.
Is electrostatics and electromagnetism the same thing?
Why does it matter?
Okay, because you keep conflating the two, and you don't understand the significance of it.
You're applying the strength value to electrostatics, which is not where that strength value is. That strength value applies to the whole force of electromagnetism.
No, it's electrostatic potential, resting potential of 10 to the 26 power stronger than gravity claims to be. I just told you I can cite.
I don't think you understand what that even means. Can you hash that out? What was the potential you just said?
Yeah, it has a resting electrostatic potential.
What is that?
Small scale. The potential to the ability to cause work, to do work.
No, not what energy means. What when you said electrostatic potential. What is that?
The electrostatic ability to do work.
I don't know.
All right, brother.
Okay,
All right, brother.
because what you're referring to is called it's not really called the electrostatic potential. It's often just called the electric potential or the electric field potential, and it is the amount of energy needed to move a unit of electric charge from some given point to some other specified point in an electric field.
Okay, so here's a simple part of it, man. Everything that exists is electric, intrinsically. Everything, all intermolecular, molecular, all molecular and intermolecular attractive forces are electrostatic in nature. You cannot name one single exception. Please do.
You're speaking specifically molecular forces?
Name one piece of matter that's not electrostatic.
Neutrons.
Neutrons isn't a piece
neutrons. Yes, they are. Neutrons
outside of reifying the subatomic scale, right? Which, if you know what electrostatics is, that was a non sequitur anyway. So outside of the subatomic scale, actual matter. Okay.
But neutrons are matter. They make up yes, they are. They make up the nucleus of the atom. They're literally a particle of matter. Protons, neutrons, and the up and down quarks that make up protons and neutrons, as well as electrons, are all matter particles because they make up matter. The neutron is electrically neutral. It doesn't have electric charge. So it is a fundamental piece of matter that has no electric potential because it doesn't interact with the electric field.
Okay, I'm not going to debate quantum mechanics with you. It's an attempt to quantify the immaterial. It's nothing. The electron is nothing more than the dielectric end of one terminal end of unit line of dielectric induction. The terminal end of one unit line of dielectric induction. It's a gap in the sphere. Anyway, all I'm saying is, dude, you're just making up theories, and you're not actually addressing what I'm saying. It's okay. Electrostatics is much stronger. Nothing outside of the subatomic theoretical nonsense field that is matter isn't electrostatic. Everything is. So you live on an electric Earth that's stationary, geocentric. The sky moves over top of it in cycles, and this is all that we have evidence for, and you've not been able to provide any evidence to the contrary, unfortunately. That's actually viable.
So I really hope somebody listening in the chat can go to the Wikipedia page on quantum electrodynamics and make sure that they edit it to say that I am the one that's apparently made all that up. Please do that, because I'd love to be credited for that instead of people like Richard Feynman and I think Wheeler, Paul Dirac, people like that who actually developed it. I'm just, reiterating the factual information that we have. I have provided evidence. Not only have I shown that there are things that only make sense if the Earth is spherical, but I have shown that when talking about the broader models, the methodologies that we as humans use for understanding the world, I've shown that it's through those methodologies that we know that the Earth is a sphere. So I have provided evidence and justified why that evidence is in fact evidence. And I remember going on an entire spiel about grounding counterfactuals and how this relates to something's being evidence. And to say that something is evidence, to say that something accounts for something else, is to say that there are counterfactuals that can be grounded such that we can show an accountance of the thing that we're trying to explain.
Okay, I think this has reached its end, but I'll ask you this one more time. If the radius value that is claimed is falsified, does that falsify the entire model, yes or no?
No, of course not.
Okay, well, you'll get there, bro.
What we're going to do is jump into Q&A and want to mention a couple of things. Whoa. My mic is funky tonight, folks. Sorry about that. That's why that echo was popping in before, and I'm going to work to try to reduce that during the Q&A. But I want to let you know, first, folks, if you've been watching this long, it's really good odds you enjoy at least one of these speakers, and I want to let you know they're linked in the description. So if you're like, I want to hear more, well, you certainly can, and that includes if you're listening via the podcast, as we put our guest links in the description box for the podcast as well. And in fact, they're at the very top of the description box, so you don't miss them. Also, we're going to jump into these questions. We have so many, folks. I'm going to move fast, but bear with me. We're going to try to get through every single one of them, and if we don't, forgive me. But Zippy the Pinhead says, may the true Earth shape win. Thank you for that, Zippy. And Magellan says, Witsit bingo. They say that this is on their Witsit bingo card. Reification fallacy, presuppose R, omnidirectionality, electromagnetism, and perspective. Witsit, what do you think of this smack talk?
I think it's pretty interesting that all those things still refute your position, and I'm forced to say them every single time. So, cool.
Thank you very much for this question. Coming in from Magellan as well, says, Witsit, No. The burden of proof is on the one questioning the status quo in this case. That is you.
Oh, well, objectively, your opinion doesn't get to change the way it works. The person making a positive claim has the burden of proof, so I don't have to prove anything. Falsification is independent of replacement. And of course, we did falsify your model by physically measuring the surface of the Earth. Welcome to 2021. The Earth is flat.
May I provide just a very brief comment to that question,
Sure.
James, or do we not have time?
Ready for you. Go ahead.
So I just wanted to say that they make a very valid point. Austin Whitsitt is correct that if you make a positive claim, you are committing yourself to a burden of justification to provide some sort of reason that confers warrant for accepting the claim that you made. But the questioner there is correct in that if somebody is questioning what the academic consensus is and what the empirical literature show, then the onus would be on them to confute that, because since there is methodologically sound and a vast amount of empirical literature all pointing to the same thing, and then the expert consensus being thrown on top of that seems to indicate that we have good reasons for believing this thing. So if somebody's going to challenge that, then they would be required to provide good reasons for why they are challenging that consensus.
We must move to the next question. Let's see. I got to keep it in mind that we've got to rush through these. So we as long as we can have them. I know that I'm like being so unfair to you guys because these topics deserve plenty of time to be hashed out. And so that's why I hate pushing you guys to be as pithy as possible. But Haywood, thanks to your, I realize what your name says. It says, why are all other planets spherical but not Earth?
Yeah, so saying other planets is just stupid. No one says that the Earth is a planet. And actually, I document the quote-unquote planets all the time. They're not static. They constantly fluctuate and move and pulsate, and they look like they're in a fluid-like medium. And if I look at the cylinder and I say, look, there's a light bulb, that must mean the ground's a light bulb. That's ridiculous. And we physically measure the surface of the Earth. It isn't a plane. It's not a planet. It's a plane. And it's not out in space in the solar system. That's all fake. That's called a straw man fallacy.
You got it, Ann. Thank you very much for this question coming in from Ozzy, and says, entropy, pressure finds equilibrium in a closed system. Earth has a pressure gradient. Earth is not a closed system. Gradient proves gravity, Whitsitt.
Yeah, so gradient doesn't prove gravity. And again, we're asking about the antecedent of pressure. The necessary antecedent of pressure is containment. So that's X. You're talking about delta X, a change in pressure. Basically, once again, redefining and begging the question of the pressure's antecedent relationship and then telling me about its characteristics. That's called conflating qualitative and quantitative characteristics.
This one coming in from Hillside says, the angle of the sun, Leo? Visit flatearthintel.com and educate yourself.
I did. I actually understand things like physics and chemistry and geology and a variety of other subjects. So while I don't know everything, I actually, consult professionals in the field and the relevant academic literature when I have questions, not conspiratorial websites.
Gotcha. Thank you very much for your question. This one coming in from Germania says, if the Earth is flat, why would they, whoever they are, want to keep it a secret? What's the point in the secrecy of the Earth's shape? P.S. I love Leo. Give you a chance to respond to that. Whitsitt.
Yeah, I don't know. Why did they tell us there were weapons of mass destruction that they knew were there and then went and fought a war and then discovered that there weren't there? You know why? Because they had a motivation to lie, probably resources. But no, just hiding vast amounts of land, as this guy preemptively doesn't follow my logic and thinks somehow I'm diverting. If you were to lie about major portions of the Earth, you probably would have a little bit of control over resources that no one knows about, wouldn't you? As it's literally illegal to privately explore past the 60th south latitude or to fly within 500 miles of each direction of the center. So why would they lie? Why would they not lie? And whether or not you know why they lied has nothing to do with the fact that you can falsify the lie.
You got it, Ann. Thank you very much for your question. This one coming in from Kango44 says, Whitsitt holding the most dishonest position ever. If you really wanted to measure the shape of the Earth, you could do it in a weekend.
Yeah, I make long distance observations all the time. They're consistently in no way demonstrating a globular Earth with a radius of 3959. I've debunked the physical obstruction that is needed for the globe Earth all over the United States. So if anyone wants to actually, enlighten me of physical measurement of Earth curvature, I'm all ears. Until you actually come up with that, the rest is all talk.
You got it, and thank you very much for this question. Coming in from Kango44 says, it's crazy to think that we have Google Maps, but are arguing about the validity of an experiment 2,500 years ago measuring the Earth.
Google Maps uses a flat Earth, maps are flat, so cool story.
Next up, this one coming in from Leo's buddy, Standing for Truth, says, James the man, always looking fresh. Thank you for that kind word, Standing for Truth. And thank you, Leo. Seriously, I appreciate you, man. I was so cranky with you earlier, and I'm sorry about that. I really do appreciate you, and thanks for always taking it so well. I appreciate your passion. And this one coming in from Jay Mole says, for Witsit, how do you explain the northern lights?
It looks like an effect of the polarization with an electromagnetic field. It's just illuminating the excitation that is light around the central point of the magnetic source. So that would be my answer. You can't get to the actual central convergence point. It's illegal.
You got it. Kango44 strikes again, says, Witsit, please send a link to the website with all your experimental evidence to back your position. I hope it's more than the black swan photo where you just don't understand refraction.
Yeah. So standard refraction is called terrestrial refraction 7/6R, which uses the R value, which is what's literally in contention, to reify and beg the question of a geometric claim, and the value to then say it proves the R value is actual absurdity. Actually, refraction is the difference between two media. It's called Snell's law. You need a differential equation to apply it to the Earth, but most of you guys don't know that. That's why he's uncomfortably laughing, but not really my problem. Ignorance is pretty see-through. And yeah, there you go. There's plenty. I don't have a website with all the evidence for you. Go to 24/7 Flat Earth Discord.
Just one sentence. I'm laughing because you don't understand optics.
Cool.
This one coming in from Amazing. GPS says, Austin, have you studied orbital dynamics?
Have I studied it? No, I have looked into parts of it, though. I've actually talked to numerous aerospace engineers about the specific requirement of the radius value that this guy said they're wrong about. So I've talked to aerospace engineers and read different books, but no, I haven't studied orbital mechanics. I haven't studied Narnia either.
This one coming in from Mark Reed says, Austin, if you are suggesting the size of the Earth is wrong, what method would you use to calculate the actual size?
I don't make a size claim to the Earth. It's literally illegal to go past the 60th south latitude privately. So I don't make a size claim. I falsified your claim. If the Earth was a ball, it'd be really simple. You'd physically measure the Earth curvature. You could shoot a laser over water and get physically obstructed by the Earth curvature at the rate necessitated by the radius. It does not do this. There are numerous things that you could do. None of them actually work, and every time you actually test the surface, it never has that curvature rate. So there you go. Physical measurements of Earth curvature would be great, and it simply don't exist.
You got it, Ann. Thank you very much for your question. This one coming in from Sphincter of Doom says, any object of sufficient mass will, due to its own gravity, take on a spheroidal shape. The minimum calculated mass for this to occur is 0.0001 Earths.
That's what's up. So, yeah, a theoretical presupposition of a magical fairy tale reification fallacy called gravity that gives physical properties to conceptual abstraction will cause things to coalesce into perfect spheres, I promise. And if I can ever see something be a sphere on the small scale, that must mean that the Earth's radius that's been falsified is actually true, and I'm in a vacuum that defies the second law.
Can I ask Austin just one really quick question? Just simple yes or no. Yeah. Austin, do you know what a diffeomorphism is?
No.
Okay.
Okay. That must make the Earth a ball.
I'm working on
just
the
gauging
echo,
your
folks.
understanding.
People have told me the echo is still there. Don't worry. I've got my sweet earbuds. I'm going to open these up. But Grimlock says, stay in school, kids. Math skills are important. Although that could be an insult toward either of you. maybe even both of you. I don't know who they were actually intending it toward, but
I don't think it's towards me. I actually understand math. I'm so good at math.
Except for the radius value. You don't seem to understand the radius value very well. If you understood math that much, you would know your entire mathematical construct and framework of the heliocentric model depends upon the accuracy of the R value and is intrinsically falsified upon the falsification of that number. So yeah, I agree. But math is pretty simple. Geometry is like what, 6th grade? So maybe the
yeah. You say that you didn't know what a diffeomorphism is, so I guess we'll leave it to the audience who has a better understanding of math.
I tried to open my earbuds. Oh man, I accidentally chopped my earbuds while opening the packaging with the scissors, and now it's frayed. Don't worry, they were on clearance for $1. I've got another one. King044 says, Witsit, please share a link with all the photos of the Black Swan oil rigs. You did take multiple photos over many days, didn't you? You understand you would need multiple photos of the same location to make a measurement.
Well, it's just about the horizon is an apparent location, and the flat Earth knows that the horizon is on a real place. On the globe Earth, it's a real physical, tangible place that obstructs your view at a certain geometric rate. So just seeing the horizon one time beyond that geometric limitation falsifies it. And not only did we see it beyond it, we saw it 10 times further, requiring the radius to be over 250,000 miles. And this guy didn't answer. There are no sufficient rebuttals. No one ever answers. So, it is what it is. I mean, whatever.
This one coming in from Kent Woods says, it is the mark, and this is they're quoting Aristotle, it is the mark of an educated mind to be able to entertain a thought without accepting it. Not sure who that's meant for. Next up, Ray the Way says, could you both agree that we could live on a convex lens, a flat Earth model, but the surface curves? Just an idea, by the way.
No, it'd have to be a full sphere because of the things that we observe about our existence on that sphere.
Yeah, there's no concavity or convexity to the surface of the Earth, so either way, it doesn't work.
And can I just make one really quick statement to the last quote that we heard from the Aristotle? I don't really know who that quote's attributed to. I just wanted to say, a witty saying proves nothing. And that is, I believe, from Voltaire.
This one coming in from King Conquest. Says, Witsit, why do you think we should see a geometric horizon through miles of atmosphere? Who told you that? Why doesn't refraction work in your misunderstanding of the globe?
I don't know. I was just taught that from like 5th grade up, that boats disappear over the curvature of the Earth. And the reason that I can't see cities in the distance is because of the curvature of the Earth. And the reason that the sun sets is because of the curvature of the Earth. And the reason we only see parts of the sky is because of the curvature of the Earth. So why do I think that? Because that's literally what your model claims. And a physical geometric sphere edge or tangent point would physically obstruct your view and physically be there. It doesn't just disappear because there's air there. So that's probably why I think it is, because it's intrinsic geometrically within your own claim.
You got it. This one coming in from King044 says, Witsit, the sun does not change angular size to an observer during the day. So during a sunset, is the sun going behind the edge of the Earth?
Actually, at times, the angular size does change, and no, it doesn't go behind the edge of the Earth. When something moves in the distance, it reaches the vanishing point due to angular resolution limit, and you can't see it anymore. This is exactly what we observe. So unless you want to look at the end of a long railroad or street with street lights and say, look, those street lights are going behind the curvature of the Earth, then you understand it's simply perspective, angular resolution, and then atmospheric conditions playing into that. So there you go.
You got it. And thank you very much for your question. John Kramer says, thank you, Modern Day Debate, for having these First Amendment open free speech debates. Good stuff. Thank you for your kind words. And I pass all the credit to the speakers, as they are the lifeblood of the channel. We really do appreciate them. They're linked in the description. Folks, if you've been listening this long, there's no doubt you must like at least one of these guys to where you're like, oh, yeah, okay, I want to hear more. And this one coming in from King Conquest Strikes Again says, Leo, Witsit is playing a character. They all are. They are unsuccessful. Oh, this is like, why do you have to make it personal? And then they say, they don't believe this, but they don't understand the globe fully. So I think we'll give you a chance. I mean, they address Leo, but I mean, I got to give Austin a chance to respond to this. They're saying, Austin, because you didn't maybe reach your dream that we all have of becoming a Hollywood celebrity or whatever it is. They're saying, Austin, are you now making up a flat Earth to become, quasi famous, or I don't know. What do you both think of that?
Openly stating that I think the Earth is flat has been nothing but detrimental, right? Because people are weak-minded and they conform to groupthink. People that are ignorant of the radius or anything about it will say, I'm stupid for knowing all about it and reading the theory of relativity 2 times. So I guess that what it really comes down to is I had to give up a job offer with six figures starting out for this and get death threats and all kinds of crazy stuff. So if you want to convince yourself I just do this to be relevant or whatever, that's a cool story, bro. But the truth is it's actually very difficult. It requires a lot of integrity to stand up in the face of societal ostracism and speak the truth. So
this one coming in from 7 Dank. I didn't see a question attached, but let me know if you had one. But thank you for your support. And Wolf von Hinslick, good to see you again, says, I'm a retired Army 13D 10, in parentheses, artillery. By the way, thanks for serving, Wolf. And they said, and we absolutely had to factor in Earth's rotation, depending how far out the shot needed to be.
So this is basically the empty claim that they had to account for Coriolis, which isn't true. It's in a manual, if anything, and not in reality. You don't actually have to account for Coriolis or Earth curvature with any long-distance trajectories whatsoever, unless you claim that it's built in. And which way did you do it? East or west? Which way were you shooting? Which way did you have to update? Was it consistent? And all of it doesn't actually exist in reality. I know long-distance snipers myself.
This one coming in from Made by Jim Bob says, Leo, do you own anything signed by Neil Tyson deGrasse?
Well, it's Neil deGrasse Tyson, and no, I don't. If I'm being honest, well, I can't really say that I think that Neil deGrasse Tyson is like a morally deficient person or anything, despite the fact that there are, what I would argue, some credible accusations against him in a particular area. Investigations were done, and nothing really came of it, so I'm not really going to comment to that. But I'm not really the biggest fan of Neil deGrasse Tyson or people like Michio Kaku or Lawrence Krauss, because they're not science educators to me. They're science popularizers. They'll talk about science in a way that makes it seem like this special, mystical, ethereal thing that try to get people interested in it, where I believe in just communicating and explicating what science is and why it's important to us. So I'm really, while I'm not making any statements about his moral character, I'm not particularly a fan of Neil deGrasse Tyson.
You got it. I couldn't tell if they were asking because they were like excited. They're like, ooh, I'm so excited you have a book that's signed by him. Or if they were going to say like, it's sad that you do have something signed by him. Because, it's true. 10 years ago, he was untouchable and people thought of him as like, everybody just thought like, oh, of course he's cool. And now there's it's a more mixed opinion set among the population. But this one from Chris Gammon says, for both, how high do I have to fly above Dallas, Texas, home of DebateCon? Thanks for that plug, Chris. Says, before I can see Mount Everest with a super powerful telescope.
Can you see Mount Everest from any elevation above Dallas, Texas? I don't know.
It's incredibly ignorant to think that you would. Basically, what he's doing is strawmanning the flat Earth, which is all you'll ever get. Which is, if the Earth's flat, you should be able to see forever. Effectively, see.
Oh yeah, if the Earth is flat, you should be able to see Everest. Yeah, totally. How high up would you have to go?
It's called angular resolution limit to the eye. You can't see forever. You have a vanishing point in the sky.
Okay, we're not in the debate. Never mind.
Yeah, let's not. It's just ridiculous. It's like a very remedial straw man. But if you want to be honest about the conversation, look into it. If you still think flat Earth means you could see across the whole world, you have not even fully understood the position.
I see that. I get the point of the question because it's on the other side of the planet.
Yeah.
Whether you be, does that terminology still work on a flat Earth model? That it's on the other side of the planet. You could say like it's far, far away. I don't know, but I get.
Yeah, we just on the other side of the plane or the Earth.
Juicy.
We don't like
Astronaut 66 says, Witsit gets it. Why can we use Foucault's pendulum to determine our latitude anywhere on Earth? And why does it not show any effect on the equator?
Well, actually, there is a pretty consistent drift over top of the Earth. But in 1851, with your little pendulum that you keep bringing up from literally 1851 is the best evidence of axial rotation, I guess we have. But it doesn't prove anything. It has to be started itself. It doesn't have an independent frame of reference. And something called the Elias effect happens during eclipses, where, in fact, it goes the opposite direction. It in no way in no way is measuring axial rotation. Elias effect disproves it, as does the lack of independent frame of reference, in that you have to start it yourself and have some type of mechanism to keep it going.
Can I say one thing?
Sure.
Just one to clarify to Foucault's pendulum. It measures, it picks up the angular momentum of the orbit of the Earth, and it traces out a figure 8 as it goes back and forth instead of just a straight line. Obviously, I'm exaggerating a little bit. That is due to conservation of angular momentum. So
why'd you go the opposite way during the eclipse, though?
During the eclipse, I would have to see data on that.
Okay.
Juicy. This one coming in from, do appreciate it, Hillside says, not knowing how the radius was calculated just begs the question of how Leo got into this debate. Leo, are you going to take that?
I guess I didn't realize that was like a dig at me. I have this debate because I think it's important for people to realize that there are certainly valid methodologies we can utilize to understand the world that we exist within, and when we apply them, we find that we are living on a planet that is about 25,000 miles in circumference and is rotating at about 3 degrees per hour, and that orbits a star.
You got it, and this one coming in from Astronaut66 says, oh, we got that one. And Mark Reed says, Witsit, you never answered the question. Where did the rocket go when it was launched? It didn't come down. Where did it go?
Yeah, you didn't answer that question.
What rocket didn't come down? You're talking about the Jake Webb telescope specifically?
Yeah, the Wellescope space telescope.
Oh, man, I was too busy not being a loser, not watching that. So I guess I'll have to go check it out before I give any comments on it. I'm sure it was shot over the water with a parabolic trajectory, though.
Yeah, but don't things, when they're launched, have parabolic trajectories?
Yeah.
Isn't that an aspect? Well, no, that's just a result of the drop in the density of Earth's atmosphere, the rotation of the Earth as you pull away from it, and you leave its gravitational field. There's a lot of things that result in that. Also, what is the thing that flashes and looks like a really, really giant satellite that I can see through a telescope going by that they tell me is the International Space Station? And why can I see it at the exact place they're going to tell me that it's going to be at that exact time when I go to look for it there?
Yeah, the ISS moves in a cycle, the ISS, and it's definitely not 252 miles in the air going 17,500 miles an hour, 5 miles a second with glitches all over their cameras. So cool story, bro.
So then what is it?
Oh, light in the sky.
But it's not. I've seen it. It looks like a satellite. It looks like
the only time
big thing.
Did you watch a lunar transit?
What does a lunar transit have to do?
The only time you can even supposedly see it is a lunar transit.
No, you can see it through a telescope. You can actually see it fairly decently through a good pair of binos on a clear day. I looked at it through a telescope.
You just see the light. You don't see the actual structure unless it's a lunar
I did
transit.
though. I saw it. Anyway, we gotta go on.
I had the wrong mic on this whole time. That was where the echo was coming from. So embarrassing. This one from 7 Dank attached their question this time, says, Happy New Fear, in quotes. All the best, James, in 2022. Thanks for your support. I don't get it. Is this a new hip phrase among the young people? You guys? Okay.
I don't know. I have no clue.
This one coming in from Spectre of Doom says, odd that Witsit is able to exert pressure on his vocal cords to create statements that gas pressure requires a container.
Yeah, lungs are containers.
Wait, so how come when you inhale, the air doesn't rush out of them equally in all directions? How come you can hold your breath?
You close your lungs.
Is it because there's other forces holding the gas where it is?
It closes your lungs.
Yeah. There are other forces that are holding that gas where it is.
It physically closes the containment.
Well, actually, no, that's not really what happens. There's physical. There's forces acting that hold it. Yep. Okay.
Okay, we'll move on.
This one coming in from Kango44 says, Witsit, I'm about to slap the taste out of your mouth. They said maybe even learn about thermodynamics before trying to debate it.
Yeah. Okay. Cool story. As thermodynamics, the second law of thermodynamics applies to this fairy tale that you think is real, right? It would fill the available space, seeking equilibrium, entropy would increase. And so this is an impossibility according to natural law, and your model claims opposite to that.
Can I ask you a question? Just a quick question about thermodynamics.
What's up, man?
Do you know what the Alden rate is?
Nope.
No. Okay.
Okay. Do you know how you could have a vacuum next to gas pressure?
Yeah, I do.
Just you call out your big G word.
Yeah, gravity.
Gravity.
That thing that we can measure.
This one coming in from, do appreciate your question. Long Nights YouTubing says, land was surveyed using telescopic transits. Then laser transits were used, and now we have GPS. All confirms a spherical Earth. How are they all wrong, Witsit?
GPS actually comes after what predated it, called the Lorentz system, which is a Cartesian coordinate system. All I did was add a z-axis. The only way you have any of the locations mapped out is, of course, planar survey. Then you put that out onto a mapped out surface, and you presuppose that it's a sphere, and think somehow that proves there's a sphere, when literally the use case of GPS predates anything to do with a z-axis or a sphere. So it's just a very ignorant question, I would say.
This one coming in from, do appreciate your question. Mr. Monster says, what is the moon made of, in your opinion, if it's not a steroid rotating around Earth, another spheroid? I think they meant spheroid instead of steroid in the first case. So what is it? What is the moon made of, in your opinion, if it's not a spheroid rotating around Earth, which is another spheroid?
Yeah, of course. And back to the first part here, which is that falsification is independent of replacement. But the moon just an apparent location pretty clearly. We have lunar waves. We have numerous things. Now, I don't believe that the moon's actually a sphere, that if it was spinning 1 mile per hour faster or slower, we'd see the other side, but conveniently it doesn't. And conveniently, it just happens to be 400 times closer than the sun. So optically, based on pure random cosmic happenstance, they look like they're the same size, because the diameter of the moon's also 400 times smaller than that of the sun's. That's a whole bunch of fairy tales. I see a night light, a daylight, they're like the same size, they move over top of the Earth, and that's all that I have to say. Falsification's independent of replacement. So
what process emits the electromagnetic radiation from the moon?
What process emits it?
Yes.
Well, there's an electromagnetic field encompassing all of it. So then
but what's producing that field?
The power source is clearly in the center.
Yeah, but what is it?
Some type of magnetic source that it's illegal to go to.
Yeah, well, what is that source?
It's illegal to go there. How would I know?
What do you mean? What do you mean it's illegal to go? You're going to tell me you're going to go to the center of the moon?
You can't go to the North Pole. No, I'm saying no. What's the source of the magnetism on the Earth? The center of the Earth is
electromagnetic. No, I'm talking about what's the source of the light the moon emits. Like, because with the sun, it's it's a nuclear fusion.
No, the moon is nothing more than a light.
So then, what's producing the light?
The polarization based on the electromagnetic field.
What's causing the polarization?
You're asking me to literally theorize something that you know nothing about.
No, I don't. I think it's you who doesn't know anything about electromagnetism. No. I'm done.
Okay, good, cool story, man. So yeah, there's electromagnetic field on the Earth, and that the moon's the apparent location. I don't have to make claims of solidity, sphericity, or any other nonsense that can be falsified with stuff like the Selenian eclipse. I just stick where in this world I can be honest and not have to believe in fairy tales. It's pretty easy.
This one coming in from Sphincter of Doom. It says, forces aren't limited to gravity. The forces of quote-unquote other gases will also influence the dispersion of a gas. Denser gases concentrate at the surface.
Okay, so like I said, we have an equipotential electric field in the Earth that goes up 100 volts per meter equipotential with a downward current, and that electrostatics that's on the Earth in the resonance field is known to be 10 to the 26th power stronger than gravity even claims to be on the smallest scale. So you cannot isolate gravity if something 10 to the 26th power stronger is there. Now, can you? So you have no evidence on the local scale of gravity. Your own model admits this. Einstein's theory of relativity admits this, but you can just jump on YouTube, say I'm stupid, and somehow it makes sense.
You got it. And thank you very much for your question. Decepticons Forever says, Witsit sadly doesn't get it. Okay, next up. Oh, man. These people. You're public enemy number one out there, Witsit. Does that make you feel proud? You know, it's like, Steven, thanks for your super sticker. Appreciate your support, as well as Question the Answer says, literally just saw Leo Google what electrostatics were, then read it like he was teaching it, laughing my butt off. Great. And they said Earth is flat.
Yeah, I don't know what that has to do with anything. I Googled electrostatics and then read what it was to show that my opponent was not correct on what they were saying it is. And you're going to attack me for that? That's just funny. What point are you making? I looked something up to show that somebody had it wrong. What?
Well, they technically, I censored it a little bit. So they said, then read it like he was condescendingly teaching it, as if you like knew it beforehand, I think is what they're saying.
Static, I did say what it was before I looked it up and then read the actual technical definition. It's a study of static electric fields.
This one coming in from Surgeon General says, hashtag beta bits, make the world go round. Whoops, wrong chat. Thanks for your support. That's right, we do have a Twitch chat, folks. And I will throw that in the old live chat for you in case you happen to prefer that more. And thanks very much for your question. Sphincter of Doom says, I don't think I've heard one argument for why the Earth was flat from Whitsitt, only that it isn't spherical. If so, he's engaging in a false dichotomy.
Oh, well, in my opener, I very clearly gave you evidence that the Earth is flat. We shoot radio waves over 10,000 miles with no physical Earth's obstruction. Sextants have been used for hundreds of years and can successfully navigate hundreds of miles using celestial objects obtaining elevation angles requiring a horizontal, which is impossible on a globe, yet they still work. There's 100 different proofs that the Earth is flat. I'll say it again because Globers hate it, but it doesn't change it. Falsification is independent of replacement. I feel the burden of my one positive claim that the surface is flat. Next.
You can shoot radio waves on a globe Earth.
This one coming in from, do appreciate it, Stupid New Year's Whore Energy says, why doesn't the angular size of the sun change throughout the day if it is small and near? And also, why am I a beta? What? Okay, we'll go ahead with the first question, though. What's it?
Angular size of the sun and the moon do occasionally change. Actually, okay, have you never seen like a harvest moon? Have you never seen the moon at whenever it's rising? Have you never seen the sun when it rises and sets? There's not much angular size change difference in apparent location. We don't even know what medium it's in. And there is an angular size change throughout the year as well. So, yeah, we actually do see it change. So how does that work on your model?
This one coming in from Question the Answers. Says, humbly ask the creator of this world to open your heart and mind to, quote, in all caps, the truth, and then actively seek it instead of endless ridicule. Earth, and then in all caps, is level. Level just means flat, eh?
There is no creator of the world.
Shocker.
This one coming in from Pineapple Platypotamus. Which one of you practices forgiveness the most? Juicy personal question.
How could either one of us have a spectrum of that? I don't know this guy.
I don't know what that means.
Let's see. I'm curious in your personal philosophies because it's such a fun. I think it's an interesting question. Maybe it's because I'm in psychology, but do you hold forgiveness as a personal value on a scale of 1 to 10? Are you guys willing to say?
I guess I would probably say yeah. I guess I don't use the word forgiveness, but I am one of those people that kind of, if somebody does something to me, usually I'll just move on.
Oh yeah,
get on with my life.
Philosophically, I would say yeah, it is very important. I would say 10 because it actually will it'll manifest problems personally, right? So I would say yeah, it's important to forgive people.
Juicy. This is the one time where I have to be able to see, because I think people have heard me preach the idea of forgiveness before. One, in the sense of you're definitely not, well, I can't. But one thing I heard interesting, I read this the other day, is that, any time that you're using while trying to quote unquote get back at somebody is like a waste of time in the sense that you could be using it to put yourself in a better position, like working on developing your own new skills or meeting new people or making new relationships, whatever it is. It's something interesting to consider. T-Fish says, Leo, stop laughing. Whitsitt took you to the cleaners.
I guess I'm a dirty boy and I need to be cleaned, you know. What with all my talk of like, you know, these crazy ideas like gravity, you know, things falling down, we're all out here flying around. What are you talking about? Einstein ain't gonna get me with his convoluted ideas.
You got it. And Huge R's says, Witsit, why can I see the South Celestial Pole any clear night from my home in Australia? How can there be two celestial poles on flat Earth?
There isn't a celestial pole. So, you know, all you're doing is all listen very carefully. All the stars in the sky, all of them, they all go east to west. Clockwise and counterclockwise are nothing more than apparent locations or apparent rotations. They're not the same as actual directions. So there's the answer. You're conflating the two.
Juicy. This one coming in from Do Appreciate It. One sec, loading. You guys remember when we were at the library the last 2 nights? I'm so glad to be home. Warren Evans says, according to thermodynamics, contained pressurized systems should have equal pressure everywhere. Why doesn't the Earth have equal pressure if it's contained?
Yeah, it's a closed dynamic system. There's a constant fluctuation of temperatures everywhere, as are electromagnetic energies, etc. We have wind currents. We have gas constantly being produced at the surface level. We have a higher density. Again, we have electric voltage that goes up 100 volts per meter up in our atmosphere. We have atmospheric electricity, and that would tie right in with the gradient, which has nothing to do with the question of how's the pressure here in the first place again, though.
This one coming in?
Yeah,
Go ahead.
I was just going to say that all explains it perfectly. All of those reasons are why it's not in equilibrium, because the Earth isn't a closed system. Because anybody who's like ever opened up an actual textbook on thermodynamics knows that if you are feeding energy into a system from outside of it, the system is open to that energy, and its entropy will not be increasing. So, yeah.
Okay.
This one coming in from Do Appreciate It. Question the answer says, some fog hinders sight from 20 feet. Of course, it can't be seen from that far away. There is a lot of precipitation in between that alone would hinder the view. I think they're maybe referring to, like, could be anything. Maybe, like, for example, Mount Everest. I think they're trying to say that there's just too much in the air.
Yeah.
So, maybe you...
Yeah. Yeah, that would be
that? My guess is you agree, yeah. Austin.
Yeah, like basically when you bring up, you said that I should see Mount Everest across the world if it's flat. He's saying no. I mean, fog alone or something like in the air, density of the atmosphere itself wouldn't allow you to see that.
But what if there was no fog?
Well, what if there was no atmosphere? That's your question. What if there was no?
Well, no, is that what I asked? I asked what if there was no fog?
There'd still be density of air.
So.
Okay, so you can't look through infinite distances.
But are you saying Mount Everest is infinitely far away?
I'm saying you can't look through the air forever.
So Mount Everest is forever away?
No, it doesn't have to be.
Okay, so then we would only be seeing a finite distance to Mount Everest.
Yeah.
Why can't we?
Whenever it's really humid in Florida, you can't see 3 miles away, bud.
Yeah, but what if there is no humidity?
What if there is no humidity?
Yeah, what if there wasn't enough humidity to obstruct your vision?
There's still a compilation of a dense medium, and it's denser lower to the surface, so you can't see through a compilation of
denser lower to the surface.
Yeah.
Why?
Because I already told you about the voltage potential, and you still don't get it.
Has nothing to do with it.
Really? So there's not a downward current on the Earth in the electric field?
I have no idea what that even is supposed to mean.
Okay, so again, you're ignorant, so we'll move on.
Well, it's not that I'm ignorant, it's that the terms you're using are just not terms that anybody that actually understands these things would recognize. Given that I've actually watched lectures taught by, people like Alan Guth in electromagnetism through MIT OpenCourseWare, the terms you're using are not terms I've heard examining academic literature. So that's what I just keep saying. I don't know what you mean because
I just quoted Richard Feynman. I just quoted Richard Feynman.
Quotes aren't arguments.
No, you just said that no one says that. Richard Feynman, the guy you brought up earlier as your hero, I just explained to you what he explained. If you look up Richard Feynman's lecture on the equipotential electric field on the Earth, 100 volts per meter, how there's a downward current on the Earth. So, okay.
You got it. This one coming in from, do appreciate your question. Oh, let me just be sure I'm in order. Oh, Cincture of Doom says, flat earthers are hard to find. It's like they fell off the face of the earth.
Yeah. No one thinks you can fall off. Can you fall off of a lake? No, you reach the shore. That's called a straw man.
Juicy, this one coming in from King Conquest says, Austin's character depends on his strong attitude. You have to say silly things with conviction to be relevant, or else you'll just be dismissed. I think this is a personal attack on you, Austin. Is that what it is?
No way. No, they love me, man. This guy secretly loves me, James, and watches all my YouTube streams. I'm not even kidding. He probably does, bro. But yeah, cool story, man. We falsified the radius. The whole model has been falsified. If that radius value is wrong, the Earth is flat. Don't make this weird.
You got it. And Warren Evans says, did we read this? I think we did. According to thermodynamics, contained pressurized systems should have equal pressure everywhere. Why doesn't the Earth have equal pressure if it's contained?
Once again, it's a closed dynamic system with transfer of heat constantly going on, production of gases in the gas cycle at the surface. We also have greater density at the surface based on an electric field that's equipotential 100 volts per meter all the way up.
So one, Earth is an open system, unless, Austin is trying to argue that the Earth doesn't get energy from the sun. Also, I just because I was curious, I looked up this electric potential of the Earth thing, and I found out that because that's what I do. I look things up when I don't know what they are to find out what they are, and then when I find out the person is wrong, I correct them. The Earth actually has a very, very low electric potential. That's why we ground things, by touching the wire to the Earth.
Okay, yeah, so the Earth typically has a neutral or negative charge on the surface, positive building up 100 volts per meter. So, thanks.
This one coming in from, do appreciate your question, Mike Vincent. I've never heard anyone say, quote, I don't know what that means, unquote, so many times in one debate. Maybe after Leo gets done playing Fortnite later, he can go learn more about gas pressure.
So I don't play Fortnite. I PK on RuneScape. That's what I do in my spare time if we're talking about video games. So if you think you're tough, let's meet in the Wildy, buddy. Let's go. Anyway, if you get it, you get it. Anyway, I've said I don't know what that means so much because I have never in my life so much heard a drastic butchering of the terminology that scientists would use. Look, if somebody says a thing and I have no clue what they just said, I'm going to say, yeah, I don't know what that means. That's not a testament to how little I know. It's a testament to how little I can understand of whatever the person I'm saying it to is saying. If I don't understand what you're saying, I'm not going to know what you mean.
You got it. And thank you very much for your question. This one coming in from Nuclear Creations. Appreciate it. I didn't see a question attached. Let me know if you had one. But it is about 9:30. What we have to do is I've got to tell you, one, folks, our guests are linked in the description. If you've been listening, and that includes via podcast, we put our guest links in the description box at the very top every time because we really do appreciate our guests. Seriously, they're the lifeblood of the channel, and so you can find their links. As well as Mango T, thanks for your questions, says Flat Earth is true. Witsit is correct. Globers want to continue to brainwash others. Leo, do you agree?
I mean, I guess we're also brainwashing them by teaching them that to calculate the area of a circle is pi r squared. That's propaganda too.
You got it. And thank you very much for your question, Mr. Monster. Does the flat earth go on forever or does it end somewhere at a wall, Austin?
That's a great question. I mean, some claim that it could be infinite. I don't know. I just know that it's illegal to privately explore past the 60th south latitude. I mean, obviously, this isn't scientific at all, but the scriptures say that it'll never be measured. But either way, I mean, it's literally illegal to go there. So you can't privately go there. So I don't know, man. I wish that maybe more people would wake up and stop letting everyone think for themselves. So maybe we figure questions like that out.
Juicy.
Yeah, I agree. Governments don't have the right to limit this planet.
With that
is round.
We have got to wrap up. It's already been 2.5 hours, and so I want to say thank you to the debaters for staying this long with us. We do appreciate you guys. As mentioned, they're linked below, folks. You'd be crazy not to check out those links if you want to hear more. If you're like, yeah, sure. Go ahead and click them right now. I'm going to be back in just a moment with a post-credit scene. Just like at the end of the Marvel movies, I'm going to tell you about some of the upcoming juicy debates that we have going on, including, folks, if you didn't know this, Modern Day Debates, first ever in-person conference, 2 days, January 15th and 16th in Dallas, Texas. That, as for example, is picturing one of the debates that's going to happen during that conference at the bottom right of your screen. You can see it. And I will give you updates about those debates as we have put up new debates. There's going to be about 14 debates that weekend. So I'm probably going to hibernate the rest of the winter after that conference is done. But I want to let you know, we appreciate our guests. So Leo and Witsit are both linked in the description, and I'll be right back with that post-credit scene. Stick around. Ladies and gentlemen, we are 100% thrilled. I am pumped to not be rushed tonight. The last 2 nights that we streamed, I was in the library. They're kicking me out. They're like, Jace, you got to go. It's 8 o'clock. I said, listen, we can't stop winning. We have to keep winning. And so I just wanted to keep going on with the stream forever. But I've got to tell you, my dear friends, a couple of things that I'm especially pumped about. And thanks for your last minute super chat. King Conquest. Man, I'm so sorry I did not get to read that. We just missed it as Austin just left. But I do want to say this. King Conquest, thanks for being with us, as well as T Brown, we're glad you're here. Green Bastard, good to see you there in the old chat, as well as Brass Man and Drace equals love, wisdom, harmony. Thanks for your kind words. I've got to tell you folks, we have got big stuff going on. Right now, Modern Day Debate is on the cusp of a major breakthrough, a major leap in terms of our growth, and that's something that I've got to say thank you to you for. You guys have helped us get this far. We're pressing up against 60,000 subscribers, which is insane, my friends. We're absolutely thrilled about that and want to say thank you for making that happen. You guys, honestly, I enjoy this so much. You guys make this fun. I want to say you really do, just by being here, asking questions in the live chat, as that helps us put on a good Q&A. Just hanging out with us seriously makes it fun, and you really do help the channel just by being here. So we do appreciate you, no matter what walk of life you are from. Christian, atheist, Biden backer, Trump supporter, Bernie bro, flat earth, globe earth, you name it. We really are thankful for you. So seriously, I appreciate you. It's always fun with you. And I've got to tell you what else. My dear friends, we have got some based stuff coming up. For example, I had already mentioned, this conference is going to be huge. It's January 15th and 16th, and tickets are on sale. This is the last night for the early bird pricing. I have continually said, like, let's just give it a little longer, because I really do want everybody to get a shot at the early bird pricing. So, for real, folks, do click onto this link that I'm about to throw into the old live chat right now, as you do not want to miss this conference. It is going to be monstrous. And if you're like, I can't commit to 2 days, is there a one-day ticket? There is actually. Yeah, you can actually get a one-day ticket, because we have religion debates on Saturday the 15th of January, and then Sunday the 16th. That's actually going to be political debates. And it's going to be at the Ibn Trademark Hotel near Dallas Love Field, the airport. You guys, I've got to tell you several things. One, for example, I've got to also say thank you so much to the person who contributed to the crowd fund, as we not only have in-person tickets, but if you want to watch all the debates live, you can from home if you throw into the crowd fund. Now, some of the debates will be live no matter what. In other words, even if you don't throw into the crowd fund, but some of the debates are going to be set up such that you'd either have to, 1, throw into the crowd fund, or 2, be a part of the Patreon for Modern Day Debate, or 3, be a channel member. So that's really big, folks, is I got to tell you, either of those will work. And I want to encourage you, throw into the old crowd fund, because believe me, it is going to be gigantic. You don't want to miss any of these debates. And once they're live, we're going to take them down so they won't be up immediately after. We're going to try to edit some of them, and then some of them we're just going to kind of like cut out the music and things like that and re-upload them later. And so you don't want to wait. Be able to watch every single debate that weekend. And I've got to tell you this too. We are absolutely pumped. If you look at the thermometer on the far right of your screen, we have hit the 1,000 mark. And you might be like, James, but out of 5,000, that looks scary. There's only 14 days left. Believe me, the last 2 weeks, and especially the last week, and especially the last few days, are when most of the donations come in. So we're actually on track. We're doing well with this crowd fund. And like I said, throwing into the crowd fund, which I will link in the description as well, will get you all of the debates to watch live. And I've got to tell you, there are also other perks in there. So let me give you a review, because you might be like, I don't know about, like, what is this crowdfund stuff? That's weird, James. Well, let me tell you about it. Don't worry. Don't worry, I'm not a ghost. I'm still here. So as you can see, my dear friends, on the screen, DebateCon is the name of our conference. It is going to be 2 days with approximately, it's going to be 10 debates. It's up to 14 debates now. So some of them, if you attend in person, you would actually watch one of 2 particular debates live. And so that's something to keep in mind. But I've got to tell you, we are using Indiegogo for this crowd fund. They are trustworthy. It's only about 5%, which isn't bad realistically. And so that way we can put more funds to the actual conference. And that's absolutely essential for us. But I want to show you, you might be like, James, how do I sign in though? Well, take a look at this. You can actually, without even creating an Indiegogo account, sign in with Facebook. It's so easy, piece of cake. And that way, you can throw into the crowd fund, and it might be you want one of the perks. You can throw into the crowd fund, whether it be to watch it live or for one of the perks. For example, even though we'll have an in-person audience, if a person throws in $50 into the crowd fund, they'll actually be able to ask a question in live time to the debaters, where I'll basically either through text messaging or through Gmail, I will get their questions during the debate, and then we'll actually read them during the Q&A. So that's one perk example. And I've got to tell you, we're absolutely determined and we are absolutely encouraged. We are going to make our goal. It is going to be gigantic. And I've got to tell you, you might be like, tell me more about this, James. How does it work? Well, this is, as an example, what you would see in the Indiegogo website. So let's say you logged in through Facebook, and then you'd see these perk options where you can click on whatever it is you want. And so, for example, you can watch all the debates live, as some of them are going to be live. But like I said, you have to be either a patron for Patreon or a member or throw into the crowd fund. The other stuff, let me show you this, because you're like, tell me more. We've successfully done this before. My dear friends, this is not our first rodeo. We have made this work before, and we are confident that we can do it again. So for example, if you look at the screen right now, you will see Mike Jones and Michael Shermer. And the reason is because we did a crowdfund for that debate about a year ago. And it was a successful crowdfund where we met our goal, and it was a phenomenal debate. And I've got to tell you, you might be like, James, are you sure you know what you're doing? I mean, that's only one. Good for you. No. We've done it twice. So if you remember this one in the summer, we did a crowdfund that was successful. And we met our goal for that one. So believe me, we absolutely believe it's going to work. And you might be wondering, you're like, James, I don't know. Well, what's with the crowdfund stuff? I mean, James, are you trying to raise enough money to go on vacation? No. 100% of the funds that come in through the crowdfund, as well as through the ticket sales, are being reinvested back into DebateCon Part 2, as we plan on having a conference in May. Now, Toby, thanks for your super chat, says, James, considering your background, what's your true personal opinion about Flat Earth? Don't hide behind your overly neutral PC moderator persona. Be honest, please. That's funny. I don't know if it was ever about being PC. I really am not super PC, actually. But Grimlock says, oh, by the way, yeah, I mean, I think you guys already knew that. I'm actually a Glober. So I welcome Flat Earthers. And I welcome people who are globe earthers in the same way that, I can't agree with everybody. You guys know where I stand on a lot of these things. But Grimlock says James is secretly a cube earther. I mean, yeah, that might be true too. But want to say, in terms of our budget, you might be wondering, like, James, I don't know, why is there even a crowdfund? Why not just have all of the debates streamed live for the public? And that's just it. It's like, well, you know what? This actually helps us raise funds to cover the cost. Because you might be thinking, like, oh, James, is everything free? Not quite. And here's why. For example, and I'm not complaining. I mean, we took on this goal and this challenge, and we're taking a big leap, but we know it's going to pay off. In other words, we think that we'll be able to cover with ticket sales and the crowdfund together. I think we'll be okay. And it'll allow us to do this again in the future, because we do plan on doing another in May. But let me show you. One, on the far right side of the blue pie graph, that blue chunk is the venue itself. The venue is actually quite expensive. So it's about, on average, in Dallas, it's about $4,500 per day for a venue. It is quite pricey. Second, that's the average. Speaker hotel rooms is the orange chunk on the bottom, as that obviously costs money, as we are flying in the speakers. And so for them, basically, to be not like having to jam in both of their flights on the same day and then try to debate between those flights, that would just be exhausting. We are putting the speakers up in a hotel room, and not only that, but if you look at the far right side, or I'm sorry, what I meant to say is the speaker per diem for food is the orange chunk, so we are covering their food while they're there because we appreciate them being there. None of them are actually being paid honorariums. And that might be surprising to you. A lot of people think, like, oh, I bet these people just fly around for free. And it's like, well, if they're taking time from their work, they rarely do. Like, most people will want an honorarium. There were people that asked for an honorarium, and I was like, maybe we can work something out. And I was like, no. I was like, you're asking for too much. To be honest, I was like, no, it's just not going to work. And we let them go. And there's a big name person in particular. But the reason is we were like, hey, listen, we are willing to cover travel costs if the speakers are willing to come in and debate without an honorarium. And we're thankful. These speakers are awesome, because for them to only have their travel costs covered, I would say is a generous move on their part. We appreciate them. And so that's why we are covering their food, their hotel, their flights. And I've got to tell you, look at the chunk on the left side. That gray chunk is their flights. And so some people, we are thankful, some people are local, so we can actually that reminds me, I've got to book somebody's last minute flight. 2 seconds, writing this out. Book Daniel's flight. Is that, here's how this works. It is a big venture, and we really believe it's going to pay off. In particular, for example, we really believe Modern Day Debate is going to have some crazy growth. Like, I think we'll probably have a new couple of thousand subscribers within the 3-day span of the debate. Like the first day, second day, and the day after, I think we'll probably grow by about 2,000 subscribers. Which for 3 days is a massive jump for us. That's like our usual per month. So this is going to be big time, and we think that it's definitely going to help us keep growing at a faster rate in the following several months. And so we are not ashamed to say we want to grow. We don't think there's anything wrong with it. We think it's a good thing because we actually believe in our vision. Namely, we are absolutely determined to provide a level playing field so that everybody can make their case on a neutral platform like Modern Day Debate. We are absolutely determined to do that and to get people from different walks of life communicating. That's our goal at Modern Day Debate, and to do it in the most fair way possible. So our Twitter, our YouTube, as tempted as I am, I'm not really tempted with YouTube, but Twitter, sometimes I'm tempted to put a little juicy, spicy tweet out there that shows my own personal views, but I won't do it. The reason is Modern Day Debate, regardless of it being our Facebook, Twitter, YouTube, Twitch, is going to be neutral. That's something we've already decided, and that's the way it's always going to be. This channel is never going to turn into like, oh, like James is going to turn this into his pushing his own views on this or that. No. This is always going to be a debate channel, and it's always going to be a platform for everybody to make their case on a level playing field in the fairest way possible as we try to get people from different walks of life talking. And Jerry Ray Sissom, thank you so much for being a subscriber with Prime. I see you there in the old Twitch chat. We appreciate you subscribing with us. Seriously, thanks for using your Amazon Prime sub on us. For real, I'm dead serious. Like, that really means a lot. And in the old YouTube chat, pumped to say hi to you, though. My dear friends, I've been going on, and I do want to say thank you so much for all of your support of the channel. I am pumped for real. I really believe we've got a couple of people. I'm excited about this conference. It is going to be huge. Let me show you the poster, because you might be like, oh, James, like, there's a poster? What are you talking about? Oh, there is. Tapazzo did a fantastic job with this poster, and I've got to show it to you. So let me pull this up, because you might be like, like, who's all going to be there? This is big time, folks. This is not like me debating with like my Uncle Remus. Like, we're getting big time speakers. Believe me, you won't want to miss it. Let me just show you some of the debates, because you might be thinking like, like, I don't know what's all going to be there, but tell me more, James. Well, I will. So for example, here's a panel that we are planning. Destiny, Amy Newman, a surprise guest, and Xander Hall. If you look at the main page of our YouTube channel, it'll show you debates like these. We've got them all up now. And so, like I said, some of them will say you got to be there in person to watch it. That's a small percent. There's only like, oh man, I think there's only like 3 or 4 debates out of the 14 that you'd have to watch in person if you wanted to see them live. And then we're going to release those eventually on Modern Day Debate, but it's just good for you to know that. And I would encourage you, though, check out our main page. So if you just click on our little icon there under the video, it'll show you all of those debates, which is just nuts. Seriously, we are absolutely pumped for this. And we're excited to fulfill this vision, and we're thankful for the speakers in helping us do that. Now, A Little Too High says, this is honestly fun to watch and participate in. Thank you, everybody, LOL. Thank you, A Little Too High, for your support. Seriously, we appreciate you. And is it Decian Wilkes or is it Deshaun? Deshaun Wilkes, I think it is. We're glad you're here. Let me know if I pronounced it right. Heat Shield, good to see you. Thanks for being with us. And thanks for being with us, David. Pumped you made it. As well as TJB, pumped you came by. Master Optics, glad to see you back. And Huge R says, is Nathan still a Patreon member? I don't know. I honestly don't. Cranky Beast 2259. Want to buy James a new Spider-Man for his man. I don't know what that means. But Extra J, pumped to have you here, as well as Nano, pumped you are with us. And Cannabear, am I saying it right? Cannabeer? Oh, that must be it. We're pumped you are with us. Chad Nuts, glad you are with us. Nathan, thanks for dropping in. Sage, Ohio, good to see you there. And ZXCVBNM, pumped you're with us. Flat Earth Viking, thanks for coming by, as well as Crow Magnum and GG Cash, glad to see you. St. May, pumped you're with us. La Tornado, good to see you again. And Rook Chavez, good to see you, says, please hit that like button before you leave. And I do appreciate that. We appreciate that. Thank you for your support of the channel. Seriously, those are ways that you help the channel. They say it helps boost us in the algorithm, and I think there's truth to that. And we do get a lot of recommended video views. In other words, YouTube does show our videos to a lot of people. Like, they recommend them in people's, because I can see our stats. Like, they're phenomenal. We are, like, YouTube has helped us grow. That's like why we've gotten to 60,000 almost in 3 years, a little over 3 years. But it has been a fun ride, and we are excited about the future. Join us now while we're small, folks. Believe me, we are still small. We've got big things that we are planning. And the Mrs. Vader, pumped that you made it. Thanks for being with us. And Alpha 100, glad you are here. Extra J and Prof. Phil Bell, glad you came by. Thanks for being with us. Let's see here. Toby, glad you're here. Rock E. Shepherd and Quantum D. Greaser, thanks for being with us. Pear D. Bear, glad you're with us. And Georgiev, thanks for being with us. Jerry Sissom, glad you're with us. And let's see here. Oliver Catwell says, I feel like you could justifiably steal the conference money, stating, quote, "I told you it's debate con. I was up front the whole time." That's funny. We're excited. It's just like TwitchCon or VidCon. DebateCon is going to be monstrous. I am pumped for that. It is going to be the biggest debate conference in so long. For real. It is going to shake the foundations of the online debate world. We are absolutely serious about that. You guys, it's just going to be great. Heat Shield says you might want to tell new viewers what you're even talking about. Why should I be interested in what's going on? You should be interested, and that's a great question. You should be interested in this in-person debate conference that we have January 15th and 16th in Dallas, Texas. And you should show up live if you're anywhere near. The tickets for that are actually, oh, that's right. Let me put that in the chat again. As early bird tickets are still available, we wanted to give everybody a chance so that they weren't kind of like, oh, James, I hadn't even heard about it. Yes, we have early bird tickets. And so these are honestly dirt cheap. Like, we've looked at other debate type conferences or panel conferences, and we're like, hey, like, we're competitive here. Especially because, in my opinion, my biased opinion, we're offering a bigger lineup of better debates. And I've got to show you some of these. So I've already showed you on the bottom right. You can see that one. You're like, James, what else though? I mean, that's just one. Is there other stuff? Here's another one. This one's going to be only in person. Grudge match between Dylan Burns and Infrared on whether or not Taiwan is a part of China. You don't want to miss that. As well as, let me pull this last one up and show you this. Joe Biden on trial. Whether or not Joe Biden has delivered well since he's become the president, that is going to be there as well. You guys, that's going to be an epic one. That's the starter for the political day, so I am pretty pumped about that. It's going to be a lot of fun. You can watch them from home, as I had mentioned, and you guys, it's going to be absolutely based and or red-pilled, as my friend Sideshow Nav would say. Nano, pumped you were with us, as well as Alpha 100 and Free Thinker, glad you were with us. Grimlock says, what about the budget for the wicked after parties where everybody gets hammered? Yeah, I actually don't have that built into the budget. So if anybody wanted to get alcohol and get crazy afterwards, we don't actually like offer that. In terms of like, we're not covering that. It's something that we, this is our first conference. Maybe we'll offer a free drink in the future or something, but frankly, right now, it's just not in the cards. And frankly, I just feel like in the future, even though I don't want to be closed-minded, I don't really feel inclined toward doing that, just because you guys, as the viewers, I think would rather see your funds, like your contributions to the crowd fund or buying tickets, be used for getting more speakers into the next conference, because this isn't going to be our only conference. We are actually going to be doing, if this goes well, which we think it will, probably twice a year, and bigger than you can imagine. Seriously, it is going to be a lot of fun. I'm pumped about it, and you guys, seriously, you will be absolutely pumped about it as well. It's going to be great. So, but yeah, I hadn't even got to tell you guys. How are you guys doing? Tell me how you are, because I am curious and I want to know. And I do like to get to hear like how you're actually doing rather than just me talking up here. I want to say, how are you? Nano, good to see you. Says, I want to see another T-Jump and R and Raw debate. Those are my faves. That's a based idea. I like it. Aaron's actually traveling at that time, so we didn't get him for this conference, but we do plan on getting him for the May conference. And thank you for your kind words, Georgie Georgiev. Thanks for your kind words. And thank you, Cranky Beast, for your kind words. I'm pretty sure you're still Sarah, but that's appreciated. And Alpha 100, thanks for being here. Soy boy, and that's right. Thank you for all of you who are channel members. I don't say thank you enough, seriously. Oliver Catwell, for example, thank you so much, as well as Brooke Chavis, Sideshow Nav. Thanks for your support of the channel. Seriously, there's a lot of you out there. Jared A., thank you so much for your support. You guys, I really do appreciate it. We all do. I got to tell you, happy holidays. Like, seriously, I'm pumped for you. We're probably not going to have a debate for the next 2 nights. I'm going to take a little rest time, and I've got to recover. I'm actually a little bit sick. I'm getting better, but I am glad to get to recover the next couple of nights. We'll probably be back Sunday, and then we will... The plan is to have pretty much a debate every day leading up to the conference for the last like 10 days. And I've got to tell you though, you guys, I love you guys. You guys are like a fam. You guys rock. It's just a blast with you guys. So happy holidays. Happy New Year, you guys. I hope you have big plans for tomorrow night. I think I may go to sleep early because I actually am just so wiped out. This week I've been wiped out from travel and I've been wiped out from being sick. So I actually probably going to go to bed early just so I can get up the next day and hammer away at Modern Day Debate Con. As I'm telling you guys, these debates are going to be unreal. It is going to be so fun. I am seriously just pumped. So I love you guys. Thanks for all of your support. Thanks for making this channel fun because you guys really do. You guys make this channel awesome. And again, you don't want to miss this conference. Like, it is going to be some top-notch, like, super high-quality stuff. So hit that subscribe button if you haven't already, and that notification bell. And that way, you'll always know when new debates are coming out from that conference, as well as the debates before and after that conference. Because we've also got some big ones lined up for before and after, for real. We are trying to, like, have a good synthesized schedule where it's like, wow, we've got some awesome stuff. Cranky Beast 2259 says I'm cranky. Good for you. And a guy 4573 says beta. Thanks for coming by. A guy. And the Zook. Thanks for coming by. KLWEIN. Thanks for dropping in. We're glad you were with us. And I've got to rest my voice and rest tonight. So thanks, guys. I love you guys. Seriously, it's always so hard to say goodbye because I just enjoy this. So thanks, everybody. Looking forward to seeing you on the next debate. And have a great rest of your night.
Indoctrination blinded us all. From the very first day that we went to school, they put a globe in your face and that thing looked cool. The teacher explained how it all worked. Of course it sounded so berserk, but who was I to question it? Because I was just a tiny kid. It sounded crazy as could be, but teacher would never lie to me. She was real nice, she didn't know. She too was taught to believe in that globe. I don't blame her, it wasn't her fault. She was only repeating what she'd been taught. I went through life believing that lie. That spinning ball was now in my mind.
Don't let them take your mind.
Don't let them take your mind, man.
Don't let them tell you that you are not divine.
Don't let them do it, man. No.
Take control of your soul.
Take back control. Yeah.
Find the truth. Find it all.
Find it all, man. Yeah.
Don't believe their lies.
Don't believe it, man.
Let them take your mind.
Don't let them take your mind, man. All right, man. Listen up. So I'm hurling through space on a road to nowhere. So I live my life without a care, cause I was taught that there ain't no creator. That's what I was told from my educator. So I live my life so selfishly, there ain't gonna be no hell for me. I'll do what I want with no care for others, with no respect for my brothers. Until one day when I woke up and I drank some truth with my coffee cup. I learned that things ain't what they seem. This so-called reality is just a dream. There's deception everywhere that I look. The news, the TV, and in my school books. And pretty soon I'll realize that everything's just a pack of lies, man.
Don't let them take your mind.
Don't let them take your mind, man.
Don't let them tell you that you are not divine.
Don't let them do it, man. Don't.
Take control of your soul.
Take back control. Yeah.
Find the truth. Find it all.
Find it all, man. Yeah.
Don't believe their lies.
Believe it, man.
Let them take your mind.
Let them take your mind, man. Yeah, man. It's deception on a biblical level. It's orchestrated by the devil. Many think that hate don't exist, but that's what he wants. That's one of his tricks. But I found out that dude's real. And I tell you, man, that's a bitter pill. So I questioned everything I was told. I had to question that spinning globe. I had to relearn it all again and get some truth inside this brain. And pretty soon I realized that the globe I was taught was a pack of lies. So I studied as hard as can be. I found the flat earth conspiracy. Man, it hit me like a ton of bricks. The globe I was taught was a devil's trick.
Don't let them take your mind.
Don't let them take your mind, man.
Don't let them tell you that you are not divine.
Don't let them do it, man. Don't.
Take control of your soul.
Take back control. Yeah.
Find the truth. Find it all.
Find it all, man. Yeah.
Don't believe their lies.
Believe it, man.
Let them take your mind.
Let them take your mind, man. I started to connect the dots, and I'm telling you, man, there are lots. I soon realized that the earth was flat. It's not a belief, man, it's a fact. And once I found out that reality, well, it did a funny thing to me. For a while there, I was pretty shocked, but now I know that there is a God. And once you get to that point of understanding, and once you know there ain't no moon landing, and once you know that space is fake, you view your life with a different take. It ain't just random chance that we're here. We ain't living on no stupid sphere. It ain't some ridiculous spinning ball. The earth is flat, and God created it all.
Don't let them take your mind.
Don't let them take your mind, man.
Don't let them tell you that you are not divine.
Don't let them do it, man. Don't.
Take control of your soul.
Take back control. Yeah.
Find the truth. Find it all.
Find it all, man. Yeah.
Don't believe their lies.
Believe it, man.
Let them take your mind.
Let them take your mind, man. Well, now I found out about all these lies. I live a completely different life. I stopped reading the news and turned off the TV. That thing is evil as can be. I started being a nicer guy. And God forbid I tell a lie. I treat people with more respect, and I've got me a wife that I'd never neglect. Yeah, being good's working out for me. Now I ain't blinded and I could see. I know that there is a God above, and if I'm good, then he'll show me love. I try to live life selflessly to be the best that I can be. I treat people how I want to be treated since my indoctrination was defeated. So don't believe in the devil's lies because it's God he wants to hide. That's why they teach that spinning ball to make you think you ain't special at all. Don't believe what you're being told. Don't believe that you're evolved. It's all an accident and you are too. No, you're someone special and God made you.
Don't let them take your mind.
Don't let them take your mind, man.
Don't let them tell you that you are not divine.
Don't let them do it, no.
Take control of your soul.
You gotta truth.
Find it all.
Find it all, man.
Don't believe their lies.
Don't believe it.
Let them take your mind.
Don't let them take your mind. Yeah, play that guitar.
I don't have to tell you things are bad. Everybody knows things are bad. It's a depression. Everybody's out of work or scared of losing their job. The dollar buys a nickel's worth. Banks are going bust. Shopkeepers keep a gun under the counter. Punks are running wild in the street, and there's nobody anywhere who seems to know what to do, and there's no end to it. We know the air is unfit to breathe, and our food is unfit to eat. We sit watching our TVs while some local newscaster tells us that today we had 15 homicides and 63 violent crimes, as if that's the way it's supposed to be. We know things are bad, worse than bad. They're crazy. It's like everything everywhere is going crazy, so we don't go out anymore. We sit in the house, and slowly the world we're living in is getting smaller, and all we say is, please, at least leave us alone in our living rooms. Let me have my toaster and my TV and my steel-belted radios, and I won't say anything. Just leave us alone. Well, I'm not going to leave you alone. I want you to get mad. I don't want you to protest. I don't want you to riot. I don't want you to write to your congressman because I wouldn't know what to tell you to write. I don't know what to do about the depression and the inflation and the Russians and the crime in the street. All I know is that first, you've got to get mad. You've got to say, I'm a human being. God damn it. My life has value. So, I want you to get up now. I want all of you to get up out of your chairs. I want you to get up right now and go to the window, open it, and stick your head out and yell, I'm as mad as hell, and I'm not going to take this anymore. I want you to get up right now. Get up, go to your windows, open them, and stick your head out and yell, I'm as mad as hell, and I'm not going to take this anymore. Things have got to change.
How many stations does this go out
You've got to
live
get
to?
mad.
67.
You've got to say,
I know it
"I'm
goes to
as mad
Louisville
as
and
hell.
Atlanta."
I'm not going to take this anymore. Then we'll figure out what to do about the depression and the inflation and the oil crisis. But first, get up out of your chairs, open the window, stick your head out and yell, and say, I'm as mad as hell, and I'm not going to take this anymore.
Who are you talking to, Herb?
CGG Atlanta.
Are they yelling in Atlanta, Herb?
Are they yelling in Atlanta, Ted? But first, you've got to get mad. You've got to say, I'm as mad as hell, and I'm not going to take this anymore.
They're yelling in Baton Rouge.
Get up, get up, get up out of your chair.
Son of a bitch! We struck the mother lode!
Stick your head out of the window, open it, and stick your head out and keep yelling and yell, I'm as mad as hell. I'm not going to take this anymore. Just get up from your chairs right now. Go to
Where
the
you
window.
going? I wanna see if
Everybody
anybody's
just go to the
yelling.
window, open it, and stick your head out and yell and keep yelling. I'm mad as hell. I'm not going to take this anymore.
I'm mad as hell! I'm not gonna take it anymore! I'm mad as hell and I'm not gonna take it anymore! I'm mad as hell! I'm mad as hell!
I'm mad as hell.
Take this anymore.
Yeah.
Yo, it's ridiculous that gas price is like $6. Ridiculous.
Yeah, man.
Shit, and I don't even have a car.
I was just listening to a podcast, and this guy was breaking down how it should work, and if there's like a crisis or a war or something, then you shouldn't see you shouldn't see the prices go up just yet. It should be like a slow domino effect. Like it should affect the kind of drilling first, and then by the time it gets to market, it should be months down the line that the price changes, but they change it instantly. It's all fakeness.
Yeah, they're trying to make that money, man.
Yeah. So I'm driving around South Wales in the UK looking for curvature. Can't see any.
Didn't find it yet?
Nah, man. I think they've been lying to us.
Let me know and I'll let you know if I find it in the US.
Yeah, man. Will do.
How many islands does it take to see curvature? Like, how many islands do you have to see curvature? Because we all know when you look past the islands, the horizon is still behind it. Uh-oh.
The road curved to the side a bit then. a little bit.
Yeah. Else. Should do my little intro. Hello, everybody. Hello, and welcome to the 24/7 Flat Earth Discord. And I'm your host, Master Beef, or Master Chief. For the people that's inside the room today, letting you know, here's Adam, we got Elijah, we got F.E. Batman, we got Hank, J.E. Burrington, Natural Alchemist, Fatty, Resolve, and Will Be Flat. I hope you guys enjoy the live stream and thank you for participating. And if there's any Globers out there, please provide evidence and show us proof of your globe and your claim. Because we all know that the earth is measured flat. I'm sorry, is measured flat.
I love it, man.
Sorry.
You still Master Beef from the burger night the other night?
No, I'm Master Chief. Apparently they named me Master Beef because apparently I have beef with everybody that comes in here talking about nonsense.
I thought it was a food related thing. I woke up, I was called Patty. And, other people had other burger related names.
All right, yeah, no, I used to like burgers. I used to like meat. I'm actually a vegan now, so it's quite ironic.
So I've decided to switch back to being a Glober.
Oh, J.E.
Oh, that's good.
He showed me a cartoon.
I'm just kidding.
And I watched some old 1980s NASA stuff, and they were showing these real styrofoam balls that were Jupiter and Mars. And why would they do that unless it was real?
Right. That's the proof of the globe, huh?
And also, I watched MC Toons. and he was so convincing because he was calling people flurf. So I figure that means it must be a globe.
Yeah.
He got really mad at this flurf, so I figure that must mean there's a globe.
Yow.
Hey, if I identified as a glober for the day, would it be a hate crime if you hated on me for that?
It would.
You would.
I mean, we all really know that flat Earth is a CIA invention just to keep people from finding the real truth.
They use these chemtrails to distort our eyes to make us believe that it's flat. They
How
trick
did
us.
you know? Wow, yeah, you're right. Yeah, that's exactly it. I mean, how could Bigfoot and UFOs exist if the Earth was flat? And how about them ancient aliens? I mean, I know the guy says he's not saying it's aliens, but it's aliens. How could they exist if the Earth was flat?
Don't get me started on them.
I was going to say, interdimensional cryptozoological creatures cannot exist on a flat plane. That's truth.
I can see why you had trouble saying that name.
It was perfect in my head.
I mean, where would all the chupacabras be on a flat Earth? You don't have a model showing where the chupacabras are on a flat Earth, so the Earth can't be flat. You got to come up with a model where the chupacabras are.
They're where the unicorns live, in the unicorn zoo.
I mean, everybody knows that the unicorns need a curvy, bendy water source to get their water from, because that's what makes them fly, is that curvy, bendy water.
And their conical horns coming out of their head, they'd be straight and flat if it was a flat Earth, not a curved horn.
That's right. That's because the way that little curved thing spins around on their horn, that's God telling us that it's really that although he said in the Bible he said flat, said stationary, we know that because of that it really means that it's a spinny curvy ball.
Hey, why do those fortune tellers use a crystal ball? Why do they use a flat glass table?
Exactly. That's a good question. Even they know.
The real fortune tellers use a scrying mirror, which is flat.
Well, we know those are the fake ones because they would have a squishy, bendy crystal ball that they would see the future in, because that's what the world looks like. It looks like a bendy, squishy crystal ball. And if a cosmic giant were floating through space, he would be able to touch it and it'd feel so smooth, according to that good-looking Neil deGrasse Tyson. Now that I've conclusively proven the Earth's a globe, I'm going to go back to being a flat earther now because I don't want to be a glober.
You can JE.
Yeah, you're kind of breaking up there. Say that again.
I got bad reception for a second. What I said, if you can hear me, I said you're a contrarian.
I just had somebody completely and entirely convince me of the globe Earth for those reasons, so I figured, hey, it must be true.
Did you know, as a fact, that if you spin a crystal ball and you pour water on it, the water will stick a curve on that ball?
Yes, exactly, yes. You know, that centripetal force, I mean, you know, the only people that would know anything like that is ones who actually got out of their parents' basement and played in the playground as a kid. But so us Globers, we don't know anything about it because we stayed in our parents' basement the whole childhood.
In my basement, I would put pillows under the carpet to make it a curved kind of shape, so it would be more comforting to me.
That's very smart.
I'd find curvature every day.
No. I tell you what, though, it is crazy some of the stuff that Globies want us to swallow, without question.
Why do you think it is that in the heliocentric model, that the only way that they can account for day and night is if it was a sphere, and that one side is in sun while the other's in shade, as opposed to thinking about the yin and the yang and a small local light source? Why is it so preposterous when you say we could all be on the same surface, and there's a light moving around above us, as opposed to them, they always feel like it's their biggest or one of their biggest, that, oh, how would you explain day and night? How can sunsets occur? It's a lack of imagination if you think that the only thing that can account for something is being on opposite sides of a sphere.
Yeah. I think it's that inability to do anything other than appeal to authority, because the authority tells them how it is and they accept that without question. And that's really all there is to that is and so they're not going to use any thought process other than the thought process that takes them to that authority.
Yeah, exactly. I often found that growing up as a child, someone would say to me that this is the way that you do it. And then I would look at them quite puzzled, because I could think of multiple ways of getting that task done. And say, well, just repeat step A, B, and C. And then I'd say, but have you ever tried step D, step E, step F? What about these other ways to arrive at the same answer? No, those are inaccurate. Let's only do step A, B, and C. And then exactly like you said, if you accept the authority, question no more, then that's how we land up in this mess.
And who was that buffoon that was on here a few weeks ago that was saying that the observer is usually wrong and that you have to always go back to the, he said experts, but might as well say authorities. He was on here one Friday or Saturday night, I think it was a few weeks ago, saying just that and that's how much they rely on the authority, that if their own observation contradicts what the authority says, they go with what the authority says. Which I guess there's a comfort in that, because then you can feel definitive in your answer that you're never wrong, because you can always say, well, the authority told me that, so you have to believe it.
But it's like being told that the answer is 2. So what is the equation where the answer is 2? And then you get told the only way to get to 2 is 1 plus 1. It can't be 7 minus 5. It can't be 3 minus 1. It can't be any of the other options. It can only be 1 plus 1, because the answer is 2. And you sit there looking at them thinking, but there's many ways to get to 2. It's not just 1 plus 1.
Yeah, I also love watching them explode when you tell them that 1 equals 0.999999999. They I love watching their head explode and telling them that. And then usually I never tell them the derivation of that. I just tell them, oh, well, go ask your Go tell your favorite globe professor that a flat Earth proponent told you that, and see what he tells you. And they usually throw a big fit about that one because they can't handle that one might equal 0.999999999.
Yeah, that's a big point. I have argued in Gem's server a few times on this exact thing where it all depends on your level of accuracy, on the level of accuracy that you find acceptable. Some people find, if the number's 1.6 and you round that up, that becomes 2 also. So is 1.62? No, it's not. But yet, when you want accuracy, you'll actually want to see all the decimal places. Don't round. I want to see every decimal place. And in their mind, 1.6 being 2 is acceptable. It's sufficient accuracy for them to continue believing their religion. So it's, whereas flat earthers, we come and we say, okay, but have you looked at the third decimal place? And they say, well, that's irrelevant because 1.6 equals 2. You say, well, when you go look, it's actually 1.559. And then you've rounded that up to 1.6 and then rounded 1.6 up to 2. And they go, no, now you're looking at it the wrong way. You just got to accept that 1.6 equals 2.
Yeah, no. But do you know how you conclusively mathematically prove that 1 equals 0.999999999?
It's not a mathematical proof. It is a language error.
Nope, it's a mathematical proof. And
it requires a language error. It requires a category error to meet the conclusion, so it's not a proof.
Nope, it's absolutely a proof.
No, it isn't.
Absolutely it is.
Wouldn't it be written as then or equal to?
Nope.
Well, look, before he continues, which I know where he's going with it, it's a category error of logic.
It's not a category error of logic.
Yeah, it is.
You can conclusively mathematically prove that 1 equals 0.9999999.
All right, go ahead and do it then.
Yeah. So, do you got a piece of paper in front of you?
Don't need one.
Okay, then when you get a piece of paper, then we'll talk.
Anyway, what you do is you divide it by thirds, convert it into decimals rather than fractions, then reconvert it back, and you end up with 0.99 because you get 0.333 repeating added together. So you can't get back to 1 if you switch the category which you're using midstream. Therefore, it's a category error. 1 does not equal 0.999. The end. Thank you.
No, it does. And you divide it by 9, not 3.
It's irrelevant.
And it is. It's mathematical.
Converting fractions to decimals is not reality. Okay, this is the problem that we run into with people that think math is reality. They make these equations and it works out quote unquote mathematically, but it's a category error in reality.
Well, no, the point is that and that's what mathematics tells you is that as much math as I've taken, once you get about the 4th class, they tell you that math is not reality. And then you start doing these examples to show that math doesn't actually prove anything. You start that about calculus 2. And that, of course, as you well know, is one of the examples. And that's the point of it is it's not a category error. It's a proof that mathematics doesn't work.
Yeah, but see, they switch fractions to decimals. Okay, fractions is one category, decimals is another. If you use them midstream, right, as equivalent, then you're committing a category error.
Well,
It's
no,
logical incoherence.
no, because in mathematics, when you do the same action to both sides of the equation, so if you add 4, so you take 1 plus 4, and then the other side is x plus 4, or whatever, you whatever you do to both sides of the equation is considered proven as long as you end up with the same equal. So if you take 1 plus 4 and 0.99999 plus 4, that's not correct. But when you do the same thing to both sides and you come up with the same answer, that's considered pure proof, QED. That's what you put on your paper.
Right.
And
right. So if you say, if you take a physical object, yeah, if you take a physical object, because this is what Scott Veach and Zanuck and Kosho used to do all the time. So they take a physical gold bar, right, and they cut it into 3 pieces, equal pieces. So they call it 1/3 each. Each is 1/3, right?
Correct.
And if you add a third and a third and a third together, you get a whole. So then you're back at 1. So instead of doing that, what they do is they assign a decimal to it. So it's 0.333 repeating. And then they reassemble the gold bar, and then they say, oh, look, according to 0.333 repeating plus 0.333 repeating, you only have 0.999 repeating of a gold bar. Therefore, 1 gold bar is actually 0.999 of a gold bar. Now, they take it, to be fair, they take it and try to assert that that proves that 1 equals 0.999, which obviously, if you look at the gold bar, it's still the same 1 gold bar. So they're wrong. What they had to do was switch the categories midstream.
Well, you're not switching categories, you're doing math, and the fact is you can't do math of decimal points on a physical object. You just can't. Yeah. Even if it's 0.5 and 0.5, you don't have 0.5, you have a half. You don't have 0.5. You know, on paper, sure. When I write down 0.5x or whatever, yeah, on paper it's nice, but you don't have 0.5 in real life. You have a half. You have.
So if you had that equation that was 0.99 repeating equals 1, and then you divide both sides by 3, you'll get the same answer. So 0.9 repeating, you'll get 0.33 on both sides. And then there's no fractions involved. You're just dividing both sides by 3.
Or 9, either one works, sure.
Yeah, but in each case, they're using a different language convention for expression. So if they start with 1 and switch to the other, that is where they commit the category error. They're replacing the convention categorically.
But when you're writing it on paper and you put 1 equals 0.99999, you're not switching anything. You're just dividing both sides by 9. Because you're not talking about an actual physical object. You're talking about, and that's why math is okay for paper, and it works out in real life sometimes, but all models are wrong, just some models are useful. That's the
yeah, and saying it in that way is fair.
Yeah, and that's the key is that's the problem with the Globies is they think that whatever model they have is right. When I promise you, no matter what model any of us come up with, no matter what map we come up with or what, it's going to be wrong. But it may be useful still. We may be able to get some things from it. But that doesn't make it right. It doesn't make any other model wrong. I was listening to it's like replacement is independent of falsification. And that's the thing that they forget is that just because they have math, that doesn't prove anything in and of itself. Oh, well, I got a formula for gravity. Okay, well, I got a formula for the way angels come land on the sidewalk out in front of our house. Uh, I can write that formula out too, and doesn't make either formula correct.
Yeah, that's the old how many angels can dance on the head of a pin.
Oh yeah, and I've got a formula for that, so I must be right. My answer must be right because I have a formula.
Yeah. Or how many tangents can you get off of a curved surface?
Oh yeah, see, I got a formula for that too, so my answer must be right.
Or how much is in my bank account? Even though the bank tells me I only have $1,000, I actually have $100,000. And I have a formula proving that I have that because all I need is some inflated dark money, and boom,
right.
Bob's your uncle. You owe me $100,000.
You're right, exactly. See, and when you add Bob's your uncle, I'm telling you, you're right on the money, my man.
Dark money is amazing. I need some dark money. There must be a lot of dark money because I don't have much real money.
Yeah, it's all about your axioms. Axiom 1, I have $100,000 in the bank. Axiom 2, bank's axiom 1, no, you have 1,000. But I choose my axiom over their axiom, and I tell them, well, I must have 900 something dollars worth of dark money, bro, because mine's correct.
And you can always just think of your $1,000 as 100,000. Same like gravity, we can just think of it as a force.
Or better yet, I identify my $1,000 as 100,000. You have to let me onto the swim team, and you have to let me do whatever I want now because I said my 1,000 is 100,000. Or how about this? My right, that maybe that's what we need to do is start writing on our $1 bills. Is I identify as a $100 bill. I identify as Benjamin.
And you hand that $1 bill to the storekeeper and you tell him, no, you can think of it like $1,000 note or $1,000,000 note. I'd like to buy your store with this $1 that identifies as $1,000,000. And then when he looks at you all puzzled, you say, but that's the heliocentric model, that if we just think of gravity as a force, that makes it a force. In fact, we can even call it a pseudo force. So this is my pseudo $1 million that you must accept as a real physical $1 million note because it's a pseudo. And everyone knows that pseudo means real, right?
Yeah, I like that. Be like George Muser there. This is not $1 million, but you can think of it like it's $1 million. I liked your subtle illusion there. That was good.
And then if he won't agree, then just use consensus. But everyone knows that this $1 is $1 million. And by you thinking of it as $1 million, it therefore makes it $1 million. We'll just call it pseudo, because in the real world, pseudo means not real. But in this aspect, it means real.
Pretty much. But it would be fun to start taking some of these logical leaps that the Globies use and translate them to other things like money, or anything else you could think of, and see just how absurd some of their logical leaps are. You know, it's like saying,
I'd call it illogical leaps, because it's exactly that.
Oh, yeah.
Like you say, as soon as you compare it to anything else, it's preposterous. It's ridiculous. No one would accept that your $1 note is $1 million just because you can think of it that way. But as soon as you say you can think of gravity that way, they say, see, proven. No need to look further. And like you say, just compare it to real world scenarios. To us as flat earthers, we understand this. We understand the illogical nature of their claim. But they seem to lack the ability to see the illogicalness of their idea. Then you say it in money, then they'll say, no, that's a bad example, or a non sequitur, or they'll say, no, that example doesn't compare with gravity being a force that you can just think of it like a force. Then you say, but the money, I can think of it like $1 million. No, wrong example. You've chosen the wrong example there, because they can see how ludicrous it is about the money, but yet they refuse to accept the illogicalness of the gravity claim.
I know I have $1 million in my bank account. You just can't see it. Well, and let me show you this bank statement here. And then I take a Photoshop image of $1,000 bills, just making something up here. And then you say, but that's Photoshop. That's Photoshop. No, it's
and then you could use,
it's visualized data.
and then like their transform equations. So you go out and measure an angle in the real world, but then you have to minus it from 90 and carry the 2 and do all this transformation to get to a number that suits the globe. It's the same with your bank statement. All you have to do is multiply it by 1,000 and then, carry the 1 and then, hey, look, now it's $1 million. You're like, but that's not what the statement said. It's fine. We can just transform the statement through a little bit of mathematics, and then we get to the right answer. You see, $1 million. It fits my model. My model must be accurate.
Yeah.
Okay, I got to run. Good chatting with you, Barrington.
Same to you. Have a good day, my man.
Later, Soda.
AI, are you still on here?
Yeah, it looks like he's gone.
Yeah. Well, I was just going to say I'll wrap with you guys later as well. I probably have a work call coming here in a minute or two, and it'll probably start picking up in the next 20 or so minutes. So you guys have a good day, and I'll jingle with you soon. I'll check in a little later today.
Always a pleasure, Jay. Take it easy.
All right, Barrington, you take it easy, bro.
Thank you, guys. Have a good day.
Sorry for the. Testing.
Yeah, good.
Cool. I was trying to make sure that I was in. Never.
Hey there, J101. What brings you round? You able to unmute, Jay? No? Gone. Let's get him off.
Oh, did he just leave?
I don't know. I haven't actually looked into playing well. I knew it was just nonsense.
Well, I mean, we don't have to talk about it here. I guess like there was a conversation going on, so I'm not trying to interrupt that. I just like put it in the chat to see if anyone else wanted to talk about it.
Sure. Yeah.
Yeah, I do.
Was it a coefficient, the K value? Is that
Well, I mean, we can talk about it if you want. When I said the modus tollens argument, I actually meant the logical syllogism, right? The actual logic of the argument, as opposed to the observation of the black swan that you talk about sometimes. Like, does anyone have an interest in the logic that goes on? Yeah, that's actually the modus tollens argument that he's talking about.
Yeah, sure. It's pretty.
You know, like the I think it's if P then Q, not Q, therefore not P. Like the logic that goes on.
That's not modus tollens. What are
if P then Q, not Q, therefore not P.
no?
That's modus tollens.
No, it's not.
It is.
It is, Helio.
Okay.
Okay, so does anyone want to talk about that? Or if they don't, it's not a big deal. Like, I'm not trying to force it on anyone.
Well, are you like are you challenging what the application to the black swan?
Yeah.
Okay, can you want to specify your point so we can then we'll
Sure. So my criticism is basically that I'll just explain it briefly. So like everyone, I'm not expecting everyone to have like, you know, a background in this. Like I don't have a background in either. So I'm not expecting everyone to like automatically understand what I'm saying. So, you know, it's fine to challenge me back. Like I'm totally comfortable with that. But I'm just gonna give like a quick overview, okay, of the argument as he puts it. So it's if P then Q, not Q, therefore not P. Okay. His formulation of the argument, I'll paste it in the chat so you can read it as well, is that if the Earth is a sphere with a radius of 3,959 miles, right, that's the P, then every horizon distance measurement must be no more than 1.225 times the square root of the observer's height in feet. Okay, and that last equation is how you ascertain the distance to the geometric horizon. Okay?
Mm-hmm.
So that's the first premise. That's a conditional premise. Okay? The Earth is a sphere part is the antecedent, and then the every horizon distance measurement part, that's the consequent. Okay? The consequent is the part I have a problem with, but I'll finish the syllogism first. Okay?
Go for it.
The second premise is the negation of Q, all right? And that is we have a horizon distance measurement that is greater than 9.4 miles, aka the black swan observation, okay?
Yep.
So therefore, the Earth is a sphere of radius 3,959 miles. The black swan observation contradicts the Q, which is this position that we apparently take, that all horizon distance measurements must be no more than the geometric horizon. Okay. Now, my criticism.
So is your? Oh, go ahead.
Can I just finish off? Like, so I'm really close to finishing right now.
I'm sorry, brother.
No worries. No. So my criticism is that the attribution of the Q to us, which is that we believe all horizon distance measurements must be no more than the geometric horizon, is actually a false attribution. It's a straw man. We don't actually take that position. And I can back that up by telling you why. Because
let's go.
For us to take that position, we would have to assume that there's no atmosphere on the Earth.
No,
right?
no,
Because
no, no.
that's the only conditions in which there would be no refraction in the atmosphere.
You're conflating geometric and apparent, bro. So yeah, his logic is.
What? Hey, wait, hold on. Did you finish? Did you finish your point?
Yeah, I'm pretty much done. That's okay. You can give me your responses now.
All right, good. Go ahead.
My response is that you're conflating geometric and apparent because you just now invoked refraction. The argument is that the physical geometric horizon must fall within those parameters. It's the physicality of the geometric horizon, the land itself. For you to invoke refraction, thus the apparent horizon, you are conflating.
Okay, so what I would say is that the importance of my criticism is that for his argument to be valid, we have to hold the positions. Okay, we have to take the position that the Earth is a sphere with a radius of 3959. We do take that position. I don't disagree with that. Okay. But I do disagree with the idea that we take the position that every horizon distance measurement must be no more than the geometric horizon. We do not take that position. That's my whole argument here.
Oh, okay. So what you're saying is that the problem is in the every horizon distance part.
Yeah.
Well, I thought there was another claim here made where you actually contacted this person that observed this. Did you say that?
No, I don't think so.
So is your claim that the horizon is basically at an optical position? Is that your claim?
No, my.
So
my
to
whole-
use the geometric constraints, which are absolute, would be negated by the claim that, well, the horizon is just optical and it's just in an optical position at any given time.
Well, I mean, that's an interesting question, right? But
I mean, it's the only counter.
Well,
exactly.
My position in relation to QE's argument is just this:
that the horizon is an optical phenomenon.
How about hold on. Let's discount QE's argument. How about us, the people that are talking about it now, let's just us talk about it.
Well, that's the thing, because my whole argument is about QE's argument. Like, my whole position is about
We're
Modus
quite
Toll's argument.
familiar with the argument. We're probably going to say the same thing.
Yeah, but you're asking me not to talk about the thing I'm trying to talk about.
Answer AI's question.
Okay. My whole criticism of QE's argument is that he's misattributing a position to us that we don't hold, and therefore his negation of that position is not valid because we don't hold it.
Okay, let's stop you right there. Let's stop you right there, though. Your position is irrelevant.
It is relevant because he's trying to negate it.
No, it's
and if we don't
not.
hold it, and he can't negate it.
It doesn't matter what position you're holding. He's trying to negate the consequences of the nature of the Earth, not your position.
Well, the Modus Tollens argument is very specific. And,
it's not about a position, is it?
Well,
is it about a position?
We're talking about geometry, Ben.
Well,
no, I'm talking about principles, like your position that you hold versus the nature of reality itself. He's not arguing against your position. He's arguing against the consequences of the sphere if it's a certain size. So your only counter is not, this is not my position. Your appropriate counter would be, there is no geometric horizon. Therefore, the horizon could be anywhere it damn well pleases.
Why do y'all have such a problem grasping this? It's so simple. I mean, it's like you're not understanding.
I know, it's just, it's math. It's like they claim to be the mathematics experts. It's like, you guys don't understand math. Well, we goddamn definitely do understand math. We understand geometry. We know that the math, the math of Earth, is 24,901. We know where the horizon is supposed to be. It's supposed to be right there.
I have a quick comment to say. What AI says
that is farther than that, then we know it shouldn't be there. But you guys just make up all kinds of shit. Go ahead, Jose.
So, what AI is saying is let's put it this way: you have a different position, but another Glover might have a different position. So he's not trying to attribute to any of your guys' position. It's strictly to the geometry of the Earth, of the shape of what you guys claim it is. So you guys can all have different positions. Doesn't mean his position has to be aligned to what you believe, because it's irrelevant. It's what the geometry of the Earth's position is.
You know what? In addition to that, Jose, we can actually attribute, whatever the haze or whatever they want to call the freaking atmospheric conditions. We can throw a little more math on it if you want to, but
no, he's just not understanding. He's saying every horizon distance measurement. Okay, so what it's infallible, bro. Like, you're just not understanding.
Do you understand my criticism, just to make sure?
Yeah, I understand your criticism. And
could you just tell me what it is? I'm not trying to be a dick. I'm just trying to figure out.
Yeah, what you're trying to say is that whenever he says every horizon distance is an inaccurate postulation from y'all's position.
What I'm actually saying is that he's arguing that we hold two positions and that they're contradicted by the black swan observation. The first one is that the Earth is a sphere with 3959 miles. Accept that we hold that position. But we do not hold the position that every horizon distance measurement must be no more than the geometric horizon. That part is a straw man.
Y'all
understand the position because we only need one. We only need one. That's why it's called the black swan.
No, yeah.
That's why we only need one.
If we hold that position, could you cite where we say that?
There's a category error. He's not arguing.
It's where the horizon distance comes from. That figure comes from any nautical manual.
But that's only the geometric horizon, right?
That's what it's about.
Yeah, that's right.
Yes, but then we don't claim every horizon is equal to the geometric horizon.
Now, how
That's not
about
what it says.
one? How
That
about
is what it
one?
says.
It says
Yeah, it
every
says-
horizon distance measurement.
Yes,
means
can be no
physical-
greater.
The physical geometric horizon
No,
is
but
in
that's
the
not what he means by
confinements-
horizon. That's not what he means by
you
horizon.
know what you know
Yeah,
what
because
it
he's
means.
yeah, he doesn't mean geometric horizon when he says horizon. Or does someone else want to disagree with me on that?
That is what he's talking
Everyone besides you agrees on that, as far as I
Okay,
can
so say
tell.
he does mean geometric horizon then. Okay, then in what sense does an observation of the black swan contradict the position that every geometric horizon cannot be greater than the geometric horizon? That's a tautology in any case, but how does a black swan observation contradict that? That's why I don't think he's saying geometric horizon. I think he means horizon in the sense that we mean apparent horizon.
Tautology. I mean, did you say tautology?
It's a tautology if he's just saying the same thing. If he's saying every geometric horizon distance measurement can be no more than the horizon than geometric horizon distance
How
measurement,
many
that's a tautology.
geometric horizons are you describing here, bro? Tautology? What the fuck does that mean?
Well, if you don't know, maybe let someone else respond to me.
Yeah.
Indio,
go ahead.
I'll shut up. My bad.
You're misstating his argument for one. Okay, it says cannot be greater than.
Yeah, that's fine. Correct. I take that correction.
Must be no more than every horizon distance measurement.
Yeah.
Must be no more than 1.225 square root of observer's height in feet.
When he says horizon,
And it
do
says
you take that as being
specifically
geometric or apparent?
horizon. It says geometric horizon right in it. It's
It doesn't.
Pink. It's in pink, dude.
Yes, it
I'm looking at it right now.
Could you post it to the chat? 'Cause I'm working on a different definition. This is the syllogism, right?
Yes.
I'm taking mine from a quote that he gave me in the chat.
Right. Do you think syllogism will win the argument when it comes to the ultimate shape of the earth?
Okay, I accept what you're saying there with the geometric horizon part, but that comes afterwards. I'm not talking about that's just him reiterating what the equation means. I accept that part. He says horizon before that, where he says then every horizon
measurement.
Yeah, but that horizon bit, that's the bit we're questioning what he means by that.
The geometry of the Earth, bro.
Okay,
That's
hold on.
geometric
He was the one
horizon.
that
If he
measured
was here,
geometric
that's what
there.
he would say. The geometric horizon. That's what he's talking about.
So when he says horizon the first time, he's talking about geometric.
Both times, yes.
And our whole side knows that.
Okay, so
I thought when you say horizon, you don't mean geometric horizon. You mean
we know the horizon.
what we would
There's no
call the
such
apparent
thing.
horizon.
There's no such thing.
Oh my goodness, bro.
In the gold model, there's 5 horizons. So which one do you mean?
Well, it's not up to me. It's up to QE. It's irrelevant what I think. I'm going based off what I think he thinks. And I thought horizon would have meant apparent because he specifies geometric afterwards, after the second part, the calculation, which is obviously referring to the geometric horizon. So he's saying here. So he's saying here that every geometric horizon distance measurement must be no more than the geometric horizon. Is that what you're saying he's saying?
Yes.
That's a tautology then, isn't it?
No,
because it's got parentheses around geometry.
Oh my goodness.
Do you see the semicolon?
Hey, can
this
you
is like
type tautology in the chat? Because when I look it up,
No, this is called sophistry. Okay? That's what
yeah,
you're doing,
this is like,
sophistry.
it says needless repetition of an idea, especially in words other than those of the immediate context, without imparting additional force or clearness, as in widow woman.
And it does provide additional clarification. So that doesn't fit those confinements or parameters. It does.
Okay, well, freaking show me where it makes any sense at all.
Enio, stop screwing over people.
Yeah, you keep using the word tautology, right? And he just read the definition. Okay, yeah, he just read
I won't use tautology anymore. So,
well, no, what I'm saying is it doesn't work, bro. It doesn't work because you're saying that it's a redundant.
He's partially correct.
Well, it's just a clarification, right? In the definition, it says without adding.
Just let me put it this way. Okay, say we all know it's not possible to see the quote-unquote geometric horizon. So the model predicts that it would be in a certain place. So if you actually measured it physically, it should be there. So it is kind of a tautology, but the error of the tautology is on the globe side, not the flat Earth side. Because the globe Earth side will say the geometric horizon is exactly where it needs to be, but you could never see it.
Okay, so let's say that's the case, and I think it is the case for the most part, right? You can never actually see the geometric horizon, okay? In what sense does this black swan observation disprove the existence of a geometric horizon?
Well, for 5 years, all we've heard is that we do see it. So now, just to stake your claim, you're saying you never see
No,
the
it's listen. He's trying to prove that the geometric horizon does not match the prediction.
Well, what's the prediction?
No more than 1.225 the square root of the observer's height in feet.
Right, but we don't claim that the horizon that you see is the geometric horizon.
Now that it's been dismantled, you don't claim that.
Well, we've never claimed that. That's why there's a term called the apparent horizon that differs from the geometric horizon.
I've heard myself over 100 times.
Okay,
that boats
so to
disappear
find
over
where the apparent horizon is, do you need to use the geometric horizon?
I think you would, and you would also apply
You cannot
the
do
refraction
any curve.
calculations to it.
Listen, you can't do any calculations without calculating that horizon first. That is going to be the first order of business.
Sure.
So if you cannot locate that point, that place, then the rest is just gobbledygook.
Yeah, this used to be the question,
Which
right?
is the point. The point is to show that the idea of using a curve calculator or saying this thing is over the horizon, under the horizon, it's just, I think the point of this is more to show the fallaciousness of using the curve calculator or apparent behind the curve, ships over the horizon, masts being visible before the bottoms of the hull is a bunch of baloney.
If the Earth was a globe, we would see the ships disappear bottom first. If the Earth was a globe, we would see the sunset over the horizon. All this kind of stuff. So
Copernicus even says this in his Revolutions of the Heavenly Bodies. Okay, so you can't just bail on this as if it. Now we're not saying any geometric horizon. We're saying that didn't exist, but Copernicus himself said it. And uses this as evidence that the Earth is a globe.
Sure.
You can't use this as evidence as Earth is a globe for 400 years and just say, "Oh, we didn't mean that."
Because the P900 came out.
So is that the position of say AI? I see you lighting up as well.
I'm
Is
not
it your
gonna speak
position
for
that
QE.
when he says every horizon distance measurement, he means geometric horizon?
Yes.
I know that's your position, Indio, but AI, is that your position too?
Look, you're trying to get it to a point where the geometric horizon is always going to be where it's going to be, but you can never see it, which you don't realize that you're actually conceding that the horizon is an optical phenomenon, not...
Yeah, it's 24/901.
But is that your position too? Is that your reading of this syllogism, AI? When he says every horizon, he means every geometric horizon.
There's only one horizon, bro.
Is that the geometric horizon?
No. What is the definition of the word horizon?
Well, are we going based on the National Geographic definition or the Andrew Young subject matter expert definition? Because they're two different.
What the actual horizon is? Okay, I'll put it to you like this. If you're going to point to a horizon in a photograph, in a video, in the real life, what are you going to be pointing at?
It would be the line where the sky appears to meet the land.
Bingo, we have a winner.
Welcome to
But then, like many subjects, you find more technical definitions when you go a little deeper. And if you go a little deeper, you'll find that there's 3 definitions. So are we to just reject that?
No, bro. If you're going to point to me a horizon, what are you going to be pointing at?
Yeah, but there are colloquial definitions for many terms that have a more
If you're
technical
going
definition.
to point at a horizon
I
in
already
a
answered.
photo, in a
I already
video,
answered.
right? Bingo. So you already answered the question.
So we are going to ignore the more technical definitions then. Why?
Present them, man.
But we're already accepting that they don't matter, so why bother? I mean,
But they're irrelevant to this. Okay, so the astronomical horizon is irrelevant to this. Are you saying
the
that ships
apparent and
go?
the geometric aren't.
Listen, are you saying that ships go over the astronomical horizon?
No, I'm not.
Okay, how about the what do they call it? What do they call it in sailing? The artificial horizon. Do ships go over the artificial horizon?
I think ships go over the geometric horizon.
The ships. Holy shit, dude! You think
is
ships
wild.
go over the geometric horizon?
Yeah.
Okay.
What?
So how do we find that?
Well, you can see it as of. I knew you have one. But
how about if I show you? How about if I show you a video of a radio-controlled motorboat on a 400-foot lake just being obstructed by nothing?
Anyway, for the flat earthers
like
watching.
Not one video, like 10 of them.
Yeah.
With weather.
Correct.
So now you have an anomalous data point. Okay.
Sure, I'll look at it. I mean, if you give me a reference, I'll read up about it.
Not a reference, a demonstration.
So is it the apparent horizon that cuts ships off from the bottom up, or is it the actual horizon that cuts them off from the bottom up?
Well, I really don't want to move off of this modus tollens argument yet, because there's a couple other things I wanted to go into. But the short answer is that I think that the geometric horizon is the one that cuts it off, and the apparent horizon is the one that you see, and that those two things are consistent with one another and they can coexist.
So when the boat is way off in the distance and its disappearance is consistent with the distant horizon, it's somehow actually being blocked by the closer horizon that's physical.
So let's take what he said in the context of this image, right? So the geometric horizon in this image is supposed to be a mile away. That is what is supposed to be cutting off. It should be cutting off the oil rigs. But you can see this visual horizon more than 9 miles away. So where did the geometric horizon go? Did it become transparent?
I think it's still there, but then...
But it's supposed to be blocking the light that is coming off those oil rigs.
Yeah, well, do you believe that light can bend through the atmosphere? Do you believe that light can bend as it travels through the atmosphere?
Can bend. Yeah, I believe it can bend, yeah.
Okay.
So then, you said it's blocking it. You said it gets blocked by the geometric horizon.
Yeah, but the light can bend over that horizon and meet your eye.
Okay, but the horizon went from in front of the oil rig to in back of the oil rig.
Well, the apparent horizon did, yeah.
Well,
the geometric one stayed where it was.
You show me or tell me or demonstrate it in any way, shape, or form how a horizon that should be obstructing something from the front can leapfrog the object that should be obstructing and appear behind it.
Well, this is another part of the...
No, just tell me.
I'm about to answer you. Okay. This is another part of the claim that's being made. And I don't know exactly where the horizon is in that image, but I can't really argue that it's definitely behind the oil rigs unless you can substantiate that decisively.
There's actually the person that took this image took some more yesterday that are a lot clearer.
Well, I mean, to really know for sure, I think you need to take more data measurements than we're taking. Isn't that the case? I mean, can you be certain of where the horizon is?
Well, if the horizon is where the land, where the sky appears to meet the land, it's a subjective visual impression.
Yeah, but that line in both of those images is not exactly clear.
Well,
I mean, it's a hazy day.
It certainly is not in front of the oil rigs.
No, I agree. Or at least it doesn't appear to be.
So how would it...
But then it could be. I mean, it could be the case that there's some strange atmospheric
mechanism which could make that happen.
Well, I don't know.
Bending light doesn't cover it because you have to bend it in such a way, I don't know what, corkscrew it or whatever. You have to bend it in such a way whereas the line, which would normally be obstructing, somehow flipped and got behind the oil rigs.
Well, you're not going to like this answer, but if it was up to me, I would say there's so many anomalous refractive artifacts in that image that it's worthwhile just throwing it out. I know you're not going to want to do that, but you have to look at that image and think there's a lot of crap going on in there.
Doesn't matter.
But it's been repeated.
Yeah, but it hasn't been repeated without a lot of artifacts of refraction. That's the thing.
So you saw the one that was done yesterday?
Yeah.
Okay, so why are you like sandbagging, like pretending you didn't see it?
Well, I did see it, and I saw refraction in that image too.
So, guess what? Turbulence, atmospheric turbulence, is not refraction.
Well, there's a lot of waviness in those image, and I think if there was better focus, you could see the cranes were distorted in a similar way as they were in the original.
Now, tell us the mechanism where waviness in an image translates to horizons jumping in front of each other, back and in front of objects.
Well, I'm not sure that the horizons are doing that because, like I said, it's hard to determine.
Listen,
if you're on a globe, it has to do
what
that.
you're doing is called FUD. Okay, it's called fear, uncertainty, and doubt. They used to do it in corporate circles, back IBM versus Microsoft, and that's all you're doing. You can't name a mechanism this would happen, not a physical one. You can't even conceive of one in your mind. Okay, you can't even make one up using a fucking exotic material. There's no way it could happen. That a horizon is going to get displaced from in front of an object to another. It's just not going to happen. It can't happen.
Well, I mean, can the horizon not appear to move further back due to impacts of refraction? I think
appear
it
to
can,
move further back means it appears higher in the frame of the in the
well,
in
I
the
think it does,
photographic
doesn't it?
frame.
Doesn't the horizon appear higher?
But listen, if the oil rigs are behind the horizon, the oil rigs will appear higher as well.
Well, we talked about the geometric horizon or the apparent horizon.
It doesn't matter with either one. It does not matter. We're talking about an apparent horizon. Wherever it appears to be, if it's in front of the oil rigs, if refraction is lifting everything up, it's lifting everything up. It isn't just lifting just the horizon up and sticking it behind the oil rig.
So let's assume that that refraction has lifted everything up, okay? And the horizon is in fact behind the oil rigs. What?
How would it get? No. We're not going to assume the second part because the second part is impossible.
Well, what prevents that from happening due to refractive effects? Like, why can that occur due to refraction? I mean, I know it's been argued that our model of refraction allows for anything to happen, but if that's the case, then why can't this be happening too? I know you're not going to like that, but
because the light comes to the camera, right?
Yeah.
So if there's a horizon and there's an oil rig behind it, and the light has to come from the oil rig, so the sunlight reflecting off the oil rig comes to the camera. The sunlight reflects off that hump of water that you think exists, that comes to the camera, and those are sequentially behind each other, right? They're in different positions, in distances, one in front of the other. Okay? No amount of lifting or twisting is going to make that horizon, the oil rig, suddenly appear in front of that physical object. Dude, what you're basically telling me is I can be on another side of a hill, there can be refraction, and it will appear I'm in front of the hill and not behind it. That is ridiculous, dude. That is a ridiculous statement. You cannot conceive of any way to do that.
Yep.
Well, like I've talked to people about this before, like in the on the Glober side, and their position seems to be that, and I think I agree with it. Like,
that refraction is magic.
No, an observation like this, with as many obvious artifacts of refraction as are in it, extreme refraction, shouldn't really be counted as a great exemplar for any position, because except for the effects of refraction, because it's so laced with it. I mean,
so a hand wave dismissal.
What about finding a black swan?
Hey, listen, bro. What Indio set up for you? What Indio set up for you is a physical relationship between objects. What you set up is just a penumbra of plausible deniability.
Concepts. We know that when there's the entire argument of shifts behind the horizon is that we're using the ideas of everyday light. When one object's behind another, you can't see it. Okay, you're saying there's just some magical light where if some object is behind another object, it can appear in front of that. That's ridiculous, dude.
I'm willing to accept this type of argument, your position that the horizon is in fact behind the oil rigs, right? But we haven't really established that concretely, have we? Because we can't. So
visually, it appears to be behind the oil rigs.
Yeah. Well, it might be.
Visually, especially in the second video, you can see the water lapping up against the bottom of the legs of the oil rigs. So we know the horizon can't be there.
In both of these videos, they're hazy. There's a lot of distortion in them.
But you can still see waves smashing against the bottoms of the oil rigs where the oil rigs meet the water. So we know the horizon can't be at the oil rig, but the globe predicts they're in front of the oil rig.
But not the globe including refraction, does it? Like this is the globe.
No, yes, the globe including refraction, even including, say, you take the standard 7.6R.
Well, this isn't a standard 7.6R day, is it?
Why isn't it?
Because we can see how much haze there is. Do you think they're both standard refraction days?
I didn't think there was particularly a large amount of haze in the second video.
Or what was the first one?
I don't know about the first one. I thought it might have been a little hazy, but the second one is way more clear, and you can see a lot more. And it's irrelevant, dude. This is all just a bunch of red herrings.
Because refraction is the whole argument.
No, refraction is not the argument, because you're not stating an argument of refraction. You're saying an object that's behind another object can teleport in front of it.
Well, we haven't established the horizon is in fact behind the oil rigs yet. I mean, to be
Why not? Why not?
Well, that's for you to do. How have you done it?
It either has to be in front or back or on it, and it's not front, back. It's not in front of it, and it's not on it, so it has to be in back of it.
You're just being dishonest.
Oh shit!
I'm not being dishonest. What have I lied about?
You're being
intellectually dishonest.
Let me put it to you this way.
Look, you guys, listen. I said this 3 years ago when the servers first started. Y'all are never kicking, dragging, screaming. You guys are never going to let go of this ships over the horizon thing. No matter what amount of evidence is shown, you're going to fucking deny it. No matter what. Despite the fact that there's 300-mile observations in Antarctica of mountains, which only could happen if a mountain was twice the height of Everest. And that's in the National Geospatial Agency. Right? They print it. It's not some flat earther. You can go on YouTube and look up sea captains talking and saying, yeah, I can see 200 miles down here. Okay, so this is all well-known shit. You guys can't accept it because boats go over the horizon, because it's a globe, because it has to. Some silly shit that someone postulated 500 fucking years ago is your best proof.
All right, well, since we don't agree with the observation, could we go back to the syllogism? Because I still have a problem with that syllogism.
Apparently, because you don't understand. You can't even agree what the fucking horizon is.
Well, it's indeterminate, I think, but in both images. But I think we could probably get to an agreement on syllogism.
Listen, if you want to deny your ice, then that's fine. There's no point in going over the syllogism because you're just denying objective reality. So, what else? Right. So you can take any of these images, right, and just apply a negative, not a negative color filter, but invert the colors. So you get more contrast. It isn't changing anything. It's just changing the color values. And you can clearly see a horizon without any problem.
Do you think there'll be a black swan without any kind of refractive issues in it? I mean, do you think that's possible?
This isn't... You act like this is the only thing. You act like that this is the only black swan in existence.
No, I know that there's... I mean, based on his definition, the majority of observations are going to be black swans, aren't they? Yeah. Any observation that has a non-geometric horizon is by definition a black swan based upon his syllogism, right?
Yeah, true. Yeah.
So that's most observations.
Well, then that's 500 years of stupid arguments, right?
Well, it's also 500 years worth of like black swans that we've been calling white swans, but now they're black.
Yeah. So what does that tell you?
Well, it tells me the analogy is kind of strained.
No, it's not the analogy that's strained. It's the fact that these were all black swans, and there was a long line of confirmation bias.
But wasn't the argument always about black swans? Wasn't the argument always about refraction, causing you to see farther than the geometric horizon? That was always the argument. This isn't a new argument, in my opinion. It's being phrased in a different way, but fundamentally, it's the same thing.
No, listen. So when a ship, when an object appears over the horizon, what is that? Is that the geometric horizon or not the geometric horizon? Like, when does this refraction take place? Like, only when an object isn't obstructed, like the prediction?
Most of the time, you're going to be seeing an apparent horizon that's being loomed up by refraction. But the thing that's obstructing,
Most of the time.
the thing that's obstructing things in the background is the geometric
Do
horizon.
you have any evidence that happens most of the time? Any?
Well, you're arguing the same thing, aren't you?
I'm not arguing anything of the sort.
Are we disagreeing that most of the time you're seeing the apparent horizon?
No, you just said loomed up. You just said most of the time objects are loomed up. Do you have
loomed up
any
in the sense of
evidence
refracted up. Most of the time,
Do you
you're
have
going to be
any
in
evidence
conditions
of
that are
that?
standard refraction, at least.
Do you have any evidence of that? Do you have any evidence that refraction is the general case?
Well, are we disagreeing that refraction causes light to bend?
We know that refraction. Listen, the fact that
So
an
what's
effect
the
can occur does not mean it does occur. Listen, this is typical bullshit sophistry from fucking Glovers. The fact that an effect can occur does not mean it is occurring, okay? And you guys proclaim that somehow refraction is the general case. It's the general condition of the fucking air that we look through every day. Well, then how did you figure out it was a fucking globe of 3,959 miles in the first place if all your measurements are optical? How'd you figure that the fuck out?
So what's your position?
So,
when it comes to refraction?
How'd you
I'm
figure
interested.
that out if everything you measured and looked at was bigger than it really was in the first place?
Well, not bigger.
Yeah, bigger.
No.
Optically larger.
Well,
Yeah,
I mean, that would be
optically
towering,
larger.
right?
Everything
It doesn't have to
is
be.
loomed up, it's spread out, and everything
It's not
is
larger.
bigger.
No, it's not. It's not
Larger.
bigger.
It's modeled as larger. What do you think
I don't think-
76R means?
Yeah, oh, you mean the planet, not the actual thing you're looking at?
Look.
Are you talking about the globe being larger, or are you talking about what you see
The
being larger?
globe would optically appear larger if
I don't think it
everything
does.
was being. Okay.
Then how are
So
you seeing
It's a way of
if I see a
constructing a rule of
horizon,
thumb.
if the globe predicts a horizon at 9 miles and I see it at 10, does the globe look like a larger globe? Of Earth of a larger radius?
But that's the problem, right? Because you're saying that this defies expectations, that this defies the prediction of the globe. But I don't know how it does that, because our prediction has never been that the horizon will always be geometric.
You don't actually
we argue
have
that
a
it's apparent.
prediction. You don't actually have a prediction. You have a bunch of post hoc bullshit, dude.
Well,
That's
I'm
all
going
it
off of
is.
Kiwi's argument, and I'm assuming you're a subscriber to that argument. If you're not, then you can tell me. I'm just going based off what his argument is.
Look,
oh shit!
His argument speaks for itself. It doesn't need to be retranslated or reconvened. You know what it is perfectly. Okay?
Yeah.
And
you just got off the fact that, listen, the globe, the measurement, the claimed radius is based on optical measurements, right? Surveying, looking at things. Now, to after the fact say, well, those optical measurements that we did, they're in fact actually wrong because things are loomed up. Like I said, what do you think 76R means? That means they increase the radius of the globe by 1/6 and then model everything as if the rays of light are straight.
Yeah, but that's just to increase the distance to the object. It's not to
But that
increase the size
increases
of the object.
the entire size of the Earth.
It doesn't increase the size of the object, though, right? You weren't saying that, were you?
It will increase the distances.
Optically, it does.
Optically, it does. It'll increase the distances because all the angles will increase in size. So optically, the Earth would look 1/6 bigger than what they actually measured it as. But what's happened was they came up with 3,959 miles. They started doing measurements, and they're like, holy shit, this doesn't fit. We're going to have to add something to this fucking formula to make it fit our fucking globe. So that's what they started doing. But that didn't work, so then they started with deflection of the plumb line and deflection of the vertical, because now down isn't down, and we got to curve the plumb line and project it on an oblate spheroid. And this is a bunch of shit you don't know that they did in surveying, but this is what they did. You guys think that like a globe projection is like some straight lines? No, it's not. They're all curved plumb lines.
Okay, do you think that it would matter if no one on the globe side actually subscribed to this position that all horizons must be no more than the geometric horizon? Would that be important or not?
I think what should be important is that they stop telling kids that ships over the horizon proves it's a globe. That's what I think.
No, they were not lying.
the next
Look,
time
if it's
QE
true,
comes
they
in,
wouldn't have to lie to kids.
because whenever I try and talk to QE, he just mutes me. The next time he comes in, could you ask him about that horizon part? If he
Whether
believes
it's
just trying to find
We're
a
talking about QE. We're talking about your ridiculous argument here.
all right, don't get
trying to find
upset.
a
It's
flaw
fine.
in the
Like,
argument.
no one's
because
emotional
you
here
can't
apart from you.
rebut
Okay,
it. You
it's
can't
cool.
rebut it, so you're trying to find a flaw in the wording.
Well, no, I was under the apprehension that he meant apparent horizon when he said horizon, but you're saying he meant geometric horizon. And if that's
So
the
why do you
case, then
keep
it does
going back
change the
to
argument
it?
quite a lot.
Darkstar, you have to think about it like this. If he's applying it to a globe earther and he's applying it to globe earth, like the geometric horizon, that's what he's talking about. He's not putting in what he believes into the argument because he's trying to test the predictions of the globe, right? With this black swan, right? So why would he use apparent horizon? Does that make any sense to you?
Well, yeah, because I'll tell you, because he's sorry, I didn't mean to interrupt you, but he's comparing an apparent horizon observation, the black swan, to a geometric horizon position, and that's if he's saying that the word horizon, okay, it's ambiguous in the context that he means to put it in because it means different things to different people, right? It would be better if he said exactly what that word meant in that context because it's not clear to me, and I was confused. I thought he meant apparent horizon when he said every horizon. Like when he said every horizon distance measurement, I thought he meant distance measurement to the apparent horizon.
Let me ask you if
not
this
to the geometric one.
Would this statement make sense? Ships being obstructed by the apparent horizon prove the globe. Would that be a sentence that made any fucking sense to you?
No.
No. So that's why he's using geometric horizon because we've been hearing for years the geometric horizon of the Earth, the leading edge of the ball, is what is blocking the bottoms of ships, objects, buildings, you name it, whatever the object of the day is. That they're saying the geometric horizon does that.
Sure,
okay?
so
if the geometric, this is basically saying the claim that the geometric horizon proves the globe because it blocks the bottom of boats is false because the horizon is not where the geometric horizon is supposed to be.
But which horizon? The apparent horizon or the geometric?
The geometric horizon, because
but the geometric horizon is exactly
this is a corollary of the original claim. The original claim is the geometric horizon. You said it yourself. Is what is blocking the bottom of objects.
Sure, but
you
the
never
argument...
said. Did you ever say that the apparent horizon is blocking the bottom of objects?
No.
Okay, you said the geometric horizon.
Yeah.
So that's the horizon he's talking about, the geometric one. The same horizon everybody's been talking about for a long time.
But we never made the claim that the geometric horizon can be...
You just claimed it about 10 minutes ago.
No, the geometric horizon is just a function of the radius of the Earth and the observer's height. So
And
that's not
10
even a
minutes
question.
ago, you claimed that the geometric horizon is what obstructs objects.
Yeah, I don't renounce that claim.
Yes.
This dude's smart,
So
he's
he's
just being
refuting that
intellectually
claim.
dishonest.
He's refuting that claim. He's using geometric horizon.
But he's refuting that claim by presenting an observation of an apparent horizon. I don't see how that does that.
Okay, well, then.
But how does that do that?
A refutation is that it's apples to oranges because he's showing an apparent horizon and not a geometric horizon.
But that's the thing, because it makes a lot more sense from his perspective.
How do we differentiate between apparent horizon and a geometric horizon? How do we differentiate which is which, right? So that's the next question. So if it's actually the apparent horizon that makes objects appear to be obstructed, yeah, so that's where we're at. The apparent horizon, because that's what it is. The images, what you look with your eyes. So that's the apparent horizon that makes things appear that way. So that means whatever's happening is a purely optical phenomenon that has nothing to do with any geometry at all.
But do you think it makes more sense, like in just reading it, that he would say that up to this point, I'll read the syllogism. If the Earth is a sphere with a radius of 3959 miles, then every horizon distance measurement must be no more than 1.225 square miles. 1.225 square root of the observer's height. We have a horizon distance measurement greater than 9.4 miles. Therefore, the Earth is not a sphere of radius 3959. Doesn't it make more sense if he's saying every horizon in the context of every apparent horizon?
Yeah, but then it wouldn't be a syllogism because then you're starting to import other logical conclusions into it.
This is exhausting.
You're trying to make really a formal syllogism, which only has specific purposes to prove one idea, and trying to import all these other conclusions off of that. Logically, this is absolutely true. Okay? Logically, it's absolutely true. The conclusions based upon the truth of this may or may not be true. Those have to be proved by their own syllogism.
But so the actual if P then Q, not Q, therefore not P, right? The Q is that every I'm gonna rephrase it in the way that you're arguing it is, which is geometric horizon, just to be clear, okay? The Q is then every geometric horizon distance measurement must be no more than the geometric horizon distance calculation, okay? The next part is the negation of Q, right?
Hold on.
So how does this observation of the black swan negate that position? How does the black swan observation negate Q? Do you see what I mean? Like, I don't see how that works.
Here's how it works. Can you guys hear me?
Look, your only argument is this picture is not Q, and it's something else.
Yeah, basically. I mean, it's the apparent horizon here, clearly, right? And we're talking about the geometric horizon in Q.
Okay.
If that's what I don't think that's what he's saying, but if that's what you think he's saying, I still don't think it makes sense.
Well,
we don't care.
I've got this. Hold on, guys.
I just think you're
all right. Check this out.
Whatever you got to do, whatever you get paid to do. I don't know.
I wish I got paid, bro. Do you want to pay me?
You're doing it for free? Holy shit!
Well, this is fun.
No, it's not. If it's fun, then you obviously paid, or you just think that we're a bunch of clowns to play with. But check this out.
It's fun to work out problems like this. It's fun to kind of think about.
All right. So, do you understand geometry? Spherical geometry. So, if you're 1 foot above the ground, the geometrical horizon cannot be further than 1.22 miles from, but you end up seeing the entire oil rigs and shit. I mean, we're trying.
Yeah, but that's the apparent horizon, isn't it? The geometric horizon isn't further than 1.22 miles, but the apparent horizon can be. That's always been the position.
What do you mean? All right. Well, how about you describe the geometric horizon? What do you mean by that?
The geometric horizon is a function of the radius of the Earth and the observer's height. It's 1.22 times the square root of the observer's height. So that's the geometric horizon.
All right. So what is the circumference of the Earth?
Was it 24,000 miles?
A little bit more, but that's closer than the other guy I was talking to got.
Okay.
So. All right. So there is a physical barrier, a hump of water between what you might or might not see at 1 foot observation.
Yeah, assuming no atmosphere or refraction. Yeah, but obviously that's a silly
Wait a minute.
assumption to make.
Goddamn minute. Hold on. Oh no, I didn't. I'm not talking.
I mean, it
about
can only be that position if we have no atmosphere.
I'm not. God, can you let me freaking talk? I'm not assuming any type of refraction or anything. I'm talking about physical obstruction here. We're talking about a hump of water between you and the observation point, which is 9 miles away. Say the second oil rig. You just picture you as the camera, 1 foot or so off of the beach, and you're looking 90 degrees ahead, and you're using 24901 calculations. Would you even be able to see that without, absent of all refraction calculations or anything in the geometric calculations? Would you be able to see that? Yes.
Absent refraction, I'm not sure. You'd have to run it through a calculator, but there would definitely be obstruction there. Yeah.
The answer is no. The answer is no. I've already done it.
Can I say
The
something
answer
real
is
quick?
no.
So, Dark Star, I don't like how you're like, when you say refraction is silly, like you're trying to imply that we think refraction is retarded. We definitely believe in refraction. What's actually silly is that you can't actually give us an example of the refraction you're describing, what is causing this observation. You couldn't even think of one when India was asking. That's more silly than anything, right? Like, it's not that we don't believe in refraction, is that what you have to believe in order to get that observation, you can't even put it in words. Like, all you
I
can
mean,
say
it's
is,
like there was no atmosphere at all in the geometric calculations. If you were on a sphere and you were at, to look at these oil rigs, you wouldn't be able to see them at all if there were no atmosphere at all. You wouldn't be able to see them at all.
Yeah.
Okay,
But then
we
all
do
of a
have an
sudden,
atmosphere, so what's the
refraction
importance of
makes
that
it
statement?
look like it's flat. Then
Wait, what's the cause? What's the cause of refraction, brother?
So it's the angle of incidence and I think the density of the medium.
Right. So it requires an angle of propagation from the point source through a differentiation in medium, correct?
I think it can be. I'm trying to remember the wording, get it right. I think that the density can be, or it can be. I don't want to badly butcher it.
It has to be different, correct?
If you say it right,
It can be a
might make it
uniform
possible. If you
gradient.
say it right, it might make it
It
possible.
can be a uniform gradient, but the same kind of medium.
Listen, if the medium is ubiquitous, then there cannot possibly be refraction.
So you're arguing that there isn't refraction then?
Okay, pay attention. You already said that the angle and the change in the medium, so that means it's different. Okay, so what India was asking you is to describe a relationship optically where the objects swap places.
The objects swap places.
That? Yes. So the hump that you're supposed to be blocking things, then all of a sudden gets behind the thing it's supposed to be blocking. Okay, so you weren't able to give any type of plausible explanation. You only just referred to refraction. Refraction exists. What would be necessary for this type of observation to happen is basically heat-seeking, laser-guided eye missiles being shot out of the ocean miles past the hump of water that's supposed to be blocking the very ocean that's shooting you in the eyeballs with its eye lasers.
Right, that's assuming that the
passing through
where you believe it is.
Passing through. No. There is no where you believe it is. You point your finger at the apparent demarcation line where the sky appears to meet the ground. That's the horizon.
It's not clear at all where the actual apparent horizon is in these images.
Is it beyond? Listen, is it in the middle of the two oil rigs, or is that still water?
It could be.
What do you mean it could be?
Can you rule it out? It could be the case that the last oil rig has parts of the uprights.
Is the Earth, in your opinion, bro, is the Earth 24,900?
Hold on, Helio, you asked him that already, and you're interrupting AI's point. 1 sec.
So I'm saying it could be. It could be that the horizon is in between those oil rigs.
But why? Why would you say that?
Well, what rules it out? Why would you deny it?
Okay, I'm gonna have to look at the picture one more time just so I can be certain what the hell you're trying to say.
The truth is we can't be certain because of how much distortion there's in the image. That's why I would say you should throw it out. But I know you're not going to do that.
No, bro, that's not how it works. Okay. Right. So here we have, let's see. We have, the sky is yellow. Then I'm scanning downwards. Scanning downwards. All of a sudden I see a completely different color. And when that color appears, it's beyond, or at least higher in the field of view, which would necessarily mean beyond, the last oil rig.
Well, the oil
At
rigs
best,
are elevated.
Well, that's
you actually
cool.
Look on an elevated, like, platform almost, and you can see that it's.
I really don't understand what the point. I really don't understand what the point of that assertion was.
Well, you just see it's not above it.
What's not above what?
What do you think I mean by that? The horizon line, you old man.
So you're telling me that the horizon line doesn't appear above the bottom legs of the oil rigs? That's your claim?
I don't think you guys are comprehending that the horizon, where the horizon's supposed to be, is like 1/6 of the distance to the first oil rig.
What are the assumptions with where the horizon should be?
The geometric horizon should
But that's
be
never going to be
there.
the horizon you see, though. So why would you expect it to be there?
That's fantastic, but it can't be in front of something that's behind it.
But you keep going back to this position as though we hold that the geometric horizon is
Because the path of the ray would have to take, it would have to come in at a higher angle on the camera. Understand it's being projected onto a plane, and for the horizon in the image to appear higher than the bottom of the oil rig, it has to come into the camera at a higher angle.
All right, I gotta go now, guys. But it was nice talking to you. I'll be back maybe sometime next week or something.
All right, peace.
See you.
Fucking glasses.
I'm bored. Dude, at the end of the day, they just don't want to admit where the horizon is. That's all it is. At the end of the fucking day, like, doesn't matter. Like, the whole refraction argument was nonsensical. The whole geometric, what QE was talking about, nonsensical. When you finally hold your toes to the fire where the horizon is, they just don't want to go there.
Ask questions. I'm listening, yo. Okay, Tariq, I got a question. I'm gonna answer accordingly, so don't think everybody going out talk me either. I'm gonna talk to you when I want to talk. So don't think because y'all running, it's a bunch of y'all and y'all running your mouth now, yo. Action. No, we got moderators, bro. Yeah, you're not gonna just talk whenever you have to talk. Cut me off, yo. You can do that too. Cut me off. We'll just mute your dumb ass, bro. So this isn't your chance. That's how we do it? That's how we do it? Nah. Hold up, moderator. This is the moderator speaking. This is the moderator speaking. That's how we do it. Yeah, I know. Hold on, I got it. That's guys, how we do it. Let's not throw some words around. Let's try and get a conversation going, right? One at a time, please. No hostility. Idiots will be idiots. Let's go, Nathan. Real quick, Nathan. This is my roommate. All right, I've given him $1 to watch Flat Earth content. There's no way I'm joking. Months. All right, listen. So we're going to take these 3 points. I've come to the conclusion. Somebody needs to step up and do Miggy's 3 points with him. Tariq, listen. Yeah, I'll do Miggy's 3 points. It's fine. All right, thank you, Nathan. Here we go. You need to listen. No problem. Be a 1v1. And I ain't gonna say shit either. Here we go. I'm gonna sit back and listen. Yeah. All right, great. So to the gentleman that thinks Earth's a globe, or you're questioning the nature of our reality. I never said the Earth was globe. You haven't even let me finish my fucking sentence, bro. I said, or if you're questioning the nature of our reality. So you gotta take a chill pill. Let me finish my fucking question, bro. He's not ready for this. Okay? You're right. No, he's right. Do you have any evidence of Earth curve? Yes or no?
So then it's flat. Do you have any evidence of Earth rotation? Yes or no? No. Right, well then it's stationary. Do you have any evidence of gas being contained by a vacuum? Yes or no? No. Okay, great. Welcome to Flat Earth. That was easy. Thanks for the floor.
What is gravity?
Okay, I have no idea. Okay, next question. No.
Hey, yo. It's Chocolate saying. It's 2021. Told y'all it's a wrap for this globe. Check it out. Way too many reifications of privations. Secular thermodynamics violations. Fuck with all these fake ass apparent deviations. Globals always flapping their gums, no demonstrations. The black swan murdered the ball with simplicity. Pretend the clowns aren't they all, no specificity. Get with me, get that geometry. Your model needs nowadays. Mostly I sound like your army needs copper bleeds. With no ball to ever show for, nevermore. Been a rap for your multi-nine core scientific. Ball is thicker that they're prolific. Crumble at the thought of flat earth, that's just terrific. My hypothesis, you know, paleo genius. You thought you had it all sewn up like a seamstress. You never see this, you ain't chillin' peeping the Gleasons. The globe model so fucking dead, so many reasons. Mad at me, cause your fairy tale of gravity is rapidly becoming a motherfucking fatality. Independent variable, no physicality. Factually, you're dealing with no type of reality. A tragedy, all of the pseudoscience of fallacy. Sad to see that was surrounded by such banality. Globe darts stepping the court for their arraignment. Gas fucking off all day, and no containment. It's automatic, you sound like a fanatic. Your heart's beating out of your chest, no need to panic. Problematic, anytime they were Socratic. Defining terms for you is like dust to an asthmatic or a crack addict, all tuned up like a mechanic. State you're leaving in when you're done, it's so tragic. You end the sneezing, all snotty nose the wheezing. You globe tarts wind up like Sub-Zero freezing. Ain't no reason for you not to remain calm. As my nigga hit you with the 3-point palm. Instant exploding paradigm technique. Backslapping your beliefs into making it sweet. Your points obliterated, finished, unable to speak. Have you looking like Tom Petty catching a leak? Your whole squad left sounding comatose. I hear Michelle Dollar keeps rocks on the head, she keeps her family close. Some of y'all think y'all the best things since butter toast. When it comes to FB, prepare to catch an overdose of intellectual honesty. The clear lack of thinking of you balls never cease to astonish me. I gotta keep it real and be honest, B. It's quite possibly the dumbest thing I heard since the cosmology is often seen as a philosophy, mythology, but actually it's a prophecy of religiosity. Get all your skills and your weight up, this crunch time. Your whack model getting ate up like lunchtime. How in the hell could we establish a baseline? Most of y'all trolls are just here to waste time. I'm not aware of what I hear through the grapevine, but you must be out your mind selling space-time. A mathematical construct of imagination with absolutely no experimental validation. Before the story begins, you need a foundation. Curvature of the earth, that's the conversation. And since the shit up and disappeared without a trace, I'd say it's also time for you to see about a space. Tall tales about vacuums, an empty place, all the while breathing air. That's just not the case. You best get out my face, cause I can guarantee you that the very air you breathe immediately you fuck off the space. We understand no requirement for your compliance. You understand that you are standing in a room of giants. I admire that you're usual in your defiance, but won't you join us in this funeral of pseudoscience? You in the mood to try us? Go ahead and test your mic. These motherfuckers think they're moving at the speed of light. How about the speed of sound? 250 miles above the ground to see that ISS is going round and round. Please don't even try, son. It's been a rap since you gave up open your geometric horizon. In the trenches hoping and praying we don't get wise and realize you're smoking more of the grass than Neil Tyson. Oh, speaking of that clown, I wonder how much longer he can keep a push of this in the background. Never debating, always up for the back down. Playing in fear of the gravitational smackdown. This little circus won't last long. I'm betting you the type of clown that sits at home alone with a mask on. Thinking you debunked an argument like the Black Swan. Never knowing that your radius could be that wrong. Oops, I really meant to say dead wrong implicitly. We've been falsified the globe empirically. Need you to listen, G. It's not logical to postulate you live in a sphere in no sphericity. It's the epitome. It's not a mystery. The globe model's all wrapped up in stupidity. It's quite simple, see. It's probably not the move for you to spew your rhetoric here or religiously. Maybe officially. One day you might find yourself vividly in the middle of an epiphany. Lyrical symphony. It's been a pleasure, but our times have both come to an end. Synchronicity.
Yeah. ODD TV. Payday Monsanto.
Let's get it, homie.
They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite. They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite.
They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite. They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite. I came here to kick some ass just like Roddy Piper. These motherfuckers that walk among us, they got me hyper. But don't be chewing that bubble gum, it's got aspartame. It's a chemical directly targeted at your brain. Just like the fluoride that put in the water supply and all the geoengineering we got in the sky. I'm trying to tell you, and I hope that you're hearing me clearly. This ain't no bullshit speculation, conspiracy theory. They live and they're controlling every move you make. From the apartment that you live in to the juice you drink. They give you television to help you ignore this prison while feeding you genetically modified organisms. They want us like the Walking Dead, just obey and consume. Don't worry about anything, keep awaiting your doom. To all my warriors out there, this is indeed my call. It's time to put a fucking end to this elite cabal. They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite. They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite.
When they try to prove their spinning ball Earth, it's remarkable. All their arguments are absolutely fucking farcical. It's clearly been shown your problems aren't resolvable. Your theory has been blown into tiny little particles. The pharmacological drugs they got the masses on precludes them from putting their rowdy Roddy Piper glasses on. And even when they do, they're unable to gaze too straight. Cause for most of them it's way too late for them to see past their conditioning. They will not be listening to anything outside their paradigm imprisonment. They are ensconced in a nonsensical certitude, brainwashed by devils to revel in their servitude. It's idiocracy, pure hypocrisy. Waking these dummies up, it used to mean a lot to me. But nowadays I wanna tip their canoes, and as they drown, tell them this is what you get when you snooze.
They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite. They live, we sleep. The alarm's going off, beep, beep. Time to wake up to the deceit. Our whole reality's made up by the elite.
Either put on these glasses or start eating that trash can.
It is Photoshop, but it has to be. It is Photoshop, but it has to be. It is Photoshop, but it has to be.
What you're seeing here is a mirage.
A lie is a lie, and it don't matter how many dumb sheeple believe it. And the truth is the truth, hiding right out in plain sight, and still people don't see it. Man, this shit got me heated, and I won't stop till the elite are being defeated. They keep us deceived about everything that we think, and they keep it a secret. What we're taught is not conducive with reality. Big bang, evolution, and there's gravity. I tell the truth, and then these motherfuckers laugh at me, telling me the earth is photoshopped because it has to be. Most people accept the deception happily, but what they're doing to us all is a tragedy. God created the heavens and the earth in a verse, but we're living in a famous on the galaxy. They say we're monkeys on a ball flying through outer space, but there's no proof, it seems to have vanished without a trace. NASA and other agencies falling down from grace. You can take that bullshit pseudoscience and get out my face. I'm the antisocial type, you're a government prototype. That's why you make it a point to tell me that I'm crazy every time you're angry, cause you know I'm right. I'm standing outside the house of cards about to watch it fall. No more living on a cartoon ball. Horizon means horizontal. Indoctrination is awful because you're taught the globe model. Ever since y'all could crawl, we follow rapists and murderers, liars, thieves, and sun worshippers, saying we can't see curvature cause we're all too small. And though it's never been proven, they say we're ripping and shooting. The earth is spinning and moving. Oh no, no, not at all. It's a criminal enterprise where deception intensifies. Assholes got us all living life on a cartoon ball.
It is Photoshop, but it has to be. What you're seeing here is a mirage.
They say that we went to the moon 6 times, but pure BS is the way that smelled. Now they're telling us that we can't even leave the planet because of the Van Allen radiation belt. Yeah, okay, sure. NASA, what you lying for? You lying now, you lied before. I can't take this anymore. The only thing they took to space was your imagination. Fake aliens are coming, now they have you waiting. We need to do something about it, no procrastination. Trying to cause the masses to awaken, that's the path I've taken. But you can see if you check the percentages. So many people having cognitive dissonance, but that's what happens at the loss of your innocence. Then you get involved with all of this wickedness. They try to do all the humans this way. So are they just idiots? Who is to say? Conditioned by the television, it makes your decisions, opinions, and you just obey. Stuck in the material domain of Satan, where everything in each and every day is pagan. Mandela effect, cause the game is changing. People waking up and now the cage is shaking. The earth is flat, and that is a universal fact. If it isn't that, then tell me where the fuck the curve is at. They tell us that we can't see it because we're all too small, and now we're spinning on a cartoon ball. Horizon means horizontal. Indoctrination is awful because you're taught the globe model. Ever since y'all could crawl, we follow rapists and murderers, liars, thieves, and sun worshippers, saying we can't see curvature cause we're all too small. And though it's never been proven, they say we're ripping and shooting. The earth is spinning and moving. Oh no, no, not at all. It's a criminal enterprise where deception intensifies. Assholes got us all living life on a cartoon ball.
It is the world that has been pulled over your eyes to blind you from the truth. Like everyone else, you were born into bondage, born into a prison for your mind.
We accept the reality of the world with which we're presented. It's as simple as that.
massive shout out to Quantum Eraser YouTube channel and Quantum Eraser himself for this concise explanation of the Black Swan argument. I'll put a link to the Quantum Eraser YouTube channel down below. Subscribe today.
The death of the ball-tard spinning space monkey religion again. Now, here's the argument. If the Earth is a sphere with a radius of 3959 miles, then every horizon distance measurement must be no more than 1.225 times the square root of the observer's height in feet. That's the geometric horizon. There's the kill shot. There's what they call CGI. And they think this thing's a boat. Unbelievable. Observer's height is 1 foot. The distance to the horizon is greater than 9.41 miles. Why? Because we can see the horizon behind the second platform. The argument isn't in regards to the oil platforms. This one, or their boat. Right? The argument is solely the horizon behind the second platform, which everyone can see. I don't care if there's a Chinese Superman on a hobbled refracted unicorn wearing a tutu on these platforms. Don't care. That's not the argument. If you bring it up, it's a red herring fallacy. That is a diversion or irrelevant. My argument is purely on the horizon behind the second platform. I hope that's clear to everyone. In about 9 months, it should be. They should be able to restate the actual argument. Like I said, the observer's height's 1 foot. I gave him 5 feet, and I'm going to show you that here in a minute. Distance to the horizon is greater than 9.41 miles. Like I said, it's behind the second platform. The distance to the horizon maximum for a sphere with a radius of 3959 miles is 1.22 miles. Based on geometry, that's it. It's hardcore. That's it. Even if he was at 5 feet observation height, which he's clearly not, but I gave it to him, the maximum distance to the geometric horizon is 2.73 miles. So way up in here. Even if he was at 35 feet observation height with his camera next to the water, the maximum distance to the geometric horizon would be 7.24 miles. That is, it should be between the first and second platforms. So they have no argument here. None. Here is the actual argument. Modus tollens. Holy shnikes, this is going to leave a mark. If P, then Q. Not Q, therefore not P. Listen closely to the argument, Globies. If the Earth is a sphere with a radius of 3959 miles, P, then every horizon distance measurement must be no more than 1.225 times the square root of the observer's height in feet. That's Q. That's the geometric horizon. Not Q, because the horizon distance greater than 9.41 miles. Therefore not P. The Earth is not a sphere. The ball-tard spinning space monkey community, please allow me to introduce to you your black plague, the black swan. There it is. Bye-bye, ball.
Ladies and gentlemen, I want to make an announcement. Has anyone heard the Earth is flat? Well, I just got kicked out of Starbucks for asking NASA employee questions because he's lying. You ever hear about the flat Earth? Did you know what's in the Bible? That the Earth's flat?
You need to turn that off.
You can't touch me.
One of the first lessons we learn in school is that the Earth is a globe and rotates on an axis and orbits around the Sun. But there is an increasingly large community of people who reject this and instead believe that the Earth is flat. BTV wanted to track down the real people behind this emerging internet conspiracy, so we travelled to LA to spend some time with flat earther Nathan Thompson.
Has anyone ever told you the Earth is flat?
I've heard.
Yeah, it's hot. I run a group called the Official Flat Earth and Globe Discussion. Could I get you in there?
Nathan runs the Flat Earth and Globe Discussion Facebook group, which now boasts close to 40,000 members.
At first, I was extremely skeptical. I thought this was the craziest idea I'd ever heard, and I was going to debunk it in 5 minutes. And after about a month of not sleeping and really just digging through the information, I was a flat earther. No one is just completely in the matrix and wakes up to the flat earth. They started out with 9/11, they started out with vaccines, they started out with chemtrails or something, because they're lying to us about a lot of stuff. It's more than just the shape of the earth.
My name is ODD, and I run a channel on YouTube called Odd Reality, and I go over many conspiracies, including the flat earth, and I recently hit 75,000 subscribers. What happens is you go to school and you're basically taught and you absorb the information that the earth is a spinning ball flying through outer space before you can even think on your own, before you can think critically. So you spend the rest of your life in that state of programming because you learned it at such an early age, it just becomes unquestionable. But what has happened is the current flat earthers have went back and rigorously looked at this heliocentric model, and we've come to find that it's highly ridiculous and hardly anything in it has ever been proven, including the curvature and the motion of the earth.
We're not dealing with normal people that run the world here. They're psychopaths. I actually can't believe how popular the group is. I woke up this morning and I have 2,200 members to approve, so the group is just exploding.
We accompanied Nathan while he was out canvassing the streets of Orange County, trying to recruit some new members.
I would say 50% of the time, someone leaves a conversation with me saying, I didn't know any of that information and I'm gonna look into it. And then the other 50% of the time, they just reject it regardless of, what you show them. Everyone's coming out about all the celebrities, Shaq, Tila Tequila, B.O.B., Kyrie Irving. They're all talking about it, and it's kind of funny is that they just make it seem like a joke, but I don't think it's a joke that NASA steals $50 million a day, $19 billion a year.
Oh.
That's crazy. That's a lot of money, So I'm just out here trying to wake people up.
Okay.
I feel like that's my purpose.
Not only do supporters think that the Earth is flat, they also believe that it's surrounded by a heavily policed giant ice wall.
Oh yeah, so it's very easy to circumnavigate.
You really can just fall off.
No. There's an ice wall around and they guard it. So since 1961, they've been guarding the ice wall. And do you know what we started doing in the 60s? Fake space travel. Yeah, of course. Yeah, my pleasure. Right, thank you.
Regarding the ice walls, it's never been proven, but it makes a lot of sense. Something has to hold the water in. We know that the water is not falling off an edge and there's no ships and boats going off the edge. That's all a ridiculous conception to make people laugh at the flat earth theory when they hear about it. So the thing is the ice walls have been a part of maps for 1,000 years. The first map with the ice walls in it comes from around the year 1000 in the 11th century by Al-Biruni. And back then it was just a map. Now it's called the azimuthal equidistant map, and it's defined much differently. It's defined as a map that's a flattened out version of the globe, when in fact they reversed engineered it, and the globe is a rounded spherical version of the true world flat map.
So if the Earth is flat, then why are they lying? Why are they hiding it from us?
The group have also made claims that space exploration is fake and that NASA is a fraudulent organisation. Much of their beliefs, instead, are based on religious ideologies.
You know, a lot of Christians are drawn to the flat earth model because in the Bible, they back up the flat and motionless earth pretty much throughout the whole thing. But me, I'm not religious, and there's many people like me who aren't religious, not Christian, not anything, just looking for the facts. And the facts are is there's no curvature to be detected, and there's no motion that can be measured. So why are they telling us that it's so, you know, that these are proven facts? Why is it taught as fact in school when it's all just a theory?
The whole globe Earth model, in my opinion, it wasn't devised by men. It was devised by the devil who wants to deceive everyone. But NASA tells you that stars are billions of light years away. NASA in Hebrew means to deceive. Now, who speaks Hebrew? There's your answer right there. So you asked me who was behind it, and I think it's pretty obvious once you do the research.
This translation of NASA is popular amongst flat earthers and other conspiracy theorists. However, when we approached a professor of Hebrew at the University of Cambridge, we were given the following translation. So while the root of the verb to deceive is similar, this frequently used translation is in fact incorrect, and NASA in Hebrew actually means to lift.
NASA, to be, you know, to deceive in Hebrew or to lift, it doesn't really matter because either way they both come from the same root word. So it's not to lift. They're basically lifting you out of the real, you know, out of reality. They're lifting your imagination into outer space, which is not what we're told. You could look up at the sky and see the stars and the wandering stars, aka planets. But it's not like you can't go traveling into deep space. Everything we see is not billions of light years away or trillions of light years away, or the sun's not 93 million miles away. It's all contained within our sky. It's our system. You know, it's just, we have a barrier up there that prevents men or anything from leaving. And you could find this information admitted by NASA.
Right now, we only can fly in Earth orbit. That's the farthest that we can go.
The kinds of technologies that we're testing out on Space Station are definitely helping us with our goals of going beyond low Earth orbit.
Early in the next decade, a set of crewed flights will test and prove the systems required for exploration beyond low Earth orbit.
And this is really the beginning, I think, of human beings leaving low Earth orbit.
You could also see for yourself that NASA admits that all the telemetry data for the moon landing missions is no longer in existence, and that we do not have the technology to go back to the moon.
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again.
I haven't seen anything that indicates the telemetry data is even in existence, and as I said, even if we had it, we don't have the machines to play it back.
Unfortunately, I'm afraid I can't really give you much of a clue as to where this data ended up and whether it still exists or not.
So you look at all that and you gotta wonder what's going on with NASA. Why were they able to go to the moon 6 times between 1969 and 1972? That's a 3-year period. They went to the moon 6 times in 3 years between 69 and 72. Here we are in 2017, and we can't figure out how to get past low Earth orbit, and we can't get back to the moon. That is very strange.
I'm here today because I was aware that the Flat Earth Society on Facebook was going to meet here. I wanted to meet with some of them and hear from their mouths what their thoughts on the way the Earth is shaped and how the solar system works.
We are not the Flat Earth Society. The Flat Earth Society has been propped up by the powers that be to be, it's basically controlled opposition. So when someone, if you start thinking, hey man, there's a lot of evidence that supports the Earth being flat, or you just you're actually one of those rare people that could do research unbiasedly. You go to look, and the Flat Earth Society is pretty much the top ranking result on most internet searches. So when you look up anything, they have a bunch of answers for things that do not make any sense. So if you like, well, what's gravity on the flat Earth? You look at their website and it basically says that the Earth is rising constantly at a certain rate, which makes up for gravity. But that's just absolutely ridiculous. If the Earth was actually moving and we were moving upward constantly, we would fly right into the sun, right? Something like that. So it's a big turnoff for new people that want to look into the flat Earth. You start looking into it, you find Flat Earth Society, you get told very strange, laughable answers to your questions, and then you give up your research right there. You're like, nah, the Earth's not flat.
Hey, have you ever heard the Earth is flat?
We invited Spencer Marks of the Independent Investigations Group to come and challenge some of Nathan's views.
The Independent Investigations Group is a rational, scientifically based skeptics organization that investigates claims of the paranormal and fringe science claims. Well, I'm pretty sure that the Earth is a globe. I believe, through research, you believe the Antarctica is an ice wall. Is that correct?
True, yeah. I haven't personally been to the ice wall. I've heard people have been turned around at gunpoint for trying to investigate the ice wall independently.
The ice walls do not have to be heavily policed, in my opinion. They keep us in the middle of our flat Earth, on the continents, you know, in the middle of the pond, if you will, surrounded by the ice wall. It's not like a 360 police holding hands, you know, with guns, waiting for someone to get there. There's an Antarctic treaty in place signed by, I forget how many nations, 50 nations, 52 nations, something like that, quite a few. And anyway, it keeps people from independently going to Antarctica.
I know water doesn't fall off because there's an ice wall on our theory. So, I mean, how about, you know, how does water stick to a ball that spins 1,000 miles an hour?
Gravity.
But gravity is nothing more than a theory.
Because there's got to be some force that keeps us on the ground, right?
Well, yeah, there is. It's called density. So if Earth's moving 1,000 miles an hour around the equator.
But you're moving with it.
So there's no Coriolis?
No, think about being on a train going like 60 miles an hour. Do you feel slammed against the back like this, or do you just move with the train and it doesn't even really feel like it's moving?
But now jump on top of the train and spin the train. I'm open to evidence, and for the first month, all I wanted was Earth to be a globe. And the more research I did, the more I found out, you know, it's just a crazy concept.
The flat Earth is something that can't be shoved down someone's throat or told. You just can't tell someone the Earth is flat. You can't tell them the hundreds and hundreds of reasons why the Earth is flat and motionless. These people and, you know, all the people out there, you got to come to that conclusion on your own. And once you do, you'll see what I mean. Nobody could tell me the Earth was flat. You know, I had to figure it out on my own, and so do you.
Do you think we went to the moon? I'm just curious.
I know for a fact we went to the moon.
Oh, for a fact?
Yes. 100% of the evidence tells us we went to the moon.
Those astronauts are liars. You could tell before they went to the moon and after they went to the moon, their demeanor had completely changed from someone who's rock star celebrity to someone who's, I'm being told to lie. And basically my life's in danger if they would have came out about it. And I think they killed some of the astronauts. If you look at the number of people who died trying to get in the space program or be an astronaut, it's astronomical.
How does the sun move on the Earth?
Take this and put it right here, right, and go around it like this.
Okay, that means the sun wouldn't rise and fall in the east to the west as it does. It would literally go out, and it kind
of does, in my opinion.
The sun rises and sets due to perspective. Now you take a ball, you're on a ball, okay? You take that ball, you rip it open, you flatten it out. It makes for a much, much larger surface area. So the sun being smaller and closer is able to circle around and go in its daily circuit and appear to come up and go down due to human perspective only.
I would believe in a flat Earth in a heartbeat if there was actual evidence to support that model of how the Earth and the solar system worked.
Most people claim that, if there was actual evidence to support the flat Earth, they would be on board, but it's just not so. They say that even though the preponderance of evidence is already in our court. There is no motion, there is no curvature. We're trying to figure out, people say boats go over the horizon. While you're on the ground looking at a boat and you're just watching, a boat will appear to go over the curvature of the Earth, right? But then you take a amateur balloon and it'll go as high as 121,000 feet or higher, and you can't see any curve. The horizon rises right to your eye level. So to say that you can see a boat go over the curve on the ground is ludicrous, because you can't even see a curve at 120,000 feet. So there's a lot of contradictions, and people, it boils down to the programming. People have spent their whole life watching space movies and reading space magazines and just loving science. You've been taught that, if you're down with science, you're smart and stuff. And people just have a hard time letting go of what they've been taught. It's called cognitive dissonance, when new information comes in and you can't handle it. So you just kind of break down, or you just continue rolling with the old information because you don't want to be wrong. You don't want to be wrong. You don't think you're wrong. You don't think you can be fooled. It's pride, it's ego. There's so much involved with it. But to be quite frank, the flat Earth has all the evidence. While you go and investigate the heliocentric model, you can't find any evidence that the sun is 93 million miles away. You can't find evidence that the moon is 238,000 miles away. You can't find evidence that the Earth is curving 8 inches per mile squared. You can't find evidence that the moon, or that the Earth is spinning at 1,000 miles per hour. You can't find evidence that the Earth is rotating around the sun or going in an orbit around the sun at 66,000 miles per hour. You can't find evidence that the Earth and the sun and the entire solar system are flying around the Milky Way at 600,000 miles per hour. You can't find any evidence that the whole Milky Way is flying through infinite space at over 1 million miles per hour. This is what they're telling us, and you can't find any of it. None of it. There is no evidence to support a spinning ball darting through outer space.
I think they cling to it because it feels to them like they have special knowledge that other people aren't aware of, and that gives you a sense of purpose and a sense of meaning.
This isn't a thing to make we don't feel special, like we're more enlightened than everyone else. This is something that hits home with people because they look into it and they see that it's true. They see that there is no detectable curvature. There's no measurable motion.
There's no proof of 24 hours. There's an online video done at McMurdo Station where the guy followed the sun for 24
McMurdo.
hours. It's a scientific station.
Can you Google that, please? Today was awesome. I thought the conversation with Spencer was fairly pleasant. He was open from the beginning to the idea the Earth might be flat, which is key anytime you're in a debate.
If you're looking to determine whether the Earth is flat or round, you don't figure out in your mind that the Earth is, a square or any other shape, and then find confirming evidence. You look at the evidence around you and go in the direction that evidence takes you. In this case, for thousands of years, we have known that the Earth is round because that's where all of the evidence points to.
When people think of the word flat Earth, they're thinking, flat, 2D Earth, but yes, we have mountains, we have hills, we have valleys, we have stuff like that. So it's not flat, but it's level. Whether we have mountains that raise up higher or valleys that go down lower or whatever, the point is that the plane that we live on is level.
The Flat Earth community is the realest group of people you will ever come across. We don't appreciate lies, and we just want to look for the truth.
And most of the time when you tell people about flat Earth, in their minds, they take the spinning ball and they replace it with a disc. So therefore they think we're just a disc hovering in outer space. But that's not the case. Everything about the heliocentric model has to go. We are a flat, stationary, level plane, just sitting somewhere, stationary. And everything you see in the sky is revolving around us. We're still just chilling on the flat, stationary Earth, just like it seems, just like your senses tell you. And you look up and you see, the moon passes by, at night. The sun comes by during the day. The stars, if you do a time lapse with your camera or something like that, you see that they just constantly rotate. So we're not a disk in the middle of outer space. We are a flat, stationary Earth, just sitting somewhere. We don't know where, but that's just what it is.
Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
You don't see the curvature of the earth. That stuff is flat.
Bye-bye moon man and rover. NASA so meteor.
shovel for the space hubble, piecing up the puzzle, need to burst your bubble, evil gonna crumble, yeah? Sit down, be humble, got the ball, you better fumble, you'll get mad, cause at this fight I'm Bob's your uncle.
And then they call me the liar. I mean, it's absolutely unbelievable the pathetic techniques that they have to use to prove their heliocentric model.
Bob shut the president, Jaren got the evidence. It was slaying Jesuits and Zach Sharkum is evident. Dead to earth electric and it's resonant. Your residence is heaven sent. I hope to settle in like some sediment. If we so wrong, why they lying to discredit it? That's not too intelligent. That's a guy, not an in court, but we ain't really in the settlement. It's time to awaken from the pseudoscience sedatives.
Blockbusters taking over. Bye-bye, moon man and rover. NASA's so mediocre. Sorry, but your ball is dead. But your ball is. Blockbusters taking over. Gotta ride this roller coaster. But the truth is getting closer. Sorry, but your ball is dead. But your ball is.
Inner World Productions.
Twilight Zone. We're living in the Twilight Zone. We're living in the Twilight Zone.
These crazy days that we live in just cause me aches and pains. Lately my life is like a season of Stranger Things. This place is flooded with demons and they invade your brains. This is an artificial hell and they create the flames. Day to day I just try to stay strong and make it through. Wake people up from their slumber, that's what I came to do. Please don't believe what you see on TV and think it's true. It's all just targeted programming and it's aimed at you. It's everywhere, you're getting lied to and yet you barely care. People with common sense are now very rare. But the way that they brainwash you isn't very fair. They can shove that mind control programming up their derriere. I do not consent to the way they tailor society. Ain't no variety. Plus I really hate when they lie to me. I use music as a tool to release the anger inside of me. You don't know how fucking crazy it's driving me. That we're living in the Twilight Zone. They claim you have freedom, but they don't honor it. The world is a prison and you're the occupant. We're living in the Twilight Zone. The government's useless and they're incompetent. And satanic pedophiles are prominent. We're living in the Twilight Zone. The things that you believe are the total opposite. And being called crazy is just a compliment. We're living in the Twilight Zone. It's ran by the New World Order conglomerate. But there's a storm coming and there's no stopping it. We're living in the Twilight Zone.
It's where we live and control you through fear and terrorism. They wanna keep you in a mental prison with their television through the television. Where the ignorance is bliss and they just keep you living in it. You're a business, getting us citizenship. What did you really think that your birth certificate is? Get the straw man on. Money isn't paid, it's all a banknote. It's only a bill exchange when you pay that loan. Like a monopoly game, but you can't pass go. When you turn on the TV, all did you get politically as entertainment? The news that you see is all suggestive. Lower brain frequencies contribute to our stress. And you're responding, telling me that we're free living in this country. Military overseas and it's all for our peace. Just a record on repeat from the programming. Like probably want a cracker. Put you through education for domestication, control the mind faster. Giving you medication to poison our masses. If you ever question what's coming from our masters, and you're rocking the boat, or you're ever having any thoughts of your own, you better hope you never caught walking alone. To be locked up a road off by the vehicle. Got your life looking like a sci-fi show. Brain scrambling when the Wi-Fi's on. Airplane mode when I buy my phone. If your eyes wide closed.
We're living in the Twilight Zone. They claim you have freedom, but they don't honor it. The world is a prison and you're the occupant. We're living in the Twilight Zone. The government's useless and they're incompetent. And satanic pedophiles are prominent. We're living in the Twilight Zone. The things that you believe are the total opposite. And being called crazy is just a compliment. We're living in the Twilight Zone. It's ran by the New World Order conglomerate. But But there's a storm coming and there's no stopping it. We're living in the Twilight Zone. I ask myself, why do I even bother? Cause people are just like sheep that are lining up for the slaughter. If they're killing rats with fluoride, then why is it in the water? They're using the news to fool us, divide us so they can conquer. The longer you stay asleep, then the longer I'm gonna scream at you. I can't believe you let them deceive you, it's inconceivable. I won't stop until you wake up and do what you need to do. This world is overran with an evil that is unspeakable. Most people don't know, so they just vote and pay taxes. The devil's hiding in the shadows and controlling their actions. And they think that the earth is a spinning globe on its axis. But I don't have any time to devote to this madness. I have nobody to relate to, so I ride alone. Just me and all these wild thoughts that are inside my dome. I feel like I don't belong here and I can't find my home. I'm tripping and I'm wishing it was different, but we're living in the Twilight Zone. They claim you have freedom, but they don't honor it. The world is a prison and you're the occupant. We're living in the Twilight Zone. The government's useless and they're incompetent. And satanic pedophiles are prominent. We're living in the Twilight Zone. The things that you believe are the total opposite. And being called crazy is just a compliment. We're living in the Twilight Zone. It's ran by the New World Order conglomerate. But there's a storm coming and there's no stopping it. We're living in the Twilight Zone.
And there's nowhere that we can go. Awake and now I'm feeling all alone.
We're living in the
Twilight Zone. And the rest that remain asleep, sedated and still thinking that we're free.
We're living in the
Twilight Zone. And there's nowhere that we can go. Awake and now I'm feeling all alone.
We're living in the
Twilight Zone. And the rest that remain asleep, sedated and still thinking that we're free.
We're living in the
Twilight Zone.
And ye shall know the truth, and the truth shall make you free.
Good evening, everyone. I just wanted to do a really quick video on Bill Nye, the fake science guy. He's got a show called Bill Nye Saves the World. And this is from episode 1, season 1, episode 1. I want you guys to listen really, really close when he explains the greenhouse effect. Now, check it out.
Our factories, cars, trains, and planes, and electric power plants almost all run on fuel made of ancient living things, coal, oil, and natural gas, and they contain carbon. And when they burn, they produce carbon dioxide, which chemists like you call CO2. And carbon dioxide has a remarkable property. As light from the sun goes through the Earth's atmosphere, it passes right by CO2 molecules. When sunlight reaches the surface, it warms the soil, the seas, and the plants. And some of that warmth returns right up into outer space as heat energy. You've probably heard that we call CO2 a greenhouse gas. It's not a perfect nickname, but here's where the expression comes from. When I point this small and happy infrared camera at my hand glows with infrared light. But then watch what happens as I dip it into this glass aquarium. Like, dude, my fingers are like totally cut off. It turns out that glass blocks infrared light. It's one of the ways that greenhouses work. The glass lets light through, but prevents a lot of the heat, the infrared, from escaping. The carbon dioxide in the atmosphere does the same thing. But Bill, there is no big glass dome over the Earth. I know, okay. But there is a big gas dome. A big gas dome. Get it? Glass dome, gas dome. Are you with me? Huh? So because CO2 acts like the glass, the nickname greenhouse gas has stuck, and the heat is held in the atmosphere. Our world has always been kept warm by what we call the greenhouse effect.
Now that makes total sense. It explains how trees grow, how grass grows, how flowers grow, how vegetation grows. It all makes perfect sense. None of this could happen on a spinning ball with nothing covering it. Now the cool thing about this is Bill Nye said a glass dome, and I want you to notice is right as he says that, either the producer or the director, somebody to the right of him said something to him really, really quick, and if you notice, he gets pissed off and he says, okay, I know. Now check this out, I'm going to show you, I'm going to play it back for you.
But Bill, there is no big glass dome over the earth. I know, okay. But Bill, there is no big glass dome over the earth. I know, okay.
So as you can see, he tells you the truth right there, then geniusly covers it up. Now here he is on another show called Big Think, and he actually tells you that there's no place to go. You can't leave the earth. Take a listen.
Now, one thing I really want your generation to embrace is that the earth is a closed system. We cannot leave the earth. There's no place to go. There's no place to throw your trash. And I wouldn't be surprised if maybe not you, but your kids develop ways to mine our landfills. Just let go of the idea of throwing stuff off the earth.
So there you go. Just wanted you guys to see some more truth right in your face. Anyways, thanks for watching. Everyone have a good night and God bless.
And ye shall know the truth, and the truth shall make you free.
I know lots of things.
Yeah.
Lots of things. Sumo on the P, what's up?
I do not care about your raps, nah. I do not care about this track, I do not care, I guess I am rare. Yes, I hear the trash, take it out back. Oh, you can't hear it, you must have your ear to the cash. I'm itching a spaz, I do not hack, but yes, I'm still with the mask. Snatch a beat right out the mainstream real quick. Fuck around, yeah, we gon' remix it. We got you spinning and now you dizzy. You looking like Disney, seeing sixes. All these agendas and all these false flags, how many times till it gets familiar? They've multiplied so many times, they form in a line to normalize the pedophilia. Half of these rappers, yeah, this shit getting handled. They're gone, with one snap of my finger, yeah, Thanos. Yeah, I see your ice, your shit be shining, but how many of those innocent African children had to die for those diamonds, huh? Tell me. They wonder why they were living all so divided, with all those rooms in that big-ass mansion with the homeless family sitting right outside it. 1,000 bodies died for that outfit, and you ain't cleaning the blood off it. Your favorite celebrities got blood on their hands, Marina Abramovic. Hillary Clinton, she's gonna send out a hit if you leaking those documents. If you a holistic doctor, they gon' pop your toss you secretly off a bridge. Exposing them, smash the internet, yeah. Cause we don't fuck with no fake shit. Nah, NASA images, yeah, thanking your highnesses, yeah, for paying the scientists. Yeah, you kneel for the anthem, huh? But you still play for the Zionists. Damn, yeah, they trying us. They splash subliminals. The Super Bowl, the halftime show. No, that's a ritual. Global warming, climate change. Next year will be a new name with a new tax and a new op and a new fear for a flu strain. Oxitex, the new Dr. Moreau, and they teamed up with the synagogue of Satan. Yeah, I see what you be doing, Q, but I still don't trust the administration. Nope. They drinking adrenochrome straight from a child's throat. You sitting down with that vegan meal, but you still drinking a Diet Woke. Lady Liberty screaming, covered up in that black burqa. They looking at me like I'm the devil, but I don't see him though. Matt Murdock, all these dark occultists and globalists, the ones causing a mass murder. They try to swerve at me, throw the curve at me. So I had to flat earth them. Listen, boy, I don't care what you say and all the bullshit that he said, she said. All I care is about you waking up. If you don't, you gon' get her, him, you need that. Let the 5G spread, and you gon' see there's a bunch of pissed off and stressed Americans. Say hi to my friends, they're all domestic terrorists.
Hey, yo, I only know what I see.
I seen enough to know what it means to me. Learned from red dirt and I got degrees. Veered off left turns and wild out east, and we're poor and rich and hold all that class. Don't wanna know any signs, don't wanna know where you are. Mind made up already, we're not here to ask. We just don't wanna fall off the edge and into the dark. So we clench our fists, clutch our pearls to anybody critical about view of the world. Tongue like a slammed door I keep closed just to beat those doubters of these blindfolded free throws. And the channels love a G up, shoot the heat up, we'll beat up and eat up, and I don't wanna have to read up. Just drop a grenade and put my feet up.
I don't wanna fall off the edge of the earth. Don't wanna hear nothing. I wasn't real if it's not what I felt. 'Cause I filter it out.
Don't tell me what to believe or accept what I cannot see. Fuck you and your facts, I'm free. If you don't like it, leave. I didn't even wanna walk in your shoes. What about me? Flutter, flutter. Flutter, flutter, flutter. World gone mad and it's too PC, and they're trying to take away the freedom that I wanna speak. Click, click, cut them off, run them out of town, shut them off. Shh, I don't wanna hear another beat, but my gut got this, then my head take note, cause I know when this story's a slippery slope. So stay in your lane, son, stick to your songs. I don't care where you're coming from, just a simple answer to confirm a doubt, and then baseless opinions that come out of my mouth. In a nerd, tell me I don't know what I'm talking about. When the so-called experts ever sorted this out, when we're swamped by Muslims, swamped by Asians, different time, same old station, crowd ovation, whip up hatred, that old chestnut, that vocation, do anything to truth but face it.
I don't wanna fall off the edge of the earth. Don't wanna hear nothing. I wasn't real if it's not what I felt. 'Cause I filter it out.
Don't tell me what to believe. Fuck you and your facts, I'm free. Don't tell me what to believe. Fuck you and your facts, I'm free. Don't tell me what to believe or accept what I cannot see. Fuck you and your facts, I'm free. If you don't like it, leave. I didn't even wanna walk in your shoes. What about me? Flutter, flutter. Flutter, flutter, flutter. Don't tell me what to believe or accept what I cannot see. Fuck you and your facts, I'm free. If you don't like it, leave. I didn't even wanna walk in your shoes. What about me? Flutter, flutter. Flutter, flutter, flutter.
I know lots of things.
Yeah.
Sumo on the P, what's up?
I do not care about your raps, nah. I do not care about this track, I do not care, I guess I am rare. Yes, I hear the trash, take it out back. Oh, you can't hear it, you must have your ear to the cash. I'm itching a spaz, I do not hack, but yes, I'm still with the mask. Snatch a beat right out the mainstream real quick. Fuck around, yeah, we gon' remix it. We got you spinning and now you dizzy. You looking like Disney, seeing sixes. All these agendas and all these false flags, how many times till it gets familiar? They've multiplied so many times, they form in the line to normalize the pedophilia. Half of these rappers, yeah, this shit getting handled. They're gone with one snap of my finger. Yeah, Thanos. Yeah, I see your ice, your shit be shining, but how many of those innocent African children had to die for those diamonds? Huh? Tell me. They wonder why they were living all so divided with all those rooms in that big ass.
Okay, so that's a fair chunk there. I have to do the math here. It's going to take me a bit, but
yeah. Why don't you just look at the Beyond Horizons? They're the professional long-distance Guinness World Book record-winning photography. They've got all the information in their website. They're not flat earthers. They're photographers. So why don't you look up Beyond Horizons and look up the information they've done? Then you can. You can put that together with what you're saying you're calculating or whatever. These are actual observations done by photographers.
Yeah, look at 29 minutes after the hour. It has all the information you need. The target distance is 255 miles away. The observer height is 9,136 feet. There should be over 12,000 feet of the target hidden by Earth curvature.
Do you have a favorite Earth curvature measuring program? Do you know how to do it? Grenade head.
Wait a minute. Am I on? Is my mic on? Oh. Dave, get the numbers here. I'm just seeing what's going on here.
Okay, so you see the picture right there. Okay, you're not supposed to see any of that. We can see the mountains coming down to the shoreline, and we can see all the mountains. How does that work?
I'm
sorry.
I'm going to research this a little bit. I'm not going to sit there and make a comment about it until I know more about it.
Okay, fair enough. So you understand why we're saying it couldn't work on a globe, though?
Well, I understand what you're saying. Yes, I do. But I don't understand what's happening in this picture, so I don't want to make any.
You want me to throw you a life jacket? You want me to tell you what your side's going to make you say?
No, I'm looking at this. I want to find out where this is at.
Request.
Yeah, welcome to Flat Earth. Because
this is just one of hundreds.
The photo's in infrared, by the way.
Yeah, which limits the spectrum of light, right? Which limits the effect of any type of movement of that light. I mean, this is so staggering. It's not even close. It's 3 miles should be there. 3 miles. Well, why can't I see the shore, dude? There aren't 3 miles there. There's nothing there. I can see the shore. 3 miles. That's super long, bro. So drive 3 miles on the road and then flip that up vertically. That's what should be there.
Yep.
I mean, you wonder why Flat Earth's censored? You wonder why famous people would never debate a Flat Earther for the world to see? You want to know why I've been kicked off PayPal for being a Flat Earther? And Venmo, and Twitter, and Facebook, and Instagram, and YouTube, and DLive.
Can I ask you a question?
Yeah, go ahead.
What makes you trust your own vision so much?
Well, it's not really about trusting my vision, right? It's falsifying the globe radius. Are you saying that if I can see mountains and they look exactly like they're there, and I can go touch them and know they're there, that it looks like they're actually there, like they actually are, but in fact nothing's there? Is that what you're saying?
No, I'm saying that almost every single quote unquote empirical science, globe priests, whatever, one of the main first tenets of every science is that the first observer is the least reliable. So I'm wondering how come you're saying that your measurements taken by your senses are reliable.
Okay, we can do this. First of all, measurements, right? So the way we have measurements is we measure the Earth. That's how we know the mountains are that far away, because we measured it using planar survey, right? We measured over a horizontal. That's how you have maps. That's how we measured it. So we know how far the mountains are. Now, if we can zoom in with a camera and see all the mountains, we know we did not zoom in through a mound of Earth curve, right?
Mm-hmm.
So how, I don't even know the question. And there's many ways you can do. You can shoot a laser over the top of water or a frozen lake, and it hits the other target completely horizontal without any curvature blocking it, when there should be hundreds of feet blocking the laser. You can use mirror flashes. Long distance observations test the globe, right? You're not supposed to be able to see stuff in the distance because we're supposedly on a globe.
And is there is there empirical evidence to suggest that a device that does not require your any of your sensory input will demonstrate that there is no curvature? Because personally, I don't believe in anyone's firsthand accounts or anyone's firsthand experience on globe or flat.
Do you believe people went to space?
I don't believe any of their firsthand accounts.
Okay, nice. Just seeing if you're consistent. So we can throw the moon landing out and every story NASA said because we can't believe them. It's just first-hand accounts of people that are Masons.
I don't believe anyone's first-hand accounts.
Okay, that's perfect. We want you to go test it. I've done it. I did it around the whole U.S. for the last year. Almost everyone in this room has done it. This is one of thousands of observations. You can test it yourself. So would that fulfill your parameters where you can verify or falsify it yourself?
Sure. Can you explain to me the experiment?
Well, this is an observation. This is actually not an experiment. But yeah, you just take out a P900 or a P1000 and you zoom in to the distant object and you see if it's blocked by Earth curvature.
That sounds to me like your senses with a filter on it. Very,
so you're saying
very,
that
very rudimentarily.
Oh, so the 125 times zoom camera is making images up, is what you're saying.
No, I'm saying it's filtering your view. I mean, like it's not. It's still filtering your view. Your view is not.
How is it filtering it?
So it's not your original. Like it's the same. So light enters the camera. Light enters the camera.
So tell us how it's filtering it. Please.
Light enters the camera. It's refracted by lenses and changed and zoomed in whatever way you've set it, and it hits your eye. And that's not. Wow, that is actually incorrect. So light hits the object you're looking at. Light hits the atom you're looking at and bounces off directly at you. We're assuming that nothing else occurs outside of this. It bounces, goes inside the lens of your camera, goes through whatever reflective lens and whatever mode or settings you've put, and then hits your eye. So the baseline receiver of said at all interactions is your eye.
So you've been told to not trust your senses, and what you're telling us is a religious doctrine that comes from your school of thought that has basically been driven into you that you can't trust your human senses. So congratulations on that. We're talking about empirical evidence that can be verified by measurement. Do you know what a measurement is?
Yes.
Do you know the difference between a measurement and a calculation?
Yes.
Could you explain the differences, please?
Sure. Do you want like a dictionary definition, or do you want my perception of it?
You said you know, so I want to know how you know the difference. Tell us the difference between calculation and measurement.
Okay, so a calculation would probably be. It's hard to say probably be because I'm sure there's a universal definition for it, or
probably
some
is not an answer to the question. But continue on.
I mean, I don't know the exact wording that you would prefer.
It's not about what we prefer. You're making statements. All I'm asking you is to tell us how you know the difference between calculation and measurement. So explain the differences, and I've heard nothing yet but evading answering.
Evading answering.
If you don't know, just say so. It's okay. I
I don't know your exact wording, so I'm going to try and find the most universal wording that I can.
We're not.
Don't be afraid of the exact words. We're just asking if you know what the difference is.
I didn't ask you to go find something. You said you know. Okay. So I'm asking you, what is the difference you said you know between calculation and measurement? And you can't seem to tell us. Okay, I'll just ask you directly. What is a measurement? A direct measurement. What is that?
A direct observation of...
No, I didn't say observation. I said measurement. What is the definition of a direct...
I'm trying to explain to you without using the word measurement.
I don't want an explanation, I want a definition. What is
Okay, so then I'll find you a definition. I'm not a dictionary.
So you don't know.
So I don't know the definition. No, I don't.
You don't know the difference between calculation or a measurement. And you don't know what what a measurement is. You've just shown that to the whole entire audience. Thank you.
A measurement is the act of measuring something. I'm so okay, and then a calculation is like, wow. I'm not.
If you want to know if something is curving, or flat, would you measure it directly?
To answer your question directly, yes.
All right, so do you think that in order to know whether or not the Earth is a sphere or a topographical plane of existence, do you think we should measure it directly to know for sure?
I think to know for sure you can measure it directly, yes. However, for me personally, and the results of an experiment that I would accept would have to be again where none of your human senses are involved, because I don't trust human senses. I believe that very simple things your senses are usually wrong about. Just like on a neurophysiological scale, it just doesn't compute.
So you already
then by default you're already.
You're just saying we can't
quick, can I just
One
say
at a
this?
time, please. One at a time. I
know,
hear
please.
like a
One at a
massive
time.
mix of
Right.
words.
One at a time. Just 1 second. So you're already admitting then you don't believe in outer space or the globe religion.
I did not say that. I
okay,
believe in the globe religion. Yeah.
So
no, this is like the guy who was on here a little while ago who's like the brain in a jar guy. He thinks he's a brain in a jar, pretty much.
I joined yesterday. I joined actually earlier this morning. I have no idea what you're talking about.
No, this isn't that guy. But real quick, you just by your concession of expectations and point of view, you don't even have a claim for a globe Earth.
I don't have any claims as of yet. No. I asked the question that I have not received an answer yet.
Exactly. Welcome to Flat Earth. That was easy.
Yeah, you just have a belief and then you don't want your senses to be true. So here's Marconi wireless telegraph. That's a transmission of 10,553 miles. That's impossible on a globe.
I mean, like I'm hearing a lot of measurements, and this would be impossible. But nobody's answered my previous question. Like you guys assumed as to where I'm taking it, and given me answers to where you think I'm taking it. And
what's the question?
The question was what makes you, or by you, a person who believes in flat Earth, what makes you
it's not about belief.
Trust your senses to the
we don't
degree.
believe,
I just
and
explained
we don't
something
listen.
that didn't require just your senses.
One at a time,
so
please.
What the fuck?
Listen, hold on. We don't. So stop putting words in our mouths. That would be a good start. For one, we don't believe that the Earth is flat. None of us in here have a belief. It's based on fact. Stop interrupting.
I'm sorry.
So that's the first starting point. Like, I don't have to believe if I measure my table. When I go into the restroom and take a pee, I know that I measured it. There's been a transfer of energy. That's what a measurement is. Okay?
Let me ask him a little question. I'll just be real quick. Say you don't trust your senses. So if you look outside your car, your window, and you see a car out there, and you don't think you can walk up to that car, touch it, feel it, and verify for yourself that the car actually is there and you're actually seeing it, it's real. I mean, you can trust your senses at least that far, right? If you're looking at something and you can go out and touch it, you can then verify that your senses are not lying to you, correct?
In the exact scenario of the parameters you've laid out, yes.
Yes.
Okay. Is that it?
Well, no, the second part was going to be, so if you go out and you use your eyes to see something, and you go out and take a measurement for the distance. Let's say you're looking at something in the distance, and you could guess, it looks like it's maybe 10 miles, maybe 50 miles, whatever. But you can actually measure that, right? You could get in a car, drive it. You could, whatever, look on Google Earth if you trusted that, whatever, and come up with a very close number as to the distance that you're looking at, right?
Yeah.
Would you believe that?
In the parameters that you've laid out, yes.
Okay. Good, because we have observations that follow those exact parameters that show that the surface is flat, by the way. I'll let somebody else take it from here.
Okay.
Do you agree that the default position is that the Earth is flat and not moving, and that the stuff in the sky moves?
What does that mean, default position?
Yeah, like that's where you begin, because that's the observation, that's what we observe, and that's what we always have being the case, right? The horizon's horizontal. We have plains. We have the abyssal plain in the bottom of the ocean, 70% of it all completely flat. We have all kinds of planes on the Earth that are super flat. You've never felt the Earth spinning. Planes have to pretend the Earth's not spinning to work. Shooting missiles has to assume the Earth's not spinning. And you see the sun and moon move in the sky. You see the stars move in the sky. So our default position based on empirical evidence is that the Earth is flat and stationary and the stuff in the sky moves. So if you're going to make a claim opposite to that, then you would have the burden of proof, right?
Can you say what my claim was? But I don't
That the Earth's a
think
magic
anyone.
spinning cartoon ball that defies physics.
I just said I believe that. I don't think that.
Yeah, you
Claim
believe
it.
in something. You believe in something.
I'm not
that has
claiming.
no
I have.
evidence,
I've
that
asked.
has the
I've
burden of
asked
proof.
a question, and I've received like your claim is wrong. Like you're going down pathways that I maybe would like to go down at some point, but like right now, I just want to know like why like no quote unquote globe priest trusts their senses, but flat earth like
Do you have
everyone
a
trusts theirs.
citation? Do you have a citation for what you just said about no scientists believe their own senses? Can you give us a citation? Which scientists?
Well, I don't have a specific necessarily citation.
There we are again. So you're making these claims, bro. I'm just trying to point them out. I'm really not a bad guy. I know I sound like the bad cop today. I make a really
He didn't say scientists, Sonny. He said globe believers. He said globe believers. He said, I'm wondering why globe believers don't trust their senses, but flat earthers do. That's what he said.
Okay, there you
Welcome
go.
to flat earth.
Yeah.
I thought I just clearly explained to him why we trusted our senses, because we went out and verified what we'd seen was real.
Well, let's hear
We
him
measured it.
respond. Let's hear him respond, please.
I mean, I thought I gave him an answer.
I have nothing to respond. I don't know the answer to the question I asked.
Because to believe the globe religion, you can't trust your senses. That's all.
So here's the thing: why flat earthers we don't have a belief. Because see, you've come into a place where we've studied and we've investigated these things about the human eye, the sizes of things, ocular resolution, like all the how perspective works, all these different things that we've looked into. That's why it's not a belief anymore, because you can take the size of the aperture of the eye and you can make certain reasonings based on that are real, empirical data as far as size, distance, and so forth. So we've done measurements where we have known distances, known heights of objects over and over and over and over again. It's like measuring your kitchen table 1,000 times, or measuring every kitchen table within 100 miles. Like, we've looked into this, so that's why it's not a belief anymore. I wanted to clear that part up. What you have
sorry, I won't use that
is
word
a
anymore.
belief. You have a belief because you cannot provide any kind of empirical data of anything exacting or specific at all about your fairy tale globe.
I'm laughing because I have nervous laughter. I apologize.
There's nothing that you can provide. Listen, if you could even provide us a claim that a globe Earth is being used in any technology that is using real physical objects, over, under the water, anything like that, we would love to see that because we've looked for it for almost 7 years.
I got a question too for the new guy. Why are all flight simulators, and yes, all of them, programmed over a flat stationary Earth? Why would they do that? Why would they teach them that if it's a globe?
Yeah, that's why it's called a plane, right?
I actually have not yet seen any simulation that well, except for Kerbal Space Program, which
That's a video game, dude.
yes, that's what a simulation is it not?
We don't have to talk about simulations. I'm talking about the flat and stationary being used everywhere, all military, radar, rail guns, okay? Line of sight, hundreds of miles. Get out of here. It's not a
Bro,
globe.
when they train a pilot, bro, right? They put them in a simulation to learn how to fly. And in that simulation, they negate what's called the gravity vector. They just completely negate it in the simulation. And then the simulation is built to fly over a stationary flat Earth. That's how they're trained. That's how the blueprints of the plane read as to how they were built. That's what he's explaining to you, right? We're not
Yeah,
talking about a video game.
yeah, it's not video games. It's real world shit, because those people are going to be in flight training in the real world. A lot of those people are going to be pilots who love to play those kinds of games, or they already are pilots. Again, why would it ever be considered once to teach someone about flat and stationary if it were a globe? Why would you ever have to bring up flat and stationary, let alone the amount of times that they already have, which is in the tens of thousands at least?
What's up, y'all?
You
What's
gotta
up?
admit that's kind of weird, bro.
Well, what's up with the?
What up?
I'm sitting here watching. I know you guys are talking, but I just want to mention this as an aside. Like, I'm watching Vinny, Vinny B from the guy that was on the podcast with Dave Weiss. I went back to his original video that he did on there, and he's talking about the Jesuits and laying down so much information. I'm like, oh my God, I got to look into this. Talking about the Roman Empire is still running things. And the reason that these people have this strong heliocentric belief that they live in a ball in a vacuum is literally because of the church. The irony is killing me, bro.
Yeah, the Jesuits, bro.
That's got to be pretty shocking. I mean, think about that. Iron Dan, is it Iron Dan?
No, it's,
Iron Dan.
is it?
What do you think, Iron Dan, that your whole entire paradigm of the space thing, the Big Bang, was created by a Jesuit, a Catholic priest?
The entire thing?
Yeah, George Lamont.
Yeah.
He proposed the Big Bang.
And he was buddies, many meetings with Einstein, other pseudoscientists of the period.
Okay.
Which is why we say heliocentrism can't really be that old, because all of the other sources for it, they're not primary sources. Like Eratosthenes, nobody knows this man existed. There's no other literature surrounding where he's come from or wherever he's come. Like, none of that is. You can't really verify any of that, even from a historical standpoint.
Yeah.
Like, it's.
Isn't it kind of interesting that you were
so
never
crazy.
taught any of these things? Doesn't that kind of make you think, like, why wouldn't I know these things? Why do flat earthers in 2022 have to teach me about all these things, right? And we didn't get taught them either. We had to figure them out, but that should make you wonder.
Before you brace against it as like, all right, they're saying some more crazy shit and blah 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 blah. Just look up the name Georges Lemaitre and type in "father of the Big Bang" and see what comes up. I mean, it's none of this stuff is hidden that we're talking to you about. I think I heard them telling you about all of the government documents that in there reference flat Earth. Like, I mean, why would that exist? Think about it.
You can actually go get these documents and read them, where they say that they train pilots and build planes to fly over a flat plane.
What you do have is YouTubers who tell us no. What you do have is various YouTubers that popped up after people have been questioning flat Earth to tell you that, well, mentioning that stuff is in there is out of context. Tell me how you can simplify mathematics for a sphere to flat planar geometry. How do you? It's not even the same thing. when they say, "Oh, this is just the simplification," and they're actually misleading people. Okay, well, whenever we ask them for the complicated version, that doesn't really exist. So it's kind of like you have to fact check the fact checker. Because imagine you find out some bullshit, then you go to a person and you're like, "Why'd you lie to me?" And then they give you their first objection. Do you normally go, "Oh, okay, I guess you're right"? No, you dig into it a little deeper. Have them give you verification for their justification.
Can you
I'm
imagine
just,
flying a plane and trying to land on a surface that was spinning or moving at 1,000 miles an hour? And people want to say, "Oh, it's your momentum you took with you." What if you turn the plane and go opposite direction and then turn around and go this direction, that direction? Then you go to land on an object that is spinning at 1,000 miles an hour. How do you really think that's possible? Do you really think a plane could land on an object moving that fast?
Answer your question directly, no.
That's exactly right.
Hey, Iron Dan, you can read, right? Simple.
before you, I'm sorry, I don't mean to interrupt. Because I'm just trying to dispel, because I know what people, like normal people, respond with. And okay, so obviously you can look and then people will say, "Oh, flat earthers are wrong again because actually it's 1,000 miles at the equator, not everywhere." But it's really an RPM, right? So if you have a surface of something that's moving like a sphere, look, matter of fact, I'll do you one better. Imagine something spinning like a tire. Does it matter where you put your finger on that tire that's going 100 miles an hour? Honestly, it's not like it's not going to be moving if you land on one place of the tire versus the other. Like if you land on, say, like the middle, like where the axle is. No, it's still moving. And as far as Earth's movement, there's no accounting for it whatsoever. But there's a justification for why not. It makes no sense. I'm sorry.
We can't find any citations where it was empirically demonstrated to measure or detect the RPM of the Earth. So many people tried in history and never actually did it.
In fact, Einstein said that he's come to the conclusion no optical experiment would ever prove the rotation of the Earth, the movement of the Earth. So even Einstein said it can't be proven, and that it's because of relativity. And then, basically when things fall down, really the Earth is could be going up as well. It's all relative, and there's no way that you could know. So it may look like it's still, but it could just be moving. That's the actual, still to this day, best argument.
Cool.
But to be
Sorry, my
fair,
mic was done.
If he's new to this, he's getting all this information for the first time. So, I mean, it's all good. It's crazy, bro. It sounds crazy, but just keep listening. I mean, these are all verifiable facts.
If you really think about it, you've never seen Earth curvature, right? If you've been in a plane at 35,000 feet, because the globe indoctrination is so thick, people will see like the two sides of the window on left and right bend just a little, but that's because there's 7 fucking panes of glass between the viewer and outside. You think none of that's going to be bending? It's crazy. It's flat, horizontal, all the way up. The horizon stays right in the middle of your vision. How is that possible? The higher you go up, it should be dropping exponentially. We should be able to see half the fucking Earth from 30,000 feet.
Again, you got the. I'm sorry to bombard you. So I know I just jumped into the conversation and I said all this. I didn't even introduce myself. My name is Elijah. It's good to be speaking with you. Sorry to just unload on you like this, but I just feel like every time someone says something, I'm thinking about the counter, and it's like, well, let's think about that counter for a second. Like the fact that people, first of all, Neil deGrasse Tyson came out. There's another guy, planetarium director, Paul Larson came out, and said mathematically, obviously, with the area that you can see with your field of vision, you can't see the curve. In response to us sending up balloons to, I think, 120,000 feet, and it was like, where's the curve? Why is this curve that they're telling us is the curve? Why do we not see it when we send up balloons? Which is why they had to start saying that. But ask yourself this, like, for all of the, because there's a flat earth debunk website that says, yeah, Neil deGrasse Tyson is wrong and he should apologize. Ooh, scary words. But if it is curving in your field of view, just put that image in your mind for a second, that it's curving just a little bit. And then begin to do a turn. And when you get 180 degrees in your mind, tell me how that curve makes sense. As a matter of fact, tell me what you can get on a plane and you're looking out and it's curving. So then you go to the other side of the plane and it's curving the same way. How does that make sense? But this is what they tell people, and this is what they've reinforced people with. I've seen the curvature on the plane. I've seen it. Because it's on like Good Morning America or whatever. It's like, oh yeah, people. Of course, people. No, they haven't. And if you claim you have, it's like, word, you seen the curve through that little window, and then you didn't really think about what happens if you did a 180 degree or 360 degree on that curve that you think you see. How does that even make sense geometrically?
Did you know that every single star in the sky moves east to west in a circle around Polaris, the North Pole star in the center? And it's done that for all recorded history of mankind. They say we're on a 66.6 degree tilt, wobbling, revolving around the sun, 66,000 miles per hour, as the sun drags us through space 500,000 miles per hour, and the galaxy shoots through space 1.3 million miles per hour, and we're on an elliptical orbit that constantly changes, and yet the sky has done the exact same thing, resetting back where it started around the center star for all recorded history.
Which indicates no movement at all.
And that all of those stars reset at exact geographical locations over the flat plane of Earth, as they have for all those thousands of years as well.
Surely you've seen these ancient buildings that show the summer solstice. They show the sunlight coming through a little hole in the wall, and it shines on a specific spot. And they view that every year, year after year after year after year. If we were spinning, flying through the universe or whatever, you think that light, that the sun would shine on that exact spot every time, the same time of year, exactly in the same spot? It's impossible, bro. We're not moving. That's why.
Iron Dan, your thoughts on any of this?
At this point, I feel as though anything that I say is going to create controversy, give me name calling, and
no one's going to call you names, bro. That's not what we're about.
The
hasn't happened yet, has it?
Text would disagree with you.
Well, why not? Why not answer the question? What was that about? You know how weird it was to say, "What are your thoughts on what's been said?" And for you to say, "Well," unless you're gonna answer with a non sequitur, aka things that are totally not related to what's been said, which would kind of piss off anyone in any conversation. Why wouldn't you just answer the question as it relates to what we've tried to say? I mean, I know we've said a mouthful. Maybe you could say something like, "Could you repeat that thing about the Jesuit priest? Like, that was interesting. What were you saying? What was his name?" Or something like that. Like, I mean, because unless you're going to say what we're saying is wrong, in which only thing we're doing is citing information. Why? Because we didn't make it up.
Right, but he's not being real combative, right? So like he came in here, you know, maybe thinking that this was crazy, but to be fair, if someone was going to be honest, if we were unloading information on them like this, they probably would kind of not have much to say because it's a lot to take in. So
Yeah,
Well, I
it
mean,
is.
you can hold on. You can just say I don't really have any comment right now because it's a lot to take in. That thing about people be mad if like I said, only if you don't respond directly to what's been said. If all you have to say is I don't have anything to comment right now, but I do have a question, that's honest. Or it's I mean it's better than nothing.
Sure. I don't. It's hard to recollect a lot of the things that you were saying. I think it's interesting the analogy that you made about the spinning tire. You said 100 miles an hour, right? And you said at any point that you put your finger on the tire, it's still 100 miles an hour.
Right.
Okay. I don't know. I feel like if I comment at all in any way, it's just instantly, globe priest indoctrination, and you can't make assumptions based on your school of thought. Like I'm really cornered here, at least intellectually.
Well, we don't make assumptions. Everything we've told you are not assumptions; they're just facts that can be verified. So
Yes, but like when I'm
say
solo and
you're
there's like
landing a
30 of
plane.
you, then everything I say is assumptions, and everything you say is assertable fact.
if you state a fact, we're gonna go with it, dude. We're gonna know if it's an assumption, though. We do know these things.
Yeah, so let's break through some assumptions and some of the stuff that we were talking about initially when it comes to planes flying, right?
Mm-hmm.
And somebody mentioned that all flight simulators are, flat stationary, right?
Mm-hmm.
So what I'm going to do, just to get some participation here, is I'm going to post something in Livestream voice text. It's from NASA. It's a nasa.gov website, and it's a PDF. Do you have the ability on your computer or your phone where you're at to pull that up?
Yeah, I'm looking at it now.
Okay, cool. Can you do me a favor and just read me the summary? So you'll scroll down past the table of contents, and then you'll come to the summary of the document. Can you do me a favor and just read that aloud?
I'm not going to read it out loud. I'm sorry. I'll read it to myself.
I mean, you can go through it slow. Nobody's going to make fun of you whether you're mispronouncing something or anything like that. That's not the exercise I'm trying to do. And let me know if there's anything in that summary that stands out to you.
If someone read it to you, would you listen to every word?
No, that isn't my point. But yes, I see that it says that it's a rigid aircraft of constant mass flying over a flat, non-rotating Earth.
Right. So this is NASA.
Linear aircraft model. Okay.
Yep. So this is NASA's derivation of the linear aircraft model, right? Okay. Why would they utilize that language, and why would they use a flat, non-rotating Earth for their aircrafts? Why would that be the case? Why do you think that is? Because this is coming from NASA, right? Which is obviously you've heard us say that we don't necessarily trust NASA. So what we're doing is we're using what's called a hostile. Yeah, we're using a hostile witness. So we're using NASA as a proof of our point here.
Fortunately, they're telling the truth on this document.
Well, yeah, so people's lives are at stake when it comes to flying planes, things like that.
Yes,
right?
exactly.
So when people's lives are at stake, we have to assume that it's a flat, non-rotating Earth.
right, I mean that's the only way NASA can fly anything. I mean, what does NASA look like not being able to fly anything?
Even if you go ahead, brother.
I was just gonna ask your thoughts on reading that document from NASA. Do you have anything that comes to mind? Anything on your mind?
I'm going through the introduction right now. The only reason I could think of that they would be specifying over a flat, non-rotating Earth is because, as you mentioned, that's what their current model that they're speaking of here. And what does it say? 1988, 1988. The model that they have for linear aircraft. It doesn't even say flight. It just says just a linear aircraft.
Right.
So,
why would they have that in the 80s if they went to the moon in 69, bro?
those sound like two totally separate topics. It seems like the only reason they would support that would be because they're, especially early models like models and simulations definitely just couldn't compute a full rotating body beneath you. To do that, you have to like render the whole body.
That's ridiculous.
Otherwise, it's just like a treadmill.
So you just assume that the thing is the exact opposite of what it really is when you're preparing to fly over it? That's ridiculous.
Hey, you
Well,
want to know why they can't do it?
Wait a minute.
They actually.
What's it? This is one of those moments where everybody just needs to take this in, because realize everybody, we all know this matches reality. This matches reality. Isn't that crazy? And that's the point, is that this model matches what we experience. Wow.
That is
Right.
kind of
I want you to know, though, like they can't even mathematically propose it on a spinning ball. So they actually can't even come up with an equation. It's called the three-body problem. They can't do the math. They have no choice. They can't even mathematically explain this model. But like you said, they model it based on reality because they're flying in reality. And if they don't do that, people would die.
So the linear verbiage there, linear being a straight line. Yeah. So that would insinuate that this model craft is flying at least in a straight path.
Do you see kind of how this kind of comes back to what I told you at the beginning, bro? Like how this is actually the default position, right? Because like all observations and measurements show the Earth is flat and not moving. And to do anything successfully in the real world, practically, whether that fly, shoot ballistic missiles, use ground weapon system towers, whatever it is, you have to assume the Earth is flat for the practical use case to work, right? For you to be able to practically do things, you literally have to treat the Earth as if it's stationary and flat. So it's the default position. It's the only way anything works. So if you're going to claim anything else or believe anything else, you have what's called the burden of proof, right? You have to substantiate that what you're claiming is true, even though opposite to all evidence ever.
So, for example, in this case, can you find us a document that describes how nonlinear aircraft work on a curved Earth?
I can't, no.
You could try. You didn't even try. Come on, give it a search. Give it a whirl.
I mean, you agreed with me a minute ago that it wouldn't be possible to land on a surface that was moving at 1,000 miles an hour.
I agree to your direct premise. Yes, I don't agree in the sense that a plane taking off, like you said, the detractors would say, is that the Earth constitutes an inertial frame of reference relative to the rest of the quote unquote heliocentric model, and when that plane leaves the ground, it still maintains the momentum of the rotating Earth relative to another body that is within the same heliocentric model. So that would be relative to the moon.
Yeah, but you didn't. I guess you didn't hear the part where I said the plane went up and turned and went in one direction and then another direction and another direction, which takes away all that angular motion, all that momentum. It's gone at that point because you're going in completely different directions.
There's
Sorry,
also
sorry.
a problem when you're traveling from the equator and towards the imaginary poles on the ball. You're going from an area of higher rotation to an area of lower rotation, so there should be a deceleration somewhere.
So turning in a plane is not just turning; it's also I'm sorry. What are the four forces? Lift, drag, thrust, and load. No, weight or load. I don't remember
So
which
you're
one.
just going
All on a flat Earth. Yeah.
So when a plane is turning, there's a lot more involved than just turning. There is first it has to bank, right? It has to.
I'm not talking about turning. I'm talking about the change.
I'm answering the previous
acceleration.
gentleman's. I'm answering the previous gentleman's thought where he said that you're losing all of the inertial momentum imparted on you by turning. I don't believe that's the case, considering that the atmosphere moves with the Earth. Not
Place this
exactly
claim.
right. It's
Can you
not.
give me evidence of this.
I'm sorry. I was told I shouldn't interrupt anybody. So could you
Well,
offer
when
me
you
the
make a
same?
baseless claim, can you? I'm asking you to clarify your baseless claim. Can you give us evidence of the gas being attached to the rotating object?
I'm not saying it's attached to it. I'm saying that it's a part of it, so to speak. If we are to follow the premise of the globe model, my point ultimately, like I'm not going to go into stuff that I can't prove to you or that I don't know personally, but I will tell you that
You know that violates gas law 100%.
No.
Gas does not attach or bond to anything. That it violates all gas
I'm sorry,
laws.
that was wrong. That was wrong of me. I didn't mean to phrase it that way. I meant to say that the air still acts upon the aircraft, and still, like, the momentum is still conserved somewhere, right? So so if a plane turns, the momentum of the plane changes, but some energy is still dispersed into the air. Some minimal amounts of it, but it's still primarily efficiently pushed in the direction that the flaps are turning it in, and thus going in that direction. However, you're still conserving the same momentum that you had when you took off, because if that were not the case, if there was no atmosphere, for example, and it was a rotating ball, then yes, you would have to, depending on the speed that you attained in the plane, and that could be honestly however much the proportion speed, whatever of said thrust generating source. I'm
So this
not
is
making
what
sense
I
of myself anymore.
this is what I wanted to ask you before we got. Look, okay, because I just wanted you to think about the words that you're using initially to justify this. But I'm gonna ask a question, which is kind of annoying to us, so I would understand if, but trust me, it makes sense to ask this.
Sure.
What kind of momentum are we talking? Linear momentum or angular momentum?
That you're discussing right now?
Well, when you say it has to conserve momentum, which kind of momentum are you thinking? Because I would be thinking angular momentum, seeing is that you're traveling over a curved surface.
You are, but as the globe priests say, you're moving at 1,040 miles an hour before you even take off, right? And then depending on the direction that you take off and the vector in which you take off,
A red herring. And let me explain why. Because it's not dealing with the kind of momentum you're saying you're conserving. I'm just asking you which one you think it is.
I don't know. I just know that there's no such thing as absolute motion, and that every motion is relative, and the plane is relative to, at least in the context that we were discussing, the plane is relative to the ground from which it takes off. So
right. So the ground is curving and the air is curving. So you would have to conserve angular momentum. How would you be doing that? Seeing as that you're flying a linear aircraft. I mean, have you thought about it before? You don't have to force an answer.
I'm trying to force an answer that makes sense to me, let alone applies to either
Okay.
globe or flat.
Okay.
But it doesn't make sense to
Like
me.
for instance, if I spin a yo-yo,
Mhm.
the yo-yo portion is attached to the string and it's attached to the rotation. However, if I cut off the yo-yo, it's going to fly off in a linear fashion. Well, obviously, it's going to drop to the ground at some point, but we're talking about moving in a linear path.
Mhm.
So,
And without the influence of gravity or any sort of atmosphere or anything at all, then yes, it would most likely be linear motion. But it's not, considering there's so many other factors involved when a plane takes off the ground, like 4 forces, right, that I mentioned, which is
Then why?
thrust, drag.
Then why? That's what we're saying. Why aren't the ones that are actually manufacturing the aircraft or flying the aircraft? They're not doing any of what you're saying. Why is that?
Well, they're not doing it in 1988, and they're not doing it based
No,
on
they're not doing
this
it.
assumption of a linear.
No one's assuming anything about a rotating globe underneath the aircraft. Only flat and stationary.
So
I think it's because it doesn't make sense to assume that it is rotating, because it wouldn't have an impact. In the sense that
Do you realize that all you can do to argue for the globe is go on and on trying to explain why we never experience Earth as a globe?
I also want to point out,
guess
like,
you could put it that way, yeah.
used this argument now a couple of times of they in 1988, like it's just so outdated. Don't you think if they came up with new information, NASA.gov might have updated that information?
Yeah, because actually, the other gentleman is right. All you have are excuses for why none of us ever experienced, nor has anyone ever experienced, a rotating globe.
Yeah, just nothing can explain the ways.
That's
How
excuses.
long has the Boeing 747 or the 737 been in use? Do you know?
No, I don't know that.
Okay.
well,
Because we've been flying planes the same way since 1988, right? The surface of the Earth hasn't changed. The way that we fly these aircraft really hasn't changed much, right?
Okay.
So at what point does the spinning, rotating, and curving Earth come into play? What year? What year did we have
I'm
to
not
account
saying
for
that it does come into play at a certain point, but I just, like, it doesn't. I can't even give an example that makes sense. Like it.
well, okay, so the because the problem is logical fallacy.
Wow.
And so we're saying, well, the documents say that you're flying for all intents and purposes over a flat, non-rotating Earth, which is in opposition to what people believe it is. And so when we ask you questions where we think, well, if it were curved, if it were moving, shouldn't these problems happen? I mean, obviously, if you simulate it in your mind, it presents a problem unless you accept the ad hoc explanation for why none of this would happen. So it's actually begging the question, because the conclusion already is, well, it is a globe bird. So the reason that we don't experience it is, add whatever ad hoc explanation you like. So the question for me is,
Can I add an
why do you
ad hoc, or
believe
do you
that?
not want to hear it?
I'm just asking why one would believe that. I mean, it's like so many different. I mean, you can believe what you want. I'm not telling you not.
Shit. My bad. Shit. I wanted to turn on the volume of the bot for me, but I accidentally mispressed. Fuck. My bad. Shit. Anybody around?
Yeah, do you know the time that it went off?
No. Fuck. Oh, man. Hopefully I didn't ban it.
You banned the bot? What'd you do, Roger?
No. Didn't ban it.
Okay.
Dumb. So what's happening? How you guys doing?
That's where I'm at. How you doing, Roger?
I'm doing fine.
I don't see any new people on here right now.
Driving home.
Hank Hill, he might be a Glober. You ever heard of him?
Glover?
Yeah.
Yeah. He's got propane to sell, right?
Mayo 1973 used to be Rookie is here. He's a anti-Glober, I believe.
Anti-Glober.
What's good in the Netherlands? Is all the mileage
Good, yeah.
service over with?
Yeah, everything is pretty much done here. So, yeah, back to quote unquote normal, right? That's what they tell us.
Tomorrow in the headlines, it'll be aliens invade Ukraine and give everybody COVID-19. How about that? Just wrap them all up in one. Anyway, if anybody's listening to Roger and I converse at the moment, and you think you live on a spinning ball zipping around through nothing, please come in and talk to us about it. We have some information to share with you.
Oh man, that was stupid of me.
Well, can you just restart it where you had it at?
I don't know which one was playing, so I don't know.
Elijah was just making a good point about how they just have to make up a story and excuses about why it's a globe. You know, they start with the assumption it's a globe, and here's the excuse why you don't feel any of this, or you don't have to account for any of this when you're flying or whatever. It's just excuses, man. It's just fantasy land. There is no globe, like my icon says, does not exist. It's in your mind. I'll shut up now.
Yep. Here's my claim, but unfortunately, it can't be validated because.
Insert excuse here, right? Yeah.
Yeah, my bad, Elijah. I had the bot turned down for me, and I tried to turn it up, and I'm driving, and with my fat finger, I pressed disconnect button.
Make sure you're operating
What you
your motor
guys were
vehicle
playing, I
correctly.
just.
Sorry, Elijah, go
I
ahead.
don't know.
No, I had just walked in. I'm not sure what was playing.
They were playing a conversation with Iron Dan, you and Whitsitt and Napalm were talking to him, and Sonny. It's been like a month ago. Some guy named Iron Dan that was clinging to the globe, and y'all were explaining to him how it's kind of silly to cling to that belief, but maybe you got it through to him. Who knows?
How long were you listening to the? Oh wait, I can see this, right? 1 second. It was an hour in. Okay, so I can fix this. Let me fix this.
So they want to be used. Some of us think that they want to be used and abused. And somebody said, "Why would anyone go through this? Why would anyone not just accept the truth?" It's like because some people want to be. Listen, that song pretty much sums it all up. Sweet dreams are made of these.
Who am I to disagree? Travel the world in the seven seas. Everybody's looking for something. Some of us want to abuse you. Right? Wait. Some of us, no, some of them want to use you. Some of them want to get used by you. Some of them want to abuse you. Some of them want to be abused. Because it's true.
Nanny Lennox in 1985 or whatever. Good job, Elijah.
Yeah, Marilyn Manson covered that.
And that video happened to have a spinning globe in it. She was playing with it. You remember that?
Wow, that's wow.
I think the opening scene of that video, she's like in a classroom or something. I can't remember exactly, but I know she's spinning the globe around.
That's interesting.
She says something like, yeah, sweet dreams are made of these. And then she spins the globe, something like that. You should watch the original clip. It's like in the first minute.
What's the bot command to start at a specific time?
Yeah, I've got it. So it's M exclamation mark skip to, and then the time. So M exclamation mark skip to. Let me post it in the here. I'm gonna post it in the bot command post. You see it, Napalm?
Yeah.
So they were an hour in, an hour. Exactly. Then I.
Well, before you started, let's some other new people have joined. Does anybody else want to chime in or say something? Think you live on the globe? Anybody? I'll take that silence as nobody wants to talk. Continue, Roger.
Sorry, don't got no curve.
Why'd you change your name to mayonnaise? It's 1973.
Because everybody else changed theirs to ketchup and pickles, so I thought it'd be fun.
I thought it was related to that movie, Officer and a Gentleman. Remember that one? Mayo, mayonnaise. Only two things come out of Texas: steers and queers. Which one are you?
Mayonnaise? What? I think there's more options than that in there.
Nobody remembers an Officer and a Gentleman but me. I'm showing my age again.
No, I know it.
So the ISS travels 17,500 miles an hour. Really?
That's funny.
And
Yeah,
the
that's
Earth
pretty
only
fast, huh?
spins. Yeah, the Earth only spins supposedly, right?
1,000 miles.
Once. Yeah, 1,000 miles per hour. So that difference in speed, like how would you would never be able to see something like that?
Yeah, it would be
You know
too
what I'm
small.
saying?
Too small
Yeah,
and too fast.
it's all relative, Elijah. Don't worry about it.
No.
They get that.
Relative will.
They
I
they
don't
get
know
that.
what that means.
They
Go
get
ahead.
that. Sorry, they get that imagined
Relative to
speed
the way they get out of an argument.
calculations because they imagine the ISS is so far away, and then they see the light move across the sky. They can calculate based on the imagination of how far away that light is, how fast it's going.
Yeah, but the calculation is bullshit. Because again, you can't. 1,000 miles versus 17,000 miles. Like you can take the fastest thing moving
Dude,
that we can think of, and this.
If the ISS were moving at 17,000 miles per hour, any space dust up there or anything traveling in any other direction would vaporize the station.
Then you have a leak.
That's called good engineering.
Then you have a leak. It's hilarious. But I mean, how is it going that fast though? Like, how'd they get to that speed?
It's just not. It's just
Because even if it's going that fast, there's not enough gravity to hold that within. Even if you're thinking about the circular, like the actual spin of the Earth, like, and somehow the gravity was able to hold this thing that's actually moving 17 times faster than the spin. Like
sorry. They never think about that. It's kind of like with the Earth and the Sun. Sun's gravity is too weak to have any effect on anything on the Earth, so we don't detect it. But it's supposedly holding this fastball going 66,600 miles per hour.
That doesn't even speak to the how many miles an hour? 700 and something thousand miles. Hold on, let me make sure.
Yeah, the orbit is 67,000 miles per hour or 66,600 miles per hour. They rounded it up to hide the 666.
I might have the bot ready to go. It could be wrong, but you want me to try it?
Before you do, I think kind of like with how they added dark matter and dark energy to explain how the galaxies are all rotating faster on the outside than on the inside, which doesn't make any sense, and which means that they should fly off and not be attached to it. They added all that stuff to make it hang together. They're going to have to do that here. They're going to have to add all that dark energy and dark matter to make everything work.
Look at this. I don't even know what this means. So the sun is moving towards Lambda Hercules at 20 kilometers per second or 12 miles per second, or in units per hour, 45,000 miles per hour is what they're saying. Okay, so that's one vector apparently, or motion, because also the sun moves at 448,000 miles per hour. So, as it pertains to these speeds, how the hell does the ISS stay with the Earth?
Because they compartmentalize everything, and they don't actually factor in the speed of anything on anything else. Otherwise, nothing would work.
That's stupid.
Yeah, it's because
That's
the
so
model
dumb.
doesn't work. They don't have a working model. They just have contradictory ideas they claim work.
That doesn't work at all.
Good thing is we have a math professor in here who can explain it all to us, right? So they're saying 17,000 miles per hour for the ISS. Is that in relation to the center of the Earth? Like the surface at the equator has a speed of 1,000 whatever it is, 71 miles an hour. Are they taking into account the same thing, right? So you'd have to go another 250 miles out.
Yeah, it's in reference to the frame of reference of the Earth, like the North and South Pole, which are stationary, basically.
So is it going 17,000 miles an hour faster than the speed at which, if you had like a tangent point that went further out from the equator, say you went straight out from the equator 250 more miles, right? Obviously it's going, that position would be going faster than 1,071 miles an hour or whatever they claim at the equator, right?
Yeah, slightly faster, maybe 10% faster, I don't know.
Right. So we would add, let's say, 170 miles an hour in there.
Well, not 45, but what's wrong with the 17,000 miles an hour?
Nothing.
My question is that in relation to the Earth below it, right? So does that mean it's going 17,000 miles per hour faster than the speed of the Earth?
Yeah, I mean, yes, it is. It doesn't even matter how it's relative to the Earth. Yeah, it does. Because they're saying, well, it's orbiting, circling. It's still a circle, and it's going around this circle ball that is the Earth 17 times faster than the Earth can spin in an hour.
Right.
So does it orbit 17 times a day?
About every 90 minutes, so I don't know, 15, 16, 17, somewhere in that range.
Let's say, hypothetically speaking, the Earth was stationary and it was making an orbit of, or a circle of 24,901 miles. How fast would it have to be going to orbit 17 times a day?
I don't know, but about 17,000 miles an hour? What do you mean?
Yeah, I guess it would still be the same, regardless.
But where's the math that would express this working out?
The math, orbital mechanics?
Along with the movement through the galaxy, yes.
You can ignore the movement through the galaxy and the orbit around the sun because the Earth's gravity is much stronger and the main influence on the ISS. So you can ignore the other ones.
But when you say I'm sorry, when you say it's stronger, therefore you don't have to think about it. Well, no, I'm asking mathematically how much stronger. Like, where can you actually, logically, mathematically show me this?
In the equation for gravity, r squared is on the bottom of the equation, and so the r squared stands for radius, and so that means the distance to the object is a major factor. The ISS is only 200.
So there's no way to actually take into account the supposed extra energy that would be required from gravity to hold the orbit as if that motion isn't actually happening at all, along with the other motions.
So as I was explaining, r squared is on the bottom. The height of the ISS is something like 250 miles away from Earth.
Yeah.
But the distance from the ISS to the sun is 93 million miles, so it's much, much smaller.
Okay. What does that have to do with what I said?
You can ignore the movement around the sun because the gravity of the sun is so much smaller on the ISS than the gravity of the Earth.
Yeah, but I'm not. Yeah, I'm talking about accounting for the how fast was it?
17,000.
The almost 500,000 miles an hour that it's traveling with the sun. Where's the math that expresses that's happening and the forces that are holding it intact as if that's not happening? That's what I want to see.
Oh, where is that? Orbital mechanics and gravity. I mean, it's fairly simple.
Say again?
Orbital mechanics and gravity.
You understand what Elijah's saying, right? You're going to have to account for the Earth also moving in a specific direction at whatever it is, nearly 500,000 miles an hour, or however fast it is that we go, 66,600 miles an hour?
That's kind of what I wanted to have Matthew try to explain with gravity. When the Earth is moving at 66,600 miles per hour towards the bottom or the underside of the ISS, which is supposedly falling around it, how is it not getting closer?
Orbital mechanics.
No, but that doesn't work.
Because you don't understand it doesn't mean it doesn't work.
Let me
at it, then there should be a shortening of distance. It's supposed to be falling.
But let me tell him why okay, so Matthew, here's the reason that you saying he doesn't understand orbital mechanics was actually an ad hominem attack. Which is pretty rare for you, but it's a technicality, so it is what it is. You just, correct me if I'm wrong, but you just said that you can ignore that movement. So if you're ignoring that movement, then it actually has nothing to do with orbital mechanics, which is what I'm trying to point out is no, you actually can't account for that in your math, but you would absolutely have to.
Okay, I know you don't believe in gravity, but the gravitational force is calculated as mass times mass divided by r squared. That r squared is the distance between the two objects, right? Now,
it has nothing to do with it.
The ISS and the Earth are much closer than the ISS and the Sun.
It's not about the sun's gravity. It's about the Earth's motion towards the ISS.
Yeah, they're in the ISS. You can do all the calculations in the frame of reference of the Earth.
Yeah, but the Earth is supposed to be moving towards the ISS at some points and away from the ISS at other points. So that would have a difference. Where's that difference?
Right, you can ignore that movement altogether and assume that the Earth is stationary for the calculations because you're using the Earth's frame of reference.
In other words, you're divorcing reality.
No, it'd be like calculating how things are moving on a moving train. You can choose your frame of reference. I mean, this is basic orbital geometry.
The difference here is that that you're claiming the ISS is outside the train and moving in circles around the train, and then all of a sudden the train starts moving, and now they hit the front end of the train.
Almost, but it doesn't start moving. It's moving in a constant.
It's moving constantly, and therefore the ISS would have to account for it, but you don't.
That's right. We don't. We use the to simplify. We use the frame of reference of the Earth most of the time.
What's the medium that maintains that frame of reference for the ISS?
The gravity well of the Earth.
That the gravity well is the medium?
That's a good way to think about it, yes. I mean, it's
the
a
gravity
vacuum.
well is holding the ISS away from the globe? Is that what you're telling us?
Orbital mechanics and, yeah, That's a good way to think about it. Sure.
So gravity pushes the ISS away from the Earth when the Earth is moving towards it, but when it's moving away from it, it pulls extra hard. Is that what you're saying?
No, the pull of the Earth on the ISS changes throughout the 90 minutes. Both of them are in the same frame of reference going around the sun, and so you can cancel out that frame of reference and look at just the pull of the Earth on the ISS.
It doesn't work like that.
I promise you it does. I'm sorry if you don't understand it.
No, you can't just say you promise that it does.
Okay, I will say, as a math professor, it's my sincere belief that it does work that way, and
so
I'm sorry if you don't believe that.
The Earth goes at 66,000, or let's just round it up like most globers do and say 67,000 miles per hour. That's traveling towards the ISS while it's in the sky above you.
Yes.
Yeah, why is the ISS not getting closer?
Because it's also doing that same speed around the sun.
It's going in that same speed around the sun, you say, but
yeah,
then it's also falling away from it in the other direction, so it's going backwards and forwards at the same time?
Yeah, it changes by maybe a factor of 34,000 every 90 minutes. 34,000.
Mathematically show us this claim.
Orbital mechanics.
No, because you said it's not taking into account the movement of the galaxy.
Look, you guys are complaining about orbital mechanics when you don't even believe it. I'm saying here's our story, and it works with our equations and our stuff. And I'm sorry if you don't understand it.
No, you admitted that you don't account for it, and we're asking you to account for it, and you're saying it accounts for it.
And I'm refusing
already
to account
admitted
for
it don't account for it, so you're just double speaking.
I wouldn't call it that.
Is there any citation for gravity being a medium?
No, gravity's not a medium.
You said a gravity well. Okay, so I need to include the word well. Is there any citation for a gravity well being the medium?
It's a sort of colloquial way of thinking about it. If you want to do the actual gravitational mechanics, you have to learn physics and calculus and do all the equations. But the medium is empty space.
So the medium is nothing.
Yeah.
Okay, so you used a metaphor of a train and objects in a train. Are those objects that are moving with the motion of the train maintaining their motion due to the medium or no?
No.
And how can you prove that?
Newton's laws. Like an object in motion will continue in motion unless there's a force.
Uh-huh.
Well, you don't think Newton was right?
Unless there's a force.
Yeah.
Uh-huh. So that's why I asked you what the medium was.
I'm still not. So there's the force. Gravity works across empty vacuum with no medium.
Except when it doesn't. I thought the days were over when people were claiming that gravity was a force, but it's still getting used as a...
No, it's a pseudo force, kind of like centripetal force. It's a convenient way of doing calculations.
So I love metaphors. I'm a big fan of metaphors and analogies. Cool. So when somebody is only pseudo faithful to you, like a spouse or something like that, is that pseudo fidelity sufficient to prove fidelity?
No.
Yeah. In this world of whether or not things are or they are not, and there's a modern denial of status, binary status, for instance, because of the Kabbalistic ideologies in the realms of quantum, where it's now okay to be relative in between, basically denying the law of non-contradiction. I understand the popularity of it, but that jives with your conscience?
So I'm with you. I don't like it when people are relativistic, and I believe in the law of non-contradiction, and I think society, especially in regards to morals, has become way too relativistic. I think we're talking about something slightly different here.
So yeah, but I'm likening the conversation of saying that something is a pseudo force and also acts as a force as very akin to Kabbalistic ideologies.
I see what you're saying. So let me describe what I mean by pseudo force. Let's say you're driving I'm driving in a car and you're holding a cup of tea, trying to drink it, and then suddenly I go around the corner really tight, a really tight corner really fast, and your tea sloshes out of your cup, right? So that force that moved the tea out of your cup, we could consider that a pseudo force, centripetal force, going around a curve, it sloshed your tea out, right? And that's a convenient way of thinking of that force, even though typically it's actually a pseudo force. Really what was happening is the car was moving and your tea was attempting to go in a straight line. So that's what I mean by pseudo force, a convenient way of
Okay, so essentially what you just described to me, for all intents and purposes, means that the use of the word pseudo is a misnomer.
That's just the way it's used in that context.
Help me understand why the invocation of pseudo was initiated in the first place, because it seems to me like you can rationally explain there's a change in direction that is the cause. So why does it have to be called pseudo?
Because it's not a force sloshing your tea out. Instead, the real thing is a force moving the cup underneath it. But it's convenient in the context and the frame of reference of the car to describe it as a force moving the tea.
So not only is pseudo a misnomer, but force itself is a misnomer.
Yeah, and so I wouldn't call it a misnomer. I'm just describing what people mean when they say pseudo force.
But they're basically both misnomers in that they don't imply what the word is actually defined as.
Oh, sure. I'm okay with you saying you don't like the use of that word. I was describing how most people use it, but we could use some other word if you don't like that one.
So, if you were to give it your best effort, what would be the new word that you'd use apart from using the word pseudo and apart from using the word force? What would you describe gravity as?
A description of how things move in curved space-time, something like that. I mean, because
okay, so here's what I find interesting about that description. Not criticizing it at all, but if you analyze the way that comes across, that would be in the equation of cause and effect. That would be on the effect side.
Yeah, right. Gravity is always described as an effect, right?
Gravity is always described as that's not the impression that I get from all conversations centering around gravity. The impression I get over and over again is that gravity is not only the effect, but it's also the cause.
Fair enough. I see what you're saying. It's convenient. It might be convenient to describe it as a force and as a cause. That makes the calculation simpler.
You don't find a circular logic failure here?
No, like if you drop a rock and try to calculate how long it takes to get to the ground, it's convenient in physics 101 classes to describe the force on that rock as gravity and treat it as a cause.
What was the actual cause of the rock falling?
The curve of space-time, and the rock is going along a line of gravitational.
Let me ask you a good old kindergarten question here. If I'm holding the rock,
yes,
can the rock fall?
No.
So if I let go of the rock, what caused the rock to fall?
The easiest way to describe it would be the pseudo force of gravity.
Actually, the easiest way to explain it that a 6-year-old could easily explain is that, well, it fell because you let go of it.
Yeah.
That's the cause. At least the most initial or originating cause.
Sure. Yeah. I mean, I suppose you could have lots of different layers of explanation. You know,
but
you let go of it because you decided
first,
to. You
yeah,
decided because somebody's told you to. You know.
But this is in relationship to the rock itself. The rock doesn't care what you thought. Okay. So in relationship to a rock falling out of your hand, the most originating or the beginning cause of the rock falling was it being no longer supported by your fingers or hand or however you're holding it.
Right. So
it seems to me that in this conversation, not just between you and me, but over and over again, this seems to always be, well, that's beside the point. The fact that you let go of it is really besides the point. What we are discussing is everything in between, and but my argument here is that you're ignoring the initial cause and then claiming that there's another cause in addition to the first cause without actually proving that there's an extra cause.
Yeah. So
rather than there's
That's
just
the
effect to the cause.
Yes, you're right.
That's the fallacy of when you say yes, you're right. You're saying yes, you're right. To you committing the fallacy of begging the question.
I might need to finish the sentence before you analyze it.
Go ahead.
Okay, so yes, you're right. The person letting go of the rock is the cause. In physics, we would describe it as when the rock is being held, the gravitational force points down, the normal force points up, and they balance each other so the rock doesn't move. As soon as you let go, that gets rid of the normal force, and now the force of gravity is the only thing acting on the rock, and it begins to fall.
And that's where Elijah's comment about the begging the question. There's the presupposed downward force without I could presuppose so many things, and they can be part of reality, or correspond perfectly to reality. That doesn't mean that my presupposition is accurate, just because it always corresponds.
Right. Yeah.
I've talked about ninth dimensional unicorns farting in your eyeballs as the reason that you blink more than once, and just because that's my presupposition, not that it actually is, but for the sake of the conversation, it is, doesn't mean that that is actually what is happening. But it works 100% of the time because it's an unfalsifiable claim. And I am principally opposed to unfalsifiable claims. That's why I despise the Mandela effect, for instance. It's an unfalsifiable claim. In fact, yeah, anyway, we won't go there. But
I agree with you on the Mandela effect.
Yeah, well, that's how I see gravity, because it's an unfalsifiable claim.
But it's convenient and describes motion pretty well.
Yeah, so are ninth dimensional unicorns that fart in your eyes that cause them to blink. Ninth trans-dimensional unicorns, I might add, because they are interacting with our dimension, and our eyes are not accustomed to liking the unicorn farts. So, and they're very tiny little creatures, but only you can think of them as tiny. In reality, in their dimension, they're massive.
Well, if you could use that theory to predict.
So this is what's wrong with begging the question, because while you can see and understand what's wrong with the form of argumentation, it's almost like what's the word? It's not Is it special pleading now at this point? Like,
no offense. I kind of do want to hear where he was going with that, because I think it brings some clarity to the lack of just to your perspective. Go ahead, Matthew. If I could use the ninth trans-dimensional unicorns farting in your eyes idea, go ahead.
If you could use that idea to predict when people would blink, and you had some equations that described it, and then there was experimental evidence backing you up, then people might start believing in them.
Okay. So what I would invoke, personally, if I were going that way, and let's just say hypothetically I was running a unicorn cult, and I just had some fun esoteric ideas about unicorns and stuff. Anyway, what I would invoke is a quantum algorithm, by which, of course, requires new symbols to represent what is algorithmically taking place for the frequency of their flatulence, and I would write it all out on a piece of paper, and I would explain each and every new symbol that I just created as part of this quantum algorithm, and it would be essentially a snow job to make everybody think it sounds just fantastic. But are you familiar with snow job, like snowing somebody under?
Yeah, got it.
Okay. So, yeah, maybe there's a lot of people that just be like, yeah, that's just a bunch of gobbledygook, and it doesn't make any coherent sense. It doesn't translate to our form of language or our understanding of physics and math. So therefore, I think that this is just a charlatan, pretending with silly ideas, and he's dismissed. However, that doesn't mean that it isn't essentially the same thing that's going on. It's all about those presuppositions.
Yeah, I see what you're saying. You could make a bunch of smart looking, quantum this and that, and use a bunch of language and make up new terms for your unicorn theory. The key distinguisher would be whether you can do predictions with it or not.
Yeah, but what if all the predictions checked out because they're based on quantum, aka magic, Kabbalah, Zohar magic, and really and truly, it no longer matters whether or not you're blinking or not blinking. Is actually just conceptual anyway. We're really always not blinking and blinking at the same time anyway, and whether or not you are or you aren't depends on actually your degree of quantum awareness.
Yeah, I see what you're saying. So in that case, it would be unfalsifiable, and I don't think many people would believe it. However,
okay, what would falsify gravity, bro? That's what I'd like to.
Okay, so similar. Let me draw an analogy. Similar to your unicorn theory, if you did come up with something quantifiable, like, oh, I used my equations, and here's a list of all the times that you will blink tomorrow, and then I took that list and trained a video camera on my eyes tomorrow and saw if it matched or not, then it would be falsifiable or not falsifiable. With gravity, you can take a rock and drop it and measure how fast it drops according to the equation, and then see if it matches the equations, ballistics, all these kinds of statics for building buildings, all these types of things you could see if they work in the real world.
Isn't the equation based on the observation itself?
No, like something drops
at
32 feet per second squared.
What's the equation for helium balloon of a certain mass? For how quickly it drops to the ground?
Oh, it doesn't drop because it's lighter than air.
But so it doesn't have mass?
It has mass, yes.
But the mass is not attracted by the other mass.
No, it is, just not as much as the air around it. I mean, it's like a log in water. Logs float. They don't sink to the bottom of the lake. It's because the log is lighter than the water.
So mass doesn't attract mass, always?
It always does, yes.
Except when it doesn't?
The log is attracted to the bottom of the lake, but the water is attracted to the bottom of the lake even more, and so the water displaces the log, and the log moves up, even though the log is heavy.
Yeah, but if you put a floatable log at the bottom of the lake, it will still float to the top.
Right.
Even though there's no water to displace it.
The water around it displaces it.
You could cut a log in half, put the flat end on the surface of the bottom of the lake with no water underneath it, push it down.
Good.
What?
Sorry.
No, I'm just saying.
There will be an imbalance. The water above the log and the water to the side of the log is still heavier than the log itself.
So then I'm failing to see how this is unfalsifiable then, because when he asked you how it's unfalsifiable, inevitably you came down to, or eventually you came down to, well, 10E. Yes, there's this rate of fall in which you can record, and it's like, well, what about a helium balloon? Well, that's a different effect, but it's due to the same thing. So how do you falsify it then?
You could look at the equations of ballistics and say, okay, according to gravity and ballistics, we predict that if we shoot this cannonball, it will land here, and then we can go test it. We can falsify whether that works or not. Unfortunately, it works, as we've seen in a certain country.
So the claim of mass attracting mass and then mass not attracting certain masses, you're now bringing in, well, mass doesn't always attract mass because if another mass exists around that mass and it's of a greater mass than the other mass, then it won't be attracted because that other mass will get in its way.
No, I didn't say it won't be attracted. I said it was attracted less. That's a key difference.
Yeah, that's what you believe.
No, I mean, this is how boats float, right?
Now think about this for a second.
No.
When a helium balloon is rising rapidly in the air, is there greater pressure above it or below it?
Below it.
No, actually not. There's greater pressure above it because of displacement.
Oh, you mean when it's rising? If it's already in motion, yeah, you're right.
Yeah, that destroys your idea that the air under it is pushing it up.
That's a good point. Let me think. I don't know why. I mean, it's in motion. It's moving. If it's still, the air pressure is more on the bottom.
Yeah, you can also see this with hot air balloons. Hot air balloons destroy any notion of the idea that cold air is getting attracted more, therefore pushing up hot air, because a hot air balloon can lift tons away from the surface, and the attraction on cold air is not enough to lift tons.
I'm not 100% sure I'm following. But with hot air balloons, the air inside the balloon is less dense than the air outside, so that's why it's lighter.
That's why it rises. It doesn't mean that the cold air is pushing it up.
I think it's I don't know.
Essentially, when a hot air balloon lifts tons away from the surface, you have to claim that the attraction on cold air is overcoming the attraction on the tons of solid weight.
Yes, just like a log floating. Logs can be very heavy, but in the water
that's not possible. That's weaker.
No, it is possible for logs to float.
Greater attraction. That doesn't work in your idea.
Sure, it does.
No.
The force is balance. Okay, so a log floats because the downward pressure of gravity on the log is less than the downward pressure of the equivalent volume of water surrounding it.
You keep running away from the actual example.
Well, because the thing is, the log is now in equilibrium. Well, it'll probably move with the flow of the water, But
yeah, on the surface it's an equilibrium,
but
right?
so but a balloon is not, so it's not analogous at all. So you can't use that explanation or example to try and explain how it's possible, because you have the it's just not analogous. You already know.
Okay, so if you don't accept the standard definition of how logs float and balloons, hot air balloons work, what would you
No,
say?
it's not about accepting it. All I said was, with the point that Drace made, the example that you use is just, it's not related to what he said. Is all I'm saying.
Okay, I understand what you're saying.
So it's not a mental fix. So where do we go from here?
The interesting thing would be to say, okay, if this isn't how it works, then how would you say it works?
Would you say hot air rises?
Yes.
Oh, and that's how it works.
And just that's enough of an explanation. Just hot air rises.
Yeah, because you're not on a globe in a delusion. It just works.
Okay, so I was saying hot air rises, and this is how, and you'd say no, don't say how, just say hot air rises.
Well, you don't have any proof that's how hot air rises. You don't have proof that cold air is the cause of hot air rising.
I guess you're right. I don't have proof. I would think other people might have a better way of explaining it than I do, but I don't have proof.
Well, that's as honest as it gets, right? Because when you tried to use an example, that was in light of not being able to make sense of it, right? And so with the example not being a good example, you're still left with not a good way to make it make sense. Therefore, you're like, well, maybe someone. So at the very least, it doesn't make sense right now to you in a way
no,
that you can.
it makes perfect sense to me. I'm just not explaining it well enough, and I understand that it doesn't make sense to you, and that's fine.
How does that? I mean, are we both speaking English?
Yeah, I never claimed it didn't make sense.
So did what just happened? So I didn't just summarize what happened accurately.
You said that it doesn't make sense to me. I think the analogy is a good analogy. I don't know how to explain it very well. So you're right that I don't know how to explain it very well.
Well, it's not about explaining it. The it thing that you tried to, the it thing that you couldn't really, you didn't have an answer for. You thought, well, the answer was this example, which was not analogous, which leaves you with not a good way to reason for your argument initially to what Dre said.
No, I think it's analogous.
That's not an well tell the audience how it's analogous.
Yeah, things float.
Okay, but we're talking about air. It's not analogous with the log. And I explained why. And you said, yeah, you're right. So it can't be, yeah, I'm right and I don't understand. It can't be both.
I see what you're saying. Yeah. I don't understand the exact mechanics and equations of how all of this works. The broader picture, it makes sense to me, but I don't understand the details. And the analogy that I was trying to say is, hey, look, things float in liquids and in gases. So logs float in liquid water, hot air balloons float in cold air. The analogy is just that things float. That's all.
Well, I think that the claim is actually not that things float, but rather things are supported. Because to say that things float is conceptually contradictory to things are attracted to the center of
I'm
mass.
sorry. I'm sorry. That's what the reason I said it wasn't analogous is because you're talking about things floating. Drace is talking about something in movement.
I'm also addressing actually his claims, or that things are going up because things are going down. So we're
Yeah.
looking at the things going down and how much they would be attracted, and yeah, the cold air isn't supposed to get attracted much at all, because it's all light, it's gas. Meanwhile, we have solids in the balloon which are supposed to be attracted heavily, and that's why they're heavy. But they're being lifted away from the surface. And he claims that the cold air is pushing it up, but when we look at helium balloons rising, there's actually more pressure on the top than the bottom because of the displacement. So there isn't this greater pressure on the bottom pushing it up. It's just rising from the inside out.
I mean, I think the word float means being pushed up. I don't know why you need to make a distinction between pushed up and floating.
Well, because there's two different effects. One, a balloon is literally rising. The other, a log is just sitting there. Again, it's not analogous. I'm describing to you what you can imagine in your mind because I know you've seen a balloon rise and I know you've seen a log float. So I'm saying that distinction, that difference is what makes your example not applicable.
What?
You can't tell me I don't understand. That's unfair.
I understand, but I disagree. I think they're applicable.
Well, in both cases, you're trying to, in the log case, you're also trying to hoodwink Archimedes' principle into your delusion, which just is far older and has nothing to do with it.
I think Sad SK wanted to say something. Sorry, we cut you off.
Well, I needed to understand, like, because what I learned is that the log floats on the water because it's less dense than the water. That makes sense.
Yeah, that makes sense.
But how is the log less dense than the water if it weighs more than the actual water?
You're right. If it weighed more than the water, then it wouldn't be less dense.
Also, the way that actually, I'm looking. I was studying earlier, so I'm gonna let y'all continue talking. I'm sorry. All right.
No, you brought up a good point. Thank you.
I was just thinking.
Can I interject something real quick that's not necessarily being talked about or even thought about within this equation, which would be the energy within these states of matter or mass. So when we're talking about hot air, or even if we wanted to look at something like water that's very easy to see, it's three definitive states, right? So you have water as a solid, a liquid, and a gas. And these change, and correct me if I'm wrong, Matthew, but wouldn't these change the inertial state of the water as well? Meaning that the higher the energy that is imparted into water, once it reaches a certain state, that water will actually turn into steam or its gaseous state, and it'll rise.
Yeah, I think you're right.
And the inertial state of like liquid water, it's much easier to move liquid water than it would be to move solid water in the form of ice. So
Yeah.
do you think that these energetic relationships may also play into what may or may not be taking place with objects rising and falling?
I think they do indeed play a part in the idea that the energy of the different matter can affect their density. But in the end, the best way to calculate it would be to look at the density, and then that's how you can see whether it's rising or falling. So I think you're right. But in the end, it comes down to the density.
Hey, can I ask you a question, Matt?
Yeah, go ahead.
You mind gospel if I ask him something real quick?
Yeah, go ahead.
Okay, so you said that wood or a log doesn't sink in the water because the water is denser than the log, correct?
Yes.
Okay, so water's denser than the log, right? And so that's why the log doesn't go into the water, right? So
right.
But if you treated the wood with something, it like some type of solution that made it so it wasn't porous at all. You know what I mean? You could make the log would sink in the ocean.
Yeah, so
or
you
in water.
could make the log more dense. You're right.
So in other words, no, you can just take the air that's in the log out of the log, and it will no longer float.
All right, now my
Funny enough.
turn. Now my turn. The video I posted directly demonstrates what you guys are talking about. It's extremely applicable. So he puts a block of wood
Yeah.
and a ball bearing in a vacuum chamber that are balanced. The two objects are in balance with each other. Then he takes the air out of the vacuum chamber, because that's what those things do. And then an interesting thing happens.
And is that because
What,
there's
the
some
ball
air in
bearing
the
goes
log?
down? Yeah.
Which is what we're talking about. So again,
Yeah, so there's air in the wood.
But the wood is less dense than the water.
There's this. This is a good video to demonstrate the effects of buoyancy that are always applicable. There's not just like, well, only in water, or things are buoyant
right.
always.
So once again, here's a kind of a scientific like a demonstration or of changing the density of the.
Yeah, robot and Elijah. The other thing to point out is he puts the air back into, releases the pressure and lets air back into the chamber, and it returns. I find that fascinating.
Yeah, I like that. That's a good
Yeah,
demonstration.
and also passing the theory about logs, we also float on water too, and that's because of the air in our bodies. From most of the reason, that's why we float in
Anybody
water.
that's tried to float in water knows that if you breathe out all, you start to sink a little bit.
Yeah.
But if you take a real deep breath, you float better.
Well, some of us more than others. If you have really lean body fat, then you can sink to the bottom. Some people can't.
Yeah, I understand.
Hey, Matthew, let me ask you one more question real quick. So, what's the force that let's say I have a pot of water, right, and I flip the pot upside down. What do you think is the force that's making the water fall out of the pot to the ground?
You mean when you're swinging a pot around?
No, not swinging. Let's just say I turn a pot upside down of water, and the water comes out, and it goes downward, not upward. What do you think that? Why do you think that is?
Because the water is more dense than the air that's replacing it.
The water's more dense than the air that's replacing it. Okay, so do you attribute that to gravity?
I do.
Okay, so if I stuck my hand under a running faucet, got my hand wet, and turned the faucet off, the water that's coming off my hand down to the bottom of the sink would be because of gravity?
Yes.
Okay, so on Earth, with the water that's sticking to this ball, what's keeping the water sticking to the spinning ball?
Gravity.
So gravity pulls the water off of my hand, but gravity makes the water stick to a spinning ball.
Right. Gravity pulls the water off your hand towards the center of the earth, and gravity also pulls the oceans towards the center of the earth.
Okay, so if I put a spinning ball under a faucet, water is going to come off the ball, right?
If you spin it fast enough, yeah, you can.
Okay, what if whether I spin it or I didn't spin it, water's still going to come off that object, that ball under the sink?
Oh, I thought you were
because
talking
of gravity,
about
right?
spinning it. Yeah. So if you get a ball wet, then the water will drip off the ball towards the center of the earth.
Because of gravity.
Because of gravity, yes.
Mm-hmm.
Okay, so why doesn't the water drip off of the globe then?
Because it's pulled towards the center of gravity, the center of the earth.
So how come this law of gravity isn't applicable with my hand then, or with a ball on Earth?
No, it's applicable to all of them. Like it's the explanation for all.
But it's not applicable to the helium balloon.
Right?
No, gravity pulls the helium balloon towards.
Well, that's just begging the question because you see a different effect, but you're saying it's the same thing.
You said it applied to all objects. Has that ever been demonstrated?
I don't know what would count as a demonstration in your mind, but the equations work fairly well and are very predictive for ballistics. So that's
okay.
good enough for me.
So so we'll go with ballistics. Is there a way to, let's say, the gravity of a mountain? So let's say you're going to shoot a rocket next to a mountain. Do they take into account the mass of a mountain in its ability to gravitationally obscure a ballistic missile?
I don't know. My suspicion is that they don't, because the amount of gravity present in that mountain would be minuscule compared to the Earth.
The mass of the Earth, yeah. So even with like good old biggest mountain in the world, it's still so minuscule, so we could never actually demonstrate it. Unfalsifiable claim.
Oh, I didn't
basically
say unfalsifiable. I would say it would be so small that they wouldn't typically take it into account for ballistics. But if you were trying to measure for it, you could get the right equipment and maybe you could see an effect. I don't know.
What if the opposite effect took place? You know what they'd do? Because they do this sort of thing all the time. Well, I mean, it's the same thing that they do with the selenelian, right? We use the apparent position of objects in the sky to make, I say we, the narrative, whoever these people are, they use the apparent position as an absolute to formulate the defense of their arguments. And at the same time, they make the claim that objects aren't where they appear to be. Such as during a selenelian, where the claim is that the moon and the sun are not where they appear to be. They're actually below the horizon. You just happen to see them because of our good old friend, the R word.
Refraction.
Well, do you understand like this, or are you aware of the significance of that?
Okay, so yes.
Contradiction.
Let me see if I understand what you're saying. You're saying that in general, globers have a whole theory set up, and if they encounter observations that seem to contradict that, then we typically just hand wave and try to find some explanation for that observation.
Yeah, that's pretty fair.
That's what we do.
Okay.
Wait.
And that is something you like, or?
I mean, if we come across puzzling observations, then it makes sense to try and explain them. Yeah, I mean, that's how science works. You explain what you see.
But you explain it like you say, okay, so this would be my claim. This claim is something that had to be observed because I'm saying this is the reality. Then you observe something different and you say, yeah, well, this effect is also because of the same cause that I saw initially. You applied that to the selenelian and you've applied that to gravity and density.
Well, the problem with the Selenelian is that the claim to explain away the Selenelian actually contradicts the foundation of your whole heliocentric model.
What, refraction? How does
No,
refraction?
claim that things are or are not where they appear to be.
Yeah.
To say that things aren't where they appear to be invalidates the foundation of all the arguments, because if they aren't, then you can't be making the sorts of claims that you make in regards to heliocentric model stuff.
Right. If they're not where they appear to be, then we would want to look and see how far off they could be. How much?
How could you possibly know? What would you use to validate that what is actual?
Measurements of.
How do you measure actuality if everything is apparently inaccurate?
Or numbers.
No,
Can I ask y'all something?
Go ahead.
So I don't know if this is completely off of the what we're talking about, but I don't understand how. All right, so most flat earthers think of the sun like I don't understand how they look at the sun when one is like nighttime, like one side of the earth is nighttime and one side of the earth is daytime.
So what's the question?
So
why can't you see the sun at night is what he's asking.
Oh, because it's not very big.
Because it's not very big.
Yeah. The light from it's not going to cover the whole fucking disk, that people call it, because it's not very big. If it were the huge monster thing that everybody thinks it is, well, yeah, it'd be lighting everything. It'd be burning everything. But that's certainly not the case.
So, Glatt, let me ask you this. If you and I get together and we're hanging out at midnight and we go outside and I say, I know it's small and far, so we can't see it, but I would say, where do you think the sun is? Would you point above the horizon or below?
I would point below it.
I'd just point across wherever east and
I would
west are.
I would point across.
Point that direction. Wherever it went down, I'd just say right over there. I'd point at the horizon. Yeah.
I would point down. I would say down there somewhere under our feet.
Of course you would.
Yeah, because it's opposite.
Isn't half the world illuminated by the sun when it's in view?
So
that's what they claim.
Glad at midnight you would point somewhere across the horizon and say that it's over there, but then you would say we can't see it because it's too far away. Even
it's big enough to illuminate half the world. That's quite a distance.
Is PASA the same as JASA?
Demonstrate that it illuminates exactly half of the world.
Observations.
No. You need to demonstrate it.
Yeah, that's just what
you can't just come in here clucking. You got to give us something substantial, okay?
Do you go by the day-night maps at timedate.com? Do you think
I don't go by any map set, dude. None of them.
We kind of deviated from the question that Gospel Bear asked Matthew.
Go ahead. Yeah, go ahead.
Gospel Bear, I don't know if Matthew understood your question.
Yeah, I know. And I don't. I thought it was an applicable. Okay, we're talking about the foundation of the argument, things being where they, appear to be versus not, and how if you claim that things aren't where they appear to be, that invalidates the foundation of all of your arguments. Was that the one?
Right, and then you were asking how do you calculate where it is if it's not?
Yeah. How do you validate, Matthew, where things are if they aren't where they appear to be?
You calculate the margin of error due to refraction.
How could you calculate that if you don't have a litmus test? Let's for instance, like we have things that operating in the realm of reality. Chemistry is a really excellent exacting science most of the time, except when it bleeds into like alchemy, for instance. Like you can distill water, and then you know how distilled water behaves, through experimentation and all of that, or distilled water at sea level, boiling at 100 Celsius, so on and so on, right? We have these things that, or the temperature that water freezes, for instance, pure water. These are the sorts of things that we can demonstrate as like a rule. For instance, what you would use is freezing water and boiling water as a way to calibrate a thermometer. So if everything is just where it appears to be but isn't actual, then how would you be able to calculate margins of error if you don't know the truth?
Yeah, that's a great question. It would be impossible to do in that case. And so we use other means to determine where things are.
What are these other means you speak of?
Orbital mechanics, that kind of stuff. But this is also why
the orbital mechanics. The orbital mechanics
I have 3
comes
sentences,
after. Well,
it's more math. It's more calculations.
Really,
it doesn't actually answer my question. Is the point?
I'm sorry. Yeah, because you're not answering the question. Please don't be catty. Like you can't say orbital mechanics because that comes after assuming that you have the measurement.
Right.
One of the things you can do about observations of the horizon is make lots and lots and lots of them over many different types of weather conditions, and look for the consistent patterns in what you observe.
Okay, so an average, but not the actual.
No, but if the average is sort of like if 99.9% of your observations over, say, a year correlate to one visual acuity and then 1% fall out of it, the question is why does that 1% fall out? But you wouldn't necessarily presume that 1% is the norm, would you? And the 99% is some sort of like anomaly. That's the way the world of statistics works.
Yeah, right. But in regards to statistics and averages aren't the actual.
No, but like I said to you, if 99% of the time the observation it falls in one visual acuity and then 1% falls out of it, you're safe to presume that 99% is closer to the reality of what you're looking at.
Yeah, but what if 1% is A and the second percent, another 1% is B and another percent is C and another percent is D and so on and so on, and the average of everything is what L, right? And you're like L is the average among all these things. What?
If you're right, if it's a broadly distributed set, yeah, then the median is just it's an approximation by the fact that it's scattering the data.
Yeah, I'm familiar. I took master's level statistics twice.
Right, so you know about Gaussian curve, and if everything's distributed across it, then the median's no good to you because it's just basic. But I'm saying is in when we look at the horizon, most of the time, 99% of the time, we get one view of things, and then occasionally we get these inflections.
90% of the time. Can you quantify that? Can you show us that it's 90% of the time?
Most of the time, when you look at things at the horizon, they appear a similar way. You get certain weather conditions, and they get distorted.
What do you mean a similar way? Is the horizon at a certain distance or something? Can you go out and take some measurements and show us that 90% of the time this thing that you say is happening?
As far as I'm aware, everybody looking at the horizon.
I'm back for a second. Well, wait. Positive. When you say that the average is fine because ultimately, are you saying that ultimately the difference is negligible because the average is there's a small margin of error? Are you saying that?
No, not. I'm not talking about the actual error in any given measurement. What I'm saying is that if, for example, in the case of the black swan, the guy who took the video, in his original video, he started off by saying, most of the time when I come down here and look at the beach, it looks like this. So his personal anecdotal evidence of observing this is that most of the time it looks a certain way. And then goes on to say, under certain weather conditions, extreme weather conditions, it looks like this. And he shows you your black swan picture. So going by his anecdotal evidence, I would say...
But in 100%, in 100% of the observations he's made,
yeah,
there's an error there because none of those horizons are 1.2 miles
We're on
away.
a hall going 1,000 miles an hour.
Well, you would show me
none of them are where the math predicts it to be. So there's a margin of error. So the question here, I don't know if you missed it, was how do you know the difference? When do you find out what is actual
from what is marginally off.
Oh yeah, okay. But in that case, the assertion made here is that they're presuming a radius and then working out what the equations of the diffraction would be to match the reality of what they view.
Bingo.
Yeah, that's. But the point
Man, I'd like to nail on the freak
Is the sun
with the
flat?
hammer, bro.
Sorry, what was that question?
Do you think the sun is
Yeah.
flat as well?
Anyways, don't answer. Don't answer him. So to back to the point about things not being where things apparently being not where they would be if everything was actual, and that ruining the models because like, well, when it comes to stargazing and all this other stuff, you can't have that idea is not consistent with everything that we do.
What idea is not consistent with everything that
The things that you see in reality are not actually there for mathematical purposes, for the belief of a globe.
That's an assertion without any foundation.
What is the sun?
What do you mean? No, that's an assertion behind not having a geometric horizon, behind having stars being at pretend angles from pretend angles, meaning when they mathematically place the observer right in the middle of the sphere, right? That's not really somebody literally taking an angle measurement, right? So then, but it does have to match up with what's actually going on in the surface and the measurement that you actually did take. So ultimately, you mathematically have something you've never actually even measured. And the angle is changed only because of your belief. To have to put that in the center of something that you believe exists. Because it's not actually where the person who's not actually observing it sees it. And that not actually observed from that observable location, from that not actual observable location, the angle to the star is not actually that angle.
Right. Okay. I'm sure that made sense to you.
Well, I mean, I could just show you a diagram. I mean, I could show you a video of what's his name? The guy with the flat back head, and he has the star in one position, but he says because the rays come in parallel, you can assume you can just move the star to another angle because it works out with where you would be at the center of a ball, in the middle, and like at the center, literally.
Yeah.
So don't tell me that it doesn't make sense. I'm just trying to describe what the diagrams show.
Right.
Here, I know you all like to hand wave the black swan. Have your try it hand waving this. I just put it in the chat.
Okay, hang on.
Yes, Slug, can you mute yourself? You're dying to talk, but we're now busy having a conversation. Can you mute yourself?
Sure.
Thank you.
So I'm sorry if I wasn't clear. 50% of the time I'm not, because I'm doing a million other things like riding through New York City. But the bottom line is the reason the reason the professor had two stars, because one star was at the angle that it was actually taken, and then the one he drew
was the angle he changed it to for whatever reason.
Texas sharpshooter fallacy. Painting the target around your arrow.
Basically.
Painting the target.
Painting the target.
Basically. I didn't say it clear, but he already came up with the fallacy that makes sense. Because that's exactly what he did.
I don't know if you can see the chat, Elijah, but I posted. I've now saved these. So it's 7 images going through the details related to the Lookout Mountain
Okay.
situation.
Nice vista.
Huh? What?
It's a lovely looking vista. Where is that? Is it somewhere?
I put all the images. They show the
Scroll up here too. That's Gospel Bear. He posted like 5, 6, 7 pictures at 1:08 after the hour, or 8 after the hour today.
Okay, yeah. So that's that kind of the Chattanooga, the venue or something. Some sort of.
Yeah, it's called Lookout Mountain. It's a location where you can see 7 states simultaneously. It's the only location known in America where you can see seven states at the same time. It's carved in rock. The only issue with what's carved in rock is their number of 120 is actually inaccurate. I'm not saying that they did that on purpose, but it's suspicious that they might have done that on purpose. But then I give you the Google Map location to Pinnacle Overlook. The referenced now that's at the point, at the very tippy tip point of Virginia, where Pinnacle Mountain, all that that mountain range is part of both Kentucky and Virginia simultaneously. But anyway, there's the distance. There's the Earth curve calculator. There's the target hidden height, and there's the actual height of Pinnacle Mountain, 3730 in feet, right? In which case, that means that 1,440. The tippy tip top of Pinnacle Mountain should be 1,430 feet below the horizon. But a nurse in the days of the Civil War, a nurse was the one that initially made this observation. You know, not some type of person with a $15,000 telescope or whatever. A nurse with a nice looking glass, or a good glass, as she put it, made this observation in the mid 1800s.
Are you saying? Sorry, as the story goes, that she makes an observation that you can't normally make, or is this just a backstory on who saw it first? Or if I was stood there now, could I see what the nurse is allegedly saying she saw? Or
why does that matter? Why does that matter? Like,
I'm trying to get to another what this is about.
Do you listen for what the main point is, or
yeah,
do you purposely fish for the parts that are least significant?
No, I'm trying to work out what the main point is. This nurse apparently in the past has seen something. Is that something?
Shit.
Okay.
Let's talk about this nurse. Did she say that this was not usual? Is this unusual? I don't know.
What kind of clothes was the nurse wearing? Was she wearing shoes?
Yeah, 3
or sandals. Was she? Did they have makeup then yet?
I take it none of you are in education.
I got a phone
call. Well, we work at educating you every single day.
All right, thank you.
Does she need a PhD in some sort of science degree in order to make an observation?
Right. Was the nurse stable? Let's talk about the nurse's character.
Let's backtrack a bit. So you were saying that what's that 7 Seas plaque? Is that on top of the venue Chattanooga vantage point? Is it?
What the what C? I can't understand the words you're saying.
There's a C7 states plaque. Yeah.
Yes. Yes.
And that's at the top of the venue Chattanooga point. Yeah.
Yeah,
Lookout
it's called
Mountain.
Lookout. It's called Lookout Mountain, and yes, that's the distance. That little white circle where I put the where you see the 146.36 miles.
Yeah.
Yeah,
That's the observation point for the.
that
The
is
other.
that is where that spot is. That's where that piece of stone is.
Right. Okay. And then you got a straight line going to the Pinnacle Overlook. That's a distant point you can see from.
Yeah, that's the mountain in Virginia and Kentucky. That is the reference point for what can be seen from Lookout Mountain because it's the closest. Right. Look at the map. That's the closest distance to both Virginia and Kentucky.
Okay. Yeah. So please bear in mind I don't know any of the geography of America. So
that's okay. But that's why I included pictures.
Right. So in the very bottom picture,
where is Lookout Mountain?
What?
Where is Lookout Mountain?
Technically, it's in and outside of Chattanooga. It's in the northern part of Georgia, but it's also in Chattanooga.
Okay.
What kind of wildlife does live there on the mountain? Do you know?
Yeah, let's ask more relevant questions. Is what Elijah is getting at.
Yo, so let me ask you, like, so what exactly is the point of this observation? Based on the geometric claim that the Earth is a sphere with a radius of 3,959 miles, like, what are we looking at here? What are you getting at, Gospel Bearer? That's how you ask what the point is.
Yeah. Okay, so were you getting somewhere? Pazza, what or whatever.
Sure. So in the very picture, looking out on the vista, can you see that? You're saying you can't see the Pinnacle Overlook, or you can in the distance?
You can see Kentucky, you can see Virginia. That's not the only thing you can see of Virginia and Kentucky. Apparently, these days, not back in the mid 1800s, but in these days, it can be discerned that there's even possibly, the glowing of light from different, cities and stuff off far in the distance. But either way, at the very least, Pinnacle Overlook, this mountain, can be seen from Lookout Mountain, and that distance exceeds what is mathematically possible on a curved Earth.
Okay, now I've got. All right, so now I see what you're saying. So you've got distance of 146 miles, yeah.
Yeah.
And you've got what's the elevation again of?
2389 feet is the elevation of the observer. Plus, I added 6 feet, so I did 2395.
Yeah. And what's the elevation of the Pinnacle Outlook?
Yeah, and I posted that in the pictures. All this that I like to read what I post. I really enjoy reading for people. 3,730 feet is the target. What you're supposed to be able to see.
Hey, real quick, if the globe's 25,000 miles circumference, should we be able to see all of what we're seeing, Pazza, with these seeing 7 states?
I've got no idea. This is the first time I've seen these pictures.
It's a yes or no question.
And it's arithmetic.
You always have no idea related to what you would expect to see on your belief shape.
This is why it's funny that you're always in here defending it.
No
so idea. Weird. He can't even answer. Should we be able to see this or not on the globe? 25,000 miles circumference. Come on.
You would think you would know
That's
by
the
now.
only question that's relevant. Like, what can I see on a sphere? Since I live on a sphere, there's limitation.
As a former Glober, I say no.
He wouldn't know.
There you go.
He wouldn't
That's
know
the right answer.
He would still just come in here, like, just without knowing, like, how far you're supposed to be able to see on your own model. You would just come in here without knowing that information over and over and over.
My bad. I did lead the charge. I did lead that charge in cracking the door of obfuscation because I don't want him to talk to us. I want him to address. I want him to address Gospel Bearer.
I'm still waiting for an answer. Yeah. And I heard the subtle correction. Apparently, when I originally did this, I did it based on 148, and we're going to be as liberal as possible. So I dropped it down 146 and posted a new a new thing. But with that said, with the 3,730 feet, even 146 mile calculation, and of course 6 feet added to the max height of, making it 2395 feet. At the 146 mile mark, you've still got a horizon at 60 miles, okay, and the target hidden height is 4,939, and you're still talking about what, 1,200 feet?
Interesting.
So it's below the horizon, 1,200 feet, but it can still be seen. But not just like it's a speck. It's not reasonable to conclude, oh, look at that little speck that I'm discerning is probably. No, you would have to see a profile of the mountain to discern in the mid 1800s as a nurse. You'd have to be like, oh yeah, that's that. Yeah, I know that mountain. That mountain's in Virginia. You can see Kentucky, and that's right next to Kentucky, guys. From this point, you could see 7. Look, you could even see Kentucky and Virginia. Look at that mountain. I know that mountain.
She probably
right?
knew the mountain because she probably walked from there.
Well, I'm just saying, like, this is a thing that's set in stone, quite literally set in stone. With the stone observation, with the little marker there that says this story. I do think it's suspicious that they say 120 miles. I can't seem to find out what causes them to use that number that is obviously inaccurate.
So if you, just to be clear, if you go up there and you look where in that view, you're saying in some of the distance there, you can see the mountain in that photograph. Just as a matter of interest, is it in the photograph there, the actual mountain in question?
No, it's not in that photograph.
So is it true that most of the time you can see it, or sometime, or rarely, or is there some sort of like
clear weather?
Clear weather. Okay.
So as long as there's not clouds, because you know how clouds can obstruct your view after like 10 miles.
Totally.
10 miles. So yes, as long as it's a clear sky day, yes.
And this nurse is one of the first people to make its anecdotal recording of someone seeing it. It's the nurse, yeah.
Yeah, that's recorded.
So he's trying to ham wave it again.
No, I'm not. I'm wondering how the nurse comes into the story. That's all I'm saying. It's not
I
clear.
apparently you didn't look at the images I posted.
Yeah.
I posted a little snippet there. As the story goes I'm reading for you again, like you're a child. As the story goes, during the Civil War, there was a nurse on Lookout Mountain that wrote, "From this point on a clear day with a good glass, I think you can see 7 states."
Okay, so
that's taken directly from Lookout Mountain's website. I just copied that image from a snippet of Lookout Mountain's website.
Okay, so that's just confirming that on a very clear day you can see 7 states, yeah. That's just an anecdote.
And no globe is possible.
Anecdotal. There's a photograph here for you.
No, it's
but the point is,
it's not anecdotal.
Sorry, guys.
Using the word anecdotal is unfair and really on the verge of rude. No,
it's hand waving.
Chattanooga is famous for being able to see the 7 states from that one location. Everybody can see it. You can, and again, hop on your little Google Earth. Okay, look at the profile. Zoom down. You can get down to the surface in 3D view, and look at the profile of Pinnacle Mountain.
Yeah. I'll
Okay.
have a look.
Do it all yourself, and the fact of the matter is, it isn't mathematically possible on a curved Earth.
Okay, I'm not refuting that for the minute. I'm going to have to have a look at it yet. But all I was trying to do, and I've written down all the numbers and I'm going to check them out. But all I was really doing is working out why you put the story of the nurse there. Is it just because it's off the website, or is it just because?
Shit.
Yes, because it's a normal story that's not about flat Earth, is not related to flat Earth at all. Just a story about someone who could see 7 states from a certain vantage point.
She was just the first one to make the observation.
Why is it that?
There we
why
go.
is it that
we don't know that? We don't know that. She's the first one. She's the first one to get it published.
Well,
Yes.
okay, that's it. That's the context of why you put that textual
So,
snippet there. I understand it now.
Holy shit, we didn't put it in there. Bro, why
I
is it
did.
that everything flat earthers bring up is invented by flat earthers, no matter what
I
it
didn't
is,
say.
Paza?
I didn't. No, I didn't say that. I'm not
Yeah,
referencing.
you assume
Paza,
that. We hear it.
Oh, massively.
would it
Massively.
help you to let you know that I saw these locations with not necessarily my own eyes, but through the viewing scopes that they have there
Yeah, they
in
have
April of
little binoculars.
1988. I
Right, well,
personally made that observation in April of 1988.
Yeah, Paza, why don't you go out today and measure your geometric horizon for us? Have you tried that before?
Have I looked at the?
No, I didn't say look. You're already
You
putting
hand
words in
wave
my mouth.
everything we show you.
No,
Do you have any
yeah.
measurements
Did you
of
go out
Earth
and
curvature
measure?
yourself?
Did you ever go out and measure your curvature or geometric horizon, Paza?
How do you measure it with a pair of binoculars?
I rest my case.
Well, you
No,
can use
I
a
agree.
landmark or something
I've
like
never
that
said-
in the
I've
Black
never
Swan,
said-
you know?
I've never said you could measure the geometric horizon with a pair of binoculars.
Well, you can measure it up to 9.4 miles in that picture you keep hand
I didn't
waving.
make any claims at all. How,
Can I
what,
add on
where,
to the 7
whatever.
states?
Just like, have you ever done it? No, you don't even know.
I want to hear what somebody has to say about Lookout Mountain because it's
Well-
it's the horse I'm beating this month.
Actually, I have a question. Can you see, like, so that little mountain, the 7 states mountain, can you see from the places that they're pointing at? Like Tennessee, can you see the mountain from Tennessee?
Yeah. You can see in the direction that little graphic shows. It really is that direction. Tennessee is literally turn left. There's Tennessee. Alabama is literally turn right. There's Alabama. Those are actually pointing in the direction from the vantage point.
Matthew, tell it though, you would have to look down under the horizon. Remember that?
Well, if we were living on a cartoon ball, sure.
I thought we are looking down through it. It's just imaginary that it shows up.
Yeah, I hear the sarcasm, but these guys, it's a frustrating
Sorry,
thing because
one of them
somebody's.
deserves sarcasm, one of them doesn't. My bad.
I mean, seriously, to get on a sticking point about the origin of kind of where this got figured out, with the nurse story. Oh, let's talk about the nurse. The whole thing about state lines and all of that is a moot point in history. How many Native Americans, Aboriginals of this continent, stood at that same point and looked out and saw the same locations, but they wouldn't have said, "Oh, I can see 7 states." The states didn't exist. It's kind of a moot point.
Mm-hmm.
But the fact of the matter is, it's about the mountain range. It's about the location of the mountain range. It's about its distance.
Mm-hmm.
So these are the relevant details, and that I'm hoping. Here's what I was hoping would happen. This, and non-sarcastically, I was hoping that a Glober would take my Lookout Mountain thing, and they would say, "Well, it's just as simple as this. Google Maps is wrong on drawing the distance." That's what I was hoping would happen. And then all I would then I would ask them, "How do you know that?" And then they'd say, "Well, I know that because it can't be true. Therefore, the error has to be in the distance." And we know this because look, they obviously know that it's 120 miles. Well, interestingly enough, if you draw a line straight north from the point, you're actually going to be closer to that 120 mile mark. The problem is the pinnacle overlook that's referenced in the graphic right below the Kentucky Virginia point. The pinnacle or Mount Pinnacle is the reference point. So anyway, I appreciate the wrestling with nonsense and foolishness. I think it's a little bit of fun, and I was totally prepared and ready, waiting for a Glober to say, "Well, the map is just wrong. It's not actually 146 miles." But then, of course, they'd have to prove that. Not that I'm.
Yeah,
I'm just relying on their story to prove them wrong.
And then we're left with the same thing as before. They we're wrong, and we ask for, okay, what is the right way? And nothing is forthcoming so far.
We're gonna ask now who
Well,
made
hold
the
on. Wait.
What's up?
I want to hear the conclusion of what Gospel Bear is saying, because he's saying, I expected Glovers to talk about this, and so what actually went on? Because I know what it's like to have an argument and not have any of the points addressed, no matter what you do.
Well, the second thing that I expected to happen, if they accepted the Google Maps quote unquote authoritative data here of 146 miles minimum, was for them to invoke refraction. Now, the uniqueness here is that this is an overland observation at a higher elevation, and that's where it could really get interesting, because over and over again they talk about the fragments, the water content in the air at the ocean level, playing a massive role, invoking versions of or perversions of Snell's law and stuff. But now when we get 2,000 something feet up in the air, 2,389 feet in the air, well, now you're going to have a hard time staying consistent or using the exact same excuses that you did with the Black Swan, because we're in a slightly different situation here. But yes, I was expecting refraction to be the next place where the argument would go to, but they would have to reformulate all their arguments.
Yeah,
because of the different
they
elevation.
argued that it would be better if you actually did it at a higher up elevation, because everyone knows that the lower you do it to the ground, the more error, because of the difference between the temperature with the water and blah 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 blah.
You got it.
But actually, I would have thought that they would have saved refraction for this, because, well, you actually have to look through more atmosphere to the horizon. But I don't know how they're going to work their way out. I don't know.
It doesn't really matter what they do. They can try to wiggle all they want. Gospel Bear's right. Stand on the information. We don't have to care how they wiggle. We could talk about how they're wiggling around, trying to escape the entire premise, which we see them do here every single day by various means. It's not working.
And for those who aren't keeping up with the intelligent portion of this, because these guys are talking about stuff that's over my head, right? Earth measures flat. Bottom line, there's no curvature. No curvature.
Well, listen, they are in a romantic relationship with the concept of falsification. They're in a romantic relationship with predictions, right?
Yeah.
And they love the word predictions. And
but just post-dictions, aren't they?
If it makes predictions, therefore it's the truth. And this is the narrative. This is how they paint it. So if it makes predictions and those are falsified via like this observation and demonstration I'm sharing, Lookout Mountain, your prediction, the model you're using to make your predictions is inaccurate. That's the whole point.
Yeah.
It's not
a globe or not, the math is off, right? We don't know if it's a globe or what shape it really is, but the globe math, the accepted narrative, is way off from reality. That's the bottom line.
Yeah, it's not just inaccurate. I think this was discussed yesterday quite a bit as well. It's just dead wrong. It's wrong. We got to stop,
incorrect.
Sugar coating this.
Yeah, what was he saying? It wasn't inaccurate, the word he was using. He was saying was he saying inconclusive?
That's
right. No, incorrect.
Yeah, incorrect.
Well, he keeps, his thing the last few days with the Black Swan is to keep saying how the BML guy goes out there and he says himself that 90% of the time it looks this certain way, but he hasn't specified what that certain way is. Like, is he trying to say that 90% of the time the horizon's at 1.2 miles.
Yeah, that's just like
what does
talking
he
about
even
the
mean?
nurse. It's just like talking about the nurse.
And the other thing too is the BML videos. I don't think BML actually even talks about the horizon itself. He's just talking about how much curvature drop there should be. The horizon argument came from QE, as far as I know. So, like, yeah, I'm just wondering when he says
he's mentioned it.
Time it's like this. Like, what does he mean? Sorry, go ahead.
No, just saying BMLSB mentioned it.
Oh, okay.
The horizon.
Yeah.
But BMLSB has new videos with new observations. The subject is still the same. It's the horizon.
Mm-hmm.
The horizon being geometrically further than what was expected.
Yeah.
Not just in his videos, but also with this woman who's seen 7 states. Not with just this woman who's seen 7 states, but with National Geographic while they're cheering that they won because the flag seemed to disappear behind a horizon that was behind the boat. Yes, you heard me right. The horizon was blocking the stripes. The horizon was also behind the boat.
Well,
So
here's the preposterous.
it's not the just saying it's not the observation per se, it's the argument. It's like no matter where you go, you can apply. It's like they don't want to actually apply the method itself.
Their own they don't want to apply their own predictions. Yet while still claiming complete loyalty to their predictions.
I wonder if I'm gonna start going to schools. It's getting nice, you know. These mask mandates are starting to come down, even though they're still firing people for not getting the vax or whatever. But that aside, it's like I'm gonna start asking these teachers, man, like, yo, can you explain to me why the horizon isn't what's claimed based on like I really it could be any kind of question. Maybe not the gas pressure without a container question, because I think that's too heavy. Because the implications of them not having an answer, I could feel them kind of feeling it and kind of staying as far away from it as possible. Meaning they'll come up with justification without even addressing anything. They'll just keep dodging. But when it comes to I don't see somebody who isn't used to this argument, say just, regular professors across the country. I don't see them telling me refraction. I just don't see it.
Mm-hmm.
Because that's not a plausible answer.
See, the whole part of this conversation, the whole problem is either those things that we observe on the horizon are there or they're not. That is the question. So I think we all know the answer. Navigators and ship's captains and aircraft pilots know the answer. But there's this group that doesn't seem to know whether the things we're looking at are real or not. So they have a story they're trying to tell instead of things just being there, because when you go all the way up to it, let's say you're on a ship, it's still there and you didn't lose your view of said object on the horizon. It didn't you didn't get to a certain point closer to it where all of a sudden now the geometric horizon, boop, gone, like you're on top of it, and it didn't change like that. You see what I'm getting at? Like, where is this? It would have to flip back and forth between a mirage and real. That's how convoluted it is for them to try to obfuscate away from what we actually really do see in actuality on the horizon. It's either there or it's not.
So when do we ever actually see the real geometric horizon? Because he was being really vague. He kept saying, go out there 90% of the time it looks like this. I guess I just keep repeating myself here, but like, what is this? Is he seeing the geometric horizon 90% of the time?
Well, that's also 90% of the time the atmospheric conditions could be occluding how far you can see. that doesn't mean that that occlusion based on atmospheric conditions that happens 90% of the time is some sort of physical obstruction, just because it happens often
Right.
based on your atmospheric conditions and your weather. That's like saying I live on a perfectly flat plain and 10 miles away from me is a forest that when I don't have fog or haze or drizzle, I can see it. But when I do have fog and rain and haze, which is 90% of the time, it's actually really not there because 90% of the time I can't see it.
Yeah, and they're
You know what I'm
taking the
saying?
outliers. See, that's what they're doing with this. They're taking the outliers on this, like they're taking these numbers, right? They're taking like a statistical purview of the scene, and they're saying the outliers. They're just throwing those in the globe bucket because they already have the presupposition. So they're looking for anything they can. Oh, if the flat earthers can't see it, then it's got to be a globe. So we'll throw all these outliers in these observations. Like if we had a large number of large number of these observations, and you did statistics, they're saying on the days you can't see the black swan, all those we're throwing in the globe bucket, and we're going to make one word to make it work: refraction.
There's
And if
a really good Earth
we
curve, but when you actually look at humidity, it's well known that humidity does limit how far you can see, and when there's really low humidity, you can see really, 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 really far, and that just destroys them.
Mm-hmm.
And what you're seeing here is a mirage.
It seems to go down to the basics, distortions of cause and effect, and I don't know. This other thing is just you see what you see and drop your assumptions, and it becomes less confusing.
I liked the forest example. I've never heard that one before, but I will remember that.
Sure, I have another example too. It's like saying if I based my assumption of distance to stars based on their brightness, and I live in a state like Florida where it's humid all the time. Well, guess what? In the wintertime, when I get a nice low humidity evening and the stars are brighter, does that mean the stars are actually closer to me? Because 95% of the time or 99% of the time, they're much more dim.
Mm-hmm. That's how these assumptions with these numbers collide with reality.
Yeah, there have been reports of seeing the Antarctic coastline 200 to 300 miles away, but Antarctica is, of course, an Arctic desert. There's very low humidity there. So that kind of makes sense, but where's the curve for the globe? It would still be required to be there, hiding Antarctica from everyone.
Hmm.
You don't see the curvature of the earth.
Was that Bill Cosby?
Bill Cosby.
You don't see the Jello pudding pop.
Oh shoot!
It did sound a lot like him, actually. It was good.
No, he's not.
Yeah, that's Bill Cosby.
I bet Neil deGrasse can't see his toes most days.
What it is, I don't know.
What do we do with the outliers there?
If you make stupid sounds when you answer a question and you make it all stupid sounding, then that makes it more legit.
Mockers. It's just the behavior of mockery.
So on the days that Neil deGrasse can see his toes, does that mean he went from fat to flat?
I have no idea. Okay, next question.
When we answer questions like that, we get yelled at for not answering a question.
I have no idea, but the Book of Zohar sure has a great idea. I can tell you all about it.
Yeah. But instead of talking about the content of the book, I'm going to talk about the color of the binding.
I want to talk about why they used the one glue versus the other glue, because that's really the glue that binds it all together.
Or the stitching. Do you know sometimes they actually sewed the binding?
Hmm.
Yeah,
Yes.
that time in old books.
That's what like having a conversation with Paz is like.
Well, all I know is you're not allowed to insult or criticize the Book of Zohar, otherwise you might be called an anti-S. People deriving from the lineage of Shem, you'll be referred to as an anti.
That could take some further investigation for myself. Yeah, I could look it up.
Oh, yeah, right. I see what you're saying.
I follow.
Seriously, that's why you won't find very much. It's hard to find negative content about the Book of Zohar, is because of ADL and other entities that accomplish really thorough scrubbing.
Yeah, scrubbing's a good word. Like destroying data, destroying information. Which isn't, that's an impossible statement. We don't destroy information.
Wasn't that Winston's job in 1984?
He was a revisionist, yeah.
So was it 2022 years ago that they reset the calendar from 13 to 12 months?
I'm not sure about that, but back to Winston, just real quick. Anybody think it's a coincidence that the book 1984 was published in 1948? Dun, dun, dun.
Not surprising at all.
So one thing I noticed when I recently revisited the movie Ready Player One is there's multiple references to at least imagery of Rush's album 2112, which has a right side up pentagram in a circle, and below it says 2112, so 2112. Just throwing that out there. Don't know what it means per se, but there was
Rush's album 2112, The Man in the Star?
Yeah, so at the end of the movie when he beats the last game and he goes in to receive his golden egg, and he's in the bedroom of the game creator as a child. He has a Rush 2112 poster on his wall, and one of his players on his team, the one that is a female in real life but was playing as a male character, the one who drove the van, she's wearing this very same Rush 2112 t-shirt. Yep. I just found that interesting. I don't have a specific tie to give you guys, or
right on. And every episode of The Goldbergs is a reference to Rush in there.
That's very odd how all these references are throughout those album covers and the music itself, the lyrics. Like there's some kind of, I think, well, we already know there's some kind of deep code in there. Seems to be something. There's clues in all of it. What does it
1949
all
in
mean?
June.
48. Wasn't that the year high jump ended or something?
There is all everything is saying 1949 for 1984. There is something peculiar about that. Trying to remember something as it relates to that book. It might have been that he
wrote
started.
it in 1948.
Yeah, started writing it in 48 maybe, but
on that recording we played yesterday, if you heard it, there's a little preface by the narrator that says that he wrote it in 1948.
Gotcha. So I misspoke on the publish year.
So I'm going to have to revisit this 2112 album, see if there's any gems in there. Just going through the song titles: Overture, The Temple of Sphinx, Discovery, Presentation, Oracle the Dream, Soliloquy, Grand Finale, A Passage to Bangkok, The Twilight Zone, Lessons, Tears, and Something for Nothing.
Yeah, I used to listen to this album like all the time back then. I haven't heard it for years.
So somebody on a literature network forum was discussing that 1984 wasn't discussing what they thought would happen in 1984 or whatever, but rather it was describing 1948 as it actually was. It wasn't a future dystopian novel. It was a descriptor of what was taking place in the present.
Listen to these lyrics. We've taken care of everything. The words you read, the songs you sing, the pictures that give pleasure to your eye. One for all and all for one. Work together. Common sons. Never need to wonder how or why. We are the priest of the temple of Syrinx. Our great computers fill the hallowed halls. We are the priest of the temple of Syrinx. All the gifts of life are held within our walls. Whoa. Look around this world we made. Equality, our stock and trade. Come and join the brotherhood of man. What a nice, contented world. Let the banners be unfurled. Hold the red star proudly high in hand.
Yeah.
The red star.
You need to go listen to that album that
That's
you've never
great.
listened to it before. I know that backwards and forwards on drums.
Neil Peart's not an easy man to mimic, that's for sure.
Backwards and forwards.
Yeah, we have Xanilla, probably butchering his or her name.
Zanilla, she was here last night.
Okay.
Yeah, she's awesome. Good to see her back, Zanilla. Good evening, Roger.
Good evening.
Yeah. Morning here, just before noon here.
Just before noon? Okay, yeah. Well, it's just before 8 here.
Yeah.
8 o'clock.
So we're like exactly 8 hours difference, huh?
Mm-hmm.
Okay, Roger, do you have daylight savings next week?
Yeah. Is it next week?
The 28th, around that kind of, yeah.
Wait a minute, really?
We just had ours.
Yeah, it just happened.
Yeah.
Last weekend.
We're a bit
Oh
off
yeah, that's correct because
and
we
decided
we are always a week or a week and a half. Yeah, a week or a week
Isn't
or
that
two behind.
so? More
Well,
gerrymandering of the
when this
time.
started, when this like, because when it switched, when the time switched last time, you guys were first. But when we're coming out of it, it's like now we're first because I'm remembering the Nathan Oakley show and he started at 10 o'clock, or was it?
Yeah, it's
He
the
started at
27th.
10 o'clock because the time went back for us. But he's still going. But I'm confused. I confused myself, y'all. Sorry.
Yeah,
Don't y'all
it's
think we've saved enough daylight by now? We should stop doing that stuff anyway.
Mm-hmm.
The point is, his time went back or forward or whatever it was first, and that caused the show to be at a different time. Now our time is moved and first, and it's caused the show to be at a different time, which is the same time, which is 10 o'clock until either of our times switch back, and then it's 9 again.
Yeah, so ours is the 27th. And the 30th of October, it will go back.
And you're an hour ahead of us there, Roger. And we're so close.
Yeah. Yeah, it always messes me up, man. That summer of daylight saving always messes me up for a week or so. I'm like, ugh.
I did.
Did 4 or 5 people just dip out?
Yeah, it sounded like it.
I don't know.
So is Pazza now going to figure out the math and come back with the refraction calculator or something?
Yeah,
Tell
but
us that.
but the thing is, 7.6. That won't.
He's gonna go out.
It doesn't jive.
He's gonna go out and measure the geometric horizon for us himself. Yeah, he's gonna bring us that geometric horizon measurement. Yeah, let's see him try it. Let's ask him if he made a measurement himself ever of Earth itself. If he looked at, did he do an observation himself to check out the numbers?
But nobody can use the horizon to measure the radius, right? That's what they all tell us.
Mm-hmm.
4939 times 7.
I don't know. What do you say to a person like that? Well, you just don't believe that what you're seeing is real, so I don't know if we can help you.
Right. It's just a hologram of the mountain. It's not actually
So how could you fucking know anything? How would you even know if you're awake then? So, like, fuck off.
But Roger, that claim Alberoni did it. Alberoni, yeah.
Yeah, you use the flat Earth to measure an angle to the mountain.
Oh gosh.
You had to know how high the mountain was, right? So you used the flat Earth to do that.
Mm-hmm. Yeah, how to measure other heights of everything. Sea level.
Then he got specific measurements from an apparent horizon. That was a pretty good job he did there, wasn't it?
It's there, but you can't see it.
Okay. How do they do the 7/6 in any ways? So how does that apply to, for instance, the hidden, the target hidden height, that number? How would 7/6 apply to that number in their estimation?
I would like to see that myself.
Because it changes. It changes. All it does is change the radius.
Yeah, so everything else changes around that.
instead of talking about the ground, you know, you're talking about a ray of light, and the radius extends to whatever elevation that is above the ground.
So
now effectively it's just a bigger value.
I have the big one pulled open. The Walter Bislin's Advanced Earth Curvature. Does it have the? I see a spot for refraction, but I don't even know how to use that one. I don't usually use it.
You're asking if it actually, if you can fiddle with it to make it
I'm sure you
sense
can
with the Black Swan. I haven't seen it.
Mick West's refraction simulator does that, but it doesn't show how.
Okay, great.
There's a box for standard refraction, and it gets the geometric horizon to the distance that we see in the picture, but it doesn't go into the calculations or show the work or anything.
Yeah, I'm talking about this Walter Bislin one that's got like, it looks like a flight simulator. It's got so many different, fields that you can change the values of. Like you can change everything.
Yeah, so is anybody better at math than I am? You know how in the Black Swan, so at 10 miles, it should be about 66.6 feet. So can anybody figure out that away from the observation, the observer, that's an angle away from the observer? What angle is that? It's like, obviously if it's on a ball, it's going downward, so it's also an angle that's going away from the observer as well.
Tilted. So you want to say that the platforms are tilted? Wasn't that 1 degree per 60?
objectively, the surface would be tilted back if it's supposed to be a ball. So
Right.
I want to know the angle that it's tilted back because that's where their light's hitting first.
Wasn't that 1 degree at 69 miles? Something like that?
1 degree of tilt. Oh, let's say about 69 miles. That, yeah. They have to start there. So let's see how their refraction works on a surface that's facing away from them and below the observer's height by 70 feet. This is where I'm. This is the hill I'm going to die. That I'm going to. I'll fall on my sword on this hill. It's angled away from the observer. So like Canahu also. So how many miles is that? How many degrees of backward tilt is that supposed to be? So every observation, Jay Tollins, let's say minimally he's seeing 800 miles. How much tilted back is that? So 69. So 10 degrees, 20 degrees.
Okay, I found it. There's a refraction tab on that globe calculator. I just found it. But I don't know how to read the results. Hold on. Horizon, hidden. So yeah, what's the hidden with the refraction? Refraction. Hidden.
Wait a minute. You're in Walter. Can you drop a link for that here? I would like to walk through the steps myself.
Yeah, I posted it.
Oh, you did?
Yeah, it's just 2 posts back.
I'm looking. Thanks. Wait a minute.
And it throws in. It does the graphics and everything. Curvature calculator showing refraction, distance on surface, distance from eye, drop 2394. Apparent radius. Yeah, so they make the radius 4,000 feet. No, 4 million. I'm sorry, 4 million feet larger in order to do the 7/6R distance.
Just in the Black Swan.
No, I'm still on Lookout Mountain. My dead horse that I'm beating.
So this right here, this Walter Bislin is exactly what I used to look at when they first started trying to apply this to the Black Swan. And I looked at like I plugged in I made it fit with the observation. And when you look at the light rays, which is theoretically what the light is doing on its path to our eye, it literally looked like a light bulb.
So on the refraction tab on that globe calculator thing, there's a 7/6 option, but there's even a 7/2 option. Which, I mean, they're all silly, but
standard.
Yeah, there's standard amount and then, or standard atmosphere, and then
kilometer. K equals 0.13,
which is referring to that coefficient K thing.
0.17, 7/6 over 7/6 or 7/2. What is TP? TP. Barometric link. Baro link. Standard atmospheric. So I want to do. Let's go 1 meter. Just go through the Black Swan distances.
I put in the 7/6R. It still very much appears to be
Wait a second. Distance.
not working.
Okay, reset. I'll change this to feet and miles. Too bad that left to right drop has never been measured, ever. They're talking about it here. Can't be seen. Do you know where you change the settings in this to make it like whatever measurement type?
Oh yeah, it's under units.
Okay, I don't know why I wasn't seeing.
Which is just above nearest target data.
Units. Here we go. Thanks. Right there in front of me.
What are these people talking about? What Ghost? Are you talking about me?
Foot.
Who are these people?
Temperature. Let's go. Miles and feet.
You people. What you mean by that?
Who says you people?
What you mean by that? You people.
Trying to be racist or something? Stop.
I'm talking about Lookout Mountain, man. It's the horse of the month. It's the dead horse of the month.
20,000 feet. What's the distance, fuckers? Distance on surface 3.137 miles. So at 1 foot, 3.137 miles. So according to this one, that's the distance. That's it. So Black Swan destroys this data.
You mean at the 7/6?
Yeah.
Yeah. Dave, I heard you, but you came in like a robot.
Let me see. Standard.
You're still coming in hardcore like robot.
Yeah, they changed the freaking radius.
The argument is from them is that it's not standard refraction; it's extreme refraction.
1.345 miles with standard refraction. So good on you. Okay, so you're saying, yeah, I'm saying it can only make it shorter. But okay, we'll give them the plus or minus. So you got 1.3 miles in. Great job.
Yeah. And in the Mick West simulator, when you use standard refraction with it, somehow he's placing the horizon at 10 miles, and it doesn't say how or anything.
They just conveniently changed.
I'm trying to find.
They changed.
I'm trying to find where I found the graph with the rays and how they looked, because that's like how they did it. I just don't know where it's at. I used to post images of it, screenshots of it all the time. I have no idea where it's at, but I know that it was here. It's just I don't know where it is now.
Refraction angle. Lift absolute. What is all this nonsense? Tilt. See, that's probably what I'm talking about. So they're not accounting for everything that all this stuff is. If they want to We'll just go with this and have them explain every single data point.
It's a complicated calculator.
Mm-hmm. Yeah, but still, here's the problem. Distance on surface, 1 foot above surface, 1.344 miles.
Okay. I mean, it should stop right here. Radius of Earth 3959. Apparent radius 4,618.
Yeah, mine went up
apparent
to,
geometric
look at what my
horizon.
radius changed to 4,773.27 miles. So they conveniently change it almost 100 miles back and forth. They are literally inflating and deflating their radius.
Or apparently, if you do the 7/2 instead of 7/6, you could get a 13,855 mile radius.
Yeah, that's right. That's what mine showed too.
But they still got almost 250,000 miles to go
To what? The freaking
for the
moon?
Black Swan to make sense.
I know, right? Oh, damn. They are so screwed trying to use this.
Black Swan. What would the diameter like? Nah,
The
they
diameter would
wild.
be 28, 200 and, no, hold on.
They're wild.
It'd be 26,000 mile diameter, 27,000 mile diameter instead of 8,000. 27,000 miles. Right there, back and forth. This one makes that radius 76R. It's a 4,600 mile radius. The 0.17 is 47 again. The 0.13 is 4,500. Standard is, even with standard refraction at 1 foot above the surface, they're saying the radius is 4,773 feet. I mean, miles. 4773 miles. Make your radius anything you want. Step right up. Put your nickel in, son, and give it a shot. See what your radius will be today. Wow.
Why? I don't understand why the radius comes in. Like if you were actually trying to argue and make sense of things, you would just keep the radius the same and you would make the math work with the given radius no matter what.
Yeah.
You would
So
never.
this is the slam dunk to like this right here.
That's too logical, Gospel Bear. Glovers don't like that.
Watch them throw all this under the bus. They'll do it. They'll
But
do
I'm
it.
telling you what they're saying is what they're gonna try to say, because what they've been telling me is you're this is what they're saying, that it's actually the light that travels to your eye. The path of light is refracted. Theoretical light ray is refracted over the earth.
Over the Sagittarius.
So they've given it that radius from the center to that altitude is different. That's why the radius is different, because they're talking about the curvature of the theoretical light ray technically.
Okay, I like it. I like that a lot. So if the light's curving, then why do we have to say that the ground is curving? Bueller. Right? If the claim is that the light is curving, why must the ground curve?
I know. It's just a ball of freaking presuppositions, isn't it? It's all bound up.
And then they're like, well, we know the ground is curving. This is just our way of, okay, so, and how do you know that? Well, we know that. Okay, you ever heard of a circular reasoning logic failure?
No, we just know it. We just know it because we know it. Yeah.
Sonny, you're exactly right. It's literally a ball of presuppositions.
It is. It's all like a. That's why flying spaghetti monster fits the bill quite well. That's the psychological effects that we're having to witness here. It's really what this is, looking at these psychological effects of the ball on people's minds.
The Paschetti monster.
After 7 years of looking at this, my icon still applies. In reality, there is no globe. Prove me wrong.
Thank you. Thank you, AI.
Zanilla, are you there yet? Haven't heard you chime in yet.
I'm here. I'm just listening.
Okay, cool. I see flat 8 in the house.
The score
Feel free to
is
pipe up with questions. Go ahead, Glad. Sorry.
real quick. The score is Earth measures flat, globe doesn't. What say you? Thanks.
Mm-hmm. This has been a public service announcement from the Gladflow